DevOps and cloud are currently trending and are expected to continue to grow in popularity and importance as more organizations look to deploy their applications in the cloud as well as use DevOps practices to streamline their development and deployment process. This trend is expected to grow as more businesses adopt cloud computing and seek to optimize their software development process. Hello everyone and welcome to this session. You're currently watching an Edureka's DevOps and Cloud Computing full course video. Well, I'm certain by the end of this video, you will have a thorough understanding about DevOps with cloud computing all the way from theory to practical applications. Now, if you love watching videos like these, then subscribe to Edureka's YouTube channel and click the bell button to never miss out any updates from us. Also, if you want to learn more about DevOps and cloud computing after watching this session or wish to obtain DevOps certification course, then please see the link in the description below. Now let's begin with our agenda where we'll have a brief overview of what we will cover in this DevOps and cloud computing full course video. We shall start with some DevOps basics where we will learn about DevOps and cover the very basics that you must and should know about DevOps. Then we will move ahead and learn about Git, followed by Jenkins. We shall also cover Docker and Kubernetes. Now it's time to delve deep into the concepts where we will see how DevOps works on cloud. We'll start with AWS DevOps. We will then cover Azure DevOps. At last, we will also cover some of the important concepts in GCP with DevOps. So stick till the end. Now let's begin with our first topic.
What is DevOps? DevOps is basically a combination of two words, development and operations. So what do we get when we combine these two? Simply speaking, DevOps is a culture that implements technology in order to promote collaboration between development and operations team to deploy code to production faster in an automated and repeatable way. The goal of DevOps is to increase an organization's speed when it comes to delivering applications and services. Many companies have successfully implemented DevOps to enhance their user experience. Let's take for example, Facebook's mobile app, which is updated every 2 weeks, effectively telling users, you can have what you want and you can have it now. Ever wondered how Facebook is able to do this so smoothly? It's the DevOps philosophy that helps Facebook ensure that its apps aren't outdated and that its users get the best experience. Facebook accomplishes this through a code ownership model that makes its developers responsible. That includes testing and supporting through production and delivery for each kernel of code they write and update. It's through policies like this that Facebook has developed a DevOps culture and has successfully accelerated its development lifecycle. Industries have started to gear up for the digital transformation by shifting their needs to weeks and months instead of years while maintaining high quality. As a result, we will soon see that DevOps engineers have more access and control of the end user than any other person in the enterprise. So what are you waiting for? Don't be in the sidelines when that happens. To master your skills, enroll in Edureka's DevOps certification program and become a leader.
Why do we need DevOps? The birth of DevOps occurred when there were some drawbacks with the existing software development models for application development. The first model we'll be addressing today is the waterfall model. So the waterfall model is a model of software development which is pretty straightforward and linear. So this model follows a top-down approach as you can see in the image. It has various phases starting with requirements gathering and analysis. So the first phase is where you get the requirements from the client for developing an application. So after this, you try to analyze these requirements that you've acquired. Next comes the design phase where you prepare a blueprint of the software. So in this phase, you think about how the software is actually going to look like. Once the design is ready, you proceed further with the implementation phase where you begin with the coding for the application. So here, the team of developers work together on various components of the application. And once the application is developed, it is tested in the verification phase, that is the fourth phase. Here there are various tests conducted on the application such as unit testing, integration testing, performance testing, etc. After all of these tests on the applications are done, it is finally deployed on the production servers. At last, that is the fifth phase, is the maintenance phase. So in this phase, the application is monitored for performance. So any issues related to the performance of the application are resolved in this phase. But unfortunately, this model, that is the waterfall model, has some major drawbacks. So the first drawback is gathering and documenting your requirements each step of the way can be extremely time consuming, not to also mention difficult. It is hard to assume things about your product so early into the project. And because of the same reason, your assumptions might be flawed and different from what the customer expects. The second drawback is that now, if the above case is true, your customers are basically dissatisfied with your delivered product. Adding changes to the product can be expensive and most of all difficult to implement. So the third drawback is that in general, the risk is extremely high with the waterfall approach because the scope for mistakes is extremely high. If things go wrong, fixing them can be hard as you have to go a couple of steps back. The next model is the agile model. So agile is an iterative based software development approach where the software project is broken down into various iterations or sprints. So every iteration has phases like the waterfall model, such as requirements gathering, design, development, testing, and maintenance. You can see each of these iteration in the image. So each of this iteration generally lasts for about 2 to 8 weeks. So the difference between agile and waterfall model is that you release the application with some high priority features in the first iteration. After its release, the end users or the customers can give you feedback about the performance of the application, so the necessary changes are made to the application along with some new features. And once these features are added to this application, it is again released, which is in the second iteration. This procedure is repeated until the desired software quality is finally achieved. Now, in spite of being used often, the agile method has a few disadvantages. The first one is that for the approach to work, all the members of the team must be completely dedicated to the project. That is, everyone must be involved equally if you want the whole team to learn and do better on the next run. And this is mainly because Agile focuses on quick delivery. There might be an issue with hitting deadline. The second drawback is that the approach may seem extremely simple, but it is hard to execute. So it requires commitment and for everyone to be on the same page, ideally in the same physical space. The third drawback is that documentation can sometimes be ignored. Because agile methodology focuses on working software over comprehensive documentation, things might sometimes get lost through each stage and iteration. As a result, the final product can feel different from what it was first planned. So these are the few drawbacks that the agile model or the agile methodology gives us. So in delivering valuable software to customers, development and operation teams are always in conflict with each other. While development wants to deliver its changes to customers quickly, operations want stability, which means not changing the production systems too often. So the gap between the development and operations team occurs on three different levels. The first one is the incentives gap. This is because of different goals of development and operations. The second one is the process gap, which is the result from different approaches of development and operations and how to manage changes, bring them to production, and maintain them there. The third one is the tools gap, which results from the fact that development and operations often use their own tools to do their own work. And this is resulting from the fact that development and operations often use their own tools to do their work. As a result, from all of these reasons, development and operations often act like silos, as they are two distinct teams. So the conflict between development and operations is because of two reasons. The first one is need for change. This is because development results in change. That is, they're always working on new features, bug fixes, etc. It wants the change to quickly roll out to production. And the second one is fear of change. Once the software is finally delivered, the operations department avoids making changes to the software to ensure stability. This is the major conflict between both of these teams. So this is where DevOps comes into picture. DevOps links software development to operations. I hope that is clear. That is, DevOps bridges the gap between agile software development and operations experiences. It is important to know that DevOps is a set of principles to break down silos. Specifically, DevOps is all about culture, automation, measurement, and sharing. So the first one is culture. So in culture, people and processes comes first. If you don't have a culture, all automation attempts will be fruitless. The relationship is important in culture because its functions include engage early, engage often, destroy silos, be open to options, and stop blaming. And the second one is automation. So once you understand your culture, you can simply start with automation, right? Now you can finalize various tools to achieve automation for DevOps. That is tools for release management, provisioning, configuration management, systems integration, monitoring and control, and orchestration becomes extremely important pieces for DevOps. The third is measurement. So if you cannot measure, you cannot improve. Makes sense, right? A successful DevOps implementation will always measure everything it can as often as it can. Performance metrics, process metrics, people metrics, capacity planning, trend analysis, fault finding, etc. All of these have to always be measured. So the last one is DevOps is about sharing. Sharing is the loop back in the cycle. So creating a culture where people share ideas and problems is extremely critical. So exposing ideas can create great open feedback that in the end it helps to improve, share ideas, share metrics, give DevOps shell access, see what technology can be leveraged, etc. So DevOps is all about these four particular features. I hope this is clear. So now let's move on to the next part of today's session, that is Introduction to DevOps. So finally, we will address what is DevOps. DevOps is simply a combination of two words. You can see that. One is the software development and the second one is operations. So this allows a single team to handle the entire application lifecycle. That is from development to testing, deployment, and finally operations. So DevOps really helps you to reduce the disconnection between software developers, quality assurance engineers, and system administrators. That is, it basically promotes collaboration between the development and operations team to deploy code to production faster in an automated and repeatable way. So DevOps basically helps to increase organization speed to deliver applications and services. It also allows organizations to serve their customers better and compete more strongly in the market. It can be also defined in another way, that is, it is also a sequence of development and IT operations with better communication and collaboration. So, in the market, it has become one of the most valuable business disciplines for enterprises or organizations. With the help of DevOps, the quality and speed of the application delivery has improved to an extremely great extent. Organizations that have adopted DevOps notice a 22% improvement in software quality and a 17% improvement in application deployment frequency. They have also achieved a 22% hike in customer satisfaction. Overall, a 19% of revenue hikes as a result of the successful DevOps implementation has been achieved. Moving on, DevOps workflow is another important concept. So what is a DevOps workflow? So it basically provides a visual overview of the sequence in which input is provided. Also, it tells about which one action is performed and output is generated for an operations process. So basically, DevOps workflow allows the ability to separate and arrange the jobs which are top requested by the users. Also, this workflow gives the ability to mirror their ideal process in the configuration jobs. Moving on, let's see some of the DevOps principles. So the main principles of DevOps are continuous delivery, automation, and fast reaction to the feedback. But there are 6 other principles that we'll be discussing today. The first one is the end-to-end responsibility. So DevOps teams need to provide performance support until they become the end of life. It enhances the responsibility and the quality of the products engineered. The second one is continuous improvement. DevOps culture focuses on continuous improvement to minimize waste. That is, it continuously speeds up the growth of the products or the services that has been offered. The third one is automate everything. Automation is an essential part of the DevOps process. We'll be discussing about this later on in this session. This is for the software development and also for the entire infrastructure landscape. The fourth one is custom-centric action. So the DevOps team must be customer-centric so that they should continuously invest in products and services. The fifth one is monitor and test everything. The DevOps team needs to have robust monitoring and testing procedures. The last one is work as one team. In the DevOps culture, role of the designers, developers, and testers are already defined. So all they need to do is work as one team with complete collaboration. These principles are achieved through several DevOps practices, which include frequent deployments, quality assurance automation, continuous delivery, validating ideas as early as possible, and in-team collaboration. Now let's move on to the third topic of today's session, companies using DevOps. By now, you must have figured out that DevOps helps to increase an organization's speed to deliver applications and services. This is exactly why many organizations such as Amazon, Netflix, Etsy, HP, Adobe, and many other organizations are adopting DevOps and its practices. We will now discuss how Amazon makes use of DevOps to increase their work efficiency. You must be aware that Amazon is one of the biggest e-commerce companies in the world. But way back in time, their website followed a traditional monolithic architecture. So in this type of architecture, all the processes are coupled together and run as a single service. Over time, as the code and the source files grew, it became hard to scale, maintain, and upgrade their applications on physical servers. So what did Amazon do? Amazon simply solved the problem of the monolithic architecture by moving from physical servers to cloud-based Amazon Web Services. You all must have heard of AWS. Currently, AWS follows a microservice architecture. In Amazon, there are basically three types of microservices. They are users, threads, and posts. Developers here apply frequent but small changes over their code via version control tools like Git and GitHub. Practices like code deployment help fix bugs and adds new features to improve the underlying software application. AWS Code Deploy is one such service that keeps track of deployments and simplifies the entire software release process. Amazon also uses Apollo. Apollo is a simple one-click internal deployment tool. So Apollo's job is to deploy a specified set of software across a group of hosts. On the other hand, practices like configuration management and infrastructure as code help to monitor and make changes in the software. It keeps track of the system's performance and resources used by developers. So in this way, the testing team can identify problems way before in hand and fix them immediately. So this is how Amazon implement DevOps and its practices. Now let's move on and understand one major concept of DevOps, that is the DevOps lifecycle. So if you're into DevOps from quite some time now, you must have heard at least one of these DevOps phases, that is continuous development, continuous integration, continuous testing, continuous deployment, and continuous monitoring. So all of these phases that I just mentioned make up the DevOps lifecycle. As you can see on the screen, and as I've already mentioned, all of these phases make up the DevOps lifecycle. The first phase is the continuous development phase. So this is the phase that involves planning and coding of the software. So the vision of the project is decided during the planning phase, and the developers begin developing the code for the application. There are no DevOps tools that are required for planning, but there are a number of tools for maintaining the code. The code can be written in any language, but it is mainly maintained by using version control tools. So here, maintaining the code is referred to as source code management. So some of the most popular version control tools are Git, SVN, Mercurial, CVS, etc. Also, tools like Ant, Maven, Gradle can be used in this phase for building or packaging the code into an executable file that can eventually be forwarded to any of the next phases. The next phase in the DevOps lifecycle is continuous testing. So this is the stage where the developed software is continuously tested for bugs. For continuous testing, automation testing tools like Selenium, TestNG, JUnit, etc. are used. So basically the tools that I just mentioned right now allow quality assurances to test multiple code bases thoroughly in parallel to ensure there are no flaws in the functionality. So what automation testing does is it saves a lot of time, effort, and labor for executing the test instead of doing this manually, right? Also in this phase, Docker containers can be used for simulating the test environment. Selenium here does the automation testing and the reports are generated by TestNG. So this entire testing phase can be automated with the help of a continuous integration tool called Jenkins. We'll talk about Jenkins later on in this session. So now let me explain you this with an example. Suppose you've written a Selenium code in Java to test your application. Now what you can do is you can build this code using Ant or Maven, and once the code is built, it is tested for user acceptance testing. So this entire process can be automated using Jenkins. Besides that, the report generation is a very big plus point. The task of evaluating the test cases that failed in a test suite gets simpler. We can also schedule the execution of test cases at predefined times. Once the entire testing is done, the code is continuously integrated with the existing code. The third phase of this life cycle is continuous integration. So now this stage is the heart of the entire DevOps lifecycle. It is a software development practice in which the developers require to commit changes to the source code more frequently. This may be on a daily or a weekly basis. So every commit is then built, and this allows early detection of problems if they are present. Building code does not involve compilation, but it also includes code review, unit testing, integration testing, and packaging. The code that is supporting new functionality is continuously integrated with the existing code. Since there is continuous development of software, the updated code needs to be integrated continuously as well as smoothly with the systems to reflect changes to the end users. As I've already said in the previous slide, Jenkins is a very popular tool used in this phase. So whenever there is a change in the Git repository, Jenkins simply fetches the updated code and it prepares a build of that code, which is in an executable file. So once this entire build is performed, it is then forwarded to the test server or the production server. Now let's move on to the fourth phase of the cycle, that is the continuous deployment phase. So this is the stage where the code is deployed to the production servers. It is very important to ensure that the code is correctly deployed on all the servers. Now before moving on, let us understand a few things about configuration management and containerization tools. Now these set of tools help in achieving continuous deployment. Firstly, I will talk about configuration management. It is basically the act of establishing and maintaining consistency in an application's functional requirements and performance. So let me put this in simple words. It is the act of releasing deployments to servers, scheduling updates, and most importantly, keeping the configurations consistent across all the servers. Since the new code is deployed on a continuous basis, configuration management tools play an extremely important role in executing tasks quickly and frequently. Now, some popular tools that are used here are Puppet, Chef, SaltStack, and Ansible. Containerization tools also play an equally important role in the deployment stage. Docker is one of the most popular tools used for this purpose. Basically, these tools help produce consistency across development, test, staging, and production environments. Besides this, they also help in scaling up and scaling down of instances very swiftly. Basically, containerization tools help in maintaining consistency across the environments where the application is deployed, developed, and tested. Using these tools, there is no scope of errors or failures in the production environment as they package and replicate the same dependencies and packages used in the development or testing or staging environment. Basically, it makes your application easy to run on different computers. The next stage is the continuous monitoring stage. This is the last stage in the DevOps lifecycle. This is a very crucial stage where you continuously monitor the performance of your application. So here, vital information about the use of the software is recorded. This information is processed to recognize the proper functionality of the application. The system errors such as low memory, server not reachable, etc. are resolved in this phase. The root cause of any issue is determined in this phase. It also maintains security and availability of the services. Also, if there are any network issues, they are resolved in this phase. That is, it helps us automatically fix the problem as soon as they're detected. So now this practice involves the participation of the operations team who will monitor the user activity for bugs or any improper behavior of the system. The most popular tools used for this phase is Splunk, ELK Stack, Nagios, New Relic, and Sensui. So what these tools do is they help you monitor the application's performance and the servers very closely, and they also eventually enable you to check the health of the system proactively. Now, using these tools, they can also improve productivity and increase the reliability of the systems, which in turn reduces IT support costs. Any major issues, if found, are reported to the development team so that it can be fixed in the continuous development phase. This also leads to a faster resolution of the problems. The stages are carried out on loop continuously till you achieve the desired product quality. Therefore, almost all of the major IT companies have shifted to DevOps for building their products. Moving on, if you want to become a DevOps engineer or be a part of this ideology, it is extremely important for you to be familiar with some DevOps related tools. Today, I will be talking about 7 important DevOps tools. Now, before we understand the tools DevOps engineers use, it is important to understand containers. So, what are containers? Containers allow you to package your application and its dependencies together into one manifest that can be version controlled, allowing for easy replication of your application across developers on your team and machines in your cluster. This is exactly why container-based microservices architectures have profoundly changed the way development and operation teams test and deploy software. Containers really help companies modernize by making it easier to scale and deploy applications. But they have also introduced new challenges and complexity by creating an entirely new infrastructure ecosystem. IT companies are now deploying thousands of container instances daily, and that's a complexity of scale they have to manage. How do they do it? Here is where Kubernetes comes to the rescue. Kubernetes is a container management technology developed in Google to manage containerized applications in different kinds of environments, like physical, virtual, cloud infrastructure, etc. So it really is just an open source system which helps in creating and managing containerization of applications. Its container management responsibilities include container deployment, scaling and descaling of containers, and container load balancing. It is extremely important to remember that Kubernetes is not a containerization platform, it is a multi container management solution. Now let's move on and discuss some of the features of Kubernetes. The first one is automated scheduling. So Kubernetes provides an advanced scheduler to launch containers on cluster nodes based on their resource requirements and other constraints, while not sacrificing availability. The second feature is self-healing capabilities. So Kubernetes allows you to replace and reschedule containers when nodes die. It also kills containers that do not respond to user-defined health checks and does not advertise them to clients until they are ready to serve. The third feature is automated rollouts and rollback. So what Kubernetes does is it rolls out changes to the application or its configuration while monitoring your application health to ensure it does not kill all your instances at the same time. So if something goes wrong with Kubernetes, you can simply roll back the change. The fourth feature is horizontal scaling and load balancing. Kubernetes can scale up and scale down the application as per the requirements with a simple command, using a user interface or automatically based on CPU usage. Now let us understand the architecture. The Kubernetes architecture has two main components. The first one is the master node, the second one is the worker node. So the master node is responsible for the management of Kubernetes cluster. It is mainly the entry point for all administrative tasks. There can always be more than one master node in the cluster to check for fault tolerance. So there are a few components in the master node that I'd like to discuss. The first one is the API server. So here the API server is the entry point for all the REST commands used to control the cluster. The second one is the controller manager. It is a daemon that regulates the Kubernetes cluster and manages different non-terminating control loops. The third one is the scheduler. So the scheduler schedules the tasks to worker nodes. So what it really does is it stores the resource usage information for each worker node. The fourth one is the etcd. So the etcd is simple distributed consistent key value store. So what it mainly is used for is to share configuration and service discovery. Now that we know how the master nodes work, let's move on to the worker nodes. So these worker nodes contain all the necessary services to manage the networking between the containers, communicate with the master node, and assign resources to the scheduled containers. So the first component that I'll be talking about in this worker node is the Docker container. So Docker runs on each of the worker nodes and runs the configured pods. The second one is the kubelet. The kubelet gets the configuration of a pod from the API server and ensures that the described containers are up and running. The third one is kube proxy. So kube proxy acts as a network proxy and a load balancer for a service on a single worker node. The fourth one is pods. So a pod is one or more containers that logically run together on nodes. With this, we come to the end of the first tool in DevOps tool. Let's move on to the second tool, that is Docker. So what is a Docker? Docker is simply a containerization platform that packages your application and all its dependencies together in the form of containers to ensure that your application works seamlessly in any environment. So each application here will run on a separate container and will have its own set of libraries and dependencies. It must be really convenient to move around these containers, right? So containers also ensures that there is a process level isolation, meaning each application is independent of other applications, giving developers surety that they can build applications that will not interfere with one another. Now, the quality assurance team need not install all the dependent software and applications to test the code, and this helps them save lots and lots of time and energy. This also ensures that the working environment is consistent across all the individuals involved in the process, starting from development to deployment. So here the number of systems can be scaled up easily and the code can be deployed on them effortlessly. There are some basic concepts of Docker you must be aware of. That is Docker file, Docker image, and Docker container. So a Docker image is created by the sequence of commands written in a file called Docker file. When this Docker file is executed using a Docker command, it results into a Docker image with a name. So finally, when this image is executed by Docker run command, it will by itself start whatever application or service it must start on its execution. So I hope Docker file, Docker images, and Docker containers are clear. We'll understand what is Docker Hub now. So Docker Hub is basically a cloud registry where you can find Docker images uploaded by different communities. Also, you can develop your own image and upload on Docker Hub, but first you need to create an account at Docker Hub. So let's move on and understand what a Docker engine is. So the Docker engine is the heart of the system. It is simply the application that is installed on your host machine. Basically, it works like a client server application. It uses a server, which is a type of a long running program called a daemon process. It also uses a command line interface client. And finally, it uses an REST API, which is used for communication between the CLI client and Docker daemon. As per the image, in a Linux operating system, there is a client which can be accessed from the terminal and a host which runs the daemon. We build our images and run containers by passing commands from the CLI client to the daemon. However, in the case of Windows or Mac, there is an additional toolbox component inside the Docker host. So this Docker toolbox is an installer to quickly and easily install and set up a Docker environment on your Windows or your MacBook. So this toolbox installs Docker client, machine, compose, which is only present in Mac, and VirtualBox. With this, we come to the end of Docker. We'll move on to the third tool of DevOps tools, that is Git. So Git is an extremely important tool for software developers. It is a free open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. It was created by Linus Torvalds in 2005 to develop Linux kernel. Git has the functionality, performance, security, and flexibility that most teams and individual developers need. It also serves as an important distributed version control DevOps tool. So Git is primarily used to manage your project, comprising a set of code or text files that may change over time. Now, before we go further, let us take a step back to learn about version control systems and how Git came into existence. So version control is the management of changes to documents, computer programs, large websites, and other collection of information. There are basically two types of version control systems. The first one being centralized version control system. The second one is distributed version control system. So Git is a distributed version control system where every contributor, that is the user, has a local copy or clone of the main repository. What is a repository? A repository is simply a storage space for your project files. Here, everyone maintains a local repository of their own which contains all the files and metadata present in the main repository. So the local repository is usually on the local machine of the user. So every programmer maintains a local repository, which is actually the copy or clone of the central repository on their hard drive. The central repository may be present on a web hosting platform like GitHub. They can commit and update the local repository without any interference. They can also update their local repositories with new data from the central server by an operation called pull and affect changes to the main repository by an operation called push from the local repository. So I hope everyone understood how Git works. Now moving on, let us understand the role of Git in DevOps. So Git plays a very vital role when it comes to managing the code that the collaborators contribute to the shared repository. So this code is then extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to the production. Tools like Git enable communication between the development and the operations team. When you're developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators while making changes within the project. Commit messages in Git play a very important role in communicating among the team. The bits and pieces that we all deploy lies in the version control system like Git. To succeed in DevOps, you need to have all of the communication in version control. Hence, Git plays a very vital role in succeeding at DevOps. Now let's move on to the next tool, that is Selenium. Selenium is one of the most widely used open source web user interface automation testing suite. It was originally developed by Jason Huggins in 2004 as an internal tool at ThoughtWorks. So Selenium supports automation across different browsers, platforms, and programming languages. So this tool can be easily deployed on platforms such as Windows, Linux, Solaris, and Macintosh. Moreover, it supports operating systems for mobile applications like Windows and Android. Selenium supports a wide variety of programming languages through the use of drivers specific to each language. Languages supported by Selenium include C Sharp, Java, Perl, PHP, Python, and Ruby. Currently, Selenium WebDriver is the most popular with Java and C Sharp. Selenium test scripts can be coded in any of the supported programming languages and can be run directly in most modern web browsers. Browsers supported by Selenium include Internet Explorer, Mozilla Firefox, Google Chrome, and Safari. So basically, it can be used to automate functional tests and can be integrated with automation test tools such as Maven, Jenkins, and Docker to achieve continuous testing. It can be also integrated with tools such as TestNG and JUnit for managing test cases and generating reports. So now moving on, what are the advantages of Selenium? Why should we choose Selenium? Since Selenium is open source, there is no licensing cost involved, which is a major advantage over other testing tools. There are many other reasons behind Selenium's ever-growing popularity. The first one is that test scripts can be written in any of the programming languages, that is Java, Python, C Sharp, PHP, Ruby, Perl, .NET, etc. Tests can also be carried out in any of the operating systems, that is Windows, Mac, or Linux. Tests can also be carried out using any browser, that is Mozilla Firefox, Internet Explorer, Google Chrome, Safari, Opera. We've all discussed this in the previous slide. And the last use is that it can be integrated with Maven, Jenkins, and Docker to achieve continuous testing. So in short, Selenium can be used for automated testing. Also, because it has cross-browsers compatibility, it is more preferred. And it also increases test coverage and reduces test execution time. Now moving on, let us understand an important concept in Selenium, that is the Selenium Grid. Selenium Grid was developed by Patrick Lightbody and initially called it Hosted QA. It was used in a combination with remote control to run tests on remote machines. In fact, with Grid, multiple test scripts can be executed at the same time on multiple machines. Parallel execution is achieved with the help of hub node architecture. One machine will assume the role of hub and the others will be the nodes. Hub controls the test scripts running on various browsers inside various operating systems. Test scripts being executed on different nodes can be written in different programming languages. Grid is still in use and works with both WebDriver and remote control. So we'll be learning about the WebDriver in the next slide. However, maintaining a grid with all required browsers and operating systems is a very huge challenge. For this, there are multiple online platforms that provide an online Selenium grid that lets you access to run your Selenium automation scripts. For example, you can use Lambda Test. It has more than 2000 browser environments over which you can run your tests and truly automate cross-browser testing. Now let's understand what is Selenium WebDriver. Selenium WebDriver is a web-based automation testing framework that can test web pages initiated on various web browsers and various operating systems. In fact, you also have the freedom to write test scripts in different programming languages like Java, Perl, Python, etc. It is important to remember that Mozilla Firefox is Selenium WebDriver's default browser. Now, some benefits of Selenium WebDriver are that they support 7 programming languages, they test on various browsers, and they work on different operating systems. Also, it overcomes limitations of Selenium version 1, like file upload, download, pop-ups, and dialogues barrier. Now, let's move on to the next most important tool, that is Jenkins. Continuous integration is the most important part of DevOps that is used to integrate various DevOps stages. Jenkins is the most popular continuous integration tool. It is an open source automation tool written in Java with plugins built for continuous integration purposes. Jenkins is basically used to build and test your software projects continuously, making it easier for developers to integrate changes to the project and making it easier for users to obtain a fresh build. It also allows you to continuously deliver your software by integrating with a large number of testing and deployment technologies. So basically, with Jenkins, organizations can accelerate the software development process through automation. Jenkins integrates development lifecycle processes of all kinds, including build, document, test, package, stage, deploy, static analysis, and much more. So this tool also achieves continuous integration with the help of plugins. Plugins are extremely important. It allows the integration of various DevOps stages. If you want to integrate a particular tool, you need to install that particular plugin for that tool. For example, Git, Maven to Project, Amazon EC2, HTML Publisher, etc. There are many advantages of Jenkins, and I'd want to discuss each one of them in detail. So the first one is it is an open source tool with a great community support. The second one is it is extremely easy to install. The next one is it has more than 1,000 plugins to ease your work. Now, if a plugin does not exist, you can simply code it and share it with the community. The fourth advantage is it is free of cost. The last one is it is built with Java. Now, if you have been coding for some time now, you must be knowing that Java is portable to all the major platforms. So this gives an added advantage to Jenkins. So what makes Jenkins different from the other continuous integration tools? There are two reasons. The first one is adoption, the second one is plugins. So Jenkins is widespread with more than 147,000 active installations and over 1 million users around the world. The adoption of Jenkins is extremely high. The second one is that Jenkins is interconnected with well over 1,000 plugins that allow it to integrate with most of the development, testing, and deployment tools. So these two features, that is adoption and plugins, make it one of the best continuous integration tools currently available in the market. Now let's move on to the next tool of DevOps tools, that is Puppet. Today, the most mature tool for configuration management is Puppet. But I know you must be wondering why Puppet is so popular and what makes it unique when compared to other configuration management tools. Puppet is a configuration management tool that is used for deploying, configuring, and managing servers. So now let's understand the functions of Puppet. So the first one is it helps in defining distinct configurations for each and every host. And it also continuously checks and confirms whether the required configuration is in place and is not altered on the host. The second function is dynamic scaling up and scaling down of machines. The last one is it provides control over all your configured machines. So a centralized change gets propagated to all automatically. Puppet basically uses a master-slave architecture in which the master and slave communicate through a secure encrypted channel with the help of SSL. Now let's see this architecture in detail. So as you can see the diagram on the screen, the Puppet agent sends the facts to the Puppet master. Facts are basically key value data pair that represent some aspect of the slave state, such as its IP address, uptime, operating system, or whether it's a virtual machine. Puppet Master uses the facts to compile a catalog that defines how the slave should be configured. Catalog is a document that describes the desired state for each resource that Puppet Master manages on a slave. Puppet Slave reports back to the master indicating that the configuration is finally complete, which is visible in the Puppet dashboard. Now with this we come to the last tool of DevOps, Nagios. Nagios monitors your entire IT infrastructure to ensure systems, applications, servers, and business processes are functioning properly. It is an integral to the DevOps lifecycle. So it is basically used for continuously monitoring of systems, applications, servers, and business processes in a DevOps culture. So in the event of a failure, NAG iOS can alert technical staff of the problem, allowing them to begin remediation processes before outages affect business processes, end users, or customers. With this tool, you don't really have to explain why an unseen infrastructure outage affects your organization's bottom line. NAG iOS runs on a server, usually as a daemon or a service. It periodically runs plugins residing on the same server. They contact hosts or servers on your network or on the internet. One can view the status information using the web interface. You can also receive email or SMS notification if something happens. The NAG iOS daemon behaves like a scheduler that runs certain scripts at certain moments. It stores the results of those scripts and will run other scripts if these result changes. NAG iOS also uses plugins. So these are compiled executables or scripts that can be run from a command line to check the status or a host or a service. NAG iOS also uses the results from the plugins to determine the current status of the hosts and services on your network. NAG iOS is built on a server or agents architecture. Usually on a network, a NAG iOS server is running on a host, and plugins interact with local and all the remote hosts that need to be monitored. So these plugins will send information to the scheduler, which displays that in a graphical user interface. With this, we come to the end of DevOps tools. Let's move on to the next part of the session, that is DevOps automation. Automation is the crucial need for DevOps practices, and automating everything is the fundamental principle of DevOps. We discussed this initially in the session. Automation kickstarts from the code generation on the developer's machine until the code is pushed to the code, and after that to monitor the application and system in the production. Automating infrastructure setup and configurations, software deployment is the key highlight of DevOps practice. DevOps practice is dependent on automation to make deliveries over a few hours and make frequent deliveries across platforms. Automation in DevOps boosts speed, consistency, higher accuracy, reliability, and increases the number of deliveries. Automation in DevOps encapsulates everything right from the building, deploying, and monitoring. In large DevOps teams that maintain extensive, massive IT infrastructure, the tools can be classified into 6 categories. That is infrastructure automation, configuration management, deployment automation, performance management, log management, and monitoring. So for infrastructure automation, a great example is the Amazon Web Services. Being a cloud service, you don't really need to be physically present in the data center. They're easy to scale on demand, and there are no upfront hardware costs. It can also be configured to provide more servers based on traffic automatically. For the second one, Chef is a great example. Chef is a handy DevOps tool for achieving speed, scale, and consistency. It can be used to ease out complex tasks and perform configuration management. With the help of this tool, the DevOps team can avoid making changes across 10,000 servers. Rather, they need to make changes in one place, which is automatically reflected in other servers. For deployment automation, Jenkins is a great example. As we have already discussed before, it helps facilitate continuous integration and testing. It integrates project changes more efficiently by quickly finding issues as soon as builds are deployed. For the fourth one, that is performance management, Application Dynamic is a great example. It offers real-time performance monitoring. The data that is collected by this tool helps developers to debug whenever an issue occurs. The fifth one, that is for log management, Splunk is a great example. This DevOps tool solves issues such as storing, aggregating, and analyzing all logs in one place. So for the last one, that is monitoring, NAG iOS is a great example. It notifies people when infrastructure and related services go down. It is a tool for this purpose which helps the DevOps team to find and correct problems immediately.
Let's start out with what's version control. So to understand what is version control system, we need to understand first why we need a version control system. So we'll see why do we exactly need a version control system. So for that, let's take a scenario where there are 3 developers working remotely on a web application or a mobile application. Now, for simplicity's sake, let's just assume that it is a streaming application and one of them is working on a streaming page. Let's call them developer 1. Developer 2 is working on a user information page, and developer 3 is creating the payment portal. Now, all 3 of them are done with their respective pages at 10 o'clock, 11 o'clock, and 12 o'clock, respectively. Now, the thing is, all 3 developers are working in isolation. There may be their own changes, there may be changes in somebody else's page. They're all kind of adding some new files or modifying older files, changing the source code or something like that throughout the course of this project. But how exactly are they going to collaborate considering that they are working remotely? The solution to this is a version control system. With this system, I'll tell you what happens. At 10 o'clock, developer 1 uploads all the files regarding the streaming page. With a version control system, this modification is recorded and updated to one central directory or folder. So every time you're modifying an older file or adding a new file, it creates a snapshot of the latest version or the latest update of the changes that you've made or all the files that you've uploaded. So the snapshot of your update at 10 o'clock is saved, and then when developer 2 adds their user info page, this modification is also saved as a snapshot. Now there are 2 snapshots saved, and finally the payment portal page is added, and this is the last modification done at 12 o'clock, and this is the most recent snapshot saved, along with other snapshots of other updates and modifications done throughout the course of this project. Every change in your project, a snapshot is created and your entire project is saved that way. And these snapshots are actually known as different versions, which are basically the state of your project at a particular time or at the current time. It means that it will contain the kind of files your project is storing at one particular time and what kind of changes you have made so far between the previous version and this particular version. And this is exactly how a version control system works. So version control system basically is a system that records changes to a file or a set of files over time so that you can record specific versions later. These versions are recorded in a repository and they can be recalled anytime from these repositories during the course of your project. So version control systems essentially are of 3 types. Now the local version control system is one of the simplest forms of VCS and has a database that keeps all the changes of the files under revision control. So all the files are saved by this one user and they manage all of the files. But it's actually really hard to maintain the changes of the file, and you can accidentally replace one or the other file that you need. It also needs something known as RCS or revision control system, which keeps patch sets or the differences between updates in a special format on your disk. All of this, your local version control systems maintains all the track of all the files within your local system. As a user, you can track specifically versions later, and it basically works as an independent standalone system for an application. So your applications like spreadsheets and word processors have this control mechanism. So that's one type. Apart from this, you also have your centralized version control system, which basically uses a central server to store all the files and enables team collaboration. So it's not one local system, but multiple systems which work on a single repository to which users can directly access as a central server. So the repository is a central server that could be local or remote, which is directly connected to each of the programmer's workstation. And the third kind of VCS is a distributed version control system. Now these systems do not necessarily rely on a central server to store all the versions of a project file. In a distributed version control system, every contributor has a local copy or a clone of the main repository. So everyone maintains their own local repository, which contains all the files and the metadata present in the main repository. and they can push or commit or update the main repository if and when required. Now we are going to cover more on the latter two version control systems further in the session. So now let's try and understand in depth what's the difference between a centralized version control system and a distributed version control system. As I had mentioned before, in a centralized version control system, each programmer working on a branch, on a project, has absolute access to the central server. So the centralized version control system uses a central server to store all the files, and everybody on the team can directly access the central server as it is one single repository. So if you have 3 workstations, workstation 1, workstation 2, workstation 3, all of them can directly commit to the repository and get updates from the repository, which is your central server. The repository here indicates a server that could be local or remote, directly connected to each programmer's workstation. Every programmer can extract or update their workstations with the data present in the repository, or can make changes or updates or commit in the repository. And every operation is performed directly on this repository. Even though this seems pretty convenient when we are just talking about 3 people, to maintain a single repository like this has some major drawbacks. One of them is that it's not locally available, meaning every change that you have to make, you will have to be connected to a network to perform any action. Also, in any case, the central server getting crashed or corrupted will result in losing the entire data of the project. Also, another small thing which is revertible, but is if one person accidentally makes some unwanted updates, instead of his or her local system, they will be making that changes directly in the central server. So recovering that part back will be again a time-consuming process. This is where distributed version control systems come to the rescue. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In the distributed version control system, each and every contributor has a local copy or a local workstation clone of the main repository. That is, everybody maintains a local repository of their own which contains all the files and metadata present in the main repository. You will understand it better if you take a look at the diagram. As you can see, every programmer maintains a local repository or a local copy on its own, which is actually the copy or clone of the central repository on their local hard drive. They can commit and update their local repository without any interference from one another. And then they can update their local repositories with new data from the central server by an operation called pull. Once they are done with their bit of the code, they can affect the changes of the main repository by an operation called push from their local repository. Now, this system or this act of cloning an entire repository to your workstation and making all the changes on a local repository gives you a couple of advantages over a centralized version control system. First of all the operations except push and pull are very fast because the tool only needs access to the hard drive and not a remote server. Hence, you do not always need to be connected via a network connection, or you always do not need an internet connection. Committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So you complete your set of code on your local system and then you push all the files once and for all into the main repository. Third, since every contributor has a full copy of the project repository, they can share changes with one another on wanting to get some feedback before affecting the changes in the main repository. So this enhances the essence of collaboration amongst a development team. And finally, if the server gets crashed at any point in time, the lost data can be easily recovered from one of the contributors' local repository. And that is why distributed version control system has been picking up popularity over the past decade. So why version control is important? First of all, it helps collaboration. It allows remote development, shared workspace, and real-time updates. All versions of your code are preserved, hence it helps you manage versions of the same code. Easy rollback from current version. Suppose a part of your project has been headed to a wrong direction, you can easily roll back from the current version to the last version which was stable. Now, because you can reverse faulty updates, you can save time and hence it reduces downtime of your project development. And finally, it improves visibility. You can analyze and compare different versions, and that gives you like a 50-foot top view of your entire project, which just accelerates your product delivery. So now that you have a fair sense of what is version control and why do you need version control, let's understand one of the most popular version control systems that exists today, and that is Git. So Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance from developing quality software. So basically what it does is that it lets you and your team of developers work together on the same project remotely from anywhere across the world. Your team members can work efficiently on files and easily merge their changes into one source without the fear of losing or deleting anything of importance due to the easy rollback feature. Git is primarily used to manage your project comprising of a set of code or text files that you may want to change from time to time. Now, Git is an integral part of DevOps. DevOps, as most of you might have the idea of, is the practice of bringing agility to the process of development and operations. A couple of years ago, it was this entirely revolutionary ideology which swept IT organizations worldwide, boosting project life cycles and in turn increasing profits. DevOps promoted communication between development engineers and operations participating together in the entire life cycle, from design through development process to production support. Now, in the entire life cycle of DevOps, starting from planning of the projects to its deployment and monitoring, Git plays a vital role. When it comes to managing the code that collaborators contribute to the shared repository, this code is extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to production. Tools like Git enable communication between the development and operations team. When you are developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators, between the developers while making changes in the project. Commit messages in Git play a very important role in this particular collaboration or communication amongst the team. The bits and pieces that we deploy or update lies in this version control system, such as Git. To succeed in DevOps, you need to have all the communication in version control. Hence, Git plays an extremely vital role in succeeding at DevOps. And due to this very reason, Git has earned way more popularity compared to other version control tools available in the market, such as Apache Subversion, concurrent version systems, and Mercurial. If you compare the interest of Git by time with other version control systems, you shall realize that larger companies' products are generally developed by developers using Git all around the globe. And some famous names out of them are Facebook, Yahoo, Zynga, Quora, Twitter, eBay, Salesforce, Microsoft, and many, many more. Now, lately, all of Microsoft's new development work has been in Git Features. Microsoft migrating .NET and many of its open source projects on GitHub, which are managed by Git. One of such projects is the LightGBM. It's a fast, distributed, high-performance gradient boosting framework based on the decision tree algorithms, which is used for ranking, classification, and many other machine learning tasks. Here, Git plays an important role in managing this distributed version of LightGBM by providing speed and accuracy. So basically, to enable version control, Git is your go-to solution. It's fast and suitable for handling massive code bases scattered across multiple developers, which makes it the most popular tool used today. Now that you know about Git, a terminology we'll be using a lot while talking about Git and GitHub is a repository. Now, repository, or a repo as it's most commonly known as, is a directory or a storage space where your projects can basically live. It can be local to a folder or your computer, or it can be a storage space in another online host such as your GitHub. And in this particular space, in this particular directory, you can keep your code files, text files, images, you name it, all of it inside a repository. Through the course of this, we shall also be talking about something known as GitHub, which is nothing but a central repository, the kind that we spoke about when we discussed centralized versus distributed version control systems. There's a central repository, and that is where all of your code will live. You have your local repository where you'll make the changes, and there you have the central repository to which you will push all of the changes. Yeah? And the central repository is something that all of the developers involved in this particular project, in a certain project, have access to. All right, moving on, let's discuss a few Git features which make it so popular amongst organizations as well as individuals. First of all, it's economical. It's free and open source. Git is released under GPL's General Public Licenses, open source license, so you don't need to purchase Git. It is absolutely free, and since it's open source, you can modify the source code as per your requirement. Second is its speed. Now, since you do not have to connect to any network for performing all of the operations, it completes all the tasks really fast. Performance tests done by Mozilla showed it was an order of magnitude faster than other version control systems. Fetching version history from locally stored repository can be 100 times faster than fetching it from the remote server. So the core part of Git is written in C, which avoids runtime overheads associated with other high-level languages, which makes it extremely fast compared to other version control systems. Next is that Git supports non-linear development. Git supports rapid branching and merging and includes specific tools for visualization and navigation of a non-linear development history. A core assumption in Git is that a change will be merged more often than it's written, as it is passed around various reviewers. Hence, branches in Git are very lightweight and is only a reference to a single commit. With its parental commits, the full branch structure can be constructed. Next, let's talk about the robustness. Nearly every single task in Git is undoable. Git gives each developer a local copy of the entire development history and the changes copied from one repository to another. These changes are imported as additional development branches and can be merged and deleted and recovered the same way as a locally developed branch. Next is the snapshots, which are recorded changes made to a file rather than the file itself. Followed by which you have integrity, which means no changes can be made without Git recording it. Since every contributor has their own local repository, on the events of a system crash, the lost data can be recovered from any of the local repositories. You will always have a backup of all of your files, and none of the changes made to the central repository will go unlogged by Git. Git uses the SHA-1 or the secure hash function to name and identify objects within its repository, and every file, every commit is checksummed and retrieved by its checksum at the time of the checkout. The Git history is stored in such a way that the ID of a particular version, a commit in Git's terms, depends upon the complete development history leading up to that commit. Once it's published, it's not possible to change the old versions without it being recorded. Then it's a distributed system, which means every user has their own copy of the repository and the data is stored locally. Git gives each developer a local copy of the entire development history, and the changes are copied from one such repository to another. These changes are imported as additional development branches and can be merged in the same way as a locally developed branch. And finally, it's easy branching. Now, branch management with Git is very simple. It only takes a few seconds to create, delete, and merge branches. Feature branches provide an isolated environment for each change to your code base. So when a developer wants to start working on something, no matter how big or small, they can create a fresh new branch which is not interfering with the main branch which ensures that the master branch or the main branch always contains production quality code. So any little experimentation that you want to do or little things that you want to try out can always be on a separate feature branch instead of the changes made to your master branch. Because ultimately, your master branch should contain your publishable product. So now that you know the basic features of Git, let's try and understand what the basic workflow of Git is, or how does Git work. So the basic overview of how Git works goes like this. You basically create a repository or a project with a Git hosting tool like Git or Bitbucket. You copy or clone the repository to your own local machine or your working directory. You add a file to your local repository and commit the changes, which basically means you save the changes. Then you push the changes to your master branch. Then you make changes to your file and commit. Then you pull the changes to your local machine. You create a branch or a version, make a change, commit the change, same process, open a pull request, and merge your branch to the master branch. Now this is a little complicated listening to it like this, but once we get on to our demonstration, I think things will be way more clear. You can still take a good look at this diagram, but if you don't get it, don't worry. I will be explaining these operations one by one when we get to the demonstration part of this Git tutorial. Moving on, let's get to the good part, the hands-on section, starting with the installation and setup of Git. Now there are two ways in which this goes. First of all, for Windows users, you need to install Git Bash for Windows. And for Linux users, you'll have to start by updating the package index and then install Git using the terminal. So first of all, for our learners using Windows, you'll have to log on to gitscm.com/downloads and then click on Downloads for Windows button and then run the executable file and follow through till you finally install Git Bash. I'm not going to install it completely as I already have Git Bash downloaded, but I'm still going to open the page to show you guys. All right. So the latest source release is Git 2.30.1 on the 8th of Feb, and you can just click on this button. The moment you click on this button, it's going to start downloading Git for you. And once you have the executable file, all you have to do is open it or run it in your own system, right? Next, for people using Linux, this is an example considering you are using Ubuntu. If you're using CentOS, a lot of the commands don't change, but instead of apt install, you will be using yum install for CentOS. So for that, now I'm going to open my terminal on a virtual machine. So here I have running an Ubuntu machine using the Oracle VirtualBox. So I'm going to start by running an update. All right, this is going to take a while. Kindly be patient. So here I have my Ubuntu running on a virtual machine. So to install Git on your Ubuntu machine, you have to start by updating. So this will take some time. If you're going to use sudo apt update, if you're using CentOS, you will be using yum instead of apt. Let's clear that out, and then we're going to install Git. And then you can look for the Git version. Yeah? All right. Now that we have our Git installed, let's go ahead and look at the operations and commands that we are going to take a look at today. You have your repository setup, which include the commands init, clone, config, and alias. Then you have your save changes operations, which have your add, commit, diff, and stash. All of these commands we are going to go on and off and look at collectively mostly. Then we are going to look at the inspect operations, your inspect repository operations. of which the git status command is something we are also going to look at throughout this demonstration right from the beginning. So apart from that, you have your git log, git tag, and git blame commands. So you have your merge rebase command. So let's move on to our first set of git operations. First of all, you have your git init command, which basically creates a new empty git repository. Now this can be used to convert an existing unversioned project to a git repository or initiate an absolute fresh git repository. Now most other git commands are not available outside of the initialized repository. So this is usually the first command that you will run in a new project. That is, if you're using git bash. So when I run git init, it reinitializes an existing git repository, which I already have here. Now what this does is it reinitialized my existing git repository in this particular directory, in this .git directory. Yeah. What git init does is that it creates an empty git repository or reinitializes an existing one, like it did for me right now. It basically creates a .git directory with subdirectories and template files. And when you run the git init command in an existing repository, it will not overwrite the things that are already there. It will rather pick up the newly added templates. So that's the repository initialized. You can go ahead and create some files in the directory or repository, whatever you call it. Now that is about initialization. Now, what about if there was an existing repository on Git that you had to act upon, that you had to make updates to, that you had to add files to, things like that? That's where you use the git clone utility. Yeah. Now you have the git clone utility, which you use to target an existing repository and create a clone or copy of this particular repository on your local machine. Now this is one of the features provided to you by a distributed version control system, as we had discussed before. So this is a blank file called Edureka rep with just the readme text file. Let me just go ahead and copy this. And then I can just git clone and paste its HTTPS URL. And as you can see, it's cloning this into Edureka rep. And now if I change directory to Edureka rep, you can see the readme file is right there. Yeah. So we're basically going to work off of this particular repository today, Edureka rep. Yeah. So now that we created a clone, moving on, we have the git config command, which basically is a convenience function that is used to set up your git configuration values on your global or local project level. This command is basically used to modify your configuration text file. So if I typed git config global user.email, and here I type, so there I gave in my email ID as the global user email ID. So if I ask for what the global user email ID is, it will return my ID back to me. Yeah. Basically, these configuration levels, like your username and your user ID, correspond to your .git config text files. Now executing this basically will help you modify the configuration text file. Git uses this series of configuration files to determine non-default behavior that you may want. Yeah. So the first place Git looks for these values is in the system-wide configuration file, which contains settings that are applied to every user on this system. So basically, if you pass the option to your git config, it will read and write from this file specifically. And the next place the Git looks is the config/git config file, which is specific to each user. Now you can make Git read or write to this file by passing your global option, which is what I did. And the final command in the setup operations that we are going to look at is an alias. Now, alias, as the name suggests, is basically used to create shorter commands that map to longer commands. They enable more efficient workflows when you obviously have to use lesser keystrokes to execute a command. There are these lengthy commands which obviously kill a lot of your time. So these aliases you can use to shorten those commands. And these are also something that you will create via the git config command. There isn't really a direct way or a direct command of creating aliases. Yeah, this is just something I wanted to add in here along with the git config command. Like a very common alias created is CO for checkout or anything else, CK for checkout. So yeah, this is something that you can do using the git config command, just creating aliases. Moving on, let's look at operations that you use to add changes and save changes to your Git repository. Now, the first two commands here that we're going to look at are git add and git commit. Now, this combination is basically used to create these snapshots that I was talking about initially in the session, right? So basically what you do is first you use the git add command to add a change in your current directory or your working directory. And you add that to the staging area. It tells Git that you want to include a particular set of updates or changes in a particular file in the next commit. Then what you do is you move on to git commit after making the changes to your working tree. Then you use the git commit command, which captures a snapshot of your project's current state. So basically, you use add to update the index using the current content found in your working tree. And then you basically prepare the content in the staging area for the next commit. Then you run the commit command to take that snapshot of your project's current status. Now remember, this is very important and you have to do it each time. You must use the add command to add any new modified files to the index. You can't directly commit anything without adding it to the stage area first. Now what I did was I quickly went ahead and added 3 files to my repository Edureka rep. So if I go into this repository, you can see there are 3 files, Edureka file 1, file 2, file 3. Now let's see if these files are in my index or not using the command git status. Now git status basically displays the state of the working directory and the staging area. It will list all the modified files which are ready to be added to the local repository. It lets you see which changes have been staged and which haven't, which files are being tracked by Git and not. So if I typed git status, you can see on your main branch, you have 3 untracked files, which are the 3 files that I just added, Edureka file 1, 2, and 3. These are not added to the index yet. This means I cannot commit these changes unless I added them explicitly to the index. So now we are going to add these 3 files. This command will update the index using the current content, which is found in your working tree, as you can see in front of you. And then it'll prepare the content in the staging area for the next commit. So either I can just git add and put in the directory name, or I can just use git add with an extension of A, which means all, and this will add all of these files to the index which are in the directory but not updated in the index yet. Yeah, now I've done that. Let me go ahead and use git status again, and you can see all of these file names are written in green, and you can see changes to be committed written here, which means all of these changes are ready to be committed. They are added to the index. Now these files are added to the index. You're ready to commit them. Now, as I had mentioned before, we're going to commit them, and committing refers to recording the snapshots of the repository at any given time. So your committed snapshots will never change unless it's done explicitly. So I'm going to clear this, and we're going to commit this by typing git commit and then adding a tag or a message called committing 3 files. Let's try this out. as you can see. 3 files changed, 3 insertions. You can see our Edureka files 1 to 3 have been committed. The git commit command has committed the changes in the 3 files in your local repository. Now, if you want to commit a snapshot of all of the changes in your working directory at once, you can always go with commit-a. Now, let me add a couple more files to my directory just to show you the difference between your files added to the index versus the ones that are not. If I type ls again, you can see there are 2 more files over here. As you can see, I have 2 other files. I'm just going to add the Edureka file 4 and now the file 5. And then I'm just going to git commit committing files. And as you can see, only one file changed, only one insertion happened. And that only happened because Edureka file 5 is not added to the index. And even if I use the extension A, I cannot add Edureka file 5 because that has not been added to your index. Now, if I just go ahead and add Edureka file 5, voila, the change has occurred in our Git repository. Now, if I typed git status, there are no more files to add or commit. Our branch is ahead of the origin or main branch by 3 commits. And you can use git push to publish your local commits. Now, what is git push? This is something we will cover later in this session. Now, understand that before you affect the changes made to the central repository, you should always pull changes from the central repository to your local repository just to get the most updated version of your branch. You'll get all the work of your collaborators that have been contributing in the central repository. For that, you use the pull command. Now, as you can see, there's nothing to commit and your working tree is clean. There are other commands like the git status command, which you could use for similar purposes. For example, you have the git log command, which only operates on committed history. It basically will display to you the committed snapshots and will let you list the project history, filter it, and search for specific changes. So if you typed git log, it's going to show you all the commits that have happened since we started with this git file. Okay, so you can see at the bottom, your original main, there's your initial commit, right? Then our first commit where we committed 3 files, then we committed the 4th file, and finally when we committed file number 5, right? These are all the commits, including the initial commit, the first one. Yeah, along with the author and the date and time. Remember when I told you about everything is recorded when you're using Git? This is what I meant. You can always access who made commits at what time and what commits were made when you use a version control system such as Git. Now, at a point like this, I think it's crucial to mention one more command, which is the git tag, and it's used to basically capture a tag in history or a point in history that is used for a marked version release, right? So it's basically like a branch that doesn't change, and after being created, they have no further history of commits. Yeah, so that is one. And another one is git blame. Now, the git blame function displays of the author's metadata attached to a specific committed line in a file. It's used to examine specific points in a file's history and get context as to who the last author was that modified that line. So if I went back and typed git blame Edureka file 5.txt, it's going to show who the person is that is to blame who committed this particular file or made this particular change, right? It'll also, if you paid attention, give you the commit number As you can see, this E9D63EFO commit number. This also has this E9D63EFO, which is the first few characters of this particular commit number. Yeah. So now that you know how to check the status of the changes and see who made the changes, it's time that you understand how you fetch changes from your remote repository to a local repository, and how you push commits from your local repository to your remote repository. So here we are going to look at two commands called pull and push. Now, first of all, you have the git pull command, which fetches changes from your remote repository to a local repository. Basically, it merges upstream changes in your local repository, which is a common task in Git-based collaborations. But at first, you need to set your central repository as the origin using the command git remote add origin, and I'm going to add the link to my central repository, which is this. And as it says, the remote origin already exists. Now that your origin is set, and now we're going to pull our main branch. So I'm just going to type git pull origin main, and it says we are already up to date. Now, certain number of tutorials or documents that you might be following might even give you the command git pull origin master, in which case you're working on the master branch. Now, to know which branch you're at, you can just use the command git branch vv. Yeah, I'll tell you which branch are you working on. Yeah. So yeah, we are working on the main branch, and we are already up to date with the branch, since my local repository was already updated with files from the main branch. This is the message of an up-to-date branch. Now you can also use git pull origin and your whatever branch name. Here I'm using main. That's a mistake on my part. Maybe I was trying to clear the screen. All right. So here, even if I pull from the branch using git pull origin and the branch name to my local Git repository, you can see it's already up to date. So now my local Git repository is now all updated with the recent changes. So now it's time to make the changes to your central repository by using the push command. So we're going to use the push command. This command transfers commits from your local repository to your remote repository, and it is basically the opposite of your pull operations. Pulling will import commits to your local repositories, whereas pushing will export commits to your remote repositories. It's going to ask you for your username. And password before it lets you push into your main branch there. So I've put in the username and password for my GitHub account. And with that, this has pushed the changes from my local repository to the remote repository, along with all the necessary commits and internal objects. Now this has created a local branch in your destination repository. The use of git push is to publish your local changes to a central repository. After you've accumulated several local commits and are ready to share them with the rest of the team, you can then push them to your central repository by using the git push command. Now the files which have already been committed previously in the commit section and they were all push ready, you will use git push origin master to reflect these files in the master branch of your repository. All right. So let's go ahead to our repository and see if changes have been made. And yes, you can see all of our files on our GitHub repository. You have Edureka file 1, 2, 3, 4, and 5. All the 5 files that we had created on our local repository. Yeah, you have all these 5 files and the README file here. Here also you have the README file and all the 5 files that we had created. Now at this point in this Git tutorial, I hope you have understood the basic commands of Git. You have pulling, pushing, adding, committing, things like that. Now let's take a step further and understand the 3 basic commands of parallel development. Here I'm going to be talking about branching, merging, and rebasing. So first of all, let's talk about merging. Now, merging is a way to combine the work of different branches together. This will basically allow you to branch off, develop a new feature, and then combine it back in. As you can see in the diagram, it shows you two basically different branches, new branch and master. Now, when we merge the work of the new branch into the master, it creates a new commit, which contains all the work of the master and new branch. Now, if we merge the two branches with the merge command, as I had mentioned before, Git allows you for easy branching, which means you have parallel branches with your master branch that help you carry on your individual work while not interrupting your main product, which is your master branch or your main branch. So branches in Git are nothing but pointers to specific commits. Yeah. So Git generally prefers to keep its branches as lightweight as possible. Now there are basically two kinds of branches via local and remote tracking branches. A local branch is just not the path of your working tree. On the other hand, the remote tracking branches have special purposes. Some of them are linking your work from your local repository to your central repository and automatically detecting which remote branches to get changes from when you do a Git pull. So you can check what your local branch is by using Git branch. So you know you are at your main branch. And the one thing you should understand, one thing is like a main mantra of people who use Git are branch early and branch often. Yes. So to create a new branch, you're going to use a command git branch and your branch name. And in this case, I'm just going to use a branch name Edureka images. All right. And here you can see this diagram shows the workflow of a new branch that is created when we create a new branch. It originates from the master branch itself. So since there's no storage or memory overhead with making many branches, it's usually easier to logically divide your work up than having big chunky branches. Hence, the branch often part. Now let's see how to commit using branches. Now branching includes the work of a particular commit along with all parent commits, right? So as you see, the new branch has detached itself from the master or the main branch, and hence it'll create a different path. So we are going to check out the branch name, which in our case is Edureka images. And then we are going to git commit. So you have untracked files, Edureka images, and nothing added. So you made that branch. Now, merging is a way to combine the work of different branches together. So basically what this does is, now that we've branched off to something known as Edureka images, you can go ahead, add files to it, develop a new feature, and then combine it back into your main branch. Here you can see two different branches. You have your new branch and your main branch. And when we merge the work of a new branch into the main branch, it creates a new commit, which contains all the work of the main branch and the new branch. So now if we merge this branch, as you can see, it's already up to date. It's important to know that the branch name here should be the branch that you want to merge into the branch that you're currently checking out. So make sure that you are checked out of this destination branch. So let's just merge all the work of the branch Edureka images into your main branch. For that, I will first check out my main branch and then merge Edureka images with git merge Edureka images. And as you can see, all the data from the branch Edureka images has merged into the main branch. Now notice that merging in Git creates a special commit that has two unique parents. Now this is one way of merging into the main branch. There's also another way of combining the work between two branches, which is called rebasing. Now rebasing takes a set of commits, copies them, and stores them outside your repository. The advantage of rebasing is that it can also be used to make linear sequence commits. The commit log or the history of the repository stays clean if rebasing is done. Now our work from the new branch is placed right after master, and we have this nice linear sequence of commits. This command doesn't copy but moves all our work from the current branch to the master or the main branch. They look like they've been developed sequentially instead of having developed parallelly. So if I just did another branch called Git branch Edureka images 2, and then maybe Git checkout, okay, then we Git commit this, and then I could just Git rebase main, and your current branch will be up to date. This command basically moves all of your work from your current branch to your master branch, and it'll basically look like it has been developed sequentially instead of having developed parallelly. Now, apart from these, there are certain operations that you ought to know. Firstly, archiving your repository. You can use this command. It stores all of your files and data in a zip file rather than a .git directory. This creates only a single snapshot, omitting version control completely though. This comes in handy when you want to send these files to a client for review who doesn't have Git installed in their computers. Apart from this, you can also bundle your repository, which basically turns your entire repository into a single file. This pushes the master branch or the main branch to a remote branch, only contained in a file instead of a repository. You could alternately change the repository, clone the repo bundle, create a copy, and use git log, but that is like 5 commands instead of 1. Why not just use 1 command? And finally, stashing uncommitted changes. When you want to undo adding a feature or any kind of added data temporarily, we can always stash them temporarily. You can use git status, stash status, and then you want to reapply the changes you stashed using git stash apply. Having said that, let's move on to another very important topic in this Git tutorial. Let's go through a brief introduction to SSH. Now, what is SSH? What is an SSH key? Now, an SSH key is an access credential for Secure Shell Network Protocol. It's basically an authenticated and encrypted secure network protocol and is used for remote communications between machines on an unsecured open network, for remote file transfer, network management, and remote operating system access. So basically, it's typically used to log into a remote machine and execute commands in it. But this also supports tunneling, forwarding TCP ports, and X11 conditions. It can transfer files using associated SSH file transfer or secure copy protocols. It provides you several alternative options for strong authentication and protects the communication security and integrity with very strong encryption. It's a secure alternative to the non-protected login protocols and insecure file transfer methods such as FTP. So basically, how do you create SSH keys? You start by using the command ssh-keygen, and then you'll be prompted to enter a file in which to save the key. So home, Edureka. Then we're going to enter a passphrase. I'm just going to leave it empty again. And you can see our identification has been saved in the file that we specified. And we have something known as a key fingerprint. And finally, what we have to do is add the new SSH key to the SSH agent. And then you will see identity added. And that's it. You have created an SSH key.
The need for GitHub. It is extremely important for software developers to work on a web-based platform to share their projects and collaborate with other developers. This platform must be a version control system, that is, it must enable multiple people to simultaneously work on a single project. Each person edits his or her own copy of the files and chooses when to share those changes with the rest of the team. This application must also be capable of hosting millions of programmers and hobbyists that download and evaluate each other's work. GitHub is one such platform of choice for developers that can host multiple programmers and review their code. GitHub has several competitors. For instance, GitLab. GitLab is an open source web interface and source control platform based on Git, whereas Microsoft Team Foundation Server is an enterprise-grade server for teams to share code, track work, and ship software for any language, all in a single package. Bitbucket, on the other hand, stores all of your Git and Mercurial source code in one place, with unlimited private repositories. So what really makes GitHub so powerful and popular among developers? GitHub is an open source platform, and the community is really what fuels it. Moreover, GitHub is the platform of choice for developers from various large corporations too. Microsoft is the number one contributor to the system, but there are also Google, SAP, Airbnb, IBM, PayPal, and many others. Exposure and insight that you can get on GitHub are simply unmatched by any other platform. Here you can discover code written by others, learn from it, and even use it for your own projects. Versions control on GitHub works very much like Microsoft Office or Google Drive. It simply tracks all the changes made to your code and who makes them. You can always review the detailed change log that neatly hosts all of the relevant information. Using GitHub eliminates the need for complex corporate security solution because everything is on cloud. The platform protects code branches, verifies commit signing, and controls access. Now that we know why we need GitHub, let us understand what is GitHub. GitHub is a Git repository hosting service that provides a web-based graphical interface with many features. A repository is usually used to organize a single project. Repositories can contain folders, files, images, videos, spreadsheets, anything your project needs. Let's say, for example, a team wants to work on a particular project. Here they can simultaneously write and update their code to a central repository which is present on GitHub. So GitHub is a highly used software that is typically used for version control. It is helpful when more than just say one person is working on a project. For example, a software development team wants to build a website and everyone has to update their codes simultaneously while working on this project. In this case, GitHub helps them to build a centralized repository where everyone can upload, edit, and manage the code files. Most software projects have a bug tracker of some kind. GitHub's tracker is called Issues and has its very own section in every repository. Issues basically are a great way to keep track of tasks, enhancements, and bugs for your project. Moving on, people often get confused between the terms Git and GitHub. Now let me clearly explain the difference between them. Git is simply a version control system that lets you manage and track changes within your project, whereas GitHub is a cloud-based service that lets you manage Git repositories. So basically, Git is the tool and GitHub is the service. Now that we know the difference between Git and GitHub, let us move on and understand how these two work hand in hand. We already know that Git is a version control tool that will allow you to perform all kinds of operations to fetch data from the central server or push data to it, whereas GitHub is a code hosting platform for version control collaboration. GitHub is basically a company that allows you to host a central repository in a remote server. Now, without any further ado, let's get started with the demonstration on how to use GitHub. So for this demonstration, we're working on the website version of GitHub. There's another version of GitHub that is the desktop version, which you can download it to your personal computer. So we're simply going to search for GitHub in our search engine. The first link will lead you to the official website of GitHub. So I'm going to click on that. So this will redirect me to the main homepage of GitHub. As you can see, there is a search GitHub option. There are also two buttons that says sign in and sign up. If you're new to GitHub, you can simply enter in your credentials, that is a username, email, password, and sign up for GitHub. But if you already have an account like I do, I'm simply going to click on the sign in button and it'll redirect me to a page where I have to enter the credentials, that is my email address and password. I'm going to do that now and I'm going to click on the sign in button. Now, this is the main page of my account. As you can see, I have no repositories. It's all new, it's all fresh. But if you're not new to GitHub, you can view all of your repositories on the left-hand corner. Now, before we move on, I'm going to explain you all the features that are present within GitHub. So you can see a search bar here. So the search bar will allow you to look for profiles, certain keywords, look for different kinds of projects that are available on GitHub. All of those can be done using this bar here. And you can see 4 options next to the bar that says pull requests, issues, marketplace, explore. Pull requests we'll learn later on in this session, but the issues and marketplace we won't be discussing in this video for now. The explore button, on the other hand, is an extremely important and interesting button. So once I click on that, it'll redirect me to a page with some activities that are going on around in GitHub. You can see here they're trending repositories, they're trending developers. Basically, this is a feed that will allow you to interact with developers and other people, collaborators from all around the world, basically. In Instagram too, you have an explore button which will allow you to interact with different people from all around the world. So the same concept is implied in the GitHub explore button too. So you can explore topics, you can explore trending repositories, developers. Basically, it's an interaction with other people from different parts of the world. So I hope that's clear. Now, the most important part of the session are the 3 buttons that are available in the right-hand corner of the navigation bar. So you can see there's a bell icon, there's a plus icon, there's a pixelated icon on the right-hand corner. So the bell icon allows you to read notifications of your activities that occur in GitHub. So that's what it really is. You can see the inbox will allow you to view all of the notifications. You can also view the unread notifications by clicking on this unread button. As of now, I don't have any notifications, so there's nothing available. You can also group these notifications by the date or repository by clicking on this group by button here. You can also view your saved notifications by clicking on here. And the done button, on the other hand, will let you mark all of your notifications that you're done with, your previous notifications. So these are the 3 important buttons you'll have to know in this bell icon. And the filters are not necessary as of now, so I'm not going to discuss that. This button, on the other hand, will allow you to manage your notification settings and your subscriptions too. So that's all for this bell icon. The next important button is this plus icon. As you can see, there are 5 drop-down options that appear here. The first one being new repository, followed by import repository, new gist, new organization, new project. So new repository we've already discussed previously in this session. A repository is a place where you create your files for your project. It's basically a storage space, right? So your repository can directly interact with your Git, right? So the new repository option will allow you to make files, a repository, to your GitHub account, right? The Git, on the other hand, the tool that which we use to make local repositories in our personal computer, can be directly pushed on. The local repositories can directly be pushed onto your GitHub account. So that's what the new repository button allows you to do so. But the new project, on the other hand, is a place to track issues, features, and other tasks that are related to the code within the repository. You can also connect with the DevOps build and deploy process, assign people to tasks, and so on by using this button. That is the new project button. So the difference between the new repository button and the new project button is that projects in GitHub are only a part of GitHub, but not Git. But the new repository option is a part of GitHub and Git. So that's the main difference between new repository and new project. I hope that's clear. So the next button will drop me down some interactions that I can make with my profile. So if I click on this your profile option, it will redirect me to a page where I can edit my profile. I can really create my identity using this page. So here, if I click the edit profile, I can add a bio about myself. I can add the company in which I'm working in, the location at where I am, the website, Twitter username, etc. All of that I can add here, all of the information about myself. I can also view the repositories I'm working on currently, or the repositories I've worked in the past, projects that I'm working on, the packages, and the entire contributions I've been making on GitHub from the last year. So basically, it allows me to build an identity, or it'll help me build my profile on GitHub. So I hope that's clear. Now, if I click on this button and if I want to sign out from a profile, I can simply scroll down and click on the sign out button here. and this will sign me out of my account. So that's all for getting started with GitHub. These are the basics on what GitHub is and what each of the button and options really do. Now, if I want to move back to the main page of my GitHub profile, I can simply click on this Octocat. That's GitHub's logo. So I'm just going to click on this Octocat logo, and here I'm back to my main page. Now, before we move on and work on the different operations and options within GitHub and learn different things about GitHub, I'm going to give you a brief overview on how to download the desktop version of GitHub. So I'm simply going to search for GitHub Desktop on my search engine, and I'm going to click on the first link that's available on this page. Now I can simply click on this button that says download for Windows 64-bit. That's compatible to my current version of my personal computer. If you have a Mac, you can simply click on the Mac version and download it to your desktop. But as I've already mentioned previously that we're going to work on the website version, so I'm going to simply switch back to this. Now let's quickly move on to the next part of the session. Create a repository. So firstly, let us understand what a repository is. It is simply a storage space for the correct project that you're working on. GitHub is a very popular central repository that allows you to share your files, whereas Git allows you to create local repositories that are present on the system you are working on. So you can basically push your local repository into GitHub and share it with other collaborators via the central one. Now that we know what a repository is and how it works, let's go on to the demonstration part and create our first repository. So you can do this in two ways. Either you can click on your create repository button that is present on the left side, or you can, as I've already mentioned in the previous part of the session, you can click on to this plus icon and you can click on the new repository option. So this will redirect you to a page that says create a new repository. You can add your repository name. I'm going to name my repository as Edureka, and it's available. All of your repository names must be unique from one another to identify them easily. You can also add a description, which is optional. I'm just going to add the description. This is my first repository. And a description allows people or other collaborators to understand what your repository is all about. But as a good developer or a good programmer, you would definitely want to add a description and give an overview of what your repository is all about. There are two options now available that says private or public. Now you can choose your repository to either be public or private. So the private one lets you decide who can access your profile, whereas the public one lets anyone view and access your repository, but you can choose who can commit to it. That's the difference between public and private repository. I'm going to let my repository be public as of now. Now, if you scroll down, you can see that you can initialize your repository with three options. The first one being add a README file. The second one being add a git ignore file. You can always choose add a README text file to your project, which often contains information about the project and other necessary details the user must be aware of when he or she is accessing that particular project. Now, I want a README file for my repository, so I'm going to click on this button here. That's going to check it. The next option is add a .git ignore file. So this file will let you ignore a list of files when the user is pushing files to GitHub. That's what this option really does, but I'm going to let this be unchecked for now. For your repository to truly be open source, you will need to license it, so others are free to use, change, and distribute the software. You can simply click on choose a license option and pick the required license for your project. There are several licenses like MIT, GPL, Apache License 2.0, BSD, etc. But for this repository, we don't really need a license, so I'm going to untick this too. And now you can see there's a piece of information that says this will set master as the default branch, but I'm going to ignore this for now. I'm going to explain about branches later on in this session. So this is all you have to do to create your first new repository. You add a name, you choose a description, you add an optional description, you let your repository be either public or private, and you initialize your repository with either of these three options. And I'm simply going to click on my create repository option. Now this will redirect me to a page with all the information and the files that are currently present in my repository. You can see here my repository name is present here with the optional description that I gave, and the number of files. Currently we have only just one file, that's the README text file, and that's present here. So this is all we have. Congratulations, you just created your first repository. Now you can see there are some options that says issues, pull requests, actions, projects, wiki, security, etc. We don't have to really talk about all of these right now. We will just learn about one option that says code here. So this is really important. If you click on this button, you can see that there's a link that is available here, an HTTPS link. So if you copy this link and paste it on your Git terminal that's present on your computer, you can download this entire project directly to your local system. So that's what the link is for. I hope that's clear. And the next option that says open with GitHub Desktop will allow you to open this entire repository in your GitHub Desktop version. And you can also, the last option that says download zip will allow you to download this entire repository in the form of zip files. So all of your project files will be within that zip file. So that's all you have to really know about your repository. And I'm going to click on the README text file that's available. It will take me to another page with some extra information about that file. You can see currently we have 2 lines and the memory space that is allocated to this file. So we currently have 2 lines, that is Edureka, and this is my first repository. And you can also see the number of contributors to this project. That is just one, that's just me for now. And you can view the history of the commits or the changes that have been performed in your file. So we'll come back to that part later on this session, but you can move back to your main page of this repository by clicking on the name button here. So Edureka is the name of my repository, so I'm going to click on that. So now I'm back to the main page of my repository. Before we learn how to create our first branch, let us understand what branches are. Branches allow you to work on other features that can be included and merged with the master branch if required. So what is the master branch? The master branch is the main branch where your project resides on. So all of the changes, all of the activities that you do with your main project lies or is on your default branch that is named as the master branch. So what really GitHub allows you to do is it allows you to create additional branches. So on these additional branches, you can work on the other features or you can experiment with your project. And if you're happy with this, you can simply merge these features to your main branch, that is your master branch. This is what branches are really for. So they simply allow you to work on other features. That's what branches are. So let's move on to the demonstration part and look at how we can create our own branches. So now if you look on the left corner, you can see a button that says master. So currently we're on the master branch, and there's only one branch, and the master branch, as I've already mentioned, is the default branch. So when you create a repository, you're automatically creating a master branch. So this is where your project will be residing on. And now if you want to create another branch, say let's name this branch 1 branch. So this is what I want to name my additional branch. I'm simply going to name it and I'm going to click on the enter button. So it will redirect me to a page. So this is the exact replica of your master branch. And you can work on this branch. You can work on any other feature, or you can add something, you can remove something, you can really experiment on this branch. And if you're happy with this, you can merge back this feature or the experimentation that you've been working on to your master branch, right? So you can see there's a README text file. It's exactly the same. There's the name of your repository, the description of the repository. You can click on the README text file and everything's the absolute same. You can quickly switch back to the main page. But the only difference is that you're currently on a branch named branch 1 branch. You're not on your master branch. Now, if you want to switch back to your master branch and work on it, you can click on this button and you'll find the master here. You can click on that and it will take you back to your master branch. Here you can work on your project. So there are currently 2 branches. You can see that, and everything's normal. Everything looks simple. That's all for branches. It's really easy. I hope it's clear. So you can look for branches here on this bar here that's present here. You can also create new ones in the same option. So that's all for branches. Let's move on to the next part of the session. Make a commit. Now, what are commits? Commits simply record changes to one or more files in your branches. So basically, they save the changes that you're making in your project. Git always assigns each commit a unique identification, which is called SHA or hash, that identifies the specific changes. So for any changes are made to your project files, you can simply go back and look at the version history or the history of each commit you've performed on your project files. So that's what really commits are all about. It's extremely easy. Let's go ahead and make our first commit. Now I'm going to switch to my branch 1 branch and I'm going to make my first commit. I'm going to click on my README text file. That's the only file currently in our repository. So we'll make the change in the README text file. There are 3 really important icons that are present in the right corner, as you can see. The first one is a PC icon that says open this file in GitHub desktop. So if you click on this file, this entire file will open in your GitHub desktop version. The next one, that is the pencil icon, will allow me to edit this particular file. That is my README text file. And the third icon is a bin icon, which will allow me to delete this file. Now, what we'll be working on is the pencil icon. That's the edit this file option. I'm going to click on this and I can simply view a space or a file that will allow me to make changes to my README text file. I'm going to add another line here that says this is my first commit. This is what I want to add to my README text file. And if I want to preview the changes, I'm going to click on this preview changes button. You can see that this is my first repository. This is my first commit. This is my first commit is the additional piece of information that we'll be adding to my README text file. And it's highlighted in blue, so we know that that's the additional information. I'm happy with this change. I'm going to switch back to my edit file. I'm going to scroll down. And if I want to add a description about the change that I'm performing to my file, I can do that. A good programmer would always add a description to the change that he's making to the project file. So other collaborators, when they view the commit or they view the change, they can read the extended description and understand what the change is about. So that's a good habit that you must follow. But as of now, we're not going to do that. So I'm going to leave this blank. As you can see, there are 2 radio buttons that are currently available. The first one says commit directly to the branch 1 branch. This will allow me to make the change or save or make the commit directly to my branch 1 branch only. So the change that I'm making currently is only implemented to my branch 1 branch. The second option allows me to create a new branch for this particular commit and start a pull request. We're not going to talk much about this option right now, but the first option is extremely important. So we'll let this be stuck on to the option that says commit directly to the branch 1 branch. And I'm going to click on the commit changes options. And this will simply implement the entire change to the file. You can see that the change is implemented. The additional piece of line that says this is my first commit is added to my README text file. Now, the interesting part is if I switch to my master branch, the change is not implemented in my master branch. So the change is only currently present in my branch 1 branch. And now if I want to view the history of the changes that I've made, I've already mentioned in the previous part of the session that the history button will allow me to do so. So I'm going to click on this history button and you can see that I made my first commit 23 minutes ago and I made my new commit 41 seconds ago. And there is also a hash number, unique hash identification number that allows me to distinguish between both of these changes. So all of my commits that I'll be making on this branch will be available here. So that's the main point of a version control system, isn't it? Understanding and keeping a record of all the changes that we're performing in our files and our projects. So this gives full justice to the word version control. So that is what GitHub is all about. Now that we learned how to make our first commit, let's move on to the next part of the session. Open and merge pull requests. So what are pull requests? Pull requests let you tell other developers about changes you've pushed to branch in a repository on GitHub. So once a pull request is open, you can acknowledge and review the changes with collaborators and add follow-up commits after which your changes are merged into the base branch. So there are 2 ways to create a pull request. The first one being pull request from a forked repository and the second one being pull request from a branch within a repository. Currently in this demo, we will work on the second one, that is pull request from a branch within a repository. Now I'm simply going to switch to my demo part. Okay, now currently I'm on my master branch. I'm going to click on this pull request option that's here. Now it says branch 1 has had recent pushes 3 minutes ago, compare and pull request. I'm not going to click on that. I'm going to simply click on the new pull request option here. So this will allow me to compare the changes. There's a base branch and a compare branch. The base branch is the master branch and the compare branch, I will compare my master branch to my branch 1 branch. So this notification says that the merge between the branch, one branch, and master branch is definitely possible. So it's a green signal. So if I scroll down, I can view the difference between both the branches. So the left-hand side indicates the information that is present on the master branch, and the right hand indicates the information that is present in my branch one branch. Plus sign indicates the additional information that is present in my branch one branch. I'm happy with this. So I'm simply going to scroll up and create the pull request. I'm going to click on that. I can also leave a comment and I can preview the change. That's not necessary for now. So I'm going to go ahead and create the pull request. Now this will redirect me to a page. So this page says that the pull request has been opened. And now I can choose to merge this pull request. That is, I can merge the branch one branch to my master branch. So it says this branch has no conflicts with the base branch. Merging can be performed automatically. And that's good news, right? So I'm going to click on merge pull request and I'm going to confirm my merge, update my readme text file. I'm happy with that. So I'm just going to confirm it. Now it says pull request successfully merged and closed. You're all set. The branch one branch can be safely deleted. I'm not going to delete the branch. I'm going to compare both of the branches and see if my master branch is exactly the same as my branch one branch. So I'm going to click on this Edureka. I'm going to go to my main page of my repository. So my master branch has the additional piece of information that says this is my first commit. Now, if I switch to my branch one branch, it has the exact piece of information. So the information that was present in my branch one branch has been successfully implemented to my master branch. So that's all for the pull request part 2. We've reached the end of the demonstration part. Now let's quickly look at the case study of how Microsoft implemented GitHub. I'm pretty sure most of you have heard of Microsoft. Microsoft Corporation is an American multinational technology company. It develops, manufactures, licenses, supports, and sells different computer software, consumer electronics, personal computers, and other related services. So initially, Microsoft was against the use of the open source because they held very tightly to the internet protocol. They were completely hesitant to adapt to this new concept of sharing code to the entire world. But in 2010, they rethought this entire scenario, and now Microsoft is one of the biggest contributors to open source. Today, about 2,000 to 25,000 Microsoft engineers maintain TypeScript, .NET, Windows Terminal, DARP, Helm, and more than 1,000 other open source projects. So first what they did was they released new processes in measured containment. But later on, they released only licensed software. So here, developers can learn from the company's source code, but they couldn't really build on it. Eventually, the stigma died, and now even closed code like .NET is open source under an MIT license. Teams realize that they need to accept contributions to get feedback and learn from other developers. To organize and understand this approach, Microsoft created their Open Source Programs Office, which enables distribution and centralization of knowledge. So the OSPO provides the resources and maintainers to manage thousands of repositories and contributors effectively on GitHub. Even though Microsoft invests in its tools, they expect other individuals and organizations to lead the way. Microsoft believes that GitHub's value isn't in any one feature, but its entire community. GitHub is the place to collaborate, it's where everyone is, and where most of the entire world's open source is already happening. It's not just a feature, but the whole thing.
So guys, let's first talk about why we need continuous integration. Let's talk about a scenario where we are not using continuous integration. Now, when we work in a development team, there are multiple developers. Now, all the developers work on different components for a project or for a code. A developer A may be writing code thinking scenario, let's say Python 1.0, and developer B will be writing code thinking of a scenario 1.2, 1.3, and so on. One of the biggest challenges that we face in an industry is how to make sure that all the developers' codes get collaborated and that we are having properly release getting deployed. That is the biggest challenge in the industry. Now, another challenge that most developers fail is debugging. Now, whenever you write a code, there are a lot of bugs and issues. Now, the code is often written thousands and thousands of lines. Now, if you don't have any proper continuous integration mechanism or a packaging mechanism, you'll see it takes days, even weeks and months to debug your code to make it 100% bug-free. Now that is a challenge that really makes the development process very slow. So how to test the code? Now testing used to be a monotonous task. Now there are teams used to spend months of a life cycle to make the code, complete the test code, and make sure it's bug free. Now what used to happen is, guys, two things. One is you are not able to deliver on time, and secondly, business never see value coming out of the IT. If businesses see IT not adding value, IT is not delivering product on time, they will start rethinking and giving a second thought. Why do we need to invest so much money in the IT industry or in the IT software? These things were hampering big time in the development and release of modern day deployment software cycles. In the modern day world, we want to make sure our deployment cycles are robust, we're able to get the main need of the market and deploy the product as soon as possible. But with this approach, we're not using the CI tools. It used to take 6 months to develop a product, deploy a product, and make it bug free. Now things change drastically when we start using continuous integration. Now, using continuous integration, we can deploy codes at the quickest. Amazon, for instance, deploys code every 11.6 seconds. Now, how is that possible if you ask? It's because they are using the continuous integration mechanism. Using CI tools like Jenkins, where we can automate the process like building, packaging, deployment, testing, and so on, so that we can do all these things with the click of a button in a matter of seconds. CI process helps us to deploy multiple releases parallelly. Now, in one day, we can do thousands and thousands of releases without impacting our environment and making sure these releases are in line with our requirement. The CI tool has an awesome notification mechanism where it notifies instantly of any success or failures happening, so that if I have to debug the code or troubleshoot it, I will know exactly at the pinpoint location where it is failing. You can do multiple notification management mechanism like an email and SMS, any ITSM tools. Now all those modern ways of notification are possible using the CI tools like Jenkins. Now we integrate these CI tools like Jenkins with modern day build and packaging tools like Maven and Gradle, so that we can automate the common problem which developers spend most of their time on. Now, developers spend half of their life cycle like packaging their code, code review, code deployment, unit testing. Now, all those things can be automated and can be done with the click of a button using these CI tools. Now, what is continuous integration? Now, we have talked about how it helps to save time, how it helps to save the energy, and how it helps to make release more frequent, and it helps us to streamline the process. Now, what actually is continuous integration? Now, if I go traditionally, continuous integration is basically, you can say, a process that helps us to combine or make smoothen the automation of tasks like compiling the code, doing the testing, and deploying the code into our life cycles. So how does this continuous integration work? So developers who works on projects generally commit their code in any version tools like GitHub, GitLab, Gitbucket, SVN, etc. So using continuous integration, we pull the code from the version control system like Git, for example. Now we automate the process like code compiling, code testing, code review, and then finally deploy the code in the lowest lifecycle environment. You can say continuous integration is sort of a development practice where developers pull the code from the version control system and make the code deploy in the lower lifecycle environment. Now, the beauty of using these CI tool is we can automate the process in such a way that whenever developers make a new commit or a new change in the version control system tools, we can create a sort of a pipeline, and the pipeline automatically picks the code from the VCS tools and compile it and then deploy the software. Another good thing about it is it does not require any human intervention. So once I have set up a pipeline, then I don't need to worry about running the code again and again or making any changes. It automatically happens in a fully automated process, as I mentioned a while back. Now we can use the process whenever a new commit happens, or you can run it on a scheduled basis or something. Now CI, or continuous integration, was first time proposed in 1991 as part of the Extreme Program concept. At that time, it was not adopted so well, but in the modern day industry, it has become the bread and butter of smoothing up release or for our development process. In a modern day world, continuous integration can be seen as a practice of merging all developers, working copy to a mainstream where you can develop and deploy the code multiple times in the same day with as many changes as possible. Now, there is no limit of how many lines of code. It can be tens and thousands of lines of code, which can be compiled multiple times throughout the duration. Let's see a case study where we try to see how things change for an organization after it adopted to the CI, or continuous integration mode. Here we have picked up an example of Adobe to see how it helped in the development process. Adobe realized at some point at the time that they have not released very frequently. When this happened, their market percentage share was down as they were not following the continuous integration approach. Now, they were using the native method of compiling the code, debugging the code, testing the code, because of which they were noticing that it used to take up to 6 months release updates. Now, 6 months was a long duration, whereas their competitors were releasing very frequently, which was helping them to capture the market share. Adobe decided some point at a time that they need to change their software development and deployment strategies, and they tried to adopt the continuous integration mechanism. Once they adopted the continuous integration mechanism, they found that the response time was a lot better and a lot faster. Now, they were able to deploy the updates more frequently with every time a change was made by a developer or new release was being released. And it helped them reduce the response times, and they were 60% more faster. The development teams were getting more effective, and they were able to really deploy losses far more in a better and structured way than what they were doing without using CI. You can see how CI helps industry. Amazon is the best case scenario. Amazon in modern day scenario deploy codes every 11.6 seconds, almost 5 times every minute. Now, this is all possible using the continuous integration. Now, what is Jenkins? Now, we've talked about what is CI, we've talked about why we need CI. Now, let's talk about what is Jenkins and how does Jenkins fit in this particular picture. Now, Jenkins is an open source automation server which helps us to automate the process of development relating to testing, deployment packaging, and others. It is a server-based system that run on software, Apache Tomcat. Now, it supports VCS store like Git, Bitbucket, etc. It also supports build automation tools like Apache, Maven, and it helps to make and facilitate our continuous integration and continuous delivery process. Now, Jenkins was first released in the year 2011, and it's completely open source software as a part of the MIT license. Jenkins is a plugin based profile. In Jenkins, you have got plugin, which basically used to interact with different tools and components. In Jenkins, plugins are primarily released in language other than Java. Plugins are available to integrate Jenkins with most version control system tools and most databases. Using these plugins, we set up purposes, for example, unit testing. Now you can do compiling, you can do packaging. Now you can create some reports. Now you can do some logging. Now all these things are possible using plugins and Jenkins. Another important component that we've talked about in Jenkins, apart from plugins, is Jenkins notification, which we call it as Mailer. Using Mailer, guys, we can configure email notification. For instance, you can configure scenario. For example, you want mail notification when build is successful. Now, all these things can be done using Mailer as the Jenkins component. Another important component in Jenkins is the SSH agent. Jenkins also follow a typical master-slave topology. Now, why do we need a master-slave topology and a CI tools like Jenkins? Now, when you work in the organization, we have got multiple teams which you want to build and deploy their own pipeline or deploy their own software project codes. Now, teams don't want the piece of code to be run on a server which is owned by some other teams. So what we can do is we can set up a master-slave topology where Jenkins may run on a server X. But you can connect multiple other servers which will act as a slave. So when you are deploying a code executing a pipeline, you can run those codes on those XYZ servers. Now this is the beauty of using Jenkins master-slave topology. Now another good thing about Jenkins is Jenkins can be deployed on any operating system. In Jenkins, you can use in a Windows mode, a Linux mode, a Mac mode, or now all these Jenkins jobs can be deployed on any operating system. It is not at all dependent. Now both master and slave needs to be of the same operating system. Another important core component of Jenkins call is JavaDoc. This is our plugin in Jenkins, which basically is a part of Jenkins core that helps us to publish results like build action, build directory, what is the expected build output. All those things that we see in Jenkins, they all are happening using JavaDoc. Now let's talk about security injection. Apart from that, Jenkins have other sorts of authorization like project-based strategy, metric-based authorization, which help us to make Jenkins more secure. We'll talk more about this when we talk about the Jenkins overall. So as you can see on the diagram, Jenkins is pulling code from the source code control system like Git, Bitbucket, etc. To start deploying it in Jenkins, we have got a notification management system using Mailer, where if the build is successful, we get a WAR file or a zip file. We can define how we want the build to be created, and if it is a failure, it will send the notification management to a developer that something happened wrongly with the specific code lines and you need to rectify your codes. Now that is the beauty of using Jenkins. So Jenkins is still the bread and butter in the industry. There are some Jenkins competitors also in the market like GitLab Jenkins and some others. But by default, Jenkins is the to-go tool for the CI industry. So far we've talked about Jenkins. Now let's talk about what is pipelining in Jenkins. Now let's say I want to deploy a code. The code may have certain steps like first step I'm building the code, second step I'm compiling, then code reviewing, then packaging, then deploying. So how do I automate a combine of all these steps which can be executed in one go? Now to deploy all this scenario, we've created a delivery pipeline. Now pipeline is nothing but it's a combination of different steps or different tasks that we need to perform in order to deploy our code. Now using a pipeline instead of doing this task or code deployment manually, we combine them and deploy them as a sort of one common approach of a delivery pipeline. Now there are multiple ways on how you can create a pipeline. The two most common ways or common approaches of using a pipeline, as you can see from scenario, a declarative approach. And the second one that is used in the industry is a scripted approach. This particular is an example of a Jenkins pipeline script. Here you are saying we are first doing a stage called build stage, where we will be combining multiple tasks. Like first we are using Java, then we are printing something called echo hello pipeline. Then we are using Maven as the build automation tool and try to deploy a package, and then we are doing a shell script output of what all things are present in that particular directory structure. This is a typical example of syntax of how to create a pipeline in Jenkins. Now let's talk about the two predominant pipelines that are used in the IT industry, scripted and declarative. Now let's talk about what is scripted and declarative and how they are different from each other. A scripted pipeline is a traditional Jenkins pipeline approach, and a declarative pipeline is a modern day pipeline approach that is used in the industry. In a scripted pipeline, the syntax was first strict, while in declarative pipeline we use something called as groovy syntax. When you use a declarative pipeline, you can get a code from any version system tool like Git. You can create something called as Jenkins file, and you can download Jenkins file from a virtual constant tool, and that can be used to run your Jenkins code. When you use a scripted pipeline, you define a code something called as a node block. But one declarative pipeline will define a code in a pipeline block, as we can see in the previous example. Now let's talk about what is Jenkins file and how it can be used. Now Jenkins file are like a text file where you define your entire structure and syntax of your Jenkins. You know only how to download the file, and in particular, you can just give the part of your Git repo. If it is true, then get the credential, the private repo, and it can pull all the contents from there and just execute your code. It is a modern deployment mechanism that we use when we work with a Jenkins pipeline. Using Jenkins pipeline, we use certain things which help us. Let's talk about this. First is code review. Now you do a Jenkins pipeline, you can easily review your code. Your code can be reviewed by multiple developers before being executed. Now how that works is in Jenkins file, they are stored generally in a version control tool like Git. You can put something called as a pull request for a code review. Now different members of your team can review the code before you actually pull the Jenkins file and deploy it. Now you can do an audit trail or refer to as a long audit. You can log each and every step's output that is being executed as part of the Jenkins file and can see what is happening when the Jenkins file is getting executed. It's sort of like a verbose log. Then you can find a single place to store all your data or all your outputs. You don't need to have developers scattered here and there and writing their own codes for executing a Jenkins pipeline. Whole organization can approach a Jenkins file methodology where code can be stored in a VCS tools, and from there the code can be downloaded and can work as a single source for your entire pipeline. Now let's talk about the Jenkins workflow in particular. How does Jenkins workflow work? Jenkins workflow always starts with a version control system, or you can say a source code repository. Multiple developers collaborate and they put their code in a source code system like Git, from where Jenkins tries to pull the data from that source control system. For your system, there is no mandatory or the source code needs to be Git. It can be Bitbucket, SVN, whatever your organization uses with Jenkins server. Now we execute tasks like build, deploy, compiling, packaging, code reviewing. Now all these things happen using Jenkins server, where your Jenkins actually installed was running. Now Jenkins server can be any operating system. It can be a Windows machine, Ubuntu machine, Linux machine, or a Mac as well. It can be any operating system of today's modern world availability. Using this Jenkins server will execute our different tasks and scenarios. In Jenkins server, we use the mail functionality for the feedback mechanism. We notify developers the commit or the code deployment successfully or it is a failure. It also has some challenges. Now, what can be done using the feedback mechanism? Possibly using the Jenkins server. So using Jenkins server, we always first deploy the code on a lower lifecycle environment. That is recommended standard practice. So what we do is we first deploy a QA server on a testing server, and once the code deployment is successful on the lower life cycle, then we go ahead and deploy the code on a production server. That is how the entire Jenkins workflow, mainly particular, interact first. Now guys, let's talk about the Jenkins installation and how to install Jenkins in a machine. As you all know, Jenkins by default run on 8080. So please make sure that if you're using any VMs in your organization, the port 8080 firewall settings are open and configured so that it can be accessible. I will get into some of the prerequisites required for installing Jenkins post, which will go ahead and install Jenkins on a window box. Now there are a few first configuration that needs to be done, and I'll be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part, then create few users, and I will get into some of the plugins for setting up various kinds of access permissions for these users, and I also put in some of the freestyle jobs. Freestyle job is basically nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon time schedule. Then I will also connect Jenkins with GitHub. Now GitHub is a source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box, and then run a few commands to build this particular repository that is pulled from the Jenkins sending out emails. Now it's a very important configuration of Jenkins or any other continuous integration server for that particular matter. Now, whenever there is any notification that has been sent as a part of either build going bad or by being good or building propagate to some environment and all these scenarios, now you will need the continuous integration servers to be sending out notification. So I will get into the bit of details of how to configure the Jenkins for sending out emails. Now, I will also get into the scenario where I will have a web application such as a Maven-based Java web application, which will be pulled from the GitHub repository, and I will deploy it into the Tomcat server. Now the Tomcat server will be locally running on the my system. Eventually I will get into the other very important topic, which is the master slave configuration. It's a very important and pretty interesting topics where distributed builds is achieved using a master slave configuration. Now all this can be very easily based up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Now, Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. Now, I've listed the popular three mechanisms in which Jenkins is usually installed in any system. Now, the topmost one is a window or a Linux-based services. So if at all you have a window like the way I have, and I'm going to use this mechanism for this demo, so I will download the MSI installer. So whenever you start as a service, it goes out and nicely install all that is required for my Jenkins, and I have a service that can be started or stopped based upon my needs. Any flavors of Linux is one of many other ways of running Jenkins in downloading this generic WAR file, and as long as you have a JDK installed. You can launch this WAR file by the command opening up a command box prompt or shell prompt defer to later on Linux box specifying jar and the name of this WAR file, typically bringing up your web application, and you can continue with your installation. Now the only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt, even into a control C, and then bringing down this prompt and in Jenkins server. And then you also have the other older versions of Jenkins where run popularly using this way, in which you already have a Java based web server running up and running. So you kind of drop in this WAR file into the root folders or the HTTP root folder of your web server. So Jenkins will explore and kind of bring up your application. All user credentials or user administration is all taken care by the Apache or the Tomcat server or the web server on which the Jenkins is running. This was a very old way of running, but still some people use it because if they don't want to maintain two servers, Now, if they already have a Java web service which is being nicely maintained and backup, now Jenkins can't run a test to it, alright? So either ways, it doesn't matter however you're going to bring up your Jenkins instance, the way we're going to operate Jenkins is all going to be very, very same or similar, but the subtle change in terms of user administration. Now, if at all you're launching it through any other web server, which will take care of the user administration, otherwise all the command or all the configuration or the way in which I'm going to run this demo is going to be same across any of these installation. All right. As I mentioned earlier, Jenkins is nothing but a simple web application that is run in Java. So all that is needed is Java, preferably JDK 11 or 17, with a 2 GB RAM, which is a meant RAM for running the Jenkins. And also, like any other open source tool sets, when you install JDK, ensure that you set in the environment variables. Now, Java home to point in the right directory. Now, this is something very specific to JDK. Now, but for any other open source tools that I've installed, there is always a preferred environment variable that we got to set in which is specific to that particular tools that if you're going to use. This is a generic thing that there is for you to know. Now, for any other open source project, because the open source project discover themselves by using the environment variables. So as a general practice or a good practice, always set these environment variables according. So I already have a JDK 17 installed on my system. But in case you do not, what I will recommend is just navigate to the browser, to the Oracle homepage, just type in your search for install JDK page. Then you'll have the accept the license agreement. Now what I will recommend is just navigate on your browser to the Oracle homepage and just type in your search install JDK. Now you're gonna navigate to the down here and install the 64 installer, that is the .exe. Now let me show you once I have installed what I've done with regards to the path. So if you get into this environment variable, so I have just set in the Java home variable. Now you can go back to your this PC, go to C programs, go to Java, and then copy this part, then click in the environment variables. I'll select the first one, that is the edit the system environment variable, and we click on the environment variables and we'll set a path here. As you can see here, Java home, and we'll go down here on the path. So this is the path for your Java home screen. So simply click on edit and click on new, and we will just paste the path which we have just copied from the install.exe Java. So I've already installed it, as you can see there, C program file. So I simply click on OK. So the only difference between the system variables and the user variables for daemon is this is control the whole system of the JDK, the system variable. So we want to edit in the system variables. So the path I've been changing here is in the system variables. All right. Now the home variable is where I have the SQLs and program friend of the JDK 17. Now you see this is my Java home. All right. Now one thing to do is ensure that in case you run Java or Java C, for a command, you ensure that you also add the path into this path variable, right? So if you see somewhere, I will say there you got the colon program files. Now you click on that and I'll show you the bin as well, which I've copied and pasted here as well. Okay. So simply just go back. So that's how you get the bin. Copy this path and paste it here, which I've already done it. So I'll just simply click on OK, OK, and OK. Now let me minimize the screen as well. So the next thing we need to do now is go to CMD to check if your Java has been installed on your system. So you simply type on Java space / version, and you can see I already have Java version 17.0.5 installed in my system and is up and running. So as you can see the runtime environments, and it's a 64-bit server. This is a VM virtual machine. Okay, so as you can see, Java is installed in my system and is up and ready. So the next thing we need to do now is install Jenkins. I'm just canceling that and open a new browser again, new tab, and type in jenkins.io. Now as you can see, this is the homepage of Jenkins. All right. So you can even read the documentation, or you can simply click on download. Will take you to this page. Now here you can see the hardware and software requirements, then what packaging is required for downloading the installing Jenkins. So this is the part for, on the left hand side we have the LTS, and on the other side we have the, which is a more stable, and on the right hand side we have the regular weekly releases. So we'll definitely go for the stable LTS download, which is a long-term support, which is released every 12 weeks, whereas the regular releases changes weekly. So I'll be going ahead and scroll down and click on window. So as you can see, there are different parameters where you can do. You can have on Dockers, then you have Ubuntu, then you have the CentOS, Fedora, or the Windows, like I'm going to install in this case in this demo. Then, but we have different aspects as well, like the FreeBSD, the CentOS, Mac OS, etc. So as you can see on the first stop, we have the .var. We can even install that and unzip that. But in this case, in this demo part, we'll simply click on Windows. So go on ahead and click Window, guys. Now you can see the download has started. So we just wait a few seconds until it's done installing the MSI. And as you can see, it's done. So this is my download in Jenkins instance. So what I'll be doing now is simply click on next. Now, as you can see, guys, on top here, it's written the Jenkins run on localhost 8080. So keeping that in mind, click on next. As you can see, this is where our Jenkins is installed. That is in C and program files and by the name Jenkins. So you can always change this location where the Jenkins has been installed. But in this case, I'll rather keep it on the C drive itself. So the next thing you need to do now is we'll run server as a local system so that we don't have to put any administrator or the password. And so the next step now is we test the port. So as you can see, you got a green tick mark. So next, now you can see here that it has failed because there is no compatible Java version 11 or 17. But as you can remember, guys, we have already installed Java 17 and we have already verified that we're using the command prompt where it has shown us the version Java 17. So what you need to do is simply click on change and select the Java 17 from Java 8. So simply click on Java 17, JDK 17, as you can see, click on next and click on the install part. Done and dusted. So I've already told you that Jenkins run on the localhost 8080, right? So we're gonna go localhost colon 8080 and hit on enter. Now, as you can see, please wait while Jenkins is getting ready for work, right? So this will take a few minutes and then you'll be having to provide the credential of the administrator. All right. So just give it a few minutes while it's starting up. All right. Now you have to provide the administrator password, right? So you can go ahead and go down out here. You can see the password is in the C and goes to the program data, then Jenkins. Then we have a .jenkins, then a secret, then you'll find the initial admin password. So we need to head out there. So what we need to do is we'll go down there. So I'm just going to minimize the screen now, minimize it once again. And as you remember, we go to the C. So you can see right where it is. I'll just show you, minimize the screen here so you can see and do it along with me. So you can see this in PC, then scroll down to C disk. Okay, this thing popped out, sorry. It's in this, so you have a program data, right? As you can see here down, there is no program data, right? So what you need to do is it's in the hidden file. So what you need to do now is click on the three buttons and view, click on show and click on the hidden items. Now let's see if it's there. Scroll down, program data, you can see at the last. Yeah, simply click on that, double click on it. As you can see, then we have to go to the folder name as Jenkins. Yeah, you can see on the top, Jenkins and .jenkins. Then we need to search for secrets. There it is, folder. And as you can see, there's an initial admin password. Now you simply click on that. We'll try with the notepad so we can copy. So simply copy that and paste it in the administrator password and click on continue. So in this case, I will not save it in my computer or system. So there are two installation plugins available, which is custom by Jenkins. One is their suggested plugins, and the other one is you can select the plugins which you want to be installed. So in this scenario, I'll simply click on the install suggested by the Jenkins. So what happened is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugins and got a dependency which is not installed and you get all those issues. In order to get rid of that, what Jenkins recommends is that there are a bunch of plugins that is already recommended and they are good to go, right? So just go ahead and blindly click on that recommended by the plugins, which is a suggested or custom by the Jenkins. And as you can see, these getting started process is going ahead. So it'll take a few minutes depending on your internet speed or on the system. Now you can see all these plugins are installing it for you. So it will take a few minutes time. So let's just wait till we get all the plugins installed in a system properly. So this is a good combination to kind of begin with, and keeping that in mind, Jenkins need a lot of bandwidth, right? Now in terms of network, so in case you know your network is not so good, it'll make for a few of these plugins will kind of fail, and these plugins are all are available on openly or mirrored site, and sometimes some of them may be down. So do not worry, in case some of these plugin kind of fail to install, you get an options to kind of retry installing them, but just ensure that you at least at the most 90 to 95% of all of these plugins are installed without any problem. As you can see, we are almost there. It's around 60% to 70%. Now once all these plugins are installed, now my plugin in the installation is all good. There's no failure in any of the plugin. So after that, we've got to create this first username, that is the first admin user. So you need to give in the username, then the password, then you have to confirm your password, give it your full name and your email address, right? So we'll start it by giving the username. I'll keep it plain and simple. Now you got to remember these password and the confirm password, because if you kind of lose or you don't remember the password of the Jenkins, it'll be really hard to get back your account. So try to keep it as simple as possible, and keeping in mind that you have to remember the password, because getting back this account will be really difficult. All right, so I'll be putting the password as well. Give it my full name. Okay, my A is small, and go to the email address damandla.mamare@Edureka.co. All right, so once it's all done, so just simply click on save and continue. So click on never, don't want to save the password. And as you remember, I've told you by default Jenkins run on localhost 8080, right? So you can simply click this, or you can copy this, or just write save and finish. You can even copy this link, save and finish. Now start using Jenkins. All right, now that's kind of complete my Jenkins installation. As you can see, it was not that tough at all. Now the Jenkins is installed correctly. Now let me quickly walk you through some of the very minimal configuration that is required. Now these are kind of the first time configuration that is required. So, and also let me warn you, the UI is a little hard for many people to wrap their head around, especially the window guys. But if you're all a Java guys, you know how painful it is to write UI in Java. You kind of appreciate how the effort that has gone into the UI bottom line. It was a little hard to wrap your head around. It becomes like start using it, possibly you start liking it all right? So I will get into some of these important ones, something called as configuration system, or the configuration a system. This is something kind of put in your configuration to complete your Jenkins instance. Now few things to kind of look out for. This is the home. Now configure system is where you kind of put in the configuration for your complete Jenkins instance. Now a few things to keep a lookout is the home directory. All right, now this is a Java home where all the configuration, all the workspace, anything and everything regarding Jenkins is stored out here in the system message. Now in the system message, you can put in some of the message on the system. You can just type anything you want, probably show up somewhere here on the menu. Now the number of executors is a very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. So you can kind of visualize like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, the number of executor you should be good enough in case at any point if there is any multiple jobs that kind of get triggered at the same time. Now in case the number of executor are less compared to the number of jobs that are out there to open up the new, so you don't need to panic, because they will get queued up and eventually Jenkins will be get up and running. So just keep that in mind that whenever a new job kind of gets triggered in the CPU usage and the memory usage, in terms of the disk, it's like a very high of the Jenkins instance. So that's something you got to keep in mind. All right, the number of executors for my system is kind of a good label. For my Jenkins, I don't want any of these usage. So how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this as low as possible. All right, as you can see, it's 2. Now this is usage. So I can leave everything to default. So what I want is I want this SMTP server configuration. Now Jenkins will be sending out some emails. What I've done here is I've configured the SMTP details of my personal email details. In case you are, in your organization, you want some sort of an email that is like an email ID that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of like send out emails. But in case you want to try it out like I have configured my personal email ID, which is of the Gmail for sending out notification for the same TP server, will be the SMTP Gmail. So it's right as username as so we have used SMTP authentication and then we're given the password. Now you can just send out an email to see if at all this configuration works again. Now Gmail will not allow you to allow anybody to send out notification on your behalf. So you just have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notification on your behalf. So I've already done that. So let's see if this works. Let's test it again since I've entered the wrong password. Let's see if this works or not. And it has given me a password has not accepted. So now as you can see, since my Gmail has not been set up, so what you have to do is you have to lower your security level of your Gmail ID so that you can be allowed to test your email configuration. All right. So simply click on save. So now we're heading back to the dashboard. Now we should go to the global tool configuration. Now look at the scenario where Jenkins is a continuous integration server. Now it does not know what kind of a code base it's going to pull, and what kind of tools is required, or what is the code that is going to pull in and how it is going to build. So you'll have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from like a source code repository. So for example, in case your source code is a Java code, and assuming that you have because this demo, this is my laptop and I put all the configuration, JDK, everything on my laptop because I am a developer and I'm working on the laptop, but my country's integration servers will be known as a separate server without anything being installed on it. So in case I want Jenkins to like run on a Java code, and I need to specify the JDK location of this out there. So okay, since I've already have the JDK installed and have already put in the Java home directly, or rather and the environment correctly, so I don't need to do it. So now if at all you want the Jenkins server to use Git, now as you know that Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you will need Git to be installed on that particular system. Now Gradle and Maven, if at all you have some Maven as you want to do this in any other tools that you're going to install on your system, which is your continuous integration server. So you'll have to come in here and try to configure it. And in case you have not configured, then Jenkins will not be able to find these tools for building your task. So since I don't want to install anything, we'll go back to manage system. Now you can see the global configure global security. Now you can see this an SSH server. Now what does this mean if you ask me? Jenkins own user database. So this is nothing but the security access control which is set to Jenkins own user database. So what this mean is Jenkins by default it uses files system where it stores all the usernames, which hashes up like these username that kind of stores them as of it. So as of now, Jenkins is configured to use in your own database, assuming that you're running an organization. So you will probably want to, have some sort of LDAP server, which will in turn have a control of your access to your Jenkins repository. So you will specify your LDAP server details, the root DN password or the managed DN. So the LDAP, as you can see, or the LDAP, which the Jenkins itself will tune in for your specific servers. Now you have the manager DN, the manager password. Now all these should be filled, all these details should be filled in case you want to connect your Jenkins instance with your LDAP server or any of the authentication server that you have in your organization. But for now, since I don't have any of these things, I'm going to use its own database. That's good enough, right? So I'll simply the Jenkins own user database. So I will set up some authorization methods So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own server, which is happening as of now. Let me put in a very simple job. All right, so let's create a new job in this video. So simply click on new item. Now simply you can add any item name here. So the most important here are the freestyle and pipeline. Now for the first demo, we'll click on the freestyle job and click on OK. So in the description, you can write anything in your description. This is an optional thing. So you can say this is my first job demo for. So in this demo, I don't want it to connect it to any source code for now. So I'm just going to leave it to none. Now we don't need to write any build environment as well. Now in this build step, we simply click on execute Windows on. So since I'm on the window box, I will say execute window bash command. All right. So what do you want to do? So let me just echo something. Echo hello world. This is hello. Welcome to my first demo job in Edureka. Then we'll specify the date and time as well. So put in date, colon as time as well. So you can see it's a very simple command. You just have to put an echo and we have something along with the date and time. So we'll keep everything as simple as possible. So we'll save this job. So once it is shipped, so you can see there's a build history. So once you have saved this job, you know the job name comes up here. As you can see, project first job. By mistakenly, I've written double T in my first job. Now as you'll see here, there's a build history. So there is nothing as of now because I've put in a job. I have not yet run it. All right. So let me try and build it now. Now you can see there's a number, my first job. So you will see a date and you will see the time since I've clicked twice. So if I've come 1 and 2. Now if you click on this, now you can see the console output. Now if you click on this, now you can see is it. And this is the output that is run. Hello, welcome to my first demo job in Edureka, along with the date and along with the time. Now if you see this, now if we navigate this, we go back to here. Now, as you can see, there's a folder created as jobs, right? So this is the directory what I was mentioning earlier regarding Jenkins home. If you can just open it up wider, you can see this folder jobs. So this was mentioned earlier regarding Jenkins home. So all the job related stuff, it's specific to this particular Jenkins installation is all here. Now all the plugins that I install, the details in each of those plugins can be found here, right? So the workspace is where the jobs that I've created, whichever I'm running would, there'll be an individual folder specific to the jobs that has been put up there. All right. So one job, one quick run. That is how it looks like. So the workspace is where all the jobs that I've created, whichever I'm running, would, there'll be an individual folder specific to that jobs that has been made up. All right. So as you can see, there's the first job that we have just created just now. So one job, one quick run that we have done. That is how it's look like. It's pretty simple. Now let's go back. So let us put on a second job. So we can go back to dashboard, click on new items and say second job. Let's get the spelling correct this time. Second, I wrote second first again. Second job, and I can put a semicolon here, underscore. Second job. We click on freestyle again. Click on OK, and you can say this is my second. So I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put on the Jenkins, which will be triggered automatically. Now remember what I've said earlier about Jenkins, because at the core of Jenkins is a very powerful automation server. All right, this is my second job. This is my second job, which will be triggered automatically. Okay, so in the build step, we'll put bash tabs, then we'll write here echo again. So we'll say here something as second job is going on here. The tools, with the tools of an automation tool. And then I'll give some date as well. Date, put in the time. But this time I'm going to demonstrate the powerfulness of the automation server that is there. So if you see here, there is a build trigger. So build can be triggered using various triggers that is there. So you'll get into the GitHub trigger or a hook or a webhook, which is kind of triggering. So we'll see that later on. But for now, what I want to do is I want to ensure that this job that I'm going to put in will be automatically triggered. Let's say every minute I'm on this job to be run on its own. So we'll put as build periodically and we will set the time. Now, if you can see here, There's a bunch of help. If you want to go through it, you can go through it. Let's just put out very simple regular expression for scheduling this job every minute. All right. So 5,000 is all I'm gonna put in. 1, 2, 3, 4, 5. Now let me save this. Let's go back. So when you build periodically, is now you can see here. Now we just copy that, and now how do we check if it gets triggered every 15 minutes? So I just don't do anything but wait for 15 minutes, and if everything goes well, Jenkins will automatically trigger my second job in 15 minutes. Now you can see here is still processing, so we have to wait for 15 minutes. Now we can go through all those commands of the scheduling time, so you can see how many stars required for each minute or for each hour. Now as you can see it's done. You can just go and go here and go to console output. Now you can see the finish is success, and you have this. Now we can go back and copy this and see if they're on your it's already there. You can go to workspace. You can see your second job has also been created automatically by Jenkins. Now that I have my Jenkins up and running, a few jobs that have been put up here on my Jenkins instance, I will need a way of controlling access to my Jenkins server. This is where I will use a plugin called a role-based access plugin and create a few rules. The rules are something like a global rule and a project rules for a specific role. I can have different rules, and I can have user who have signed up, or the users from my create kind of assign to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwanted. All right. So first thing first, let me go ahead and install a plugin for doing that. So we get into manage Jenkins, then we go to manage plugins. We will plugins, install plugins. We have advanced settings. So these are the available plugins, and then if you go to install, now these are the installed plugins. Now let's go and search for a role-based. Now you can see here, base authorization strategy. So this will happen is it enables user authorization using a role-based strategy. Now roles can be defined globally or for particular jobs or nodes selected by a regular expression. This is the plugins that we want. So you will install it without restart. So it's success. It looks good. Looks good. Now waiting for this. Yeah, it's success. Done now. So go back to the top page. Now one thing to remember, guys, is Jenkins is running on a Java using a Java instance. So typically many things will work the same way unless inherently you want it to restart. So, but a good practice is whenever you do some sort of a big installation or a big patches on your Jenkins instance, just ensure that you can restart it. Otherwise, there will be a difference in terms of what is installed in the system and what is there on the file system. So you'll need to flush out few of those settings later on. But for now, these are very small plugins. So this will run without any problem. But otherwise, if at all there are some plugins which they will need to restart, you can kindly go ahead and restart your Jenkins instance. But for now, I don't need that. So it looks good. I have installed the plugins. So where do I see my plugins and install the plugins? It is specific to the user control to the access control. Now let's go to the configure global security. Now we can go ahead and check the authorization. You can see here authorization, role-based strategy popping out here, right? As you can see, the role-based strategy has been installed and has been shown here. This is because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up, and for the authorization part in that sense that you can do what I'm going to install. I mean, I've already installed a role-based strategy, right? Now I'm going to enable that strategy. So we'll simply click on role-based strategy, okay? And click on save. So now I'm going to enable that strategy. All right, now I will say, okay, now I've installed the role-based access plugin. Now I will need to just set it up and check, I will go ahead and create some roles, and it shows that I've assigned users as per these roles. So let me go to manage the configuration, manage Jenkins, and let's see how we can create our roles. Not here as well. So we can do manage and assign roles for creating a roles, okay? Now you'll only be able to see this once and only when you have installed those plugins. Now I've enabled the plugins. Now I've enabled the role-based access control as well. Now we'll go ahead and create some rules for this particular Jenkins instance. So first I will manage roles. So this is at a very high level, which is a global role. Now there are some role to add which you can add by yourself, some item roles for some projects or something. So let me create a role which kind of visualize like a group. So we'll create our own called the developer. Typically the Jenkins instance or the CA instance are kind of owned up or controlled by a QA guys. So that's why I'm creating a role called developer, and I'm adding this role at a global role. So I will add this here, and then I can click read as well. So we've given this administrator, right? So we add this. So as you can see here, you will see this develop a rule that there is each one of these options that you can hover here and sort of see what kind of permission you have given it to this developer role that you have just created. So you can read and write, then you can create some changes. Like we have given a permission as credential, which you can create. Then you can delete, then manage the domains. So this kind of help or the permission that they're giving it. So these are some kind of sort of a help for a permission specific. So you want to see it's like how it sounds a little different, but I would want to give you a very little permission for the developer. So from an administrative perspective, I just want him to have a read and write kind of a role credentials. Okay, let's say read and write, and I can allow him to view as well. I don't want him to create agents or give him some delete. No, I don't want him to configure, build, provision, or connect or disconnect anything. So I'll just give him a read and a view. And I don't even want him to have access to my workspace as well. So I'll just give him now for run. So I won't even give him the access to that. Now we can give view as well. I don't want him to delete. And what am I doing here is just creating a global rules for the developers. And I've given him a very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs or build jobs or cancel jobs or configure jobs at the maximum. Right? So I just want him to read that is already put up there. Okay, so I would save now and create a rule. That is done. Now that I've created a rule. Now I still don't have any users that is in there in the system. So let me go ahead and create some users on the system. So we'll go back to Manage Jenkins and go to Manage Users. Now let me create another user, okay, by clicking on plus users, and we'll say this one as a developer. Give him some password and name him as develop123. And email, can just simply give my email here and click on create users. Okay, 12. So we have created. Now this developer 12 is a user that I've configured, but still yet I have not set any rules for this particular user. So I will go to the manage and gain and will give him the manage and assign roles. So now we'll go manage and assign roles, and we'll assign role. So what you're gonna see, what I'm gonna do now is I'm gonna assign a role that is specific to that particular developer. So I'll find that particular user and assign him, or means the developer role that I've already configured the rules. Okay, so this is the role that we have created. So we will search the user that we have just created, developer 12. Now I've assigned this. So go ahead and save the changes. Now let's go ahead and check the permission of this particular user by logging on to my main account and logging back as the developer one. Now let's log out from here. Log out and say developer 1. Now if you remember, this role was created with very less privilege. So there you go, I have Jenkins, but I don't see a new item. I can't trigger a new jobs. I can't do anything. I see these jobs, however. I don't think I'll be able to start this job. Now I don't have the permission to set forth at the maximum. So what I can do is look at this job, see. So this is a limited role that was created, and I've added this Damanang to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs because the Jenkins instance is owned by a QA person. He doesn't want to give developer any ethnicity or right. So the rights that he set out by creating a developer roles, or any user who's tagged as a part of this developer role will get the same kind of permission. And these permission can be, fine grained. It can be a project specific permission as well. But for now, I just demonstrate the high level permission that I've set. So let me quickly log out of this user and get back to my admin account. So because I need to continue my demo with the developer roles that was created. Now, one of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins, but it's got plugin for connecting anything and everything. Now you can find the Jenkins plugins, then you will see the index over here. There are so many plugins that are there. All of these are wonderful plugins. Whatever connectors that you will need if you want to connect Jenkins to the AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you will have a plugin. You can go and search up if you want. If you want to connect Jenkins to Bitbucket, simply click on Big. So as you can see, these are available. So bottom line, Jenkins without plugin is nothing. So plugins is the heart of Jenkins for you to connect, or in order to connect Jenkins with any of the containers or any of the other sets of tools, you will need the plugins. Now, if you want to connect or you want to build a repository which has got Java and Maven, you will need to install Maven and GTK on an instance. Now, if at all you're looking for a Microsoft build, you will need to have MS Build installed on your Jenkins instance. And the plugins that will be triggered MS Build. If at all you want to listen to some server-side webhooks from GitHub, you will need a GitHub specific plugins. You want to connect to Jenkins, to AWS, you need those plugins. Now, if you want to connect Docker instance that is running anywhere in the world, as long as you have the URL, which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. So if you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a plugin that is installed on your Jenkins instance. Now, SonarQube is one of popular statistic code analysis, so you can connect a Jenkins build. You can build a jobs on Jenkins and push it to a SonarQube and get SonarQube to run analysis on that and get back the result in Jenkins. Now, all of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to a GitHub. So now let us connect our Jenkins instance to a GitHub. Now I already have a very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. Right. So this is a very, very simple and repository is called Hello Java. And this is what is there in the repository. This is a simple class file. It's just got some one line of system .out. So this is already present on github.com at this place, and this will be the URL for this repository. So I will pick it up. So what I'll do is I will connect my Jenkins instance to go to my GitHub and provide my credential and pull out this repository which is on the cloud hosted in the github.com and get it to my Jenkins instance and then build this particular Java file. Now I'm keeping the source code very, very simple. It is just a Java file. Now, how do I build my Java file? How do I compile my Java file? I just say java.c and name. Now, the name of my class file is hello Java. And how do I run my Java file? I will say Java and hello. Okay. So remember, I don't need to install any plugins now because what it all needs is a Git plugin. So Git plugin, which is already installed on this system. So let us go back, create a new items. We'll create a first job here. Let's say this is a Git first project. Now let it be a freestyle. Okay. Now we'll go to the source code management. Remember, right? We always have been keeping it on none. So in this part, we'll put it as Git. Now, as you remember earlier in examples, we do not use any source code because we were just putting up some echo kind of jobs that did not need any integration with any of the source code system. So now let us connect this. So I'm going to put up my source code and it will show up because the plugin is already there. Now I've already copied the HTTP address from the GitHub and simply paste it here. Now what is the credential? So I'll simply add that. If we add credential this time, so I'll just click and cancel. So if we just add Jenkins, so we'll add a username here. Now, if there are any errors in terms of not able to Jenkins to be able to find the Git or the git.exe, or if the credentials are wrong somewhere down here, so you'll see a red message, okay? Like something is not right. So for now, it's okay. Now I'm gonna build trigger. Now, what will be there as a part of my build step? Because this repository just have the Java file correct, hello Java. So in order for me to build this, I will say execute window bash command, and I'll say Java, hello, Java, Java. Now let's save this. Okay, so let me try to run this. Okay, build now. Click on this. Console output. Great. Now, as you can see here, there's a lot of executed Git on the behalf. It goes on there to provide my credentials, and so it pull all my repository and my default. Now we'll pull up the master branch. This is there on the string, and it kind of builds this whole thing on Java C hello world. Finish, and it's given me a success. So it's kind of build this whole thing Java C hello to Java, and it runs this Java hello world. And there, as you can see, this is the output. It's there, and here you can see if you want to look at the content that was created on the repository. Now, if you can go there into my workspace, like I've showed earlier, you can just simply click here, and you can already see here it's been created Git first project, and it's saying hello. Now, as you can see, it's already there. Now, if you can go back, as you can see, and simply close that. Now, what it did was Jenkins on your behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to your local system. On my Jenkins instance, now it's compiled it and it ran this particular application. Now that I've integrated Jenkins successfully with Git, simply within the Java application,
What is Docker? Well, Docker has a very simple definition. Docker is an open source platform for developing, shipping, and running applications. It enables you to separate your applications from your infrastructure to deliver the software quickly. With Docker, you can manage your infrastructure in the same way you manage your applications. By taking an advantage of Docker's methodology for shipping, testing, and deploying codes quickly, you can significantly reduce the delay between writing code and running it in production. Docker has some amazing features. Like, Docker has the ability to reduce the size of the development by providing small footprint of the operating system via containers. With containers, it becomes easier for teams across different units such as development, quality analysis, and operations to work seamlessly across the application. You can also deploy Docker containers anywhere on any physical or virtual machines and even on cloud. Since Docker containers are pretty lightweight, they are very easily scalable. Because of these features, many organizations have switched to Docker. Now that we have got a brief understanding about Docker, now let us see how to install Docker. So we will be installing Docker in Windows as well as in Ubuntu. And once we install the Docker, we will see how they run in each one of the environments with the Hello World program. So I'll be using the Ubuntu through a virtual machine. So this is your Ubuntu's operating system. Now here we'll be installing the Docker. For this, we will first need to open our terminal. So to install Docker, we will be following the guide to install a Docker. Here I have the official document of Docker where we get to know how to install the Docker engine on Ubuntu. So as you can see here, there are some prerequisites, the OS requirement. The different versions of Ubuntu are available over here. So you should have 64-bit or version of any one of these Ubuntu versions. If you have Docker previously, so you can uninstall your old version and we can set up a new version of Docker. So this is the installation methods. You can follow this guide and install Docker in your Ubuntu or any operating system. So now let's quickly go back to our terminal. So before you install engine for the first time in your host machine, you need to set up a Docker repository. Afterward, you can then install and update the Docker from that repository. So first, to set up a repository, you need to update the package index and install the packages to use the repository over the HTTPS. So let's get started. So our first command is sudo apt get update. They will ask you your password, so you can give your password. And now here you can see reading all the packages in the operating system. Now once this is done, you need to install some of the packages. So we will just copy this code and we'll just paste it over here and let's run. So here it will take some time. Now let's hit yes. Now the packages are configuring. Your packages are installed. Now what you need to do is set up the Docker repository. So here, First, you need to import the Docker's official JPG key to verify packages signature before installing them with apt-get. For this, we need to copy this command, that is sudo mkdir etc apt keyring. So from here we will get the JPG key, and this is the actual Docker installation link. So from here they will install the Docker repository. We'll just paste it and hit enter. So here we need to run this curl command. So we'll just quickly paste this command and let's see. We'll just give them the access. Now what you need to do is upgrade the index and install the Docker Community Edition. For that, what you need to do is sudo apt get update. All our packages are installed. Now let's install the Docker. For that, we will write the command sudo apt get install docker ce, hit enter. Let's see, just hit yes. So it may take a while. They are just unpacking the whole Docker package. Let's wait for a while. Now, in order to check whether our Docker has been installed successfully or no, let's check with checking the Docker version. So for this, we need to just type docker/version and hit enter. So as you can see, guys, your Docker has been installed successfully. You can see all the different commands and the functionings of how to use the Docker has been mentioned here. So you can see the different type of commands they have specified here. Now let's run an hello world program and see how Docker works on Ubuntu. So here you just need to type sudo docker run hello world and hit enter. So here what has happened is, as we had typed here, the sudo docker run hello world. So what Docker has done, it has downloaded the test image of hello world and then it has been passed to the container. It prints a confirmation message. So when the Docker runs, it prints a confirmation message, as you can see over here, hello from Docker. So this is how we install Docker in Ubuntu. Now let's see how to install Docker in Windows. So let's get back to our Windows environment. So here first we need to install the Docker installation package. For that we need to go to our main page of Docker. So let's type Docker installation. So here you get this link for get Docker. So we'll quickly get into this. So once you land on this page, you can see you have Docker installation package for 3 different environments, that is for Mac, Windows and Linux. So based on your requirement, you can choose any of one of your platforms where you would like to install Docker. Currently we're going to install this Docker on the Windows. So let's go choose the Windows version. So as you can see here, this is the installation document or a guide for Docker on Windows. So in Windows, you need to have some of the system requirements like the latest version of Windows, that is Windows 11 or Windows 10 with 21H2 Pro versions, and it can be more than that. Apart from that, you should have the WSL2 feature to be enabled on Windows, so to run the Docker container. Whereas you should have the hardware prerequisites like 64-bit processor, 4 GB system RAM, and BIOS level hardware virtualization support. So these are the system requirements you need while installing the Docker. What we need to do is to first download the installing package of Docker. So you just click over here and then it automatically gets. So once you double click here, you will get your Docker installation package. So it will take a while to download the installation package. So here, as you can see, it is initializing. Here they are verifying the package, and now let's move ahead. Well, this is a very easy step in Windows, like you just need to install the whole Docker package. Alright, so our installation is succeeded. Now let's close it and let's go to our desktop and open our Docker. Now here the Docker asks for the subscription service agreement. Now you just need to accept it. So once you come to this desktop here, this is how the Docker desktops look. So first we need to sign up. I already had an account, so it has been signed in. Now let's see how to sign up as well. For that, what you need to do is go to sign up. Here, first you need to create your account in Docker. So for that, you need to give your username. So you can keep any username. For example, Edureka1. So here you need to add your email ID. So just type down your email and you need to have a strong password. So it is up to you what kind of password are you putting. Now you need to accept the agreement what they have asked and then you need to verify. Once you get verified, then you just need to sign up. So here as you can see, get started with Docker with few easy steps. So we'll just start and here you can see you can clone your repositories, you can use your GitHub. So here is a tutorial what Docker provides while you start with the Docker. So we'll just quickly skip it up and let's get started. So once you sign up, you need to log in and then you finally get landed to this Docker desktop. It automatically opens. So you can find it over here, all your login credentials and profile. And here you see the containers, image, volumes. So as of now, we have nothing on this Docker desktop. So first we'll open our command prompt. In this command prompt, we will first check the Docker version. So for that, we need to just type Docker -version. So here you get the version of the Docker, which is 20.10.21. And now let's run the Hello World program like we did it in Ubuntu. So for this, you just need to type Docker run hello-world and hit enter. So as you can see, you have got the same output as we had got in Ubuntu. We work on with the containers. This is how containers work on the Docker. Now it's time to delve into the technical concepts of Docker. First is Docker image. A Docker image is a read-only template with instructions for creating a Docker container. Docker images are the key concepts in the world of containerization, and they are important part of Docker ecosystem. They allow the developers to create and distribute software in a standardized containerized format, making it easier to deploy and run applications consistently across the different environments. If we go with the definition, a Docker image is a read-only template with instructions for creating a Docker container. Let's make it more simpler. They are built using a series of commands that are stored in a text called Docker file. These commands specify the base image to use, any additional packages or libraries that need to be installed, and any other necessary configuration. These Docker images are stored in the Docker registry, such as Docker Hub. We'll be studying in further, which is a public registry that anyone can use to store and distribute Docker images. Well, you can also set up your own private registry to store and manage your own images. Docker image is also lightweight, standalone, and executable package that includes everything needed to run in a piece of software, including the application code, libraries, dependencies, and runtime. So this was about Docker image. So now let us understand what is a container. A Docker container is a runnable instance of an image. It is defined by its image as well as any configuration option that you provide to it when you create a container. So, the Docker containers are the way to package and distribute software in a portable and consistent manner so that it can run anywhere regardless of the environment. Containers offer several benefits like isolation. Here, containers allow developers to isolate their application from underlying infrastructure so that applications can run consistently across different environments. Next is portability. Here, containers can be easily be moved between the environments, allowing developers to easily test and deploy their applications in the different environments. Next is resource efficiency. This means that containers allow developers to package only resources that their application needs, resulting in more efficient use of resources. And lastly, they are highly scalable. That means containers can be easily scaled up and down to meet changing demands, making them well suited for use in cloud environments. Now, while we were learning about Docker image, we had used the word Docker file. Well, a Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. It's basically a text file that contains the instruction for building a Docker image. It specifies the base image to use for the build as well as any additional dependencies or libraries that are needed to be included in the image. Dockerfile is basically used to automate the process of building a Docker image so that you don't have to manually install all the required dependencies and libraries. Instead, you can simply specify those dependencies in the Docker file, and the Docker build process will take care of installing all of them. So these are the key components which are used in Docker ecosystem. Now that we have come to know about the key components, let's see how these components work in the Docker architecture. Well, a Docker architecture consists of the following components. First is the Docker engine. Docker engine is the core component of Docker which is responsible for running containers and handling container related tasks. It consists of a domain, a REST API, and a command line interface that allows users to interact with the domain. The Docker engine can run on variety of operating systems including Linux, Windows, and Mac OS. Next is Docker Hub. Docker Hub is a public registry. As I had discussed before, that Docker Hub is a public registry that hosts a large collection of Docker images, which are pre-built packages that contain all necessary components to run an application. Users can search for and pull images from the registry to use a base for their own containers. Next is the Docker client. The Docker client is nothing but the command line interface that allows users to interact with the Docker domain. The client sends requests to the domain through the REST API, which then carries out the requested actions such as building, running, and shipping containers. We all know what are containers. That is nothing but a standalone executable package that contains all the necessary components to run an application. So, to build a Docker image, we can use the CLI, that is nothing but the client, to issue a build command to the Docker domain. Then the domain will then build an image based on our inputs and save it into the registry, which can then either go to the Docker hub or a local repository. If we do not want to create an image, then we can just pull an image from the Docker hub itself, which would have been built by different other users, so that we can issue a run command from the CLI, which will create a container. So this is how the Docker architecture works. Now let us move on with our next topic, that is important Docker commands. So here we'll see some of the important and basic Docker commands that are used while you're working with Docker, and we'll see each one of them respectively. So starting with Docker version. Basically this command is used to get currently installed version of Docker. So whenever you install Docker and you want to know about its current version, then you can just type down this command to know what is the current version of that particular Docker. Next is Docker pull. So this command is used to pull the images from the Docker repository. So whenever you through Docker file create an image, when you run your image, so what does the Docker engine do is pull that image to run that particular image. The next one is Docker run. Here this command is used to create the container from an image. So as I said, once your image is pulled from the repository, now it gets converted into containers, and then you can run those particular containers. So the main function of the Docker run is to create the containers out of that particular Docker image. So the fourth command is the Docker PS. Here, this command is used to list the running containers. So if you have created more than one containers and you want to see how many containers are running at that moment, then you can just hit this command and you can see how many containers are running. After this, we have the Docker PSA. So here, as in PS, we can only see the list of running containers. And in PS, we can see all the containers which you have created. That includes your running as well as the exited containers. Now, our sixth command is docker execute. This command is used to access the running containers. Next, we have docker stop. Here, we use this command to stop a particular running container. So, if any container is running and you wish to stop that container, then you can just use this command. Next is docker kill. This command kills the container by stopping its execution immediately. So, well, you must be thinking the docker stop also stops the container, whereas docker kill also has the similar functions. Well, docker kill command is slightly different from docker stop. Let me tell you how. Well, when you use docker stop, it gives the container time to shut down gracefully. In situations when it is taking too much of time for getting the containers to stop, then you use the docker kill command. Well, this was the only difference between docker stop and docker kill. Next, we have docker commit. This command creates a new image of an edited container on the local system. And then we have docker login. Use this command to log into your Docker Hub repository. You can just use this command when you're logging into the Docker. So on your command prompt itself, you can log in using this command. Next, we have docker push. So this command is used to push the image to the Docker Hub repository. That is nothing but export the image to the repository. Next, we have docker images. So here, this command lists down all the docker images, whatever you have created in the docker. Then comes the docker rm. Docker rm is basically a command used to remove one or more docker containers. So when you run this command, docker stops the container and removes the container's file system from the host. This is useful when you're finished using the containers and want to remove to free up the space on your host. This was the function of docker rm. Next is the docker rmi. This command is used to remove one or more docker images. Don't get confused. Docker rm is used to remove the docker containers and docker rmi is used to remove the docker images. So here, when you run this command, so docker removes the images and any untagged parent images that were referenced by the deleted image. So if you have any sub images, like you have a parent image and a child image, so if you delete the child image, then automatically the parent image will get deleted. Here you can also remove multiple image at once by providing a list of IDs. You just need to type docker rmi and you need to specify all the image IDs which will remove all at once. It is important to note that removing an image can cause problems if image is being used by other containers or if the image is the parent of other images. Be careful while you are using the docker rmi and make sure that you understand the consequences of removing it. So if you delete a particular image which is relatable to other containers or images, then it will affect to those containers and images. So make sure that before deleting an image, you should be aware of the consequences. Last, we have the docker build. Here, the docker build command is used to build image from the docker file. So here, the basic syntax of docker build is like you write docker build and you then specify a path and the URL, where path of the directory containing that particular docker file and the context, and URL is the URL of the Git repository, which indicates that docker file should be read from a standard input. So these were some of the basic and important docker commands which are used while creating image or working with docker. These comments, it is very easy for you to work with docker. Well, this was all about Docker. We got to know about the architecture, and we also saw some of the Docker commands. Now let's use these Docker commands and create our own project and see how they run. So now for running our project, we will be using the Linux environment. Let's quickly switch to Ubuntu server, and here we will create a Java project, and through that we will create images, and then we'll try to run that Java project. So for that we will just open our terminal. So as I said, we will be working on the different commands, whatever we had discussed in this slide. So we will work with all the commands over here, and we'll see how the Docker works. So let us start with our first command, that was the Docker version. So let's type down docker -v. This tells you the Docker version. Now let's log into our Docker account. So you just need to type down docker login, and then you need to give your username and password. Like you're not able to log in from the terminal, you will get an option here to log in through this Docker Hub. So they directly give you the link to log in. So you just open link or from the terminal, and you can head over. Automatically gets open on the your web browser. So here, once you come here, it will here you can log into your account. So I have already logged into my account. So these are some of the containers which I had created before. From here also you can log in, whereas I also log in from the terminal itself. Now let's quickly go on with our demo. As I said, we will be creating a Java project. So now let's move into our Docker folder which we had created. So let's type down cd docker. So now once you're in the folder, now as we are creating a Java project, so let's create one more folder into it where we will specify it as a Java project, mkdir Java project. Now we'll enter to this folder and we'll then start creating our Java project. Let's quickly get into it. So let's move on to our Java project folder. For this, we need to just type cd project Java project, enter into that folder. Now here we'll be creating our Java project. So we will be using the VS Code itself to create our Java project over there. So let's open our VS Code. You just need to type code space dot, and it automatically opens your VS Code. So here we will be creating a Java project and also our Docker file so that we can send the whole file to our Docker. So first let's create a Docker file. So our Docker file has been created. Now before adding the commands or the information in the Docker file, so first we'll create our Java project. So let's quickly open new file, name it as Java demo.java, and let's open it. We'll start with our classes. Class. So let us name it as class test. Then we will use our main method, that is public static void main, and we'll define the strings dot args. Inside this we will use this system.out.println code, and inside we will just write welcome to Java. Now let us add some methods to make the project look more interesting. So we will just add public static void print system properties, and now we will print the properties. We'll type this out command, that is system.out.println, and inside this we'll write the printing properties. You can name it your way, the way you design it. So it's just a simple program just to see how we can run these in Docker. So it's totally on you. Now, as we are using the properties method, so we need to get the properties. So how do we use it? We use the system class, that is system dot get properties. And now we'll specify it. Properties prop is equal to, we have called the method. Now how do we print it? We'll use the same sort command to print the properties. So system dot println and props. Now we will call this in our main method print system properties. Now let's save it and now let's run the command. Here now our Java project has been created. Now let's quickly run this on the terminal. Let's see how does it run. So we'll just quickly run this. Here, as you can see, enlarge this. You can see here. So what we had printed are welcome to Java project and the printing properties, and they have extracted all the properties of Java, the whole version, whatever properties of Java are there, and they have just printed over here. Our Java project is created and it has run successfully. Now put this whole project into Docker and let's run them through the Docker engine. Now for that we need to first create a Docker file. So let us just name it as docker java.docker file. And now here we need to give all the commands to run the project. So now here we need to first create the image. So we'll first need to give the base image. So let us give them the base image from base image. So here you need to specify what is your base image, that is your the JDK. So here you can also specify the JDK version if you want to, whereas it would be fine if you don't mention also, it will take it automatically. Now it's time to create a work directory where our Docker file will be stored. So let's create a work directory. For that we write work dir, and then now we need to give the path. So here you can see Docker and Java project folder is there. So we will take that path itself here and we will specify it Docker / Java project and / my app. Now our next step is to copy the whole file into this directory. So how do we do that is you just need to type copy. So here we'll just put a dot, which means that it will copy all the files from the source, and now we need to provide them the destination, which is Docker Java project. After this we will run few commands through Docker. Now we'll add some commands like run Java C and our Java project name, that is Java test.java. After we use the run command, we need to use one more command, that is entry point, and here we will specify Java, and after that we will also specify our class name, that is test, and then let's save it. Now once this is done, now we need to run this project through our Docker. So for that we will go back to our terminal, and here what we will do is first we need to create an image. So for that we'll type docker build and give the image name as java test image and dot. So it will take some time. Here you can see it has copied all the files and the Java project, whatever it has to be taken, and the Docker file which had to be extracted, and it has created into an image. So now let us see whether it is listed in our images or no. For that we will just type docker images, and here you will see the list of images being created in this Docker repository. So here, as you can see, we had recently created Java test image. After this, we will now run this image that will get converted into a container and then it executes. So for that, we will type docker run and Java test image. So here you can see our Java project has been executed successfully. So while we had run previously, so it had shown welcome to Java, then your properties, the printing properties, and here you can see all your properties which are mentioned over here. So this is how you build images through Docker, and then you containerize it and then execute this. Let's run few more commands. So now we had seen the list of images. Now let's see the list of Docker containers. For that, you just type docker ps. So this mentions you the running containers. So currently there are no containers. Now let's see all the containers which have been created. So here you can see there are almost a lot Docker containers, and our Docker container which we had recently created has been also specified here. So now if you want to remove a container, for instance, we can remove this Java image. For that, we will just write docker rm and we will specify the container name, that is Java image. Try to remove Java project. So here you can see your Java project has been removed. If you want to see in the list, so here you won't find your Java project. So here there were 3 Java projects. Now if you wish to remove an image, what you need to do? For that, you need to just type docker rmi, that is remove image, and you specify the image name, that is, let's take any image. Let's run. So here you can see the test image has been removed. Now let's see, check in the list. So here you can see your test image has been removed successfully. This is how you work with Docker.
With the ever-changing requirements of modern software development, it is known that Kubernetes is one such system that will fulfill these needs. If you are someone who wants to get started with Kubernetes, you're definitely in the right place. Let us start off by understanding what it really is with the help of a simple example. Imagine you're building a web application. So within this web application, the structure might be monolithic. It might comprise several modules, components, or even layers. But externally, it is a single web application, or you could also say it is a single service. Despite having different modules, the application is built and deployed as one service for all platforms, that is desktop, personal computer, mobile, etc., within a single container that is a virtual machine. Let us assume the web application grows over time and becomes large. It is now extremely challenging to make changes over the code accurately. Also, the size of the application can slow down the startup time. Moving on, what if you want to add new updates to this web application? You must redeploy the entire application as one. And during this process, in case you stop and try to restart the service, the customers on your website will not be able to access anything for that period of time, which could eventually lead to a potential loss of money. Also, bugs in any one of the components can bring down the entire process. And since all the components of the application are identical, bugs can definitely impact the availability of the application. Now, what if you have a sudden spike in traffic and have to serve 20 times the number of your usual customers? In such a situation, you have to very quickly deploy new servers, which takes a lot of effort. Later, when traffic dies down to a normal level, you now have 20 times the number of your usual servers. It can also be challenging to scale when different modules have conflicting updates or resource requirements. So instead of creating a monolithic application, we can define each component as a separate, loosely coupled service. And then we could virtualize each of these services using a Docker container. Not only can the application start easily, but the services can also be deployed independently. With Docker containers, we can easily scale any number of instances up and down according to the application's requirements, but this is definitely easy to manage when we're dealing with just 3 or 4 containers. Now, let's say we had to deal with 1,000 such containers. How do we really keep track of the containers that are healthy and the ones that are not? Orchestrating and managing these containers at the same time can be an extremely tedious task. And this led to the need for container orchestration tools. So this is where Kubernetes comes into the picture. Kubernetes was originally designed by Google and is now maintained by the Cloud Native Computing Foundation. With Kubernetes, you package your website files as containers or pods, which you can run on any instance in your Kubernetes cluster. As you can see, pods are running on nodes, which are physical systems having hardware components that are a part of the Kubernetes cluster. This implies that every service that you create runs on separate containers, and this will allow you to work and manage services independently. Pods can be running on any available node in the cluster, which has enough resources for a pod to work. In simple words, Kubernetes is an open source system for automating deployment, rolling updates, scaling services, and managing containerized applications. Kubernetes works with Amazon EC2, Rackspace, GCP, IBM Cloud, etc. Also, hypergrowth companies like GitHub, Weaveworks, CloudBoost, Walmart are becoming acclimated to building, shipping, and managing containers via Kubernetes. On average, anyone with Kubernetes knowledge can expect to earn between 5 to 6 lakhs per annum in India, whereas they can expect an average salary of $140,000 per annum in USA. As the Fortune 500 are using Kubernetes, the demand for expertise in this field is rapidly increasing, which in turn requires IT professionals who can work on this tool. So what are you waiting for? Begin your journey with Edureka's interactive Kubernetes certification training that is curated to help you learn how to set up your own Kubernetes cluster, configure networking between pods, and secure the cluster against unauthorized access.
Why do we need Kubernetes? Now, to understand why do we need Kubernetes, let's understand what are the benefits and drawbacks of containers. Now, first of all, containers are good. They are amazingly good, right? Any container for that matter of fact, a Linux container or a Docker container or even a Rocket container, right? They all do one thing. They package your application and isolate it from everything else, right? They isolate the application from the host mainly. And this makes the container fast, reliable, efficient, lightweight, and scalable. Now, hold your thought. Yes, containers are scalable, but then there's a problem that comes with that. And this is what is the resultant of the need for Kubernetes. Even though containers are scalable, they are not very easily scalable. Okay, so let's look at it this way. You have one container, you might want to probably scale it up to 2 containers or 3 containers. Well, it's possible, right? It's going to take a little bit of manual effort, but yeah, you can scale it up. You're not going to have a problem. But then look at a real world scenario where you might want to scale up to like 50 to 100 containers. Then in that case, what happens? I mean, after scaling up, what do? You have to manage those containers, right? You have to make sure that they're all working, they're all active, and they're all talking to each other. Because if they're not talking to each other, then there's no point of scaling up itself. Because in that case, the servers would not be able to handle the loads if they're not able to talk to each other, correct? So it's really important that they are manageable when they are scaled up. And now let's talk about this point. Is it really tough to scale up containers? Well, the answer for that might be no. It might not be tough. It's pretty easy to scale up containers, but the problem is what happens after that. Okay. Once you scale up containers, you'll have a lot of problems. Like I told you, the containers first of all should have to communicate with each other because there are so many in number, and they work together to basically host the service, right? The application. And if they are not working together and talking together, then the application is not hosted and scaling up is a waste. So that's the number one reason. And the next is that the containers have to be deployed appropriately, and they have to also be managed. They have to be deployed appropriately because you cannot have containers deployed in just random places. You have to deploy them in the right places. You cannot have one container in one particular cloud and the other one somewhere else. So that would have a lot of complications. Well, of course it's possible, but yeah, it would lead to a lot of complications internally. You want to avoid all that. So you have to have one place where everything is deployed appropriately, and you have to make sure that the IP addresses are set everywhere and the port numbers are open for the containers to talk to each other and all these things. right? So these were the two other points. The next point, or the next problem with scaling up, is that auto scaling is never a functionality over here. Okay, and this is one of the things which is the biggest benefit with Kubernetes. The problem technically is there's no auto scaling functionality. Okay, there's no concept of that at all. And you may ask at this point of time, why do we even need auto scaling? Okay, so let me explain the need for auto scaling with an example. So let's say that you are an e-commerce portal, okay, something like an Amazon or a Flipkart, and let's say that you have decent amount of traffic on the weekdays, but on the weekends you have a spike in traffic. Probably you have like 4x or 5x the usual traffic. And in that case, what happens is maybe your servers are good enough to handle the requests coming in on weekdays, right? But the requests that come on the weekends, right, from the increased traffic, that cannot be serviced by your servers, right? Maybe it's too much for your servers to handle the load. And maybe in the short term it's fine, maybe once or twice you can survive, but there will definitely come a time when your server will start crashing because it cannot handle that many requests per second or per minute. And if you want to really avoid this problem, what do? You have to scale up. And now, would you ideally keep scaling up every weekend and scaling down after the weekend, right? I mean, technically, is it possible? Will you be buying your servers and then setting it up, and every Friday would you be again buying new servers, setting up your infrastructure, and then the moment your weekday starts, would you just destroy all your servers, whatever you built? Would that what you be doing? No, right? Obviously, that's a pretty tedious task. So that's where something like Kubernetes comes in. And what Kubernetes does is it keeps analyzing your traffic and the load that's being used by the container. And as and when the traffic is reaching the threshold, auto scaling happens, wherein if the servers have a lot of traffic and if it needs more such servers for handling requests, then it starts scaling up the containers on its own. There's no manual intervention needed at all. So that's one benefit with Kubernetes, and one traditional problem that we have with scaling up of containers. Okay, and then the one last problem that we have is the distribution of traffic. That is still challenging without something that can manage your containers. I mean, you have so many containers, but how will the traffic be distributed? Load balancing, how does that happen? You just have containers, right? You have 50 containers. How does the load balancing happen? So all these are questions we should really consider, because containerization is all good and cool. It was much better than VMs. Yes, containerization, it was basically a concept which was sold on the basis of scaling up, right? We said that VMs cannot be scaled up easily, so we told use containers, and with containers you can easily scale up. So that was the whole reason we basically sold containers with the tagline of scaling up. But in today's world, our demand is ever more that even the regular containers cannot be enough. So scaling up is so much or in so detail that we need something else to manage your containers. Correct? Do we agree there? We need something, right? And that is exactly what Kubernetes is. So Kubernetes is a container management tool. All right. So this is open source, and this basically automates your container deployment, your container scaling and descaling, and your container load balancing. The benefit with this is that it works brilliantly with all the cloud vendors, with all your public cloud vendors, all your hybrid cloud vendors, and it also works on premises. So that is one big selling point of Kubernetes, right? And if I should give more information about Kubernetes, then let me tell you that this was a Google developed product. Okay, it's basically a brainchild of Google. And that pretty much is the end of the story for every other competitor out there, because the community that Google brings in along with it is going to be huge. Or basically the head start that Kubernetes would get because of being a Google brainchild is humongous. And that is one of the reasons why Kubernetes is one of the best container management tools in the market, period. And given that Kubernetes is a Google product, they have written the whole product on Go language. And of course, now Google has contributed this whole Kubernetes project to the CNCF, which is nothing but the Cloud Native Computing Foundation, or simply Cloud Native Foundation, right? You can just call them either that, and they've donated their open source project to them. And if I have to just summarize what Kubernetes is, you can just think of it like this. It can group like a number of containers into one logical unit for managing and deploying an application or a particular service. So that's a very simple definition of what Kubernetes is. It can be easily used for deploying your application. Of course, it's going to be Docker containers which you will be deploying, but since you will be using a lot of Docker containers as part of your production, you will also have to use Kubernetes, which will be managing your multiple Docker containers, right? So this is the role it plays in terms of deployment. And scaling up, scaling down is primarily the game of Kubernetes. From your existing architecture, it can scale up to any number you want. It can scale down anytime. And the best part is the scaling can also be set to be automatic, like I just explained some time back, right? You can make Kubernetes Kubernetes would analyze the traffic and then figure out if the scaling up needs to be done or the scaling down can be done and all those things. And of course, the most important part, load balancing, right? I mean, what good is your container or group of containers if load balancing cannot be enabled, right? So Kubernetes does that also. And these are some of the points based on which Kubernetes is built. So I'm pretty sure you have got a good understanding of what Kubernetes is by now, right? A brief idea at least. If you have any doubts, then I would request you to put your comments or queries on the comment section below. All right, my Edureka team will get back to you at the earliest. So moving forward, let's look at the features of Kubernetes. Okay, so we've seen what exactly Kubernetes is, how it uses Docker containers or other containers in general. But now let's see some of the selling points of Kubernetes or why it's a must for you. Let's start off with automatic bin packing. When we say automatic bin packing, it's basically that Kubernetes packages your application and it automatically places containers based on their requirements and the resources that are available. So that's the number one advantage. The second thing, service discovery and load balancing. There is no need to worry. I mean, if you're going to use Kubernetes, then you don't have to worry about networking and communication, because Kubernetes will just automatically assign containers their own IP addresses and probably a single DNS name for a set of containers which are performing a logical operation. And of course, there will be load balancing across them. So you don't have to worry about all these things. So that's why we say that there is service discovery and load balancing with Kubernetes. And the third feature of Kubernetes is that storage orchestration. With Kubernetes, you can automatically mount your storage system of your choice. You can choose that to be either a local storage or maybe on a public cloud provider such as a GCP or AWS, or even a network storage system such as NFS or other things, right? So that was the feature number 3. Now, feature number 4, self-healing. Now, this is one of my favorite parts of Kubernetes. Actually, not just Kubernetes, even with respect to Docker Swarm, I really like this part of self-healing. What self-healing is all about is that whenever Kubernetes realizes that one of your containers has failed, then it will restart that container on its own, right? It will create a new container in place of this crashed one. And in case your node itself fails, then what Kubernetes would do in that case is whatever containers were running in that failed node, those containers would be started in another node, right? Of course, you would have to have more nodes in that cluster. If there's another node in the cluster, definitely room would be made for this failed container to start its service. So that happens. So the next feature is batch execution. So when we say batch execution, it's that along with services, Kubernetes can also manage your batch and CI workloads, which is more of a DevOps role, right? So as part of your CI workloads, Kubernetes can replace your containers which fail, and it can restart and restore the original state. That is what is possible with Kubernetes. And secret and configuration management. That is another big feature with Kubernetes. And that is the concept of where you can deploy and update your secrets and application configuration without having to rebuild your entire image and without having to expose your secrets in your stack configuration or anything, right? So if you want to deploy and update your secrets, only that can be done. So it's not available with all the other tools, right? So Kubernetes is one that does that. You don't have to restart everything and rebuild your entire container. That's one benefit. And then we have horizontal scaling, which of course you people might be aware of already. You can scale your applications up and down easily with a simple command. The simple command can be run on the CLI, or you can easily do it on your GUI, which is your dashboard, your Kubernetes dashboard, or auto scaling is possible, right? Based on the CPU usage, your containers would automatically be scaled up or scaled down. So that's one more feature. And the final feature that we have is automatic rollbacks and rollouts. Now, Kubernetes, what it does is whenever there's an update to your application which you want to release, Kubernetes progressively rolls out these changes and updates to the application or its configurations by just ensuring that one instance after the other is sent these updates. And it makes sure that not all instances are updated at the same time, thus ensuring that, yes, there is high availability. And even if something goes wrong, then the Kubernetes will roll back that change for you. So all these things are enabled, and these are the features with Kubernetes. So if you're really considering a solution for your containers, for managing your containers, then Kubernetes should be your solution, right? So that should be your answer. So that is about the various features of Kubernetes. Now, moving forward, here let's talk about a few of the myths surrounding Kubernetes. And we are doing this because a lot of people have confusion with respect to what exactly it is. So people have this misunderstanding that Kubernetes is like Docker, which is a containerization platform, right? That's what people think. And that is not true. So this kind of a confusion is what I intend to solve in the upcoming slides. I will talk about what exactly Kubernetes is and what Kubernetes is not. Let me start with what it's not. Now, the first thing is that Kubernetes is not to be compared with Docker because it's not the right set of parameters which you're comparing them against. Docker is a containerization platform and Kubernetes is a container management platform, which means that once you have containerized your application with the help of Docker containers or Linux containers, and when you are scaling up these containers to a big number like 50 or 100, that's where Kubernetes would come in. When you have like multiple containers which need to be managed, that's where Kubernetes can come in and effectively do it. You can specify the configurations and Kubernetes would make sure that at all times these conditions are satisfied. So that's what Kubernetes is. You can tell in your configurations that at all time I want these many containers running, I want these many pods running, and so many other needs, right? You can specify much more than that. And whatever you do, at all times your cluster master or your Kubernetes master would ensure that this condition is satisfied. So that is what exactly Kubernetes is. But that does not mean that Docker does not solve this purpose. So Docker also have their own plugin. I wouldn't call it a plugin. It's actually another tool of theirs. So there's something called as Docker Swarm. And Docker Swarm does a similar thing. It does container management, like mass container management. So similar to what Kubernetes does, when you have like 50 to 100 containers, Docker Swarm would help you in managing those containers. But if you look at who is prevailing in the market today, I would say it's Kubernetes because Kubernetes came in first. And the moment they came in, they were backed by Google and they had this huge community which they just swept along with them. So they have like hardly left any market for Docker and for Docker Swarm. But that does not mean that they are better than Docker because they are at the end of the day using Docker. So Kubernetes is only as good as what Docker is. If there are no Docker containers, then there's no need for Kubernetes in the first place. So Kubernetes and Docker, they go hand in hand. Okay, so that is the point you have to note. And I think that would have also explained the point that Kubernetes is not for containerizing applications, right? And the last thing is that Kubernetes is not for applications with a simple architecture. Okay, if your architecture, if your application's architecture is pretty complex, then you can probably use Kubernetes to uncomplex that architecture. Okay, but if you're having a very simple one in the first place, then using Kubernetes would not serve you any good, and it could probably make it a little more complicated than what it already is, right? So this is what Kubernetes is not. Now, speaking of what exactly Kubernetes is, the first point is Kubernetes is robust and reliable. Now, when I say robust and reliable, I'm referring to the fact that the cluster that is created, the Kubernetes cluster, right? This is very strong. It's very rigid and it's not going to be broken easily. The reason being the configurations which you specify, right? At any point of time, if any container fails, a new container would come up, right? Or that whole container would be restarted. One of the things will definitely happen. If your node fails, then the containers which are running in a particular node, they would start running in a different node, right? So that's why it's reliable and it's strong because at any point of time, your cluster would be at full force. And at any time, if it's not happening, then you would be able to see that something's wrong and you have to troubleshoot your node and then everything would be fine. So Kubernetes would do everything possible and it pretty much does everything possible to let us know that the problem is not at its end and it's giving the exact result that we want. That's what Kubernetes are doing. And the next thing is that Kubernetes actually is the best solution for scaling up containers, at least in today's market, because the two biggest players in this market are Docker Swarm and Kubernetes. And Docker Swarm is not really the better one here because they came in a little late. Even though Docker was there from the beginning, Kubernetes came after that. But Docker Swarm, which we are talking about, came in somewhere around 2016 or 2017, right? But Kubernetes came somewhere around 2015. And they had a very good head start. They were the first ones to do this. And their backing by Google is just icing on the cake because whatever problem you have with respect to containers, if you just go up and if you put your error there, then you will have a lot of people on github.com and GitHub queries and then on Stack Overflow who will be resolving those errors, right? So that's the kind of market they have. So it's backed by a really huge community. That's what Kubernetes is. And to conclude this slide, Kubernetes is a container orchestration platform and nothing else. All right. So I think these two slides would have given you more information and more clarity with respect to what Kubernetes is and how different it is from Docker and Docker Swarm, right? If you guys still have any doubts, then I would request you to put your comments in the comment section below and my team will get back to you at the earliest. Okay, so now moving on, let's go to the next topic where we will compare Kubernetes with Docker Swarm. And we are comparing with Docker Swarm because we cannot compare Docker and Kubernetes head on. Okay, so that is what you have to understand. If you are this person over here If you are Sam who is wondering which is the right comparison, then let me reassure you that the difference can only be between Kubernetes and Docker Swarm. Okay, so let's go ahead and see what the difference is actually. Let's start off with your installation and configuration. Okay, so that's the first parameter we'll use to compare these two. And over here, Docker Swarm comes out on top because Docker is a little easier. You have around 2 or 3 commands which will help you have your cluster up and running. That includes the node joining the cluster, right? But with Kubernetes, it's way more complicated than Docker Swarm, right? So you have like close to 10 to 11 commands which you have to execute, and then there's a certain pattern you have to follow to ensure that there are no errors, right? Yes, and that's why it's time consuming and that's why it's complicated. But once your cluster is ready, that time Kubernetes is the winner, because the flexibility, the rigidness, and the robustness that Kubernetes gives you cannot be offered by Docker Swarm. Yes, Docker Swarm is faster, but yes, not as good as Kubernetes when it comes to your actual working. And speaking of the GUI, once you have set up your cluster, you can use a GUI with Kubernetes for deploying your applications, right? So you don't need to always use your CLI. You have a dashboard which comes up, and the dashboard, if you give it admin privileges, then you can use it. You can deploy your application from the dashboard itself. Everything just drag and drop, click functionality, right? With just click functionality, you can do that. The same is not the case with Docker Swarm. You have no GUI in Docker Swarm, okay, period. So Docker Swarm is not the winner over here. It's Kubernetes. And yes, going to the third parameter, scalability. So people again have a bad misconception that Kubernetes is better. It is the solution for scaling up, and it is better and faster than Docker Swarm. Well, it could be better, but yes, it's not faster than Docker Swarm. Even if you want to scale up, right, there's a report where I recently read that the scaling up in Docker Swarm is almost 5 times faster than the scaling up with Kubernetes. So that is the difference. But yes, once your scaling up is done, after that, your cluster strength with Kubernetes is going to be much stronger than your Docker Swarm cluster strength. That's again because of the various configurations that should have been specified by then. That is the thing. Now, moving on to the next parameter we have is load balancing. Requires manual service configuration. Okay, this is in case of Kubernetes. And yes, this could be a shortfall, but with Docker Swarm, there is inbuilt load balancing techniques, which you don't need to worry about. Okay, even the load balancing, which requires manual effort in case of Kubernetes, is not too much. There are times when you have to manually specify what are your configurations. You have to make a few changes, but yes, it's not as much as what you're thinking. And speaking of updates and rollbacks, what Kubernetes does is it does the process scheduling to maintain the services while updating. Okay, yeah, that's very similar to how it works with Docker Swarm, wherein you have like progressive updates and service health monitoring happens throughout the update. But the difference is when something goes wrong, Kubernetes goes that extra mile of doing a rollback and putting you back to the previous state, right, before the update was launched. So that is the thing with Kubernetes. And the next parameter we are comparing those two upon is data volumes. So data volumes in Kubernetes can be shared with other containers, but only within the same pod. So we have a concept called pods in Kubernetes. Okay, now pod is nothing but something which groups related containers, right? A logical grouping of containers together. So that is a pod. And whichever containers are there inside this pod, they can have a shared volume, okay, like storage volume. But in case of Docker Swarm, you don't have the concept of pod at all. So the shared volumes can be between any other container. There is no restriction with respect to that in Docker Swarm. And then finally, we have this parameter called logging and monitoring. So when it comes to logging and monitoring, Kubernetes provides inbuilt tools for this purpose. Okay, but with Docker Swarm, you have to install third-party tools if you want to do logging and monitoring. So that is the fallback with Docker Swarm, because logging is really important. One, because you will know what the problem is. You'll know which container failed, what happened, where is exactly the error, right? So logs would help you give that answer. And monitoring is important because you have to always keep a check on your nodes, right? So as the master of the cluster, it's very important that there's monitoring. And that's where Kubernetes has a slight advantage over Docker Swarm. Okay, so that's my take on the difference between Kubernetes and Docker Swarm. And I would also love to hear what's your take on this, right? I would like to know if you would use Kubernetes or Docker Swarm, and I would also know why. If you prefer simplicity or if you prefer stability, that choice could be yours. And it's something that's arguable, right? It's a debatable topic. So I would like to hear what are your thoughts. So please drop in your comments at the bottom. We have a comment section, right? Our videos. So put it right there. And probably in one of our future videos, we will discuss about that. But before I finish this topic, there is this one slide I want to show you, which is about the statistics. So this stat, I picked it up from this platform 9. which is nothing but a company that writes about tech. Okay, and what they've said is that the number of news articles that were produced, right, in that one particular year had 90% of those covered on Kubernetes compared to the 10% on Docker Swarm. Amazing, right? That's a big difference. That means for every one blog written or for every one article written on Docker Swarm, there are 9 different articles written on Kubernetes. And similarly for web searches. For web searches, Kubernetes is 90% compared to Docker Swarm's 10%. And publications, GitHub stars, the number of commits on GitHub, all these things are clearly won by Kubernetes everywhere. So Kubernetes is the one that's dominating this market, and that's pretty visible from this stat also, right? So I think that pretty much brings an end to this particular topic. Now moving forward, let me show you a use case. Let me talk about how this amazing game called Pokemon Go was powered with the help of Kubernetes. I'm pretty sure you all know what it is, right? You guys know Pokemon Go. It's the very famous game, and it was actually the best game of the year 2017. And the main reason for that being the best is because of Kubernetes. And let me tell you why. But before I tell you why, there are a few things which I want to just talk about. I'll give you a overview of what Pokemon Go is, and let me talk about a few key stats. So Pokemon Go is an augmented reality game developed by Niantic for your Android and for iOS devices. Okay, and those key stats read that they've had like 500 million plus downloads overall and 20 million plus daily active users. Now that is massive. Daily, if you're having like 20 million users plus, then you have achieved an amazing thing. So that's how good this game is. Okay. And then this game was actually initially launched only in North America, Australia, New Zealand. And I'm aware of this fact because I'm based out of India and I did not get access to this game because the moment news got out that we have a game like this, I started downloading it, but I couldn't really find any link or I couldn't download it at all. So they launched it only in these countries. But what they faced, right, in spite of just releasing it in these 3 countries, they had like a major problem. And that problem is what I'm going to talk about in the next slide. Right, so my use case is based on that very fact that in spite of launching it only in these 3 countries or in probably North America and then in Australia and New Zealand, they could have had a meltdown, but rather with the help of Kubernetes, they used that same problem as the basis for their success. So that's what happened. Now let that be a suspense, and before I get to that, let me just finish this slide. One amazing thing about Pokemon Go is that it has inspired users to walk over 5.4 billion miles in a year. Okay, yes, do the math. 5.4 billion miles in 1 year. That's again a very big number. And it says that it has surpassed engineering expectations by 50 times. Now this last line is not with respect to the Pokemon Go, the game, but it is with respect to the backend and the use of Kubernetes to achieve whatever was needed. Okay, so I think I've spent enough time over here. Let me go ahead and talk about the most interesting part and tell you how the backend architecture of Pokemon Go was. Okay. So you have a Pokemon Go container which had 2 primary components. One is your Google Bigtable, which is your main database where everything is going in and coming out. And then you have your programs, which is run on your Java cloud, right? So these 2 things are what is running your game. MapReduce and Cloud Dataflow were something which was used for scaling up. Okay, so it's not just the container scaling up, but it's with respect to the application, how the program would react when there are these increased number of users and how to handle increased number of requests. So that's where the MapReduce is the paradigm comes in, right? The mapping and then reducing that whole concept. So this was their one deployment. Okay, and when we say into 5, it means that they had their server capacities which could go up till 5 times. Okay, so technically they could only serve X number of requests, but in case of failure conditions or heavy traffic load conditions, the max the server could handle was 5x. Because after 5x, the server would start crashing. That was their prediction. Okay, and what actually happened at Pokemon Go on releasing in just those 3 different geographies is that the moment they deployed it, the usage became so much that it was not X number of times, which is technically their failure limit, and it is not even 5x, which is the server's capability, but the traffic that they got was up to 50 times more than what they expected. So you know that when your traffic is so much, then you're going to be brought down to your knees. That's a definite and that's a given, right? This is like a success story and this is too good to be true kind of a story. And in that kind of a scenario, if the requests start coming in are so much that if they reach 50x, then it's gone, right? The application is gone for a toss. So that's where Kubernetes comes in and they overcome all the challenges. How do they overcome the challenges? Because Kubernetes can do both vertical scaling and horizontal scaling at ease. And that is the biggest problem, right? because any application and any other company can easily do horizontal scaling, where you just spin up more containers and more instances and you set up the environment. But vertical scaling is something which is very specific, and this is even more challenging. Now it's more specific to this particular game because the virtual reality would keep changing. Whenever a person moves around or walks around somewhere in his apartments or somewhere on the road, then the RAM, right, that would have to increase. The memory, the in-memory and the storage memory, all this would increase. So in real time, your server's capacity also has to increase vertically. So once they have deployed it, it's not just about horizontal scalability anymore. It's not about satisfying more requests. It's about satisfying that same request with respect to having more hardware space, more RAM space, and all these things, right? That one particular server should have more performance abilities. That's what it is about. And Kubernetes solved both of these problems effortlessly. And Niantic were also surprised that Kubernetes could do it. And that was because of the help that they got from Google. I read an article recently that the head of Niantic's lab, he met with some of the top executives in Google and in GCP, right? And then they figured out how things are supposed to go. And they, of course, met with the heads at Kubernetes and they figured out a way to actually scale it up to 50 times in a very short time. So that is the challenge that they were presented. And thanks to Kubernetes, they could handle 50 times the traffic that they expected, which is like a very one-off story and which is very, very surprising that, something like this would happen. So that is about the use case. And that pretty much brings an end to this topic of how Pokemon Go used Kubernetes to achieve something. Because in today's world, Pokemon Go is a really revered game because of what it could, right? It basically beat all the stereotypes of a game and whatever anybody could have anything negative against the game, right? So they could say that these mobile games and video games make you lazy, they make you just sit in one place and all these things, right? And Pokemon Go was something which was different. It actually made people walk around and it made people exercise. And that goes on to show how popular this game became. If Kubernetes lies at the heart of something which became so popular and something that became so big, then you should imagine how big Kubernetes or how useful Kubernetes is, right? So that is about this topic. As said before, Kubernetes master controls your nodes, and inside nodes, you have containers, okay? And now these containers are not just contained inside them, but they are actually contained inside pods, okay? So you have nodes inside which there are pods. And inside each of these pods, there will be n number of containers, depending upon your configuration and your requirement, right? Now, these pods which contain n number of containers are a logical binding or a logical grouping of these containers. Supposing you have an application X which is running in node 1, okay? So you will have a pod for this particular application, and all the containers which are needed to execute this particular application will be a part of this particular pod, right? So that's how pod works, and that's what the difference is with respect to Docker Swarm and Kubernetes, because in Docker Swarm, you will not have a pod. You just have containers running on your node. And the other two terminologies which you should know is that of replication controller and service. Your replication controller is the master's resource to ensuring that the requested number of pods are always running on the nodes, right? So that's like your confirmation or an affirmation which says that, okay, this many number of pods will always be running and these many number of containers will always be running, something like that, right? So you say it and the replication controller will always ensure that's happening. And your service is just an object on the master that provides load balancing across a replicated group of pods, right? So that's how Kubernetes works. And I think this is good enough introduction for you. And I think now I can go to the demo part, right, guys? If you guys have any doubts, I would request you to again put it in the comment section and my team will get back to you. And in the meanwhile, let me get to the final part of this video, wherein I will show you how to deploy applications on your Kubernetes via either your CLI or either via your YAML files or via your dashboard. Okay, guys, so let's get started. And for the demo purpose, I have two VMs with me, okay? So as you can see, this is my kube master, which would be acting as my master in my cluster. And then I have another VM, which is my kube node 1, okay? So it's a cluster with one master and one node, all right? Now, for the ease of purpose for this video, I have compiled the list of commands in this text document, right? So here I have all the commands which are needed to start your cluster and then the other configurations and all those things. So I'll be using these. I'll be copying these commands and then I'll show you side by side, and I will also explain when I do that as to what each of these commands mean. Now, there's one prerequisite that needs to be satisfied, and that is the master should have at least 2 core CPUs, okay, and 4 GB of RAM. and your node should have at least 1 core CPU and 4 GB of RAM. So just make sure that this much of hardware is given to your VMs, right? If you're using Ubuntu or a Linux operating system, well and good, but if you're using a VM on top of a Windows OS, then I would request you to satisfy these things, okay? These two criterias. And I think we can straight away start. Let me open up my terminal first of all. Okay, this is my node. I'm going back to my master. Okay, yes. So first of all, if you have to start your cluster, you have to start it from your master's end, okay? And the command for that is kubeadm init. You specify the pod network flag and the API server flag. We are specifying the pod network flag because the different containers inside your pod should be able to talk to each other easily, right? So that was the whole concept of self-discovery, which I spoke about earlier during the features of Kubernetes. So for the self-discovery, we have like different pod networks using which the containers would talk to each other. And if you go to the documentation, the Kubernetes documentation, you can find a lot of options there. You can use either a Calico pod or you can use a Flannel pod network. So when we say pod network, it's basically acronymed as CNI, okay, Container Network Interface, okay? So you can use either a Calico CNI or a Flannel CNI or any of the other ones. These are the two popular ones, and I will be using the Calico CNI, okay? So this is the network range for this particular pod, and this we'll have to specify over here, okay? And then over here we'll have to specify the IP address of the master. So let me first of all copy this entire line, and before I paste it here, let me do an if config and find out what is the IP address of this particular machine, of my master machine. The IP address is 192.168.56.101, okay? So let's just keep that in mind, and let me paste the command over here. In place of the master IP address, I'm going to specify the IP address of the master, okay, which I just read out. It is 192.168.56.101. And the pod network, I told you that I'm going to use the Calico pod, so let's copy this network range and paste it here. So all my containers inside this particular pod would be assigned an IP address in this range, okay? Now let me just go ahead and hit enter, and then your cluster would begin to set up. So it's going as expected. So it's going to take a few minutes, so just hold on there. Okay, perfect. My Kubernetes master has initialized successfully, and if you want to start using your cluster, you have to run the following as a regular user, right? So we have 3 commands which is suggested by Kubernetes itself, and that is actually the same set of commands that even I have here, okay? So I'll be running the same commands. This is to set up the environment, and then after that we have this token generated, right? The joining token. So the token along with the init address of the IP of the master, if I basically execute this command in my nodes, then I will be joining this cluster where this is the master, right? So this is my master machine. This has created the cluster. So now before I do this though, there are a few steps in the middle. One of those steps is executing all these 3 commands, and after that comes bringing up the dashboard and setting up the pod network, right? Mine is the Calico pod, so I'll have to set up the Calico pod, and then I have to also set up the dashboard. Because if I do not start the dashboard and this before the nodes, then the node cannot join, and I will have various other complications. So let me first of all go ahead and run these 3 commands one after the other, okay? Since I have the same commands in my text doc, I'll just copy it from there, okay? I'll say Control C, paste, enter, okay? And I'll copy this line. So remember, you have to execute all these things as regular user, okay? You can probably use your sudo, but yeah, you'll be executing it as your regular user. And it's asking me if I want to override the existing whatever is there in this directory. I would say yes, because I've already done this before. But if you are setting up the cluster for the first time, you will not have this prompt, okay? Now let me go to the 3rd line, copy this and paste it here. Okay, perfect. Now I've ran these 3 commands as I was told by Kubernetes. Now the next thing that I have to do is, before I check the node status and all these things, let me just set up the network, okay, the pod network. So like I said, this is the line, this is the command that we have to run to set up the Calico network, okay, to allow the nodes to join our particular network. So it will be copying the template of this calico.yaml file which is present over here in this docs, okay? So hit enter, and yes, my thing is created. Calico cube controller is created. Now I'll just go back here and see, at this point of time I can check if my master is connected to the particular pod, okay? So I can run the kubectl get nodes command, okay? this would say that I have one particular resource connected to the cluster, okay, name of the machine, and this role is master, and yeah, the status is ready. Okay, if you want to get an idea of all the different pods which are running by default, then you can do the kubectl get pods along with a few options. Okay, you should specify these flags, and they are all namespaces, and with the flag O specify wide. Okay, so this way I get all the pods which are started by default. Okay, so there are different services like etcd for kube controllers, for the calico node, for the etcd master. For every single service there's a separate container and pod started. Okay, so that's what you can understand from this part. Okay, that is the safe assumption. Now that we know the cluster is ready and the master is part of the cluster, let's go ahead and execute this dashboard. Okay, remember, if you want to use a dashboard, then you have to run this command before your nodes join in this particular cluster, because the moment your nodes join into the cluster, bringing up the dashboard is going to be challenging and it will start throwing errors. Okay, it will say that it's being hosted on the node, which we do not want. We want the dashboard to be on the server itself, right, on the master. So first let's bring the dashboard up. So I'm going to copy this and paste it here. Okay, enter. Great, my Kubernetes dashboard is created. Now the next command that you have to get your dashboard up and running is kubectl proxy. Okay, with this you'll get a message saying that it's being served at this particular port number. And yes, you are right now there. You can, if you access localhost, what was the port number again? Localhost, yeah, 127.0.0.1 is localhost. Okay, followed by port number 8001. Okay, yeah, so right now we are not having the dashboard because it is technically accessed on another URL. But before we do that, there are various other things that we have to access. I mean, we have to set. Okay, because right now we have only enabled the dashboard. Now if you want to access the dashboard, you have to first of all create a service account. Okay, the instructions are here. Okay, you have to first of all create a service account for your dashboard. Then you have to say that, okay, you are going to be the admin user of this particular service account, and you have to enable that functionality here. You should say dashboard admin privileges, and you should do the cluster binding. Okay, the cluster role binding is what you have to do. And after that, to join to that or to get access to that particular dashboard, we have to basically give a key. Okay, it's like a password. So we have to generate that token first, and then we can access the dashboard. So again, for the dashboard there are these 3 commands. Well, you can get confused down the line, but remember, this is separate from the above. Okay, so what we did initially is ran these 3 commands which Kubernetes told us to execute, and after that the next necessity was bring up a pod. So this was that command for the pod, and then this was the command for getting the dashboard up, and right after that run the proxy, and then on that particular port number it'll start being served. So my dashboard is being served, but I'm not getting the UI here. And if I want to get the UI, I have to create the service account and do these 3 things, right? So let's start with this and then continue. I hope this wasn't confusing, guys. Okay, I can't do it here, so let me open a new terminal. Okay, here I'm going to paste it, and yes, service account created. Let me go back here and execute this command where I'm doing the role binding. I'm saying that my dashboard should have admin functionalities, and that's going to be the cluster role. Okay, cluster admin, and then the service account is what I'm using, and it's going to be in default namespace. Okay, so when I created the account, I said that I want to create this particular account in default namespace. So the same thing I'm specifying here. Okay, dashboard admin created. Good. So let's generate the token that is needed to access my dashboard. Okay, before I execute this command, let me show you that once. So if you go to this URL, right, /API/v1/namespaces. Yep, let me show it to you here. Okay, so this is the particular URL where you will get access to the dashboard. Okay, login access to the dashboard, localhost 8001 API v1 namespaces /kubesystem/services/https Kubernetes dashboard :/proxy. Okay, remember this one. That is the same thing over here, and like I told you, it's asking me for my password, so I would say token, but let me go here and hit the command and generate the token. So this is the token. I'm going to copy this from here till here. I'm going to say copy, and this is what I have to paste over here. All right, so sign in and update. Yes, perfect. So this is my dashboard, right? This is my Kubernetes dashboard, and this is how it looks like. Whatever I want, I can get an overview of everything. So there is workloads. If I come down, there is deployments. I have option to see the pods, and then I can see what are the different services running among most of the other functionalities. Okay, so right now we don't have any bar graph or pie graph showing you which cluster is up, which pod is up and all, because I have not added any node and there is no service that is running, right? So I mean, this is the outlay of the dashboard. Okay, you will get access to everything you want from the left. You can drill down into each of these namespaces or pods or containers, right? Now, if you want to deploy something through the dashboard, right, through the click functionality, then you can go here. Okay, but before I create any container or before I create any pod or any deployment for that matter of fact, I have to have nodes, because these will be running only on nodes, correct? Whatever I deploy, they run only on nodes. So let me first open up my node and get the node to join this particular cluster of mine. Now, if you remember, the command to join the node got generated at the master end, correct? So let me go and fetch that again. So that was the first command that we ran, right? This one. So let's just copy this and paste this one at my node end. This is the IP of my master, and it will just join at this particular port number. Let me hit enter. Let's see what happens. Okay, let me run it as root user. Okay, perfect. Successfully established connection with the API server, and it says this node has joined the cluster, right? Bingo. So this is good news to me. Now if I go back to my master, and in fact if I open up the dashboard, there would be an option of nodes, right? So initially now it's showing this master. Master is the only thing that is part of my nodes. Let me just refresh it, and you would see that even node-1 would be a part of it, right? So there are two resources, two instances. One is the master itself and the other is the node. Now if I go to overview, you will get more details. If I start my application, if I start my service or containers, then all those would start showing up here, right? So it's high time I start showing you how to deploy it. To deploy it using the dashboard, I told you this is the functionality. So let's go ahead and click on this create. And yeah, mind you, from the dashboard is the easiest way to deploy your application, right? So even developers around the world do the same thing. For the first time, probably they create it using the YAML file, and then from there on, they start editing the YAML file on top of the dashboard itself, or they create or deploy the application from here itself. So we'll do the same thing. Go to create an app using functionality, click functionality, you can do it over here. So let's give a name to your application. I'll just say Edureka Demo. Okay, let that be the name of my application. And I want to basically pull an Nginx image. Okay, I want to launch an Nginx service. So I'm going to specify the image name in my Docker hub. Okay, so it says either the URL of a public image or any registry, or a private image hosted on Docker hub or Google Container Registry. So I don't have to specify the URL per se, but if you're specifying a Docker hub, if you're specifying this image to be pulled from Docker hub, then you can just use the name of the image which has to be pulled. That's good enough, right? Nginx is the name, and that's good enough. And I can choose to set my number of pods to 1 or 2. In that way, I will have 2 containers running in the pod, right? So this is done. And the final part is, actually without the final part, I can straight away deploy it, okay? But if I deploy it, then my application would be created, but I would just not get the UI. I mean, I won't see the Nginx service. So that I get the service, I have to enable one more functionality here, okay? The servers here, click on the drop down, and you will have external option, right? So click on external. This would let you access this particular service from your host machine, right? So that is the definition. So you can see the explanation here. An internal or external service can be defined to map an incoming port to a target port seen by the container. So Nginx, which would be hosted on one of the container ports, that could not be accessible if I don't specify anything here. But now that I've said access it externally on a particular port number, then it would get mapped for me. By default, Nginx runs on port number 80. So the target port would be the same, but the port I want to expose it to, that I can map it to anything I want. So I'm going to say 82. All right. So that's it. It's as simple as this. This way your application is launched with 2 pods. So I can just go down and click on deploy. And this way my application should be deployed. My deployment is successful. There are 2 pods running. So what I can do is I can go to the service and try to access the UI, right? So it says that it's running on this particular port number 82153. So copy this and say localhost 32153. Okay, hit enter. Bingo. So it says welcome to Jenkins, and I'm getting the UI, right? So I'm able to access my application which I just launched through the dashboard. It was as simple as that. So this is one way of launching or making a deployment. There are two other ways, like I told you. One is using your CLI itself, your command line interface of your Linux machine, which is the terminal, or you can do it by uploading the YAML file. You can do it by uploading the YAML file because everything here is in the form of YAML or JSON. Okay, that's like the default way. So whatever deployment I made, right, that also those configurations are stored in the form of YAML. So if I click on view or edit YAML, all the configurations I specified, the default ones have been taken. So I said the name should be Edureka Demo. That is what has been taken over here. That is the name of my deployment. Okay, so kind is deployment. The version of my API, it's this one, extension / v1 beta 1. And then under metadata, I have various other lists. So if you know how to write a YAML file, then I think it will be a little more easier for you to understand and create your deployment, because YAML file is everything about lists and maps. And these YAML files are always lists about maps and maps about lists. So it might be a little confusing. So probably we'll have another tutorial video on how to write a YAML file for Kubernetes deployment, but I would keep that for another session. Okay, let me get back to this session and show you the next deployment. Okay, the next deployment technique. So let me just close this and go back to overview. Okay, so I have this one deployment. Very good. Okay, so let's go to this. Yeah, so what I'll do is let me delete this deployment. Okay, or let me at least scale it down, because I don't want too many resources to be used on my node also, because I will have to show 2 more deployments, right? So I have reduced my deployment over here, and I think it should be good enough. Great. So let's go back to the Kube setup, this document of mine. So this is where we were, right? We could check our deployments, we could do all these things. So one thing which I might have forgotten is showing the nodes which are part of the cluster, right? So this is my master. Yeah, so I kind of forgot to show you this kubectl get node. So the same view that you got on your dashboard, you get it here also. I mean, these are the 2 nodes, and this is the name and all these things. Okay, and I can also do the kubectl get pods, which would tell me all the pods that are running. Edureka demo is the pod which I have started. Okay, this is my pod. Now if I specify with the other flags, right, with all namespaces and with wide, then all the default pods which get created along with your Kubernetes cluster, those will also get displayed. Let me show you that also, just in case. Okay, yeah, so this is the one which I created, and the other ones are the default deployments that come with Kubernetes. The moment you install set up the cluster, these get started. Okay, and if you can see here, this particular Edureka demo which I started is running on my node 1 along with this kube proxy and this particular Calico node. So these 2 services are running on master and node, and this one is running only on my node 1, right? You can see this, right? The Calico node runs both on my node over here and on my master, and similarly the kube proxy runs on my node here and on my master. So this is the one that's running only on my node. Okay, so getting back to what I was about to explain you, the next part is how to deploy anything through your terminal. Now to deploy your same Nginx application through your CLI, we can follow these set of commands. Okay, so there are a couple of steps here. First of all, to create a deployment, you have to run this command. Okay, kubectl create deployment Nginx, and then the name of the image that you want to create. This is going to be the name of your deployment, and this is the name of the image which you want to use. So Control C, and let me go to the terminal here. On my master, I'm executing this command, kubectl create deployment. Okay, so the deployment Nginx is created. If you want, we can verify that also over here. So under deployments, right now we have 1 entry, Edureka demo, and yes, now you can see there are 2, Nginx and Edureka demo. So this is pending. I mean, it would take a few seconds. So in the meanwhile, let's just continue with the other steps. Once you have created your deployments, you have to create the service. Okay, you have to say which is the node port which can be used to access that particular service, right? Because deployment is just a deployment. You're just deploying your container. If you want to access it, like I told you earlier, from your from your host machine or all those things, then you have to enable the node port. If you want to get your deployments on your terminal, you can run this command, kubectl get deployments. Okay, Nginx also comes up over here, right? If you want more details about your deployment, you can use this command kubectl describe. You'll get like more details about this particular deployment as to what is the name, what is the port number it's residing on, and all these things. Okay, let's not complicate this. You can probably use that for your understanding later. So once that is done, the next thing that you have to do is you have to create the service on the nodes. You have created the deployment, but yes, create the service on the nodes using this particular command, kubectl create service and say node port. Okay, this means you want to access it at this particular port number. You're doing the port mapping 80 is to 80. Okay, container port 80 to the internal node port 80. Okay, so service for Nginx is created. And if you want to check which of the deployments are running in which nodes, you can run the command kubectl get svc. Okay, this would tell you, okay, you have two different services, Edureka Demo and Nginx, and they are running on these port numbers and on these nodes, right? So Kubernetes is the one which got created automatically. Edureka Demo is the one which I created. Okay, Nginx is again the one which I created. Kubernetes comes up on its own. I'm just specifying to you because this is a container for the cluster itself. Okay, so let's just go back here, and then yes, and similarly, if you want to delete a deployment, then you can just use this command kubectl delete deployment followed by the name of the deployment. Right, it's pretty simple. You can do it this way. Otherwise, from the dashboard also you can delete it, like how I showed you earlier. Click over here and then you can click on delete, and then if you want to scale it, you can scale it. So both of these deployments of mine have one pod each, right? So let's do one thing. So let's just go to the Nginx service, and here let's try accessing this particular service. Localhost. Okay, perfect. Here also it says welcome to Nginx, right? So with this, you can understand that the port mapping worked, and by going to service, you will get to know on which port number you can access it on your host machine, right? So this is the internal container port mapped to this particular port of mine. Okay. Now, if not for this, if this doesn't work, you can also use the cluster IP for the same thing. Cluster IP is going to basically the IP using which all your containers access each other, right? So for your pod, you will have an IP. So whatever is running in your containers, that will again be accessible on your cluster IP. So it's the same thing, right? So let me just close these pages, and that's how you deploy an application through your CLI. So this comes to our last part of this video, which is nothing but deployment via YAML file. So for again deployment via YAML file, you have to write your YAML code, right? You have to either write your YAML code or your JSON code, correct? So this is the code which I've written, which is in YAML format, and in fact I already have it in my machine here. So how about I just do an ls? Yeah, there is deployment.yaml, right? So let me show you that. So this is my YAML file. Okay, so here I specify various configurations similar to how I did it using the GUI, or I did it using the CLI. It's something similar. It's just that I specify everything in one particular file. Here, if you can see that I've specified the API version. Okay, so I'm using extensions dot slash b1 or beta 1. Okay, I can do this, or I can just simply specify version 1. I can do either of those. And then the next important line is the kind. So kind is important because you have to specify what kind of file it is. Is it a deployment file, or is it for a pod deployment, or is it for your container deployment, or is it the overall deployment? What is it? So I've said deployment, okay, because I want to deploy the containers also along with the pod. So I'm saying deployment. In case you want to deploy only the pod, which you realistically don't need to, okay, why would you just deploy a pod? But in case if you want to deploy a pod, then you can go ahead and write pod here and then just specify what are the different containers. Okay, but in my case, it's a complete deployment, right, with the pods and the services and the containers. So I will go ahead and write other things. And under the metadata, I will specify the name of my application. I can specify what I want. I can put my name also over here, like Vardhan. Okay, and I can save this. And then the important part is this spec part. So here is where you set the number of replicas. Do you remember I told you that there's something called as replication controller, which controls the number of pods that you will be running? So it is that line. So if I've set 2 over here, it means that I will have 2 pods running of this particular application of Vardhan. Okay, what exactly am I doing here? Under spec, I'm saying that I want 2 containers. So I've intended a container line over here, and then I have 2 containers inside. So the first container which I want to create is of the name front end. Okay, and I'm using an Nginx image. And similarly, the port number that this would be active on is container port 80. All right. And then I'm saying that I want a second container, and the container for this I could rename this to anything. I can say backend, and I can choose which image I want. I can probably choose a HTTPD image also. Okay, and I can again say the ports that this will be running on. I can say the container port that it should run on is port number is 88, right? So that's how simple it is. All right, and since it's your first video tutorial, the important takeaways from this YAML file configuration is that under spec you'll have to specify the containers and yes, everything in JSON format with all the indentations and all these things. Okay, even if you have an extra space anywhere over here, then your YAML file would throw an invalid error. So make sure that is not there. Make sure you specify the containers appropriately. If it's going to be just one container, well and good. If it's two containers, make sure you indent it in the right way, and then you can specify the number of pods you want to give a name to your deployment, and mainly establish these rules. Okay, so once you're done with this, just save it and close this YAML file. Okay, so this is your deployment.yaml. Now you can straight away upload this YAML file to your Kubernetes. Okay, and that way your application would be straight away deployed. Okay, now the command for that is kubectl create -f and the name of the file. Okay, so let me copy this, and then the name of my file is deployment.yaml. So let me hit enter. Perfect. So my deployment, the third deployment, Vardhan, is also created, right? So we can check our deployments from the earlier command, that is nothing but kubectl get deployments. Okay, it's not get deployment.yaml, sorry, it's get deployments. And as you can see here, there is an Edureka demo, there is Nginx, and there is Vardhan. And the funny thing which you should have noticed is that I said I want two replicas, right? Two pods. So that's why the desired is two. Currently we have two, up to date is one. So okay, up to date is two. Brilliant. Available is 0 because let's just give it a few seconds. In 23 seconds, I don't think the pod would have started. So let's go back to our dashboard and verify if there's a third deployment that comes up over here. Okay, perfect. So that's how it's going to work. Okay, so probably it's going to take some more time because the container is just restarting. So let's just give it some more time. This could well be because of the fact that my node has very less resource, right? So I have too many deployments. That could be the very reason. So what I can do is I could go ahead and delete other deployments so that my node can handle these many containers and pods, right? So let me delete this particular deployment, Nginx deployment, and let me also delete this Edureka demo deployment of mine. Okay, now let's refresh and just wait for this to happen. Okay, so what I can do instead is I could have a very simple deployment, right? So let me go back to my terminal and let me delete my deployment. Okay, and let me redeploy it again. So kubectl delete deployment. Okay, so Vardhan, this deployment has been deleted. Okay, so let's just clear the screen and let's do gedit of the YAML file again. And here let's make things simpler. Let me just delete this container from here. Let me save this. All right, and close this. Now let me create a deployment with this. Okay, so Vardhan is created. Let me go up here and refresh. Let's see what happens. Okay, so this time it's all green because it's all healthy. My nodes are successful, or at least it's going to be successful. Container creating. Perfect. So two pods of mine are up and running, and both my pods are running, right? And both are running on node 1. Pods 2 out of 2. Those are the two deployments, and replica set, and then services, right? So it's Nginx, which is the base image which is being used. So well and good. This is also working. So guys, yeah, that's about it, right? So when I tried to upload it, maybe there was some other error. Probably in the YAML file, there could have been some small mistake, or it could have been because my node had too many containers running. Those could have been the reasons. But anyways, this is how you deploy it through your YAML file.
Now let's talk a little bit about DevOps and cloud, or DevOps on cloud. Why do we need DevOps on cloud? Now understand that DevOps and cloud go hand in hand. They can be implemented individually, of course, but DevOps becomes twice as much efficient and beneficial when clubbed with the cloud. It can help an organization deliver new software features much faster in a more effective manner. Many organizations try to fix their application development processes by shifting from waterfall to DevOps. Now they have this understanding that DevOps alone won't be that effective. So public and private cloud solutions are now evolving together with DevOps. This brings in products at a faster rate to the market through quick access to development environment and streamlined developer processes. Infrastructure as code and automation together reduces the cloud complexity and maintenance of servers and resources, which our ops team previously was very concerned about. The security also highly increases with automated repeatable processes that serve to eliminate error that can cause further issues. And even more importantly, it builds security controls from the very beginning to the very end of the process. Now, because you don't have any servers and your continuous operations are cloud-based, it also eliminates a lot of downtime. And last but not the least, scalability, which is one of the most important factors for applications as they are developed. When DevOps and cloud are clubbed together, it reduces the cost of infrastructure, and global reach also increases with this. Now that you know why you need a cloud platform, let's go ahead and look at our cloud platform of choice today, which is AWS. So what is AWS? Now, back in the day, handling and storing data was way different than it is now. Companies preferred storing data using private servers, and that was obviously for security reasons. But however, with better usage of the internet, the trend has seen a paradigm shift for industries as they are moving their data to the cloud. Now, this enables companies to focus more on core competencies and stop worrying about storing and computation. For example, back in the day, if a streaming platform or a search engine platform, anything with a high volume database, suffered a corruption, it would take days before their operations resumed. They would face problems scaling up, and only then would they realize the need for a highly reliable, horizontally scalable, and distributed system is what they need. But now, with cloud services and public cloud platforms, this wouldn't be a problem. Now, since every company has started to adopt cloud services, it can be claimed that the cloud is the talk of the town, and AWS in particular is the leading cloud service provider in the market. AWS, which stands for Amazon Web Services, is an Amazon.com subsidiary which offers cloud computing services at an extremely affordable rates. Therefore, its customer base is strong and it targets everyone from individuals to startups to tech giants running the IT landscape. If you might wonder what cloud computing is basically the use of remote servers on the internet to store, manage, and process data, as opposed to an actual physical server or a personal computer to do the same. As we are talking about AWS, it is kind of an IaaS or infrastructure as a service, which basically gives you a server in the cloud that you have complete control over. In IaaS, you are responsible for managing everything starting from the OS completely up to the application you are running. So now that we have discussed about DevOps and AWS, let's move on to our CI/CD pipeline. Now, what is a pipeline or CI/CD pipeline? It's nothing but a series of steps that must be performed in order to deliver a new version of the software. At its bare bones, at its most basic, you have your build, test, and deploy stage. The CI/CD basically stands for continuous integration and continuous deployment. So CI is basically continuous integration, which basically means bringing together all the developers' working copies to a shared mainline. All the developers working on parallel branches of a certain upgrade of an application merge their changes into one main branch. And CD stands for continuous delivery and deployment. Now, while the CI includes building and testing of your application, continuous deployment is about the processes that have to happen after the code is integrated for the app to be delivered to the users. These processes involve testing, staging, and deploying the code. So at the end of this session, what we aim to do is build a CI/CD pipeline for our demo app on AWS. So for that, we will have to look at a few components of AWS. So DevOps, when implemented on AWS, becomes a lot more efficient and effective for a productive life cycle. And the steps that are involved in AWS DevOps are code commit, code pipeline, code build, code deploy, and optionally CodeStar. So first of all, we have AWS CodeCommit, which is a fully managed source control service, somewhat like GitHub, that hosts secure and highly scalable Git-based repository without the need of operating the system. It's mainly designed for developers who are supposed to store and version their code securely and reliably. For example, you have your IT administrators that store their scripts and configurations, and your web designers who can store their HTML pages and images, etc. The code commit is fully managed, has great availability, is secure, scalable, and pacens up your development lifecycle. For people not aware of code commit, think of it as versioning in your S3. But how it's different is that S3 supports versioning, but not collaborative file tracking features, which code commit obviously does. It manages batches of changes across numerous files made by multiple developers parallelly. How it works is that you create a repository in AWS CodeCommit service via the console or CLI, and later using Git from the development machine, you can run git clone to connect the local repository and the AWS CodeCommit repo. You can then modify your files on your development machine via the local repository and then run git add, git commit, and push it to the AWS CodeCommit repository as you do with GitHub. Again, like Git, even a Git pull can be used here to synchronize the files in AWS CodeCommit repository with your local repo, which ensures that you're working with the latest version of the files. Next on our list, we have AWS Code Pipeline, which is a combination of continuous integration and continuous delivery services for a quicker and more reliable infrastructure and application updates. It automatically builds, tests, and deploys a user code whenever there is a code change, and it is completely based on user-defined release process models. It also integrates with AWS services like AWS CodeCommit, Amazon S3, Code Deploy, Elastic Beanstalk, OpsWorks, and AWS Lambda. You can configure the pipeline either with your CLI or your graphical user interface. And like most services on AWS, even with pipeline, you only have to pay for what you use. All of this is great and all, but why should you use Code Pipeline? Simple. By automating your software build, test, and release processes, AWS Code Pipeline enables you to increase the speed and quality of your software updates by running all new changes through a consistent set of quality checks. It automates your release process, it speeds up your delivery with quality, it allows you to choose your tools of choice, establish consistent release processes, and provide a pipeline history detail as your source of truth. Code Pipeline basically breaks up your workflow into a series of stages like your source, build, test, and deploy, and gives you a revision option as a deployable content. Each stage can process only one revision at a time, even though multiple revisions can be processed in the same pipeline. And each stage will have at least one action to be performed, which is some kind of task performed on the artifact. Once all of the actions that are configured in a stage is complete, the stage is considered as complete. After a stage is complete, it transitions the artifacts created in that stage to the next stage of the pipeline, where you can manually enable or disable it, so it prevents changes from running through an entire pipeline. An approval action is granted only by the IAM user, and if an action fails, it does not transition to the next action or stage at all. So when a developer completes working on his code, he or she commits it to the source repository, and Code Pipeline automatically detects the changes and builds those changes. After that, the build code is deployed to the staging server for testing, and then additional tests such as integration or load tests are run by the Code Pipeline. Once all of the tests are run, if the code receives manual approval, then AWS Code Pipeline deploys the tested and approved code to the production instances. Also, every time when a user creates a pipeline, the Code Pipeline creates a folder for that pipeline in an S3 artifact bucket in that particular region to store input and output artifacts. Next on our list, we have AWS Code Build. Now, this is a fully managed build service in the cloud, which compiles your source code, runs unit tests, and produces artifacts that are ready to deploy. It eliminates the need to provision, manage, and scale your own build servers. It provides pre-packaged build environments for the most popular programming languages and build tools, and scales automatically to meet your peak build requests. Now, one prerequisite is that you must provide the AWS Code Build with a build project. which should include information as to where to get the source code from, build environment, build commands, and where to store the build output. How it works is that the code build will use the build project to create a build environment. AWS Code Build then downloads the source code from the build environment and performs tasks that you would specify in the build specifications. If there is any build output, the build environment uploads its output to the S3 bucket, and while the build is running, the build environment sends information to Code Build and CloudWatch logs. You can use the Code Build, Console, AWS CLI, or AWS SDKs to get summarized build information from Code Build and detailed build information from CloudWatch logs as well. Now that was all about Code Build. Now finally, let's talk about Code Deploy. Now AWS Code Deploy is a service that coordinates your application deployment and updates across the fleet of AWS EC2 of any size. It automates your code deployment to any instance, handles the complexity of updating them. It also avoids downtime during application development and rolls back automatically if failure is detected. Apart from that, it also integrates with third-party tools and AWS to make your job easier. It has 6 primary components to be specific. You have application revision, compute platform, deployment group, deployment configuration, and the code deploy agent. Now, the basic skeleton of how your deployment workflow pursues is as you can see on your screen. You basically create an application with a unique name and set up a deployment group by specifying the instances to which you want to deploy your application and the deployment type. If you're using the Lambda platform, you just deploy your deployment group's name, followed by which in your deployment configuration, you specify the success or failure condition of deployment and to how many instances you want to deploy parallelly. Then you upload the application specification file to the S3 and deploy your application as specified with the help of your code deploy agent, which is running on each instance on an EC2 platform, or as specified in your specification file to the deployment group when you're using a Lambda platform. And finally, you check your deployment results. And if you face any bugs or issues, you can always roll back and redeploy. Finally, let's discuss a little bit about CodeStar, which is basically a cloud-based development service that provides tools that you need to quickly develop, build, and deploy applications on AWS. It's basically a very templatized format where you start developing on AWS in certain minutes and you could choose from a variety of project templates. All of the software delivery is easily managed and you can work across your team very securely using the CodeStar. And apart from all of this, you also are provided with a project management dashboard to monitor your application continuously. All you have to do as an AWS CodeStar admin is create a project and add users. Your users or team members will commit changes, which in turn will be built and deployed. And through consistent monitoring of the application, if there are any updates required or any bugs, the developers take a decision, make updates, fix bugs, and then the loop closes back in on the team, and that's about it. The development process takes little to no time using CodeStar. Now that we have spoken about all of these different components of AWS DevOps, I hope building the CI/CD pipeline would seem a tad more tangible to you. If you're new learners, you can always sign up for a free tier, which is free for the entire year. Obviously, there are limitations to all of the services beyond which you shall be charged, but that rarely happens. So if you're starting out with AWS and want to try out all of its features and services, the free tier is a pretty good idea. We already have a video on how to create a free tier on the AWS console. If any of you want to know how to create a free account, you can just go ahead and check that out. So we're going to be building a CI/CD pipeline using AWS, using Code Pipeline, and I'll try to be as slow and verbose as possible, as comprehensive as possible, so as to help you guys to follow me each step of the way. So what we'll be doing here is that we'll be creating a demo application, platform as a service application, and we shall be deploying it using the Code Pipeline. So let's go ahead and create our application first. So to create an app, we will be using the Amazon Elastic Beanstalk, which basically has a bunch of templates ready for you. Now, since this is a demo about code pipeline and not web development, we'll be creating a pretty rudimentary app. So let's go ahead and type Elastic Beanstalk. Using Elastic Beanstalk, we can make simple apps very, very quickly. And if you have already created an application, created a few applications, they are going to appear right here on your screen. But since we have created no applications using this particular account, this is a screen that will greet you. So we're going to go ahead and click on Create Application. So let's call this Deployment App. We're not very original, are we? We're not going to put in any application tags. You could put them if you like, but currently they're completely unnecessary. On platform, let's pick PHP. And it automatically fills up the platform branching version with the latest ones available. Then I'm just going to be using the sample application code and click on Create Application. Now this is a platform as a service app. So basically, once I click on Create Application, I wouldn't have to worry about any background processes or creating the infrastructure. Elastic Beanstalk is going to do that for me on its own. And here it's going to show you all of the steps that are taking place, like create environment is starting, using Elastic Beanstalk as Amazon S3 storage bucket for environment data, so on and so forth. Now this will take some time, so let's go ahead and parallelly do something else. I'm going to open another tab. Now the AWS console. Okay, thankfully it did not ask me to sign in again. So while my app gets created, what I'm going to do is I'm going to create the pipeline. So I'm going to type in code pipeline. And the funda is simple even here, guys. You're just going to put in certain details and your pipeline will be created for you. Now this is your dashboard. This is where all of your recent pipelines will appear. Since in this free tier, we have no pipelines created, hence you have no results to display. So first things first, I'm going to create a pipeline. So click on this big orange button which says Create Pipeline. I'm going to give the pipeline a name. Let's just call it Demo Pipeline. So as a default, I'm just going to fill in a role name, AWS Code Pipeline, service role, US East, Demo Pipeline. Then click on Next. So for source provider, I'm going to use GitHub. And for that, I'll have to connect to GitHub. And it'll ask me to authorize the code suite. Okay. Okay, once you have successfully authenticated the account, you can go ahead and search for the repository. Here, I'm going to choose the demo-code deploy app, which is actually a sample app I have forked from the AWS code pipeline repository. You can go ahead and look for it as well. It will be available in the AWS code pipelines GitHub account. Yeah. And in the branch, let's select master branch and click on next. Now we move on to the build stage. Because I have nothing major to build, I'm just going to go ahead and pick skip build stage. Then you will be prompted with a notification which will ask you if you're sure to skip your build stage. Now, since I have nothing major to build, yes, I am going to skip this build stage. And for deployment, here we are going to choose a deploy provider. So here I'm going to use Elastic Beanstalk and put in my application name and my environment name. Now our application name was deployment app and our environment name would be deployment app environment. This is something which gets created automatically. So we're going to go ahead and click on next. And finally, we are at the review stage where you can go ahead and review all of the details that you have just put in for your code pipeline. And I'm just going to create this pipeline. It's pretty simple to do. Now this might take a few moments, so kindly be patient. And then you are greeted with a notification which says, success, congratulations, your pipeline has been created. Now here you can go ahead and release changes if you want. Our IAM role is in place that we had created earlier. Our pipeline is a success. Now all we have to do is wait for our application to get created, and then we can go ahead and deploy our application. All right, with that, our application has been created. It has OK health, and you can see the platform here. You can see the running version. You can see all the details, all the recent information regarding the app. Now, this is a platform as a service. It basically runs all of your processes in the background. Now, if you would have gone ahead, created this app, configured your IAM user, configured everything else that was needed, this would have taken you a lot of time. But because you are using a platform as a service feature of AWS, this entire process is automated and your work is simplified. So if you go down and look at the recent events, one thing you can see is your instance deployment is completed successfully. Just in the line above that, you can see that your new application was deployed to running EC2 instances. So basically an instance is running on EC2. So let's go ahead and go to EC2, click on instances running. There is one instance running, obviously, we all know which one that is. And this is your deployment app. Now if we go ahead and click on it, here you can see the instance state, it's running, and your pipeline, your source has succeeded, your deployment has succeeded. You go here, you can go down, take a look at your IAM role, your subnet ID. So with that, your instance has been deployed, and you realize that your demo pipeline has worked.
So why should you actually go ahead and consider this amalgamation of AWS and DevOps? I mean, I talked about AWS in particular, where I said that it is a popular cloud service provider which provides you with various services. DevOps again is an approach which lets you have a different look at building software applications. So why combine these two? Well, actually these two go very much hand in hand. I mean, AWS provides you with the meat or with the metal to actually go ahead and build the applications and support DevOps approach in a very good way. Let's try to understand how AWS and DevOps go well together. Again, this is a piece of text. I do not believe in general definitions. I like keeping things simple. So I'm going to talk about these things in a very simple perspective again. Let's try to understand these pointers straight away. Again, when you talk about AWS Cloud Formation, why do we need it? We've already discussed what DevOps is. That is, it supports continuous integration and deployment. That means you'd be developing, you'd be having various instances, you'd be dealing with a lot of resources. So how do you keep track of all these things? So there are two resources or two services that AWS has to offer to you, which would actually simplify your job a lot. Now, AWS Cloud Formation, what it does is it lets you create JSON templates basically. Those templates would let you kind of group your resources or the services that you use into a bundle so that you do not have to worry about keeping a track of all those things. In simple words or nutshell, that is what it does. It lets you have a template for your application which can be recreated again and again so that you do not have to do repetitive tasks, and your classification or your organization works actually becomes simplified. The other service which I also want to talk about is AWS CloudWatch. Now, it is something that lets you monitor your applications or your services in a much better way. That means whatever happens on AWS, it can be tracked by using AWS CloudWatch. So you know what happened at what time. That way you can keep track of all the developments that have taken place on your application building process. Then you have something called as AWS Cloud Pipeline. Or code pipeline rather, sorry. So what AWS code pipeline does is it actually helps you automate the process of deployment and again integration. That means you'd be having a pipeline which lets you put in data so that you can put that data or move that data to your instances, or in simple words, your servers, so that you can have replications and you can run various applications on various instances or servers parallelly. Now, for people who have worked in this domain, or for people who have worked maybe even on big data or something like that, they might have come across the process of pipelining, and they actually know how difficult it is to create pipelines. I mean, you have to write scripts for that. This is where AWS simplifies your job. It makes sure that pipeline creation is very easy, and that is why the process of DevOps becomes much easier with AWS. Again, AWS instances are something which are very important, and the reason they are important is you would be dealing with a lot of resources. So how do you do that? You have AWS instances which let you run any kind of machine, whether it's a Linux, Windows. You can actually go ahead and scale it up, scale it down the way you want to suit your needs. And this happens at mere clicks. I mean, think about just upscaling a particular instance. All you have to do is just go ahead and say that I need a larger instance, and AWS does that for you, and that too with minimal rates as well. So all in all, it is a win-win situation for you. That is why when you talk about AWS instances in particular, they play a very key role in building fault tolerant and scalable applications. So these are some of these services. Now, as I mentioned, some of the services, if you actually do go ahead and research AWS website, you'd have so many services that actually help you go ahead and perform DevOps with ease. And what AWS does is it lets you have all the DevOps approach incorporated into AWS, thus making AWS a very potent or a very powerful cloud service provider to have with you. And as I've mentioned, there are various other services as well, but these are some of the key ones which I wanted to focus on. And I hope that by talking about these things, I've justified my point as in why AWS DevOps forms a good combo. Now let's move further and try to understand AWS certified DevOps engineer, as in let's try to understand what would this particular individual do and why is this particular certification valued. Yes, when you talk about AWS certified DevOps engineer, well, if you've ever taken a look at how AWS certifications work, you'd realize that they have some associate level certifications, and DevOps on the other hand is an advanced level certification where you'd be expected to have advanced knowledge of maybe solution architecting, your admin roles, and your development roles. And once you combine these roles and then you move further, you get into advanced certification, which is called as DevOps. It brings in your operations, that is your admin team's approach, and your developers approach together. So you would be expected to go through the basic certifications and then combine them into this particular role. So if you talk about these individuals, they're actually responsible for maintaining, monitoring, and building applications. And probably you can actually go ahead and make careers in either of these individual domains as well, given the fact that if you are certified in this particular domain, you would be a well sought after resource rather. So what are the skills that you actually need to go ahead and do, or what are your responsibilities that you would be concerned with? Well, first and foremost, you are expected to implement and manage continuous delivery and deployment, which again is a key if you talk about DevOps. And then you need to understand how this implementation works, and you need to understand a very important process called as automation, because time is a constraint here and automation is something that helps you. Plus, as an individual, you need to have an understanding of what access rights you have, what access rights customers should have, and all those things, and accordingly you have to go ahead and build a particular application. Define and deploy monitoring metrics and logging systems. Yes, monitoring is an important part. As we move further, we would be discussing that as well, do not worry. And then you would be expected to build fault tolerant and scalable applications. Finally, it says that you should be able to design, manage, and maintain tools that help you automate and build these applications. And guys, an important point to note here is you should be actually having an understanding of doing all these things on AWS. And the reason you need to have an understanding of this particular thing is, as we move into the demo part, you'd be understanding how easy AWS makes DevOps approach. So guys, let's move further and do one thing. Let's just go ahead and see how we can use AWS to do something that relates to DevOps. Now guys, while I do go ahead and perform this particular demo, if I've missed out on certain pointers, that is, we haven't talked much about AWS certified DevOps administrator, so we would be discussing that as well. And parallelly, I would be going through certain pointers if I feel that I've missed out on talking about something. So let's quickly switch into the demo part and see how we can utilize AWS and DevOps together. So guys, this is what the AWS console looks like. For people who do not have an AWS account, I would suggest that you actually go ahead and create an account. AWS gives you a free tier account in which you have free tier limit where you can use certain AWS services for free for one complete year. Now again, I won't be getting into the details of how can you create an account. You can actually go ahead and take a look at the other videos that we have on YouTube, and you'd get a clear guidance as in what are the steps that you need to follow to create an account. Once you actually do go ahead and create this particular account, this is the management console that would be there at your disposal, and it actually does wonders. Let's walk through that first and then move further and take a look at the demo part as well. So these are the services that AWS has to offer to you. You can see that these services are structured or built in such a way that they meet particular needs. Like these are all the compute services that are there at your disposal. You have some blockchain services, you have management and governance services. You basically have your analytics services and various other services. Again, we would be dealing with code pipeline today, so let's stick to that. So let me give you a picture as to what we are going to do now. Firstly, we would be building an application. So we would be using a template application. To do that, we would be using Elastic Beanstalk. Now what Elastic Beanstalk is and why are we using it? Once we create the application, we would be having some 5 to 6 minutes of buffer where the application takes to build, and in that time we would be actually going ahead and discussing why we used EBS and all those things. Not EBS, Elastic Beanstalk. So once we have an application, I would be using code pipeline, and then I would be basically deploying my application to my instances. So guys, let's just go ahead and create an application first. To do that, either type Elastic Beanstalk here and you'd be having that, or you can just click on your history if you've used that in your recent times. So guys, this is what it looks like. I've refreshed my account so that it starts fresh. So you'd be getting started here, else it gives you the details about the applications that you've created. Having said that, let's just get started. So guys, creating an application in Elastic Beanstalk is very easy because it is platform as a service. When I say platform as a service, it provides you with a platform on which you have ready to use templates. You just have to put in your code or use the existing code to build an application. So the process becomes simplified. Again, this is where AWS comes into picture because it simplifies your task. We'll be talking about this particular thing in detail, but that is after we create the application. First, let's give it some name, say demo. It's a fairly odd name, but let's stick with it. Demo sample app is what I'm going to call it. Platform. Again, as I've told you, it's a platform as a service, so you get to choose a platform. So let's say we want to build it on maybe PHP. Do I need to use my code? Right now, I would be using a sample code so that it stays short and simple. You can actually go ahead and use your own codes as well if you have any plans. And then you just click on create. At times these processes take time, guys, because the reason it takes time is it would be summoning an instance, creating an instance, and as you can see there's a log here. It would be telling you what is happening in the background. So guys, what happens exactly here is an instance is created. Again, you have security groups that are associated with it, plus you have IAM users and all those things that happen in the background. So that is why this process takes a longer while. Now again, it being platform as a service. Now, if you all know what cloud computing service models are, you would understand that this particular service, that is a PaaS service, gives you a platform which is nothing but a ready to use template in which you have to put in certain details and then create an application. So again, if you were to create an application on your own, you'd be actually creating your own instance, your own security group, you'd be creating your own IAM user, and then you'd be putting in your code, and then you'd be developing an application. But this is where PaaS service comes into picture. It simplifies this process of creating application. It gives you ready to use or templatized platform which you can actually go ahead and use to build an application. Now again, this building process might take a longer while, guys. So let's move further and build a code pipeline meanwhile, or at least fill in certain details. So how do we do that? again, we come back, we click on services, and then we need code pipeline, which is here in my history. So I would be coming here and switching to this particular part. So meanwhile, our application is up and running, or it is getting created. What we are going to do is we are going to go ahead and try to create a pipeline. So how do we do that? We click on this icon, create pipeline. Okay. It says, do you want to use a new console? I do not want to. I would be happy with using my previous console as well. If you need a better experience, you probably want to switch into something new, you can do that as well. You can always have this option of coming back to this particular interface as well. So guys, pipeline settings, I need a pipeline name. So let's call it, say, sample pipeline. There you go. Now it would ask me, do you want to use an existing role? If you had one, you could have used that. If no, you can create one. So by default, that is the one, and this is the role name that it is creating. Allow AWS Code Pipeline to create a service so that it can be used with the new services what is asking, or the pipeline. Do you want to do that? I would say yes. Let's stick with it. And again, where do you want to store your artifacts? Well, for now, let's store it in the default location. When I say the default location, what it does is it probably creates a bucket if there's none, and then it stores data into it. You can actually go ahead and specify a particular bucket as well. In case if you have certain data that you've already created and put it in a bucket, you can actually go ahead and customize the location and change it here. For now, let's stick to the default one so that it creates a bucket for this particular job. And then I say next. Source provider, guys, we would be actually going ahead and deploying our application. So for that, I need a piece of code which I'm gonna go ahead and pick from GitHub. Now again, I happen to tumble or fall across a particular piece of code, and I would be using that. I'm not sure it is the best piece of code, but that should do my job for now. So let's just go ahead and say GitHub, because I want to pick it from there. Connect to GitHub. I have an account on GitHub, so I would be authorizing that account. It has authorized that account here, and again it would be asking me for that particular GitHub file or the repository. Now repository is nothing but a piece of code that is there, which you can actually copy and use for your own sake, or make a duplicate copy of it. So I'm actually gonna go ahead and make a copy of it. So I probably have this particular link here. I'm gonna copy it and paste it. Not worry guys, I would be sharing the link with you people as well. Once the session goes on YouTube, you can actually have that link as well. So this is what it says. It is some old account, that is why it says Vishal ServiceNow, because I used to work on ServiceNow back then. And again, branch, pick it from the master branch is what I would say. Yes, there you go. GitHub Webhooks, stick with it, no problem. So when I say next, an application would be created here. No, wait, we have to actually go ahead and give in a build stage. In this case, we don't need to do that. So I'm going to say skip. Yes. And I need to find a deployment provider, for which we are actually going ahead and creating an application. That is our AWS Elastic Beanstalk. There you go, guys. So that would be approved. Application name, ours is Demo Sample App, if I'm not wrong. Yes. And the environment is Demo Sample App, env. I hope I've entered this data correctly, but that is what it should be. Guys, let's check whether our application is up and running. I'm gonna refresh this particular piece of, yes, guys, it's green. That means the application has been loaded. Now again, one important point that I would like to mention is I talked about everything getting created in the background. So you can have information about everything that is happening, as in at what time, what happened. They've checked the environment health, as in whether the instances are up and running, whether the instance was launched successfully, how was the application, or what were the processes that were implemented, everything. See, it was waiting for EC2 instance to launch. Now that is a type of an instance which was launched. We would be taking a look at that as well. But see, it has notified saying that it might take few minutes. So meanwhile this was happening, we actually gone ahead and put in the details for our code pipeline. So guys, this application is up and running, and our code pipeline is also almost up and running or ready to go. So let's say next. It would give you a peek, as in, okay, these are the details that you've entered. Do you want to commit these details? And I would say, please create a pipeline. Guys, while it creates this particular pipeline, let's just go ahead and take a look at, okay, no, wait, I believe it has done the process quickly. So we can actually wait for half a minute maybe. So guys, first your source would get into picture and it would see whether the source jobs are done, that is getting in the GitHub repository and then actually going ahead and fetching in that particular repository. So it has done that. Now the next step is to deploy this particular application. So guys, meanwhile this application gets deployed on my instance, I would be showing you that, do not worry. Let's just take a look at something else. Now if you type AWS certified DevOps engineer, you come across Edureka's live. That is not something that you want to see. If you talk about AWS, this is the page I would want you to visit. For now it is in some other language. It asked me whether I wanted to translate it. I said no. You can actually go ahead and translate it to English if you know English. If you know this language, you can do that as well. So guys, here's the information where you can actually go ahead and find out as in, okay, what are the roles and responsibilities? How does the exam shape up? What are the what is the fees? How much time do you need to invest in all those things? So you can visit this website and get all the information. Again, if you're looking for a structured training, there are people who normally prefer structured training. In that case, you can actually go ahead and try out this website as well, where at Edureka we have this course, which would be, it has already been launched, but the first session would start somewhere in the end of the month, and you can actually go ahead and take this particular session. The fees is very less, and probably if you stay tuned with Edureka's channel, you might get more discounts as well, because this price is very real time. Again, you can get all the information as in what is the course curriculum and stuff like that, what are the topics that would be covered, duration and all those things. So if you want to take a structured approach, which is a very good thing to do if you want to actually go ahead and succeed in this certification, this won't be that bad of an option. Let's just go back and see whether our pipeline is up and running. As you can see guys, the code has been deployed. So you can actually go ahead and make changes to this particular stage, guys. When I say continuous deployment and integration, you can see you always have an option of editing, where you can actually go ahead and make changes to the piece of code that you've uploaded. You can actually go ahead and make changes to the storage, monitoring rules, and all those things, the IAM user that you've attached. So everything can be changed, and that is why AWS makes this DevOps process very feasible, because it helps you automate all these processes. So guys, now that our application is up and running and the code has been deployed, let's see whether it reflects. So how do we check? Well, you can just come here and click on this service, go to EC2. Probably there should be some instance that was launched by our application. You can see one instance is running. Demo sample. So this is our instance, guys. So if I just go ahead and copy this IP address here, if I just paste it here, if I click on it, it says congratulations, pipeline has been created and your instance through the S3 bucket has been deployed. Now there's one error here. It says 3 Amazon EC2 instances. The reason it does that is because, as I've told you, I've picked up a code from GitHub, and the fact that that person might have coded or hard coded this particular piece of application like that, or the notification like that. So you can actually just go ahead and go to your code pipeline, and you can make changes to the application that you've built. So I'm not going to go ahead and make changes to it, but I'm just going to tell you like how would you do that. I mean, what is the process that you actually need to do. So you can come here, you can say edit. You have this option of editing your source. You have your GitHub repository, which you can actually again go ahead and make changes. Suppose you have this particular session, you come here, you say edit. So you have your source, right? So again, this piece of code where, yeah, you've actually gone ahead and connected this particular thing. So this is where your repository lies, right? So this place, if you come here and you open your particular application, you'll realize that there's an index.html file. In that place, there must be code somewhere which says, okay, see, this is where the message has been displayed saying that this is what has happened. So you can actually make changes to the code, you can update it. And once you do that, you just come back here, you commit those changes, guys, and again, your continuous deployment, your integration, it continues. AWS CodeCommit. So you might be wondering as in what is the link? Now, DevOps being a popular approach and AWS being a popular cloud service, both were in demand or both are in demand. So when you talk about DevOps and when you talk about AWS, people wonder as in, can you implement or carry out this DevOps approach on AWS? Well, AWS responded to this request with plethora of services or a set of services basically that ensured that you could actually go ahead and carry out the process of continuous integration and deployment on cloud as well. And one of those services is AWS CodeCommit. Now, in the source code repository, where you actually go ahead and dump in your versions of codes. So when you talk about this repository, in general, you have something called as Git, which is a version control infrastructure. Now on it, you can actually go ahead and push and pull all your codes, or these codes or pieces of codes are called as repositories basically. So you can do that on Git. What AWS thought was, what if you could have this kind of version control device that is in-house or that is something that runs on the cloud platform? So they came up with a solution to this and they had their own version control device, which was called as AWS CodeCommit. Well, to go with the definition, when you take a look at AWS CodeCommit's definition, it is a version control service which is hosted by AWS that you can use to privately store and manage assets. When you talk about these assets, these can be documents, your source code, your binary files, and you can actually go ahead and do all these things in the cloud. So yes, as I've already mentioned, it is an in-house repository or infrastructure rather that lets you host or hold repositories. So yeah, this is what it does. It basically gives you an environment where you can actually go ahead and commit your code, push it, pull it. What are its benefits basically? Well, what it does is it lets you store any type of code. I mean, there are very less restrictions on the type and the extensions of codes that you store, and you can do that anytime. And the other benefit that happens here is it is highly secure. Your code that you push and pull, it is basically encrypted. So security is something that you do not have to worry about. It ensures collaborative work. Now, what do I mean by this? Now, when you talk about collaborative work, yes, I talked about CodeCommit where you can actually go ahead and push and pull your piece of code. So the fact that you can do it continuously and you can give proper access to people who can access this piece of code, who can make changes to it under different IAM users and under different security groups, this process becomes very collaborative, very engaging, and many people can work on it, commit on it, or comment on it rather, and actually go ahead and suggest quite a few things. Scale easily. Now that is the other benefit where the pieces of codes or your infrastructure that you have, when you talk about cloud platform and any service, it ensures scalability, and so does the amount of code that you push on this particular service. The best thing about it is it places your code in such locations or such places that it becomes very easy to integrate with your third-party tools as well. So guys, these are some of the benefits of using AWS CodeCommit. So guys, I've gone ahead and I've switched into my AWS console. So in this session, we are going to go ahead and create a repository on CodeCommit. We're going to push a piece of code. We're going to create a branch for it and probably commit certain changes to it as well. To do that, you have to set up your GitHub repository, or basically you have to set up your CodeCommit repository. So how do you do that? You have to go ahead and create an IAM user and a security group, or a group basically under which you can have those users which have particular access to these resources. So I'm going to create one single user which lies under one group only. Let us see how do you do that. To do that, first type IAM. You can search it here and hit the enter button. Once you do that, guys, there is something called as users here. Go there and say create a user. Let us call it CC, that is CodeCommit Demo, and I'm gonna give it AWS Management Console access only for now. It says create a group for that. Let's say okay, let's create one. So let's give it a name as well. Say CC underscore group, and we would need to select access policy. So AWS has some predefined policies. We can use those. I'm gonna give full access for now. If you are using maybe more secure data or something like that, you might want to customize your policies as well, which you can do. For now, let's stick to the basic one and say create group. So the group is created, guys. Now let us just go ahead and say next. Key value pair, I don't need it for now. Next again. And there you go, guys. A user is created. So when you actually go ahead and use this particular user, you can decide what kind of access do you want to have to your CodeCommit repositories. Do you want to access it by SSH? You can use SSH as well and HTTPS as well. So in this session, we are going to keep it simple, HTTPS. You can do it by SSH as well, but that is not for today's session. In the next session, probably we will be talking about how can you connect to your repository through SSH. So let's just go ahead and switch into the code commit service. So then you have your code commit basically. Guys, let us just go ahead and create a simple repository first. I say create. Let's name it, say, sample repository. I'm very bad at naming conventions, guys, so forgive me. And description for today's demo. The reason we put in these details is so that you can differentiate between different repositories, because while working on projects, you might have various repositories. I'm signed in as a root user, so I cannot SSH is what it says. We won't be doing that anyways. We're gonna go ahead and HTTP it for now. Here are the details. If you wish to avoid SSH, you can actually go ahead and go through the details as well. Or if you wish to don't want to go through all this process, you can learn more about it here basically. This is credential helper. Now our repository is empty, guys. We've just created a repository. So let's create a demo file for now. Let's say welcome to the session. Guys, there would be an actual code here. So this being a demo part, I won't be getting into the details. So this is not how the files look actually. Yeah, there you go. So guys, in our past 2 to 3 minutes, we've actually set up a code commit group user and we've created a repository, and now we are putting in data into that thing. So let's call this file, say, demo.txt. Author name, let's stick to my name. There you go. Just putting in a comment. And there you go, guys. My repository is created and there is a piece of code that has been pushed. It has been pushed to the master branch. You can create a pull request as well, guys, if you wish to. If you go to the repository, you can clone this particular piece of code as well. If you wish to clone HTTPS, SSH, you can do that as well. If you go to the repositories part, you would see this repository here, and you can actually go ahead and do quite a few other things as well. You can create branches of it as well. Say, for example, I come here and I say create a branch. Let's call it, say, demo branch 2, branch from master, and I say create a branch, and a branch would be created, guys, right away. You can select that, open that, and that too will have a demo text file, right? So if I just say edit it, I can come here and I can just go ahead and say changes were made. There you go. And let me just scroll down. Let's say author name is again my name, my email address, and I say commit changes. So there you go. You've actually gone ahead and made changes to the branch. This is my sample repository. You can switch here and you can actually go ahead and make changes to the master branch as well. And if you wish, you can actually go ahead and pull this particular piece of code and you can just compare it with your demo branch as well. Compare. It's mergeable, it says. You can actually go ahead and say create. Okay, so now if I just go back to the branches, I come to my master branch. It looks like this. And if I go to my sample branch, there you go. If I go to the repositories part and then to the branches, I can come here. I can see all the changes that are here. So if I actually go ahead and make changes to my master branch, which I did not do in this case, I just made changes to my sample repository. If you actually go ahead and go back and make changes to your master branch or any of the branches, and then you actually merge those two pieces of code, you can actually get the refreshed copy, whatever you're using. And the fact that you've put in your email IDs and stuff like that, you would be notified. You can even actually go ahead and create a notification group using your basically, you have groups here in AWS that let you actually go ahead and pass messages. You can use SNS and stuff like that, using which you can actually pass in messages as well, so that in case if certain changes are made, you would be notified in the form of those messages as well. So guys, there you go. In this session, we've actually gone ahead and created a repository. We've actually gone ahead and created a branch out of it, and we've made changes to the branch as well. And then I've actually shown you people as in how you can go ahead and merge the changes that are there and have the best copy with you so that you can actually go ahead and implement the freshest of copies that you wish to use. So guys, when you talk about AWS in particular, you have something called as AWS Code Pipeline, which lets you simplify this process. It lets you create a channel or a pipeline in which all these processes can be automated. So let's take a look at those processes as well. First, let's get through the definition part. Let's see what it has to say. I would be blankly reading this thing and then probably we'd be having the explanation part that follows. So as the definition says, it is a code pipeline, which is nothing but a continuous delivery service. We talked about continuous delivery already. And you can use the service to model, visualize, and automate certain steps required to release your software. Something that we've already discussed in continuous integration and delivery. So this is basically a continuous delivery service, which lets you automate all these processes. So as I mentioned, automating these processes becomes very important. So once you do use this service, these are some of the features it provides you. It lets you monitor your processes in real time, which becomes very important because we are talking about deploying softwares at a greater pace. So if this can happen at real time, I mean, if there is any change and if it is committed right away, probably you're saving a lot of time, right? You ensure consistent release process. Yes, as I've told you, deploying servers is a difficult task and time consuming task. If this can be automated, a lot of effort is saved. Speed up delivery while improving quality. Yes, we've talked about this as well. And view pipeline history details. Monitoring becomes very important, guys. So what code pipeline does is actually it lets you take a look at all the processes that are happening. I mean, if your application is built, it goes to the source, then it moves to the deployment. All these processes can be tracked in the pipeline. You get constant updates as in, okay, this happened at this stage. If anything failed, you can detect as in, okay, this is the stage where it is failing, maybe stage number 3, stage number 4. And accordingly, you can edit the stuff that has happened at that stage only. So viewing the pipeline history details actually helps a lot. And this is where code pipeline comes into picture. So this is what the architecture of code pipeline looks like. It's fairly simple. Guys, so some of this might seem a little repetitive to you people because the concepts are similar. The concepts which we discussed, those can be implemented by using code pipeline. So yes, I've talked about these things, but let's try to understand how the architecture works. And we would be using some other terms and discuss some terms in the future slides as well, which we've already talked about. But each of these services, they do this task a little differently or help you automate these processes. Hence the discussion. So let's see to how much level can we keep it unique, and let's go ahead with this discussion as well. So let's see how the code pipeline works. Basically, there are developers, as I've already mentioned, these developers would be working on various pieces of codes. So you have continuous changes and fixes that need to be uploaded. So you have various services. One of them is CodeCommit, which lets you have an initial source management system kind of a thing, which lets you basically take care of repositories and stuff like that. So it lets you directly connect with Git. I would be talking about Git, what Git is, but for people who know what Git is, if you have to manage your Git repositories, you have a service called as CodeCommit. So this is what happens if there are any changes, those go to the source, your developers can commit those changes there, and then it goes into the build stage. This is where all the development happens. Your source code is compiled and it is tested. Then it goes to the staging phase where it is deployed and tested. Now, when I say tested, these are some final tests that have to be implemented before the code gets deployed. Then it has to be approved manually. It has to be checked manually whether everything is in place. And finally, the code is deployed to the public servers where customers can use it. Again, if they have any changes, as I've mentioned, those can be readily taken from them and it goes back again to the developers and the cycle continues so that there is continuous deployment of code. This is another look at it. It is very simple, but this is more from AWS perspective. So if there are any changes that developers commit, those go to the source. Now your data is stored in a container called as S3, that is simple storage service in the form of objects. So if there is any change that has to happen, the data is either fetched from the storage container, which is S3, and the changes are built. And then again, a copy of it is maintained in the form of zip. As you can see here, there are continuous changes that are happening and those get stored in the S3 bucket. Now S3 should preferably be on the region or in the place where your pipeline is. That helps you carry out the process of continuous integration and delivery with ease. in case if you are concerned with multiple regions, you need to have a bucket at each region to simplify these processes. So again, here to the code gets to the source. It is probably submitted to the build stage where the changes happen. A copy is maintained at S3, and then it goes to the staging. Again, a copy is maintained, and then it gets deployed. So this is how the code pipeline works. And to actually go ahead and implement all the actions of code pipeline, you have a service or these services, that is your code deploy, build, and code commit in AWS. So these services actually help you carry out some or most of these processes that are there. Let's take a look at those services and understand what do they do. So first and foremost, you have your code deploy, code build, and code commit. So this is not the order in which you deal with these things. Now, these things actually help you in automating your continuous delivery and deployment process. They have their individual commitments. Let's talk about them one by one. First, let's talk about code commit, which is last in the slide. So basically, I talked about moving your piece of code to a central place where you can continuously commit your code and get the freshest or the best copy that is there, right? So code commit, what it does is it helps you manage your repositories in a much better way. I mean, think of it as a central repository. So it also lets you connect with Git, which itself is a central storage or a place where you can commit your code. You can push and pull that piece of code from there, work on it, make own copy of it, submit it back to the main server or your main or central operating place where your code gets distributed to everyone. So that is Git. And what code commit does is it lets you integrate with Git in a much better way. So you do not have to worry about working on two different things. It helps you in automatic authorization, pulling in the repositories that are there in your Git account, and a number of other things. So yeah, that is what code commit does. Then you have something called as code build. As the name suggests, it helps you automate the process of building your code where your code gets compiled, tested, certain tests are performed, and again, making sure that artifacts or the copies of your code are maintained in your S3 and stuff like that. So that is what code build does. And then you have code deploy. As I've already mentioned, deployment is not an easy task. I mean, if we are stuck in a situation where we are supposed to manage the repositories, we are supposed to work on quite a few things. In that case, if we are forced to kind of take a look at the servers as well, spawn new instances, spawn new piece of servers, that could be a tedious task. So code deploy helps you automate these processes as well. So this was some basic introduction to these things. Let's just move further and take a look at the demo so that we can talk about some of these terms and the terms that we've discussed previously in a little more detail. Now, in one of my previous sessions, I did give you a demo on continuous integration and delivery. I believe there were certain terms that people felt were taken care of in a speedy way. Hope that I've explained most of the terms with more finesse this time and in more detail. As we go through the demo too, I would try and be as slow as possible so that you understand what is happening here. So let's just jump into the demo part, guys. So guys, what I've done is I've gone ahead and I've switched into my AWS console. For people who are new to AWS, again, you can have a free tier account with AWS. It's very easy. You have to go and sign in, put in your credit card or debit card details. A free verification would happen and probably you'd be given access to these services. Now, most of these services are made available to you for free for one complete year. Now, there is certain limitation on these services. So you have to follow those limitations. If you cross those limitations, maybe you would be charged, but that happens rarely. I mean, if you want to get started, definitely this 1 year free subscription is more than enough to get hands-on on most of the services. So I would suggest that you create this free tier account. If you've taken a look at my previous videos, you would know that how to create a free tier account. If not, it's fairly simple. Just go to your browser and type AWS free tier, and probably you'd be guided as in what details have to be entered. It's not a complex process. It is fairly simple and it happens very easily. So you just have to go ahead and do that. Once you do that, again, you'd be having access to this console, guys. So once you have an access to this console, you have all the services that you can use. So in today's session, we would be working on a similar demo that we worked in our one of the previous sessions. Here we would be creating an application, a PaaS application, platform as a service application, and we would be deploying that application using our code pipeline. So there would be talking about other terms as well, like code commit, code deploy, and code build. So do not worry, we would be discussing those as well. So this is what the demo is for today's session. So guys, let's start by creating our PaaS application. To do that, we would be using Elastic Beanstalk, which lets you have a ready-to-use template and using which you can create a simple application. Now, this being a demo, guys, we would be creating a very simple and a basic application. So just come here and type Elastic Beanstalk. So when I come to this page, guys, if you've created an application, it would show you those applications But the fact that if you're using it for the first time, this is the console that you'd be getting. That is why I have created this demo account, so that probably we get to see how you can start from the scratch. So if you click on get started, guys, creating an application here is very easy, like extremely easy. You have to enter in certain details only. It takes a while to create an application, understandable. I would tell you why it takes the time, but once it happens very quickly. So all you have to do is give your application name. Let's call it, say, deployment app. I'm very bad at naming conventions. Let's assume that this is good. You can choose a platform, guys. You can choose whatever platform you want. Say PHP is what I'm choosing right now. As I've told you, it's a PaaS service. PaaS, that is platform as a service, means that you have a ready to use platform, guys. And that is why you can just choose your platform, and your Elastic Beanstalk would ensure that it takes care of all the background activities. You do not have to set up your infrastructure. It takes care of it. So once I select the platform, I can use the sample application or use the code if I have. In this case, I would be using a sample code that AWS has to offer, and I say create. There you go, guys. This thing is creating my application. So whatever is happening here, it shows that these are the processes. Now it is creating a bucket to store all the data and stuff like that. So it would take care of all these things, guys. It might take a couple of minutes. So meanwhile, let's just go ahead and do something else. Let me just open AWS console again somewhere else. I hope it does not ask me to sign in again. I've already signed in. So meanwhile, that application gets created. Let me just go ahead and create a pipeline, guys. So code pipeline again. It's fairly simple, guys. What happens here is very easy. I just go ahead and put in certain details here as well, and my pipeline would be created. So do you want to use the new environment or want to stick to the old one? You can click on old, right? And you can go back and create it the way it was done, or you can use the previous environment. I'm going to stick with that. I was very comfortable with that. So let's just stick with it. If you want, you can use the new interface. There's not a lot of difference, certain little or minor differences. So you can just come here and add in the name of the pipeline that you want to create, say demo pipeline. I say next. Source provider. Guys, I would be using GitHub here because I want to basically pick up a repository from GitHub that helps me in deployment. So I need to connect to GitHub for that. It would ask me to authorize. If you have an account, you can always do that so that it can basically bring in all the repositories that you have. So just say authorize. If not, you'll have to sign in once. So my account has been added here, guys. Repository, I need to pick a repository. This is the repository that I would be picking. Do not worry, I would be sharing this piece of code. Or else what you can do is you can just go to GitHub and type AWS-code pipeline-S3-code deploy-Linux. Now it is a repository given to you by AWS. If you take a look at it and if you type it just the way it is named here from AWS, you should get that repository in GitHub. You just have to go ahead and fork it into your GitHub account, and probably you'd be able to import that repository directly. You can see that repository has been forked here into my GitHub account. You just type the name here, this name, search it, and probably there would be an option here, fork. I forked it, so it does not activate this option for me. In your case, it would be activated. You have to just click on it and the repository would be forked into your account. So I'm getting or importing a fork from my GitHub. I've authorized my account, and then I can just go ahead and do the stuff. Branch, master branch, yes. And just do the next step. Build provider, no build here. I don't have anything major to build, so I don't need to go ahead and provide a build provider. You can use code build, right? Guys, if you want to move or basically deploy your code to EC2 instances, you can use code build if you want. In this case, I have an application in which I have an EC2 instance and stuff like that. So I don't need to go ahead and do any building stuff. Hence, no build for me. So I say next, deployment provider. In this case, my deployment provider would be my EBS. So we have that option. Yes, select EBS, Elastic Beanstalk, not EBS. EBS stands for Elastic Block Storage. That is a different thing, guys. Elastic Beanstalk. Make sure you do that. Application name, deployment app was the name, right? Yep. And the environment. This is the environment. It creates the environment on its own. I believe that it has created the environment. It says it is starting. I hope the environment has been created. So guys, let's just see whether our application is up and running so that probably I can pass in the details. Yes, the application has been created, guys. So let's just go back and select this. Say next. Now create an IAM role is what it is saying. So let's say sample. Okay guys, so what happens normally is an IAM user gets created each time you create a role. So in this case, it is asking me to create one. It's access, create a new IAM role, AWS code pipeline, and I say allow. Successful. So a role has been created. Next step. Now it gives me the details, guys. Basically, it would tell me what are the stuff that I've done. So everything is here. I don't think I need to cross check it. You might just cross check the stuff that has happened and say create a pipeline. So guys, the pipeline has been created here. As you can see, these are the stages that have happened. If you want, you can just go ahead and say release a change. Now these things are happening, guys, and let's hope the deployment also happens successfully. We've just created an IAM user. Let's see whether it falls in place. Everything is in place. As far as the source part is concerned, it has succeeded. And now the deployment is in progress, so it might take a while. Meanwhile, just go back and take a look at this application. So if I open this application, guys, it would give me an overview of what has happened with this application, guys. As you can see, these were the steps that were implemented. Now the application is available for deployment. It successfully launched the deployment environment. It started with everything that it was supposed to do, like create or launch an EC2 instance and stuff like that. So everything is mentioned here, what happened at what time. So this is a PaaS service, guys, and it works in the background. I mean, if you actually go ahead and launch an instance on your own, configure IAM users, configure security groups, it takes a longer while. But what the service does is it automates that process. It understands that you need an EC2 instance. It launches that instance. It assigns security groups, VPCs, and stuff like that. All you have to do is run your application on top of it, as simple as that. So it has taken care of everything and run a PHP application for me. So yes, this is what has happened here. If I just go back here, meanwhile, let's see whether our code has successfully run. You can see what has happened here. I've released the change as well. And you can view the pipeline history if you want. You can click on this icon and all the details would be given to you, what happened in what stage. So these are the things that have happened till time. Now guys, let's just go back and take a look at something that we could. So I'm gonna come here and say service EC2 because my app launched an EC2 instance. So there should be an instance created by Elastic Beanstalk. See, one instance is running. It has a key pair attached to it as well. So these are the details, guys. I have a public IP associated with it. If I copy it, there you go, copy this IP, and I say run this IP. You have successfully created a pipeline that retrieved this source application from an Amazon S3 bucket and deployed it to 3 instances. It did not deploy it to 3 instances using code deploy. It deployed it to only 1 instance. You see this message that it deployed it to 3 instances is because the code or the repository that I used, it was supposed to deploy it to different instances if there are multiple instances. And hence this message would have made more sense then. But the fact that we've deployed it to only one EC2 instance, it should actually display that message. So the message that you're supposed to give, you can actually come back here and make change to the piece of code that you worked on. If you go to the readme md file, I think this is where the piece of code is. There you go. Okay, no, not here. Okay, where is that file that needs to be edited? Let me just take a look at some other files as well. Yeah, this is the file, sorry. So if you go to the index.file, here is the message, guys. So you can probably make a change to this message. Instead of saying 3, you can say 1 here, edit this piece of code, and then you submit the code again. So when you do launch or type in this IP address, probably that change would be reflected. So guys, what we've done is we've actually gone ahead and created a pipeline successfully. And in that process, we've actually gone ahead and moved or deployed our application from here. So guys, in case if I do go ahead and commit changes to the code that I just talked about, those would get reflected right away in my history when I talk about this pipeline. So it does give you continuous integration and deployment. So I hope that this session made sense to you people. And we've talked or touched upon most of the stuff that I wanted to talk about. What is AWS CodeStar? Now, in my recent times, I've talked about DevOps a lot. I've talked about different AWS DevOps services as well, as in how can you actually go ahead and use DevOps on AWS. I've talked about services like CodeCommit, CodeBuild. I've talked about services that basically let you easily automate this process of continuous integration and deployment. So what is CodeStar and why are we talking about it? Let us move further and try to understand this point as well. So guys, what CodeStar does is it basically brings in different services that AWS has to offer to you in the DevOps space, like code commit, code deploy, code build, and code pipeline. For people who do not know what DevOps is and what are these services, well, basically what DevOps does is it lets you bring in an approach where you can continuously integrate a software, deliver it, test it, and also deploy it automatically. So to automate this process and to do it continuously, you need certain services, certain tools that let you automate and make this process continuous. So DevOps is this particular approach that lets you do this. Basically, it brings in the developers and the administrators or operations team together and does help you automate this process by using various tools. Now, AWS being a popular cloud service provider, it has actually gone ahead and incorporated this approach of DevOps as well. So you can actually speed up the process of software development and deployment. So these are some of the services that let you do it. You have something called as AWS CodeCommit, you have Code Deploy, and you have Code Build. Now, CodeCommit is more of a repository where you can actually put in your code and repositories that are there with you. So it is more of a version control device. Then you have Code Deploy and Code Build, which basically let you build the code, test it, and then deploy it. And Code Pipeline basically helps you have a pipeline, or basically think of it as a channel where you can practice all these things or carry out all these operations. So what is CodeStar and why is it needed? I mean, yes, we already have all these services with us, and the fact that everything is taken care of, why do I need a separate service that brings in all these things under one roof? Well, to keep it simple, instead of using all these services under different roofs and continuously switching amongst them, it is still a complicated process, right? I mean, if you're working on too many applications, too many projects, then continuously moving from one end to the other, one service to the other, can be irritating and can be time consuming. So AWS thought, why not bring these services which are used together under one umbrella? Now, what AWS CodeStar does is it basically gives you a common dashboard where you can access all these services from one place, and you can accordingly make changes or actually go ahead and perform CI/CD, that is continuous integration, delivery, and deployment using this one single service, that is AWS CodeStar. So this is what it does. It basically lets you develop applications on AWS within minutes. It works seamlessly across different teams, and it lets you manage software delivery as well. Plus, you can choose a variety of project templates. Now, as we move further and get into the demo part, you would probably take a look at the templates and the options that we have. But yeah, this is what it lets you do. So we've already discussed the definition as in what it is and what it does, but this is the basic definition as well, which says that it lets you quickly develop, build, deploy applications on AWS, and it also lets you integrate various services for better product development and tool chain management. So guys, this is what CodeStar is. It basically brings in different DevOps services on AWS under one roof, and it actually helps you save a lot of effort and time. Let us move further and talk about something else now. So guys, these are some of the important pointers that concern AWS CodeStar, or some of the components is what you can say. Basically, what we do is we have our projects, teams, extensions, dashboards. Now, projects are nothing but the DevOps projects that you're going to create, deploy, and work with them. Teams, the different teams who are concerned with this project, the access they have and stuff like that. Dashboard is a place where you can actually go ahead and maintain or bring all these services under one roof. And then you have extensions, which basically deals with quite a few things. As we move further into the demo part, I would probably discuss this part a little more. So I'm hoping that by now you have a clearer picture as to what AWS CodeStar is, what all it can do, and the remaining terminologies. So guys, this is what AWS CodeStar is, and these are the components it concerns basically. Now, who are the people that should actually go ahead and use this particular service? Well, there are no restrictions on it as in who should actually go ahead and use it. But then this service is fairly new. Now, saying fairly new might not sound very correct or won't sound that correct. The reason for that is it is still there in the market for more than a couple of years now. So it has been there for a while, but still there are quite a few things that still need work, and there are quite a few things that have been worked upon already. So basically, when you talk about this particular service, What happens here is, if you take a look at the service a year back or so, probably they did not have a channel through which you could actually see what happened with the projects in the past. But recently they've introduced a proper pipeline flow where you can actually understand, as in, okay, these are the things that I've worked on and stuff like that. So the services are improving when you talk about this particular service, that is AWS CodeStar. But yeah, there is still room for some improvement. When you talk about businesses, for them, immediately migrating to AWS CodeStar might be a little difficult, because when you talk about big businesses and organizations, they are very rigid and not rigid, but they are working on platforms, and unless and until it is very important, they won't easily migrate to something else. So I don't see big businesses right away migrating to AWS CodeStar. But yeah, it is a positive step, and we see CodeStar being used more and more these days. Little more works here and there, and probably businesses would soon move to it, because AWS is the need of the hour and people are using AWS, so they are gonna use DevOps as well on AWS. And if you are an individual who basically likes trying out new things, who likes adopting new technologies, this is a very good service to learn, because as I've already mentioned, in near future as well, businesses would be moving to AWS CodeStar, and having this skill would be very beneficial for you as an individual as well. So yeah, who would use it or who should use it? I believe everyone should use it, but uh, who would be using it? I feel for now, beginners or people who are working standalone or small businesses would find it easier to basically transition to AWS CodeStar, and with time we are gonna seeing. And with time, we are going to see various bigger businesses moving towards this direction as well. So yeah, again, if you are somebody who likes experimentation, trust me, this is a very good service to have. Having said that, guys, we've discussed quite a few pointers, as in what this service is, what it does, what AWS is. Let us quickly switch into the console part and see what does this service has to offer to you in the form of demo. So guys, what I've done is I've actually gone ahead and I've switched into my AWS console. This is something I tell in all of my sessions. If you are completely new to AWS and DevOps, and if you wish to practice AWS or DevOps on AWS, you should actually go ahead and create a free tier account on AWS website. All you have to do is search AWS free tier in any of your browsers, and you would be navigated to that particular link. Open that link, and actually you have to just go ahead and fill in certain details, like why do you want to use this account, certain basic details like what your name is, what organization do you work for, and what is the purpose of you using this particular service or AWS services. And after that, one important thing is you would have to enter in your credit card and debit card details. Do not worry, AWS does not charge you unethically or without your consent. All it does is it provides you some of the services for free for one complete year, and there is certain limitation on these services. So if you exceed those limits, then AWS has the right to charge you. So basically what you have to do is you have to actually go ahead and first take a look at the limits that these services are in, and most of those services are in limits. So even if you use them properly or to a greater extent, you won't be charged unless and until you leave a particular server running for like hours, which is a paid server. You won't be charged. So make sure that you take care of these things. And you can also set in alarms where you'd be notified if you're reaching a particular limit for a particular service. In that case, you might be alarmed and you can turn that service off. So if you're worried about getting charged, do not worry. Just go ahead and create a free tier account. Once you do that, guys, you would be having an access to this console, which is very friendly and nice to use. Now, there are so many services that AWS has to offer to you. If you click on this services icon, you can take a look at all the services that are there. I mentioned that there are somewhere around 100 services. If you just come here and scroll down, probably you can access all those services that AWS has to offer to you. There you go. These are the services that are there. And most of these services, we've talked about these services in our previous sessions. So if you're interested in knowing about those services, you can visit our YouTube channel and probably look for those services as well to understand those services to a better effect. Having said that, guys, we are going to go ahead and talk about AWS CodeStar in particular, and we are going to see how easy it is to actually go ahead and carry out all the DevOps operations with a lot more ease using this particular service. So what do? We go to the search bar and type AWS CodeStar. It says the service isn't there. That is hard to believe. Yeah, there you go. So guys, this is what the beginner's console looks like. I've deleted all the applications that I had created in the past because I wanted you to have this fresher look to the service, as in how does it look when there's nothing or no application running. I mean, if you start fresh, this is what the console would look like, and it gets updated every now and then, so you can switch to a newer console as well if you want. So guys, let's just go ahead and create a project first. So what I'm going to do is I'm going to go ahead and create an application. Now, when you create an application, guys, I've talked about that you have a project when you talk about CodeStar. I discussed this in the components part. So when you talk about these projects, basically you have various options when you create one, and you have n number of templates that are available. Say, for example, you can see that there is a project template for Go. Go is a programming language, and these are the basic availabilities with it. So you're free to choose the programming language that you want to use. You are free to choose the platform on top of which you want to put in your application. You can see that there are options here as well for filtering those things, and you can decide what kind of application do you want to put on top of that particular platform. So you have all these options. If you scroll down, you would actually take a look at, or you can take a look at all the services that are there or types of projects that you can create. So should we choose one of these, or should we just go ahead and filter one for ourselves? So let us just go ahead and create a web application, guys. Where do I want to put it on? Let's say Node.js for now. And what is the platform? Let us have Amazon EC2, which is a basic virtual machine provider, or I would say a service that lets you create computation instances. So yes, we have these three. So when we select these three options, these are the options that we have. Let us create a web application using Amazon EC2. And then it would ask you for certain details, guys. Project name. So let us call it, say, my sample project, maybe. I'm very bad at naming conventions, so forgive me for that. And guys, with that, you would get this ID, which is very important. If you want, you can edit it right now. The reason I'm telling you this is it would be associated with all the resources that are created in the background. So you might want to keep a track of it, or if you want to edit it, you can edit it to suit your needs. Because if you're working on multiple projects, at times you need to keep a track of all these things. So once you do that, guys, you've actually gone ahead and selected a template. You've put in the details. Which repository do you want to use? So again, guys, I've mentioned that with AWS, you have CodeCommit, which acts as a version control device. For open source projects, people normally use GitHub, which is very popular. But with AWS, we normally prefer using AWS CodeCommit. It is an in-house version control device. So let us stick to that for now. In case if you wish to know more about GitHub, again, you can take a look at my previous sessions. I've talked about these things. So repository name, this is what it is. And let us just go ahead and say next. So guys, these are the processes that are going to happen. You have your source, which is CodeCommit. You are going to use services, not we, but this would happen in the background. But for build, we would be using code build. It would be tested. It would be deployed using code deploy, and you can monitor it with CodeStar itself, which basically uses various parameters from different services to do that for you. Once you're done with it, AWS CodeStar would like permission to administer the resources. In short, these services which I just mentioned. So we can just say create a project. Guys, this is important. We are mounting our application on top of AWS EC2, and to log into EC2, you basically need a key pair. So you can actually go ahead and visit the AWS EC2 service, and on the left hand side, you have an option of creating a key pair. It is fairly simple. You have to enter a name and download it and keep it with you somewhere safe. You can do that. We won't be needing this key to a greater extent today, but let us just go ahead and select one. So you can create one, or you can select the one that you have. So I'm gonna select this sample SSH, which is already there. I acknowledge the fact, and then I say create project. So guys, the project is gonna go ahead and work. Now, I mentioned that there are some extensions and stuff. You can actually go ahead and pick up certain tools that help you work with the code. Say, for example, I wish to commit a change to a particular code. I need to change that code. So how do I do? I can use a particular editor like Eclipse. You can use Visual Studio if you want, or you can directly use command line interface as well. You have a choice to do that and configure this later as well. So if you want, you can just go ahead and say skip for now. The fact that we won't be working on a very big project, we do not need to do that. So let's just skip it for now. So as you can see, it says that no ID connected because I haven't selected one. And guys, this is going to go ahead and set up a particular project for me. So setting up a project takes a longer while. The reason for that is a lot of things happen. You have a particular piece of code and a number of codes actually. I'm going to show you that piece of code as well once we go back, because a template application is being generated which would be available for display. So that is why it takes a longer while. And for now, the configuration part is also happening. I mean, it would actually go ahead and configure some of the resources, because there would be a particular server or a virtual machine on top of which your application would be hosted. Certain IAM rules or policies would be created that would give particular access to particular services. Subnets and VPCs or virtual private clouds or networks basically would be created. A network under which these instances would run and can communicate with each other. So all these things happen in the background, and that is why these things take longer than normal. So let us just hope that this application gets created quicker. I've just refreshed it, but no, it is still getting created. And this is a dashboard, guys. Once this gets created, probably you'd be having application endpoints, and it would give you complete detail as in what got built, what got deployed, and what all changes can you make. So meanwhile, we'll have to bear with it. And guys, while this happens, let us just go ahead and take a look at some other stuff. Maybe we can talk about certain things or discuss certain other things so that our time does not get wasted. So guys, I talked about creating a key pair. You can always visit this particular service EC2, and once you do that, you would be taken to the EC2 management console. There are the instances and stuff, all the details that concern this particular service. So there should be something. Yeah, this is where the key pair option is. You can just click on it and just go ahead and create a new key pair. All you have to do is put in your name of the key pair basically, and you're good to go, guys. So this is what you can do: create a key pair the way it suits your needs, and once you do that, you would be good to go, guys. And if I just go back, yeah, there are quite a few other services. I talked about AWS DevOps in particular, right? And to do that, there are quite a few services. Say, for example, Code Pipeline, CodeCommit, something that I've used recently. That is why you can see all these services in the history part as well. So let us just go ahead and see whether our application is up and running. My sample project. The project has been successfully created, guys. You can see that there is status update, initial commit made by AWS CodeStar during project creation and committed 2 minutes ago. So it was committed. You can see that this is the source code commit. It is getting built, and once it is built, it would be ready to deploy, guys. So once this happens, there are quite a few other things that we need to take care of. Say, for example, this is how if you click here, you would be taken to the dashboard, which we are on already. You have your IDE. If you're using any code commit, where you have all the details about the code that you're going to use and stuff like that. Basically your code build, something that builds your code. If you want to take a look at it, you can do that as well. Deployment, you can study that. Pipeline, where you can actually go ahead and add more stages to your project. Once we are done with the deployment part, probably we would talk about it a little as in what you can do with it. So yep, these are the things that are going to happen, guys. You can see the code is still getting built. So let us refresh it for now and see what is happening and where. There you go. So it was built already and now it is getting deployed. So half a minute or so, and guys, our application would be up and running. Now again, guys, if you are looking for maybe a structured approach when it comes to getting trained in this particular technology, if you are interested, probably you can take a look at this website by Edureka, where you have this particular course, AWS Certified DevOps Engineer. And in this training, probably you'd be covered with all the details that concern DevOps and all the services that are there. See, these are the topics that are covered here, and it talks about everything that is related to DevOps on AWS, like the services that are there and the operations that you can perform. And talking about AWS code formation, this is something that has been used in a project as well that we've just created. I would talk about it as well. Getting back to this discussion for now, you can probably visit this place and take a look at the details that are there. So that is if you are interested, and probably you can get in touch with any of our executives, and probably they would guide you on how to proceed with it. I mean, what is the fees, whether there are any discounts and stuff like that, and how you would be attended in case if there is any problem related to customer service or any project details or any class details or stuff like that. So you can actually go ahead and visit this website and take a look at all the stuff that is here. I believe I've stalled enough time to, so let us just actually go ahead and see whether our code has been deployed or not. So let me just refresh it once more. I say refresh. It is still getting deployed, guys. Will happen soon. Do not worry about it. And guys, then you have Jira as well. You can integrate with Jira. What it does is it lets you track your items and issues with AWS CodeStar, and you can actually integrate with Jira as well. So there are any commitments or any changes that you have to do using Jira integration, you can do that as well. It is fairly easy. Just connect to it and enter in few details and you would be more than good to go, guys. And once this application is up and running, probably your CloudWatch. I mentioned the fact that AWS connects with other services to give you monitoring details. CloudWatch is one such service which gives you all the details. So once this application is deployed, the changes would be visible here, as in what happened, how it got deployed, and all those things. Okay, this is taking longer than normal, guys. Normally it does not take this long, but yeah, it is taking this long for now. So the fact that our code has been committed already. So guys, let's just go back to the code part. So guys, in case if you wish to take a look at the code that you've used, you can actually come to this particular place and all the details, as in what does the sample project have. See, these are the files it has, all the files that concern your particular piece of code or particular piece of application that you would be using. So if you click on this read MD file and if you say edit it, so probably all the details, if you click on say view source, so this is the code that is there in this readme file, guys. You can actually go ahead and make changes to it. You can say edit and you can change this file as well. You can do that by using basically your CLI as well, which is your command line interface, where you can actually go ahead and commit all the changes that are concerned to this particular service. And you can see that all the pull request commits and branches are taken care of when you talk about this particular service. Coming back to this particular project that we've launched, which is taking very long than normal. Let us see what has happened. There you go, guys. So our project has been successfully deployed as well. So all the operations that concern this particular service are up and running. If you click on this particular endpoint and open it, you can see that an application has been deployed. We just created a Node.js web application using this particular service, and it is responsive, guys. You can go to home, that is, it will take you to AWS home and tell you about the services, and you can contact them as well. If you click on this thing, you would be redirected to Twitter basically. There you go. You have the Twitter details as well. So guys, yep, we've pretty much actually gone ahead and we've launched an application. Again, I've talked about the pipeline and stuff. So this is the pipeline. You can actually go ahead and make changes to this pipeline as well. So if I click on this pipeline icon, probably I can actually go ahead and add more stages to it, guys. So this is how the pipeline would look like. If I just say edit, it gives me an option of editing. So I can scroll down, guys, and probably I can decide what to do. Say for example, this is the deploy stage, this is the build stage. After build stage and before the deployment stage, say I wish to basically, okay, we have it here. Say I wish to approve particular pieces of codes or builds on my own. I can just say approval, say manual approval maybe, so that I can manually approve these things. So I say add this particular stage. The stage name is invalid. Let's just stick to approval for now. There you go. And I say add this stage. I can just scroll down and I can add action groups to it. I can decide what is to be added. I mean, you can add the action name, say approve deployment, and I say manual approval. Basically, it would ask me for the details. Do you want SNS topic ARN? That is, do you want to be notified each time manually you approve something, and do you want the notification to go to other team members as well? So you can do that. You can add those here. You can save the changes if you wish, and you'd be good to go, guys. Let's not do that for now. Let us just stick to the basic stuff. So you can actually go ahead and add those details, and that particular thing would be added here in the pipeline as well, guys. Once you are done with it, there are quite a few other things that you can do with this service. Like you have this dashboard, you can decide how do you wish to play with it. Do you wish to push and pull some other components so that you can decide what is the frequently used application that you're using? And if you commit the changes, those changes would be reflected here and here as well. So this is it, guys. And apart from that, you have the teams option here as well, which actually lets you decide if you wish to add more team members, what access to give to them and stuff like that. So which member gets what access to which service and how much is something that you can decide. And you can have all these details on your dashboard here and here. Again, guys, once you're done using all the services and if you're practicing, make sure you delete all the resources that are there with you, and you won't be charged to any particular level in case if a particular service charges you. So even before we leave, we are going to go ahead and delete all the stuff that we've created. But as far as this session goes, guys, we've talked about quite a few things and we've discussed what AWS CodeStar is. I believe you have some basic understanding to this particular topic. So let us just go ahead and delete our project first, and then probably we can bid adieu to this particular session. So when you say delete, guys, you'd have to enter your ID. So I'm just going to copy it from here and going to paste it here and say delete. And then it would delete this particular service for me. Takes maybe a minute or two to do that. Once the service is deleted, you're good to go. Why do you need AWS OpsWorks? Before we talk about this particular point, let us just quickly take a look at the definition of this particular topic so that probably we can relate to the topic in hand much better. That is, once we understand what is AWS DevOps, there might be quite a few people here who might be completely new to these terminologies. So it is important we understand what OpsWorks is so that we can probably relate to the bigger picture as in why do we actually use it. So let's just do that. Let us take a look at the basic definition first. When you talk about the definition, this is what it has to say. It says that it is a configuration management service that helps you build and operate highly dynamic applications and propagate changes instantly. So too many words here. Let me just simplify it for you. Now these days we build so many applications which are built consistently and constantly. So if you think about it from an infrastructure perspective, you might be required to maintain hundreds of servers, different applications on top of it, configure those applications and do n number of activities that you actually would not want to do. Because as a developer or as a business owner, your prime focus is on focusing on the business part and on the development part. So what if you could give these laborious activities to someone else to do it? Wouldn't that be nice? Well, OpsWorks, it exactly does that. I mean, it takes care of the configuration and the management part. And when you talk about this service, it specifically helps you in various DevOps related activities. Like it lets you deploy these codes as well, or these applications as well. You can do that manually, automatically, and a number of other ways. It lets you load balance your applications. So all in all, it serves quite a few purposes when you talk about DevOps. And when you talk about DevOps, these things can be done by using Chef and Puppet. So what this thing does is, that is AWS OpsWorks, it basically lets you use configurations that support these tools as well. And Puppet and Chef, that is which these individual tools are, they also let you use OpsWorks along with them. So that is what AWS OpsWorks is. Basically, it lets you configure and basically manage various deployment processes and the infrastructure that we're talking about. As I get into the demo part, I would actually give you a deeper explanation as to what you can do with Chef, what you can do with Puppet, and a number of other things. So this is what the basic definition is. Now let us go back and try to understand why AWS Ops works. Now, when you talk about AWS Ops works, let's consider this example. Suppose you have like thousands of servers that are running at a time, something that I talked about a while ago, as in you might be required to work with a number of servers. So in this case, suppose that you have somewhere around 1,000 servers, and probably you're supposed or you're made to deal with changing the properties of certain files on these servers. If you do it manually, actually there would be a lot of laborious activities involved in this task. But if you talk about OpsWorks in particular, what it does is it lets you automate this process and it lets you do this task parallelly on n number of services. So thus it helps you save a lot of time. And apart from that, it gives you following features. It is highly productive, it is highly powerful, it is easy to use and it starts easily. It is highly flexible and it is secure as well. The plus point of it is you can run any kind of application on top of it. So that is not your concern. I mean, you do not have to worry about the kind of applications that you can run on top of it. Since you can run any kind of application, all you have to do is focus on the configuration part, then let go of the worry where you focus on what kind of application should I deploy. So guys, this was the reason why you should actually go ahead and learn AWS OpsWorks. We've already looked into the details of what is AWS OpsWorks. Let us take a look at certain components that are important to this particular service. So following are the components that this service focuses on. You have stacks and layers, then you have instances, applications, and cookbooks. Let me throw in some light on each of these terms individually. Stacks and layers. Now, when I talk about building applications, basically you're talking about so many things. I mean, you're talking about code, you're talking about configuration files, you're talking about installations and stuff like that. So all these things have to lie inside a container, right? Inside a box where these things can be managed. So that stack of these resources is called as a stack. I mean, the name remains the same, but that is what it is. And then you have something called as layers. Now, again, these operations that I just talked about, say, for example, you are supposed to install certain softwares. So you need to have a stack or maybe a substack that basically holds in these installation files, right? So that substack is called as a layer. It basically lets you have more classified approach towards the resources that you have. So a subclassification inside a stack is called as a layer. And then you have instances. I've talked about instances already, as in what it is. Again, if you talk about computation, I mean, you would be carrying out the operations that I just mentioned, right? So you need some source that lets you perform all these computations and a platform to perform these computations on top of these applications, right? So that platform is something that is provided to you by the instances that are there. Now, there are various types of instances. Let us not get into the details of those. But yeah, these instances, think of them as platforms on top of which you can put in your applications and carry out computation. Then you need certain applications that you can put on top of it. So these applications, again, you can build those on your own. You can use custom applications depending upon your need. AWS or most of the cloud platforms that you'd be using, they would give you these options where you can have your customizations, or you can actually go ahead and use the default applications that are there on these cloud platforms. Specifically with AWS, it is definitely true. Cookbooks. Now, what are cookbooks? Again, you have various configuration files or basically files that tell your service what to do. I mean, what kind of operation do you want your service to perform? So this piece of information is a configuration file. And when you talk about a cookbook, basically it is a collection of recipes. Recipe, again, is nothing but a script, basically, or your configuration file. So if you have n number of such configuration files, which basically tell your service what to do, you can club them together so that you form a cookbook. Just like our normal routine cooking practice, right? If you talk about a cookbook, it would have a number of recipes and each recipe would tell you what different dish to cook, right? So if you apply this logic into ops works, or basically if you apply this logic into configuration process, that is what recipes and cookbooks would be like. So yeah, guys, we've talked about all these things. We've talked about stacks and layers. We've talked about instances. We've talked about applications and cookbooks. Now let us just go ahead and switch into the console part and try to see what AWS Ops Works have to offer to us, or has to offer to us. So guys, what I've done is I've gone ahead and I've switched into the AWS console. This is where we would be getting a walkthrough to AWS Ops Works. Now, before we get into the details of AWS Ops Works, for people who are completely new to Amazon Web Services, AWS, what they can do is they can actually go ahead and create a free tier account here. What AWS does is it gives you some of the or most of the services for free so that you can actually go ahead and practice these services. Now, when I say for free, these services are available to you for one complete year, and there is certain limitation cap on it where you can use these services for certain limits only. So what I would suggest is you actually go ahead and log into the AWS website, this particular website, or you can just go ahead and search for AWS free tier in any browser, and you would be redirected to this page. There you'd have to go ahead and sign in or probably sign up. And once you create an account, you would be having all these services made available to you. What is the process for signing up? You have to put in certain details like why do you want to use this account? Who are you by profession? And what is your intention of using this account? Plus, you'd have to enter in your credit card or debit card details because there is a certain cap on these services. And if you exceed those limits, you would be charged post that. But again, the limits are more than enough if you wish to get started. So I would suggest that you put in your details for your credit card and debit card and you won't be charged. You can stay rest assured about that as well. So guys, once you do have an account, you can actually go ahead and use the services that AWS has to offer to you. In this case, we would be going through OpsWorks. Now, when you actually move into AWS console, you have this find services option where you can put in the details of the service that you want to use. In this case, it is OpsWorks, right? So it would be there in the suggestion here for your use. If you've recently used it, it would be shown in that option as well, or in the recently visited services as well. So you can visit it either ways. Let us just click on this icon. Today, for some reason, the internet is a little slow, so few things are taking longer than normal. Now, if you've opened or used this service for the first time, or you're using this service for the first time, this is what would appear to you, a fresh screen for a beginner. I'm purposefully using this account because I want you all to see how it looks from a fresher's perspective. So guys, once you do that, this is where you have all the stuff that you can do. Now, in the previous part of this session, I've discussed about stuff like stacks. I've talked about recipes and cookbooks, right? So that is what we are going to do. We are going to go ahead and create a stack. We are actually going to go ahead and deploy an application and see how it works using AWS OpsWorks. So as you can see, if you are a fresher, you can actually go ahead and start fresh. With this, what it does is you create your first stack. And if you already have certain instances running and you wish to use those, you can register those instances as well. But for now, let's just go ahead and start fresh. So we get to see what all can be done. So let's say add your first stack. So guys, you're given these options. As I've already mentioned, when you talk about AWS OpsWorks, it works with two services or two tools rather, that is your Chef and Puppet in a very good manner. Initially, it started on a great scale when you talk about Chef in particular. I mean, it was very easy to integrate with Chef, that is integrating AWS with Chef rather. And now the fact that Puppet is trending these days, you can actually go ahead and use Puppet as well. If you talk about adding a stack, you can actually go ahead and add a sample stack where a Node.js application would be deployed to the discussed instance or to the instance that you would be creating. And if you talk about the other options, you can actually go ahead and bring in your existing cookbooks and use certain community cookbooks as well that are there for offerings when you talk about AWS in particular. To do that, you'd have to use Chef 12 stack. And in case if you wish to use built-in cookbooks for the applications and deployments, you can switch to Chef 11 stack as well. So guys, we're going to stick with the basic application for now. Once you click or select this option, a Node.js app will be set up to help you explore the features and configuration options of AWS OpsWorks stacks. For example, layers, lifecycle events, and etc. So let's just go ahead and create one. What operating system do you want? Let's stick to any. I mean, we are not going to go ahead and explore these instances or these operating systems. So let it be Linux for now. It does not matter to any great extent. And say create a stack. So guys, these are the 5 processes that would happen. It would create a stack. The name would be my sample stack. A cookbook repository would be created basically. That is using Chef. A layer would be created. Node.js app server would be its name. Then probably a recipe would be assigned to basically using which you can actually go ahead and deploy your application. And finally, you'd add an instance layer as well, or you'd add an instance to the layer rather. So once you do that, let's just go ahead and say explore the sample stack. So all these things have happened, guys. Now, as you can see, you have a sample stack basically. So if you wish to explore, you can actually go ahead and go through these options as well. The important thing that you need to do is actually you need to go ahead and start an instance. So let's just say start the instance. So guys, this is the process which takes a long time. Meanwhile, let us just go through certain basics. If we are able to bide the time so that the instance gets launched in that duration, I mean, so basically there is a server that is getting installed here. So it's obviously going to take a longer while. So meanwhile, let's talk about certain terms and try to understand those. If we still have enough time, then I would probably pause this session meanwhile the application gets or the instance and the server gets up and running. So let us try to take a look at certain pointers when you talk about these stacks. Probably this is the layer that is there, which we have. We've talked about layers already. So again, if you come to this particular location, it would give you the information about the stuff that we are talking about. Let me just click on this thing. See, there's the information here as in what is a stack, what does it mean? Layers as in what are the layers that you're using, what a layer is and stuff like that. So if you wish, you can add more layers as well. Instances, this is where you'd have information about your instance, which is getting booted right now or booting up right now. This is the IP address that we can use. Then there are 2 types of instances, guys. You have your time-based instance and you have your load-based instance where you can customize the way your application needs to be handled. If you wish to spawn in more instances or if you wish to give in certain instructions for your instance to react to, you can set in certain time variable parameters. And if you wish to load balance better, you can actually go ahead and load balance your instances as well. If you click on this icon, no load balance based instances is what it is saying. You can actually go ahead and add those. You can edit the configuration for the same as well. Now this is the information as in what happens with a load-based instance. Then you have your time-based instance as well. Same for it as well, the information as in how it works. Deployments. This is something that we're going to do once instance is up and running. So we should wait for that. Monitoring. This is where you get all the information about what has happened once the application server is up and running. Let us just go ahead and see whether the instance is up and whether it's running. It is still booting up, guys, so I'm just gonna go ahead and kind of wait for this particular activity to happen, and once it does happen I would re-continue the discussion. Okay, booting process is done. Now it is running the setup, so I'm hoping that it's gonna happen quicker. So guys, there you go, the Node.js server is up and running and you can see the status is online. The instance that we are using right now is T2 medium. Now there are different families of instances that you use which serve different purposes. Certain instances are memory specific, certain are general instances. If I'm not wrong, T2 family instances are burstable instances which actually work at some reserved capacity in the initial phase, say somewhere around 20%. And if you require more computation, they burst into that mode where you can actually go ahead and utilize that instance 100%. Now, this is for cost saving purposes, but that is not the discussion for today. Let us just go ahead and see what we have here in store. Now, our instance is up and running, so let us move ahead and get into the deployment part. Let's just say deploy an application, deploy this particular application. Yep, command, deploy, comment, sample for today. There you go. And I say deploy. So yeah, this application would be deployed to our instance basically. So again, guys, the reason we use ops to work is what it does is it kind of simplifies all these processes. Now, this is where we've actually gone ahead and created a very simple application and we've deployed it. Again, as I've already mentioned, you have the freedom of choosing the instances that you use, choosing the application that you want to bring in, and you can actually go ahead and use all the recipes and cookbooks that you have. I mean, you can use configurations and instructions that you want to use that suit your need better. And your applications can be large, they can run on any kind of platform. So all these restrictions won't be there once you actually go ahead and deploy your application, or once you actually do go ahead and decide to use AWS OpsWorks. So yes, it is a complete service. Once this thing is up and ready, we can see what has happened. So the application is deployed, and if you wish to take a look at what has happened, the reason it took this long was these were the number of operations that were performed. See, you can take a look at the log. This is all that has happened, and this is what it has gone through, these many processes. So you can understand the amount of time it has taken. And when we say automate certain processes, it helps you take care of these many processes, guys. So yep, again, so if you wish to actually go ahead and see what has happened, you can kind of move to your instances. This is where your instance lies, right? So you can come here and kind of move to your IP. Now I've clicked on that IP and this is what I've got. You've successfully just deployed your first app with AWS OpsWorks. So this is it, guys. I mean, we've understood how OpsWorks works, what all it does, and at least the basic part. One more important thing that you need to notice, guys, when you do actually go ahead and create these applications, when you actually go ahead and do all these things, you should understand one thing, that these things might cost you. So it is very important that you actually go ahead and clear all the stuff that is there with you. So it is very important you stop your instances. It is very important you delete your applications that are there with you. So first and foremost, it is important you delete your application. Once you've deleted the application, guys, your next process is to actually go ahead and stop and terminate the instance that you're using, and you would be good to go, guys. So once you've deleted the instance, once you've deleted the application, then go ahead and delete your stack from here, because you might be charged otherwise. So ensure that you carry out these practices.
Let us understand what is Azure DevOps. Now, Azure DevOps provides developer services for support teams to plan work, collaborate on code development, and build and deploy applications. Azure DevOps supports a culture and set of processes that bring developers and project managers and contributors together to complete software development. It allows organizations to create and improve products at a very fast pace than they can with traditional software development approaches like the waterfall approach. You can now work in the cloud using Azure DevOps services or on premises using Azure DevOps Server. So you have two options. Now, Azure DevOps provides integrated features that you can access through your web browser or IDE client. Now, you can use one or more of the following standalone services based on your business needs. The first one that we'll be talking about is Azure Repos, which provides Git repositories or Team Foundation version control for source control of your code. Azure Pipelines, on the other hand, provides build and release services to support continuous integration and delivery of your applications. Azure Boards delivers a suite of agile tools to support planning and tracking work, code defects, and issues using Kanban and Scrum methods. Azure Test Plans, on the other hand, provides several tools to test your applications, including manual or exploratory testing and continuous testing. The last component is Azure Artifacts, which allows teams to share packages such as Maven, NPM, NuGet, and more from public and private sources and integrate package sharing into your pipelines. Now that we know what is DevOps and Azure DevOps, let's understand how to implement continuous integration. Before that, we have to understand what is Azure Pipelines. This is really important. Now, Azure Pipelines automatically builds and tests code projects to make them available to others. That's all it does. So it works with just about any language. It could be Java, Python, or project type. And these pipelines combines continuous integration and continuous delivery to constantly and consistently test and build your code and ship it to any target eventually. Now, you must be wondering, what is continuous integration? Continuous integration is the practice used by development teams to automate the merging and testing of code. Implementing continuous integration helps to catch bugs way early in the development cycle, which makes them less expensive to fix. Automated tests execute as part of the continuous integration process to ensure quality. Artifacts are produced from continuous integration systems and fed to release processes to drive frequent deployments. The build service in TFS helps you set up and manage continuous integration for your applications. Now, continuous delivery, on the other hand, is a process by which code is built, tested, and deployed to one or more test and production environments. Deploying and testing in multiple environments drives quality. So, continuous integration systems produce the deployable artifacts, including infrastructure and applications. Automated release processes consume these artifacts to release new versions and fixes to existing systems. Monitoring and alerting systems run continually to drive visibility into the entire continuous delivery process. The release service in TFS helps you set up and manage continuous delivery for your applications. Azure also has continuous testing on premises or in the cloud, which is the use of automated build, deploy, test workflows, and with a choice of technologies and frameworks that test your changes continuously in a fast, scalable, and efficient manner. Implementing CI/CD pipelines helps to ensure consistent and quality code that's readily available to users. And Azure Pipelines provides a quick, easy, and safe way to automate building your projects and making them available to users. The next question that arises is, why should one use Azure Pipelines, right? So the first and the most important benefit of using Azure Pipelines is it works with any language, any platform. That's one of the biggest advantage. And the next advantage is that it deploys to different types of targets at the same time. It also integrates with Azure deployments. It builds on Windows, Linux, or Mac machines. That is, it works on any OS. And it also integrates with the biggest and the most popular code hosting website, that is GitHub. It also works with open source projects. So this is definitely why one should opt for Azure to create their pipelines. Now let's move on and learn the differences between continuous integration and continuous delivery. Azure Pipeline supports continuous integration and continuous delivery to constantly and consistently test and build your code and ship it to any target. Now you accomplish this by defining a pipeline. You define pipelines using the YAML syntax or through the user interface, that is the classic way. Continuous integration. So in continuous integration, the tests are automated and builds for your project. Continuous integration also helps to catch bugs or issues early in the development cycle. when they're easier and faster to fix. Items known as artifacts are produced from continuous integration systems. They're used by continuous delivery release pipelines to drive automatic deployments. Continuous delivery, on the other hand, automatically deploys and tests code in multiple stages to help drive quality. Continuous integration systems produce deployable artifacts, which include infrastructure and applications. Automated release pipelines consume these artifacts to release new versions and fixes to the target of your choice. Now that we know the difference between continuous integration and continuous delivery, let's move ahead and learn how to create Azure pipelines. So the first way to create Azure pipelines is to define pipelines using YAML syntax. You define your pipeline in a YAML file called Azure Pipelines.yml with the rest of your application. The pipeline is versionized with your code and it follows the same branching structure. So you can get a validation of your changes through code reviews in pull requests and branch build policies. Every branch you use can modify the build policy by modifying the Azure Pipelines.yml file. A change to the build process might cause a break or result in an unexpected outcome, so be careful. And this occurs because the change is in version control with the rest of your code base and you can easily identify the issue. So the first step is to configure Azure pipelines to use your Git repository where you're going to edit your code, where you're going to really write, where you're going to really store your entire project. And then you're going to edit your Azure Pipelines.yml file to define your build. In the third step, you're going to push your code to your version control repository. And this action finally kicks off the default trigger to build and deploy and then eventually monitor your results. So once the pipeline has been created, your code has been now updated, built, tested, and packaged. It can then be deployed to any target that you'd like. There's also another way to create your Azure pipelines, that is to define pipelines using the classic interface. Now here you create and configure pipelines in the Azure DevOps web portal with the classic user interface editor. So what you do is you define a build pipeline to build and test your code and then to publish artifacts. You also define a release pipeline to consume and deploy those artifacts to deployment targets. So here the first step is to configure Azure pipelines to use your Git repository. Then you use the Azure Pipelines classic editor to create and configure your build and release pipelines. Then you finally push your code to your version control repository. This action triggers your pipeline and runs tasks such as building or testing codes. The build creates an artifact that's used by the rest of your pipeline to run tasks such as deploying, to staging, or even production. So the tasks that are released is termed as continuous delivery, and the part where you're building tasks and testing them is termed as continuous integration. Now that we know how to create your own Azure pipelines, let's go ahead and learn to set up release management workflow. So the first thing that we're going to learn is how to design a release strategy. So we have to understand what is release pipelines. Okay, so release pipelines enable teams to continuously deploy their application across different stages with lower risk and with faster pace. Deployments to each stage can be fully automated by using jobs and tasks. Teams can also take advantage of the approvals and gates feature to control the workflow of the deployment pipeline. Here, each stage in a release pipeline can be configured with pre-deployment and post-deployment conditions that can include waiting for users to manually approve or reject deployments and checking with other automated systems that specific conditions are met. In addition, teams can configure manual validations to pause the deployment pipeline and prompt users to carry out manual tasks, then resume or reject the deployment. By using gates, approvals, and manual intervention, you can take full control of your releases to meet a wide range of deployment requirements. You can also release deployment control using gates. Gates allow automatic collection of health signals from external services and then promote the release when all the signals are successful at the same time or stop the deployment on timeout. Typically, gates are used in connection with incident management, problem management, change management, monitoring, and external approval systems. Some scenarios and use cases for gates are incident and issue management. Here, you ensure the required status for work items, incidents, and issues occur regularly. For example, now you have to ensure deployment occurs only if no priority 0 bugs exist and validation that there are no active incidents take place after deployment. Also, another scenario would be to seek approvals outside Azure pipelines. Here, notify non-Azure pipeline users such as legal approval departments, auditors, or IT managers about a deployment by integrating with approval collaboration systems such as Microsoft Teams or Slack and waiting for the approval to complete. In another scenario, there could be quality validation. Query metrics from tests on the build artifacts such as pass rate or code coverage and deploy only if they are within a required threshold. There are many other use cases like security scan on artifacts, user experience relative to baseline, change management, infrastructure health. There are many scenarios that you can use gates for. So this is a really important topic. Moving on, let us learn how to implement compliance and security. Firstly, we will have to design a dependent management strategy. Before we learn how to design one, we will have to understand what is dependency management. Now, with modern software architectures and development methods, software dependencies can come intertwined quickly. With more online repositories like GitHub, Docker Hub, pre-built libraries, and services can be easily published and leveraged. Now, these projects can be managed by all sorts of individuals or groups and have a very wide range of work ethics from well-maintained solutions with good community and multiple contributors and release schedules. That is all the way to the other end of the spectrum. Code is also developed internally and is often reused. Wherever the source comes from, the problem is the same. Once implemented, one project now has a dependency on other. Now, for example, when a team comes together to build a solution, they may decide for various reasons to leverage code that already exists. Now, depending on the type and language used for that particular project, there are different sources that can be leveraged to accelerate development. For example, let's say you're running a .NET application that's going to be processing JSON that you retrieve from Azure to describe Azure resources. Now, rather than having to write all the logic to handle the JSON file, your team decides to leverage a popular package called newtonsoft.json, which is a publicly available package. You could leverage the NuGet package that's already been built and published for consumption. By leveraging this package in your code, you have created a dependency on the package for your solution. Now, you must be wondering, what is a package? A package is simply a standardized way of distributing codes that can be consumed by another application or solution. Metadata is used to help store and version and identify these packages. So there are different types of packages, right? So these artifacts can be NuGet, NPM, they can also be Maven, and all of these are a part of the packages, okay? So we'll be talking about NuGet. So NuGet is a free open source package manager designed for the Microsoft development platform used in .NET since its introduction in 2010. NuGet has evolved into a larger ecosystem of tools and services, so it is distributed as a Visual Studio extension. The NuGet packet has a NUPKG suffix and as a zip file with a specific folder structure. Maven packages, on the other hand, are often used for Java projects. Maven can also be used to build and manage projects written in C#, Ruby, Scala, and other languages. Now, a project object model file describing the metadata of the project is also stored within this package. NPM, on the other hand, is a package manager for JavaScript programming language, and it's primarily used for runtime environments with Node.js. An NPM package contains a package.json file describing the metadata of that package. The Python package index is a repository of software for the Python programming language. Python's packaging is built for distributing reusable code called libraries between developers. Now, these packages are libraries used as building blocks to create applications and have a tar.gz extension. Azure DevOps also has the ability to store universal packages. A universal package installed one or more files together in a single package that have a name and version, which is useful for many ad hoc situations where you want diversion and track files. Containerized workloads are becoming more popular as platforms like Kubernetes are becoming mainstream. We'll be talking about Kubernetes later on in the session. Docker images, on the other hand, are generally complete self-contained system. Azure artifacts are available in Azure DevOps, DevOps servers, as well as in Team Foundation Server 2017 and 2018. The sources allow you to integrate packages seamlessly into your CI/CD pipeline. Now, there are three concepts you need to understand when managing these Azure artifacts that we just talked about. That is feeds, views, and upstream sources. Feeds are the primary method for delivering packages. Microsoft really recommends one feed per project, And to achieve this, we can utilize the feature of upstream sources, which allows you to combine multiple sources into a single feed. Now, using this method allows you to control sources in your project in the various levels of access. Here we see two options we have when adding upstream sources: a public source and from an existing Azure artifacts feed from within your Azure DevOps organization. When adding a public source, the only supported package type is an NPM source, which we've already talked about. Now, when you're adding a source from within your Azure DevOps organization, you can target an Azure artifacts feed. This allows you to use different package types, that is NuGet, Python, and Maven. You can scope the visibility of your package feed to your organization, which is multiple projects. And this is by default. Now, a benefit of bringing all these packages together in one feed is the copies are made of the sources. Now, if you're using sources and those sources goes offline, you'll be able to maintain your own version of this packet. Upstream sources, on the other hand, enable you to manage your product's dependencies in a single place. Using upstream sources makes it easy to use common packages in your solution. It has the added benefit and gives you protection against outages and corrupted or compromised packages from upstream sources, and also as a copy of the packages stored locally. Now let's move on and understand how to manage security and compliance. White Source Bolt is a lightweight open source security and management solution integrated within Microsoft's Azure DevOps Services and Azure DevOps Server, formerly that is DFS products. It enables you to do many things like detect and remedy vulnerable open source components. Also, you can generate comprehensive open source inventory reports per project or build. You can also enforce open source license compliance, including dependencies licenses. And also you can identify outdated open source libraries with recommendations to update. This is just one solution to manage security and compliance. Let's move on and understand how to implement continuous feedback. So you can design system feedback mechanisms. The first one is to use application insights metric dashboards. Now, Application Insights has always provided a summary overview pane to allow quick at-a-glance assessment of your application's health and performance. The new overview dashboard provides a faster, more flexible experience. Dashboards are basically customizable, interactive signboards that provide real-time information. Dashboards are associated with a team or a project and display configurable charts and widgets. Charts, on the other hand, are query-based status or trend charts derived from a work item, query, or test results. Widgets, on the other hand, display configurable information and charts on dashboards. The widget catalog provides brief descriptions of those widgets available to you. Now, in addition, you can add widgets provided through the Azure DevOps Marketplace. In context, reports are system-generated charts that support specific services. Examples are team velocity, sprint burndown, and the cumulative flow diagram. These reports are displayed on the Analytics tab for a specific service and derive data from analytics. Power BI reports allow users to create rich, customized Power BI reports or other reports using OData queries of analytics data and the return JSON data. If you see the fourth point, you can also configure a burn down or burn up widget. The burn down and burn up widgets provide the flexibility to create charts for any type of scope, any number of teams, and within specified time periods. Burn down charts focus on remaining work within a specified time period, while burn up charts focus on completed work. In the last point, both lead time and cycle time widgets are extremely useful to teams as they indicate how long it takes for work to flow through their development pipeline. Lead time measures the total time elapsed from the creation of work items to their completion. Cycle time, on the other hand, measures the time it takes for your team to complete work items once they begin actively working on them. Moving on, let us understand how to optimize feedback mechanisms. So the application lifecycle doesn't finish with application deployment. Feedback is a very important element of refining an application, whether that's exception detection and diagnosis or improving the user experience. You can do this in various ways. You can analyze alerts to establish a baseline. You can analyze telemetry to establish a baseline. You can also perform live site reviews, and you can also perform ongoing tuning to reduce non-actionable alerts. Moving on to the next part of the session, we'll be talking about some of the Azure tools. The first one that we're going to talk about is Azure Kubernetes Service, which simplifies deploying a managed Kubernetes cluster in Azure by offloading much of the complexity and operational overhead to Azure. Now, as a hosted Kubernetes service, Azure handles critical tasks for you like health monitoring and maintenance. Since the Kubernetes masters are managed by Azure, you only manage and maintain the agent nodes. Thus, a managed Kubernetes service, AKS, is free. You only pay for the agent nodes within your clusters and not for the masters. You can create an AKS cluster using the Azure portal, the Azure CLI, Azure PowerShell, or even using template-driven deployment options such as Resource Manager templates and Terraform. Now, when you deploy an AKS cluster, the Kubernetes master and all nodes are deployed and configured for you. Additional features such as advanced networking, Azure Active Directory integration, and monitoring can also be configured during the deployment process. Windows Server containers are also supported in AKS. Now, there's some technologies used for configuration management like ARM templates, Terraform, Chef, Puppet, Ansible. ARM templates are a way to declare the objects you want, the types, names, and properties in a JSON file, which can be checked into source control and managed like any other code file. ARM templates are what really gives us the ability to roll out Azure infrastructure as code. Also, there is Terraform, which is an open source tool for provisioning and managing cloud infrastructure. It codifies infrastructure in configuration files that describe the topology of cloud resources. Now, these resources include virtual machines, storage accounts, and networking interfaces. The Terraform CLI provides a simple mechanism to deploy and version the configuration files to Azure. Supported by Chef, the Chef Automate Azure Marketplace solution enables you to build, deploy, and manage your infrastructure and applications collaboratively. Moving on to the last part of the session, we have a case study for you. So we'll be talking about how ServiceNow want to make work easier and more efficient for their customers through its software as a service workflow platform. Now, to maximize the value it can deliver, ServiceNow moved its business critical SAP estate, including 50 essential applications, more than 10 SAP landscapes, 50 database instances, and over 50 terabytes of storage and other IT assets to Microsoft Azure. ServiceNow relies on the high level of security that Azure provides, along with the scalability and agility that a rapidly growing company needs to expand. Benefits of the migration include an 80% reduction in deployment cycle time, an improved service level agreement, better disaster protection, improved SAP application performance, and a 40% reduction in TCO. ServiceNow helps some of the world's largest and most influential companies work better. It also helps customers in numerous industries reduce costs, increase productivity, streamline processes, and accelerate digital transformation. It does this by delivering a comprehensive software as a service digital workflow platform with native AI capabilities and intuitive user experience. To support its customers, ServiceNow must ensure that its own internal systems and processes are powerful, dependable, and scalable. The company has long relied on Azure to keep its operations running.
What is Azure DevOps Test Plans? Azure DevOps Test Plan is a service launched by Azure DevOps that provides a browser-based test management solution for the exploratory, planned, manual, and user acceptance testing. It provides rich and powerful tools so that everyone in the team can use to drive quality and collaboration throughout the development process. It is easy to use and it is browser based test management solution which provides all the capabilities required for a planned manual testing and user acceptance testing or exploratory testing and for gathering feedbacks from the stakeholders as well. So now that we have come to know what is Azure DevOps test plans, now let's deep dive into the concept and understand what are these test plans basically. So first let us understand what do you mean by a test plan. So a test plan is nothing but a container for storing test suites that are nothing but a collections of test cases. So these test plan function by allowing you to establish a container in which you can group your all test suites. So as you can see in this diagram, this is a container which comprises of number of test suites which are grouped and then stored into these test plans. So test suites are nothing but the collections of test cases which then form a group and then they are stored inside these test plans. So there are three types of test suites, that is static based, requirement based, and query based. So static based test suites are type of test suites that are used either as a container to group other test suites or to group a specific set of test cases. So in Azure DevOps Test Plan, you can have nested test suites. That means a static test suite itself become a form of a container where we can add different test suites, and then we can place or as a place to create a test case ad hoc. So as I said, it will be in a nested loop form. So most of the time you will be using a static test suites as you mean by grouping test suites together. Next is requirement based test suites. So requirement based test suites are the simplest and the most traceable test suites. It is basically they pull all the test cases for a given requirement. This means when you go to build a test suite, you will not be choosing test cases. Instead, you will simply choose the requirements. So what happens next is that any test cases that have already been built or connected to that particular requirement will get pulled in and populate your test suites. So you can then run all of the tests for that particular given requirement. So if you use a requirement based test suites, your team can create a traceability matrices so that you not only see how your test cases align with your requirements, but also you can see whether a particular test case has passed or failed for that particular given requirement. And next comes the query based. So query based test suites are the type of test suites which pull in a group of tests from your project irrespective of what requirement the test cases are linked to. So it affords teams that have the ability to create a test suite using any criteria available. What does this mean actually is that when you are creating this type of test suites, it asks you how you want to pull these test cases and allows you to construct an ad hoc query to do so. So here you are not concerned with how test cases are connected to specific requirements, and instead it allows you to pull in the test cases that matched a specific criteria. So when do you use these query based test cases is like when the team will run these tests on all the test cases that are currently in a given iteration, or run the test on everything with a given tag. So the idea behind the query based test suite is that you can easily include test cases from your project that you would like to test irrespective of the affiliation to that particular requirement. So as I said, a test suite is nothing but a collection of these test cases. So what are test cases? Test cases defines to test a system, software, or any application. It can be a singular set of action or the instruction for a tester for a test to perform that validates a specific aspect of a product or the application functionality. So here in this particular test suite, you can have n number of test cases which can be then grouped based on the different types of test suites, that is static based, requirement based, and query based. Now that we have come to know about the test plans, test suites, and the test cases, now let us look on to some of the key scenarios which will help us understand why do we use Azure DevOps Test Plan. So Azure DevOps Test Plan provides software development teams some of the key benefits, such as they can test on any platform. So this means that with Test Plan's web portal, you can use any supported browser to access all manual testing capabilities. It enables you to create and run manual tests through an easy to use browser based interface that users can access from all major browsers on any platform. Next is it has a rich diagnostic data collection. So here using the web-based test runner and test runner client, you can collect rich diagnostic data during your manual test. This includes your screenshots, image action logs, screen recordings, code coverage, IntelliTrace traces, and test impact data for your apps under the test. And this data is automatically included in all the bugs you create during test, making it easy for the developers to reproduce this issue. Next is end-to-end traceability. So Azure DevOps provide end-to-end traceability of your requirement, builds, tests, and bugs. You can create your requirement qualities from cards on the Kanban board, and the bugs created while testing are automatically linked to the requirement and builds being tested, which helps you to track the quality of the requirements and the builds. Next is integrated analytics. So, in this, the analytics service provides data that feeds into built in reports, configurable dashboard widgets, and customizable reports using Power BI. Data tracks test plan progress and trends for both manual and automated tests. The test analytics then provides real time visibility into test data for builds and releases. So, teams can act on this data to improve the test collateral to help maintain healthy pipelines. Lastly, is the extensible platform. So, you can combine the tools and technologies you already know with the development tools that work best for you to integrate with and extend Azure DevOps. You can use the REST APIs and contribution model available for the test platform to create extensions that provide the experiences you need for your test management life cycles. So these were some of the major key benefits that makes Azure DevOps useful for the development teams. Now let's quickly understand how does these test plans work. You can work on with the test plans with two ways, that is manual testing and automated testing. In manual testing, the Azure DevOps test plan uses test specific work item types to plan and author these tests. In addition, it provides two test tools to support running the test. Test plans, parameters, and configuration hubs provide the tools to efficiently create, manage the test items, their settings, and as well as their configuration. Now, in this, the test suites can be dynamic requirement based or query based suites to help you understand the quality of associated requirement under these development, or static to help you cover regression tests. Next is automated testing. So, automated testing is facilitated by running the tests within the Azure pipelines. So, here the test analytics provide you real time visibility into your test data for builds and releases. It helps you improve the pipeline efficiency by identifying repetitive, high impact quality issues. So, these are the two types in which the test plans actually work. Now that we've come to know what are test plans, test suites, how do they work, so now let's have a quick demo on these test plans. Now let's quickly work on some of the demos where we'll create test plans, test suites, and see how it works. So for that, first we need to log into our Azure portal. So let's quickly log in. So for that, what do we need to do? First we need to log in. Stay signed in. Alright, now that we have come to our dashboards, here as you can see, this is the whole dashboard of the Azure portal where you find all the different kinds of services and resource group and all other subscriptions and stuffs. So we'll be directly moving ahead to our Azure DevOps organization. Now let's go to my DevOps organization. So once we come here, so this is the dashboard of Azure DevOps where we can see projects and we can also create new organization. So it is basically you need to create a new owner where under which you have a different you can create different projects. So I already have one of the test plans, but we'll create a new project. So let's create a new project first and let's name it as Azure Test Plans Demo. Now we can give a descriptions to our project or else you can leave it as it is and it's just a demo for us. So I'll be taking the private option and now we can just create. So now our Azure test plan has been created. So this is our project overview. So in this, we can add boards, repos, pipelines, test plans, and artifacts. So let's quickly go to our test plans. Now once we come here, now we need to first create a test plan. So as we said, a test plan is a container where we have group of test suites. So for that, we need a container. So let's quickly create one new test plan. So let's name it as Azure test plan 1. Okay, that would be cool. And here you can choose the area path. So as our project name is Azure DevOps Test Plan, so we'll be keeping it under that. And the iterations, so here the iterations are nothing but our sprint. So we can take, or we can keep it as it is. Later we can just change whenever to sprint 1. So let's quickly create. So now that we have created our test plan, now under this, we will be creating the test suite. So now here we need to see, here we can create a test suite over here. So this is our test plan. Under this, we'll be creating a new suite. So as we discussed before, we have 3 types of test suites, that is static, requirement based, and query based. So we'll be taking here static suite. And now let's name it test suite 1. All right. Now our test plans are created and our test suite is also created. So if you go to our more options, so you can create one more under that particular test suite. You can create another test suite based on your requirements, and you can also assign testers to run the tests which are under these test suites. So now that we have created our test suites, so let's quickly go to our boards. Under that, we'll go to our sprints. So in this, we'll see whether our test plans are available or no. So as you can see here, Azure Test Plan Demo, that is our test plan. And under that, we have the test suite, which is under sprint 1. But currently, we don't have any test cases. For that, we need to create test cases as well. So as you have created these test suites, so in this you can either add new test suites under the test suite 1, or else you can assign the testers to the particular suite. But before that, we need to create new test cases. So now what do we need to do is we'll first edit our test plan and we'll choose our iteration, that is our sprint 1. So we'll be choosing that and we'll just save and close. So once we do that, we'll just go to our boards. So as you can see, this is our test suite and this is our test plan. So, and it is currently active. So once you go to our sprints, so here you can see, as I said, in sprint 1 we have only one sprint, but we don't have any test cases. So now what do we need to do? Now we'll go back to our test plans, and here, as you can see, we can have add test cases. So let's quickly new test case. So here we'll enter the title for our test case. So let's keep it quite simple. So let's create a test case like change the title size from H2 to H3. Okay, so what do we need to do is like we are changing the title size from H2 to H3. So here we'll provide the test case states that will be in the design stage. So here what do we need to do? Here we need to add the steps. How to change the title from H2 to H3. So let's quickly add some steps. Alright, so we'll just give couple of few steps, that is open home.html, then go to class is equals to hello, and then we will change from H2 to H3. So these are a couple of steps we can add, and based on that you can also give your expected results. Here we'll write size changes. That means the size gets changed. We need to check that. So we'll just save and close. Now let's create one more test case. Let's try one more. So we'll just create one more test case, that is new test case. So in this test case, we'll just write something different. Now we'll say change the title size from H2 to H1. And here, as we said, we need to give our steps. So we'll just follow the same steps. Open home.html, then go to class is equals to hello, and then change from H2 to H1. So we have also created the steps, and this will be size change as we are just changing the size. So our expected result should be same. Now here you can also add the status, means you can give it the priority to our test cases. So there are different types of priority based on which you can create. So let's keep it 2. Let's not change anything. And we'll just quickly save and close. So we have 2 test cases. Now in this define section, we are able to see the different test cases which are assigned. Now we'll go to our execute, and here you can see that your test cases are also visible. So you can select one or multiple test cases. So let's quickly select one and just run for web application. So once we run the web application, so here you can see the steps are specified here. So now what I will do is go to these web applications and I'll check whether the changes have been done or no. When I open the home.html, if it is running well, so I'll just tick mark, or else if it is not, then I will just fail the test step. And then I go to the class hello. So once I go there, so I tick mark that, and I change from H2 to H3, so I'll click that. So once that is done, whereas here you can add some more steps, like here you can see insert new step. You can just create new steps, or you can delete the steps if you are not requiring it. So here you can just add any one new. All right. So here you can also take screenshots, or you can just select the image action and also create a video. Now once you have done this, we'll just save and close. So as you can see here, our test case, that is changed the title size from H2 to H3. So here it shows passed. Now we'll also do with the second one. So let's run it together. Let's see what happens. Okay, so here you can change your test, like we have our first test, and you can switch your test cases. So currently our one test has been done, so we'll do with our second test as well. So we'll just pass all the tests and we'll just save and close. All right, it shows active state. Let's see whether it has been done or no. All right. Okay, so what did we do? We did it for the first one as well. So we'll just quickly do for this as well. And just save and close. So as you can see, our both the test cases have passed. So now that our test cases are run, now let's go to our chart section. So here you can create a new chart. So here you can either create a new test case chart or the test result chart. So now first let's create the test result chart. So here you have different kind of charts. So let's select bar as just to make it simple, and we need to group by. You can choose as per your requirement. If you have number of suits, you can choose that, or testers. So I'll take it as upper as the priority. So now here you can change the colors of your bars, and you can customize it on your own requirement. So once that is done, so now this is the test case. As we said, we have only one test suite. So based on that, our chart looks like this. So now that we have just run both the test cases and we also see the charts as well. So there were 2 test cases that had run successfully. Now we'll just go to our boards and in that we'll just select any one of the test cases. Now, as it has been run successfully, we'll just change the state. You can change the state by ready, closed, anything. So you will be just, we'll close this and we'll save it. All right. And now let's go back to the work items and let's do the same as well with the second test case, that is the change the title from H2 to H1. So let's do ready and let's save it. So what do we do is now we'll just go back to our test plans and create a new chart and see how our test case looks. So let's check based on our states. So here you can see one is in the ready state and one is in the closed state. So we had changed the state of one test case as closed, means the test has been done, and one as it is ready. As said, you can also change the colors based on your choice. You can give any colors to your charts and you can show to the people. So in this test suits, let's create a new test case chart. So in this, let's take a pie chart itself and let's group it by the states. So as we change the state of each of the test cases, based on that, we'll be seeing. So as you see, one test case was closed and I had changed one of the test case to be ready. So we can see the differentiation based on it. So it will be helpful for the team also to understand that how many test cases are closed under which states. So this is for you can create. So this was under the test suite one. Whereas you can also do it for your test plans as well. So as you can see here, it is like you can create new test cases over here, and based on that, you can create a chart. Now let's create one more suite and let's see how does that chart look. So let's create a test suite, that is test suite 2, and in this also we'll have a test case. Let's create a new test case like hello world, and we'll give couple of steps. Open hello world dot html, go to class, and then print is equal to hello world. Alright, now we'll just save and close. So this is our test case. So now we'll not run this test case now. We'll just create a chart and see how does it look like. So we'll just go to our test plan itself. So under this test plan, we will create a new test case. Okay, so here you can see it automatically gets changed. You don't have to like create a new chart over there. It automatically gets changed, and you can see one is in the design stage, one is in the ready stage and close stage. Whereas you can also edit it while if you want to change their constraints based on like state or anything. So you can change it accordingly. So I'll just keep it as it is. So this is how you do the manual testing in DevOps test plan. Whereas I said you can also do the automated testing by building pipelines, and with those pipelines you need to connect it with your test suites, and through that you can just automate all your test plans. What are Azure artifacts? So, according to the definition, Azure Artifacts is a package management system integrated with Azure DevOps that allows you to develop and share packages like Maven, NPM, and Nugget, etc., via public and private feeds to any size business. So basically, Azure Artifacts is kind of an extension that makes it easy to discover, install, and publish packages in Azure DevOps. It's deeply integrated with other hubs like Build so that package management can become a seamless part of your existing workflow. It enables developers to share their code efficiently and manage all their packages from one place. Using Azure DevOps artifacts, developers can publish packages to their feeds and share it within the same team, access organizations, and even publicly. So this was all about what are Azure artifacts. Let's quickly move on to the next, that is why Azure DevOps artifacts. So there are three main features in Azure DevOps artifact which makes it more special and demanding. So let's quickly have a look. What are those three? So first is you can keep your artifacts organized. So what does it mean? That you can share code effortlessly by storing any packages irrespective of whatever programming language you are using, like Maven, NPM, Nugget, and Python, etc. You can just feed them all together in the artifacts and keep it organized. Second is protect your packages. So here it means that you can keep every public source package that you use, including packages from npm.js and nugget.org, safe in your feed where only you can delete it, and it is backed by the enterprise grade Azure SLAs. So that means that all your packages are safe and secure. Third is integrated package handling into your CI/CD pipeline. So what does it mean? That you can access all your artifacts in builds and releases in which artifact integrates natively with the Azure pipeline or CI/CD tool. So these were the three benefits, or we can say features, that makes Azure DevOps artifacts more demanding and mostly helpful to users, basically like developers. So let's quickly move on ahead. So next is Azure Artifacts Workflow. So let's see how Azure Artifact work. So it is a three-step process in which makes it easy to work. So we can see the first step is to create a package. So basically what is it? A package feed is a location you use to host packages you want to deploy with a deployment manager. So when you set up a deployment manager, you need to choose a feed you want to use to host your package. So here what do? First you create a package feed or a team feed. So once you create a team feed, then we move on to the next step, that is build integration. So basically what do we do here is like we connect to the feed in the Azure DevOps and then we start building integration. The main purpose of build integration is to define the order in which the components and subsystem should be implemented, which builds to create when integrating the system and how they are to be assessed. After this, we move on to the third step, that is consume from feed. So here what do is that we pack and push packages to your feed and then we consume feed by running build and restoring packages from team feed and setting up new solution locally to consume the feed. So these were the three easy steps, or we can say the whole workflow of Azure DevOps Artifact. So with no wait, let's quickly move on to our demo where we'll see how do we work with the artifacts. So first we need to open our terminal. Let's open our terminal. And now what we'll do is we'll create a folder where we'll be storing our both the projects. So let's quickly create the folder. So here you can see our DevOps folder has been created. Now let's just confirm whether it has been created or no. Document. Alright. So here you can see this is our DevOps folder. So now here we'll be adding our both the projects, whatever we'll be building. So let's quickly build our projects. Let's move to our Visual Studio. Okay, so here we'll be creating our project. So as I said, I'll be using the Java project. So let's quickly make it. Control Shift P. And this is the option, create Java project. So we'll just click on this. And I'll be taking Maven. You can take any other tools like Gradle, Spring Boot, Quarkus, Microprofile, any of your choice. For me, I'll be choosing Maven and then Maven Archetype Quick Start. And our version would be 1.4. And now here we need to give a name to our group ID. So let's keep it Azure Artifacts. Alright. And now they ask for the artifact ID. So we'll keep it very simple. Project 1. And here we need to select the folder. So we'll be selecting the DevOps folder which we had created. So this would be our destination folder. So here you can see it is executing. Alright. So here you can see your group ID, artifact ID, and the version. So our version would be 1.0 snapshot. So just copy this and paste it over here, hit enter, and they asked for the confirmation of your properties. So our group ID is Azure Artifacts, Artifact ID project 1, version 1.0 snapshot. Package, so here we must update the package name. It should be similar to the artifact ID. So let's just update it. Snapshot, our version is 1.0 snapshot. And package will name it as our artifact ID. So project 1. Yes. And here you can see our project 1 has been created successfully. And here you get the message, and we'll just open this. All right. So here, as you can see, this is project 1, and you do have your source files and pom.xml. So this is the where you find all your dependencies. So let's quickly build our project 2. We'll follow the same process. Control Shift P, Java project, Maven, type 1.4, and our group ID would be same. So Azure Artifacts, and this will name it as project 2. Now select the folder, destination folder. All right. So here we see our group ID, artifact ID, project 2. Let's keep the version same. We'll just copy this, and we need to update our package. So let's update it. Project 2. Yes. All right. So our project 2 has also been successfully built. Here you get the message. We'll just open this as well. So here also you can see your source file and your pom.xml file has been created. So now both the projects are created. Now what do we need to do is to create the dependencies. So let's create the dependencies. For this, we'll just maximize this. In project 2, we'll come to this dependencies section, and we'll copy this dependency code, copy, and just paste it below. And now what do we do here is, as we need to create the dependencies, so we'll change the group ID, artifact ID, and your versions. So what would be our group ID is Azure Artifacts, which we had created. So let's just copy and paste. And our artifact ID is project 1, as we are making project 1 dependent on project 2. So let's write it project 1. All right. Our version would be 1.0 snapshot. Cool. And our scope would be system. Now below this, we need to give the system path. So let's quickly give the system path. Okay. So our system path would be $base star live project 1-1. So here we get the option 1.0 snapshot.jar. So we'll quickly save this, and we'll open our terminal. So let's open our terminal. So now to build this jar file, we need to go to project 1. So let's go to project 1, cd project 1. All right. So here what do? We'll just hit the command maven compile. All right. So here it shows it has been built successfully. After this, we'll just hit the command maven package. All right. So your maven package command has also been run successfully. Let's quickly cross check it once. Let's go to project 1. Now here we see the target folder. So let's quickly check. So here you can see your project 1.0 snapshot.jar file has been created. Now what do we need to do is we need to copy this jar file and paste it in project 2. So for this, let's create a folder in project 2. Let's name it live, and we'll copy this jar file and paste it in. Okay. Now, what do? We'll run the same commands, that is maven compile and maven package, in project 2 as well. So let's quickly go to project 2. Maven compile. Alright, so here you can see it has been built successfully. Let's run another command, that is maven package. Alright, so here you can see maven package has also run successfully. So this is how you create the dependencies between the two projects. Now let's quickly move on to our Azure. So we'll go to our Azure DevOps. Okay, so here first we'll be creating a project. Let's create a new project and let's name it Azure DevOps Artifacts. And we'll make it private. Like you can choose any one of the you can choose the visibility of your own choice. So, but I will prefer private and we'll create it. So this is our new project. Here you can see there are different options like boards, repos, pipelines, test plans, artifacts. So first we'll go to repos and here we'll be uploading our project, whatever we have created right now. For this, now what do we need to do? The first step is so let's go to our project. Now we have created the dependencies, like we have created our jar files and our both the projects are dependent on each other. So it is basically typically for like one developer environment. But let us assume like if you have two different teams, and then what you need to do, that you need to always come over here and open the jar file and just update the versions of the jar file every time. So what do you need is to have a central location where you have all these files, and then every time whenever you compile these projects, then it is going to go ahead and the latest file, and then it is basically that you don't need any more, like you won't have to just come over here and keep on updating your versions. So it would be automatically done. So for that, what we'll do, we'll just delete this jar files from here so that only the code is like transferred to our reports. So let's go to our files and go to project 1, and in target there is a jar file. So we'll just delete this jar file. Same would be done in project 2, project, and we'll just delete this folder. Alright, so now that is done. So let's move on to our terminal. Now we need to move to our destination folder where we have where we have built our both the projects. So I have come here to this DevOps folder. Now what we need to do is we need to send these two projects into our Git repository. For that, we'll git init and then git add all and then git commit and then first commit enter. So here you can see our both the files have been gone into the repository. Now what do we need to do is we will go to our repository and we'll just copy this git remote add origin. So what do we need to do is we'll just copy this link, copy, and git remote add origin, git remote add origin. And now we'll use the git push command. So let's use it, git push -u origin master. Alright, so our files are uploaded now. Just let's refresh this repository. Let's go to repos. Okay, So here you can see both the projects are uploaded over here. So it is quite clean. We just have our formx.xml and our source folder. We don't have our jar files or anything as such. Now after this, let's move on to our artifacts. So here first is we need to create a feed. So let's create a feed. Let's name it project Azure app. And here we can give the visibility. It's upon you, like whatever choice you need to give. So you can give the visibility like only accessible to the members of the organization or to the specific people. So I'll select the second option and upstreaming sources. So here we like from the public sources, we include the packages, like no matter whatever languages you're using. And our scope would be project. It can be either project or organization. So for me, I'll be selecting the project and I'll just create it. So yes, as you can see here, our feed has been created. Now next, what do we need to do is connect to feed. So here you can see all different languages, the packages which you need to like connect and you need to feed on to the artifacts. So here there are different languages like .NET, Nugget, Visual Studio, NPM, Gradle, Python, Pip. So you can choose any one of your choice. For me, I will be choosing Maven as we have worked on Maven. So let's, what do we need to do is here, let's copy this repository and we need to paste it onto our project files. So let's go to project 2 and let's search for our repository section. So do we have any repositories? So no, we don't have repository. We need to create a new repository. So let's create a repository just below our dependencies. So repository is, so let's close it. Alright, now what do? We will just paste the code over here and just save it. Now we can also copy this whole code and paste it on project 1 as well. So this is a project 1. Let's go and do the same thing under repository. Sorry, under the dependencies, we'll paste this repository code and we'll save it. Alright, so now you can see this URL. So this URL needs some authentication as this is private. So how do we give the authentication? So let's move on to our Azure DevOps. Here we'll go to personal access key tokens and here we'll be creating a new token. So let's create a new token over here. You can give any name to your token. Let's keep it project Azure app artifact. All right, and let's give the authentication. We'll give the packaging, read, write, and manage. Once that is done, let's create. So as you can see, your token is created over here, and this is your password. All right, so just copy this password. Now, where do we put this keyword so that we can authenticate? So there is a folder, Maven folder, that is m2.m2. So we'll go to that m2 and here you can see the repository folder and there's a settings.xml. So we'll go to the settings.xml file and here you can see this is the code where you can give the authentication to your Maven project. So here, this is the code server. Under this, you have your project ID, project Azure.app, and your username is your organization's name. Now let's paste the password which we had copied. So let's paste it over here and let's save it. So now let's go to our Azure DevOps and we'll go to the artifacts, connect to feed, Maven. And so here you can see the settings.xml file, your username is there, and your personal access token, which we created previously, have been initiated. Now what do we need to do is copy this repository as it has been updated. Let's copy this and paste it again to our both the projects. So we'll just copy this repository, paste it over here, and save it. Let's do the same with our project 1. So this is our project 1. Alright, so we'll save this as well. Now what do we need to do is we need to also have this distribution management code. So let's find out if we have this section. So we don't have it. Let's paste it again just below the repositories. Just close this. Copy, paste, and close. Now what do we need to do is copy the same repository code and paste it just inside this distribution management and save it. Alright, now we'll just do the same thing with, this is for the project 1, we'll do it for project 2 as well. Let's copy project 2 and paste. Alright, so we'll save it. So now let's move on to the terminal of project 1 and npm deploy. Alright, so here you can see it has been successfully built. Now let's just check whether it has come or no. Let's go back and refresh this. So here you can see your project 1 artifact have been created. Just click on this and here you see all your details, all your files are already existent. Now what do we need to do is just copy this dependency and we'll paste it in our project 2. So we'll just select this and paste it and save, and let's npm deploy. Even this has been built successfully. Let's check, refresh. So here you can see our both the projects have been uploaded, and this is how you push your packages into your artifacts.
So what are the components of Azure boards in particular? So guys, these are the terms that we would be more concerned about as we move further into the demo part. So let us try to understand these one by one. Calling them components, I'm not sure how right an approach that is, but yeah, these are more of the terminologies that concern Azure boards. Now, I've already mentioned that it is a page that brings in all the services together. So basically what it does is it lets you keep track of all the activities that are happening. So whether there are certain work items that you're dealing with, whether you're dealing with certain issues, certain tasks, whether you're talking about different views in which you wish to view all the data that is there, whether you're keeping track of all the repositories that are there, whether you're keeping track of all the sprints, if you wish to take a note of what happens in a particular sprint, or if you have certain queries that you wish to throw into so that you can understand your process or you're working much better. In that case, you have your Azure boards basically, which lets you take care of all these activities. So what are these terms and what do they do exactly? Let's try to understand those. Now, as I've already mentioned, each artifact that would go on your Azure board, I mean, whether it's an issue, whether it's a task, whatever it is, it comes under a particular classification. I mean, I want to make note of that particular artifact in the form of some entity. So that entity is my work item, as in what your work is being done, what your action is being done on this particular item. That can be taken note of by using this particular thing. Work item is nothing but basically creating a simple tab in which you keep track of everything. Okay, if I have a particular issue, say for example, I have some issue with committing a change to a particular repository. In that case, I can create a work item or an issue saying that, okay, this is the stuff that I'm working on, or this is the stuff that I need to keep note of. So this basically is a work item. Boards, now again, if you have a particular project that you're working on, now that project would have its self-defined board. In this case, you can think of it as a Kanban board basically, which is very popular. and it comes self-integrated with every project that you work on Azure boards specifically. Backlogs, yes, the fact that you are working on sprints, I mean, let me simplify this a little more for you. Basically, Azure boards also lets you keep track or lets you perform sprint management and agile development and management as well. That means you would be working on software development in different phases. So you would be working in different sprints, right? So there might be a possibility that you are working on a particular software or developing a particular software. In that case, you would be having certain backlogs, certain issues that need resolving. So in order to keep a track of it, in order to keep an order in the flow of your software development, you can always have backlogs which let you backtrack and keep track of what has happened and what has not. So for that, you have backlogs. Queries, we've already discussed that. I mean, you can always throw in queries to understand what is happening on your dashboard or on your board. Sprints, I believe we have a fair bit of idea about that as well. When you talk about dashboards, yes, as I've already mentioned, you have a separate board. Azure ensures that you get that simplicity. I mean, you get everything on one simple page. So as we move into the demo part, probably we would be understanding these topics in a little more detail. So let us quickly just do one thing, that let us quickly switch into the Azure boards and let us get started with the demo part, so that probably these terms make a lot more sense to you people. So guys, what I've done is I've gone ahead and I've switched into my Azure portal. Technically, I haven't switched into my Azure portal. Azure portal is a one-time place or a single place where you can actually go ahead and implement or carry out all the Azure practices. So that happens with most of the cloud platforms that are there in the market. So in case if you wish to practice Azure, all you have to do is go and search for Azure portal or free tier for Azure, and you would be directed to a page where you can create a free tier account on Microsoft Azure. You'd be expected to enter your credit card or debit card details. This is because these services have an upper limit or a cap on top of that, so that you cannot exceed those limits. Because if you do exceed those limits, then Microsoft Azure would charge you, and that is why they need your credit card or debit card details. But if you are a beginner and you wish to practice, do not worry, these resources are more than enough for you to practice. So I would suggest that you actually go ahead and create a free tier account. Okay, one more important point. Once you create that free tier account, you have certain credits which are somewhere around $200 if I'm not wrong, 200 US dollars. And if you are from India, the fact that I am conducting this session in India, I have a credit. If I create a free tier account, I have a credit of somewhere around 12 to 13,000 Indian rupees, which is more than enough if I'm not wrong for the practice sake. And you have a validity of 1 month to practice these services for free. Once you exceed the 1 month part, your account would be deactivated, or you won't be given access to the services. If you wish to have an access to these services, you would have to probably sign up to some plan that they have. But meanwhile, you can use these resources for free for a month actually. So with AWS, it is for 1 year. With Azure, it is for 1 month if I'm not wrong. So once you do have that free tier limit with you, you can visit this particular link. As you can see on the screen, you can actually go ahead and search for this particular screen. And once you do that, guys, probably you can actually go ahead and come to this page where you can start free with the boards. So let us see how can we get started with this particular service. So click on Start Boards. It would ask you as in, do you wish to continue? Just say yes. It is an Azure DevOps service basically. So it would ask you for the name of the organization. I mean, you have a structured approach here where you would be having an organization under which you'd be having projects. So let us call it, say, Azure Boards. Guys, I'm giving a random name because most of the names are taken. Azure Boards 1, 2, 3, 4, 5. Continue. Okay, I just backtracked accidentally. Let's say Azure Boards sample 1, 2, 3, 4, 5, and I say continue. So it creates an organization and it redirects you there, and then it says that actually go ahead and create a project. So I'm gonna say demo project for this session, and I'm gonna keep it public because I wish to add certain users. So let's just keep it public for now, because if I create a private account, I would have to look into access rights for the users that I'm creating. And there you go, your project is created. So you can go through this welcome guide if you want. I'm gonna skip it for now. So guys, this is how the interface looks like, and as you can see, I've mentioned that you can take a look at the backlogs if you've created, which I haven't in this case. You can create issues if you want. You can do that as well. You have an option of epics, issues, which lets you basically keep track of all the stuff that you're doing. You have certain work items that you can add if you want to here. Boards, what boards are you using? backlogs, you can keep track of all the backlogs that you do, sprints and queries. So if you just come to boards and then you say add a new item, let's say sample item, there you go. So guys, you can see that it comes with these two options. You have a particular state here. So for now it says to do. What do you wish to do? It is that phase. Okay. So you can actually go ahead and change the state as well, saying once you do change the state, it moves to the next part, as you can see here. So if you are working on a particular action and you've actually moving from one state to the other, you can always make changes to that, and probably you'd know that, okay, what state is the work item into, what state is the issue into. So if I click on this thing, it would probably go back again. As you can see, you can add tasks here saying that, okay, this is a particular subtask or a task that needs to be done. Say for example, clear cache, and there you go, cache has been added. If I am done with this particular task, say for example, I move into doing phase and I clear this task and I say I am done with it. There you go. As you can see, the color here has changed, indicating that the flow is correct and my task has been completed. So you can keep track of all the resources that you're using here. You can actually go ahead and add users. You can do a lot of stuff that is there with these projects. So come here and take a look at the overview. You can, suppose if you name it, say sample for today maybe. Guys, I'm gonna go very random with this session. I mean, whatever I feel is worth telling, I'm gonna go ahead and share that with you. I hope that flow is fine with you people. So there you go. Let's see if we can add a user from here. If not, we'll create a user from somewhere. Okay, so a user was added here. One user is added and assigned an access level to user one. You can view the status here as well. It says for now it has failed because probably I do not have the license to actually go ahead and assign users, but you can actually go ahead and assign users as well. So that depends upon the access rights that you have. Once you do that, you can actually go ahead and do a lot of stuff. You can just come here. Probably you can visit your dashboards and the demo projects that you are creating. Maybe go to boards. Once you do that, you can come here and add backlogs as well. Suppose I have an item here, which is this. Now so let's add a new item. Take a look at this issue. Say add to top. There you go. I can come and assign it to a particular user. Let's say I assign it to this particular individual, and there you go. The person can actually go ahead and make change to the issue. You can see the update is here, and if it is done, it's gonna go to green again. And if I come back to my boards, you can see that it is here. Work items, again, if I actually go ahead and move it to the other state, that won't be a problem. It would again go to the green part. So this is how it works. You can actually go to the project settings as well. You can come here, you can do a lot of stuff here. Say for example, you can manage your teams, take a look at the security principles that are there. You can test. Let's not get into the test part for now, but let's say if you wish to have GitHub connections, you can connect to your GitHub account as well. Just come here and probably, okay, so you can just go ahead. My GitHub account is already added, I believe here, so it shows that thing to me. Else you'd require to sign up as well, so you can just say save. And the repository gets added here. So you can actually go ahead and move to the repos part as well and take a look at the stuff that has happened here. Say for example, let me switch to some other account that I have. This is the one, or maybe Edureka boards. So if I go to samples, there was something I was wanting to tell you. Yeah, this is the part. So you can enable your repos as well if you want. Okay, you can enable your pipelines, even artifacts. You can see that all these things are available here as well now, because I've actually gone ahead and enabled those things. If you just enable these things, you can have access to these resources here and here. So if you have any files or stuff, you can actually go ahead and check if there is anything that is there in your repos or in your other services, and you can clone those. You can make changes to those services that you've used. You can commit certain changes to the code that is there. Say for example, you have some index files or some basic codes that are there. You can actually go ahead and edit those changes. Once you've actually edited those changes, you can go ahead and commit those. You can create branches as well. So you have your master branch, you have your sub branch, and you can make changes and commit those changes to the master as well. So when you talk about DevOps operations and various activities that concern a particular board, everything can be taken care of when you talk about Azure boards in particular. So this is it, guys. There is not a lot to explore when you talk about these services. These are very important to use though, because they help you keep track of a lot of things, I would suggest that you visit Microsoft Azure's documentation as well, because there are quite a few other activities that you can do with this particular service. Some basic activities which are simple, but something that are important and can be done as well. So as far as you are concerned, you can actually go ahead and explore as many services as you want, and you can understand what all can you do with Azure boards in particular. As far as this session goes, guys, I just wanted you to get introduced to this particular topic, and I believe I've done justice to that, and I hope that you've understood this particular topic to some extent where you can take it further and probably enhance your knowledge in this particular domain. Let us try to understand what is Azure Pipelines now. Now, basically, this particular service helps you carry out following things, or this is what the definition has to say. Well, it is a service that caters the need for creating pipelines on Azure cloud platform, which is pretty much evident. And what it does is it lets you build, test, and deploy applications to Azure cloud and other supported platforms. Let me simplify this definition for you a little more. Now, basically what it does is it lets you create a pipeline. Now, when I say a pipeline, when you develop a software, it needs to be built. So there are steps involved in it. You would be picking up a piece of code, or you'd be creating a new code. Once that code is there, you would build that code. You would probably run some tests on top of it. If any changes are required, you would again build that code, again test it. And once it is ready, you would deploy and deliver it to the end customer, right? So instead of doing these things individually or doing these separately, what if there was a channel in which you could do all these things and keep a track of all these at one single location? Wouldn't that be nice? Well, when you talk about Azure Pipeline, that is what it does. It basically lets you bring in all these actions under one umbrella. And these are some of the features that Azure Pipeline has to offer to you. Let us take a look at those one by one. Well, Azure pipelines are basically platform and language independent. What do I mean by this? Well, if you have your application and you wish to run it on a particular platform, well, Azure gives you option for that as well. You can run it on maybe your Windows operating system. You can run it on your Linux operating systems. You can run it on your Mac operating systems as well. Plus, it is language independent. That means whether you are building a Node.js application, you are building it in some other programming language like Python or stuff like that, you can definitely run this piece of code or build your applications using different programming languages, and you can run those on different platforms as well. Freedom to work with containers. Definitely true. What do I mean by this? Well, containers are something that let you simplify the process of virtualization, or in simple words, they let you separate your piece of code and binaries from the platform on top of which you wish to run those. So in simple words, your code is locked into a container which can run anywhere. There are containers like Kubernetes, Docker. So basically what it does is it lets you push your applications on top of these containers. You have Azure Container Registry as well, if I'm not wrong. That is an Azure service for containerization basically. So you have the freedom to move your applications on top of these containers or inside these containers as well. Deployment to the other cloud vendors. Definitely yes. Now, the fact being that this is an Azure service and it lets you create pipelines does not mean that it restricts your applications to Microsoft Azure only. If you have been using other cloud vendors or your customers or whatever it is, I mean, your end goal is to move it to some other cloud platform, you can do that. If you're talking about cloud platforms like AWS, which is popular, GCP, which is a very good competitor, if you wish to move your codes or your applications to these vendors, well, definitely deployment to these vendors is also supported. Support for open source. Yes, Microsoft Azure has put in a lot of effort in recent times to ensure that Azure is open to open source projects, applications, and tools as well. This being said, it is very easy to integrate open source services with Azure these days, and that is why if you wish to keep your project open source or you want it to be accessible to others, you can take care of that as well. So these are some of the features that make Azure Pipelines a must-have tool or a must-have service. So let us just quickly move further now and quickly switch into the demo part, because I do not want to stall any of your precious time. So let us just quickly take a look at what Azure Pipelines can do for you. So guys, what I've done is I've actually gone ahead and I've switched into the console. Now, if you talk about Microsoft Azure, they give you some free credits to use Azure services for free for 1 month. The credits are somewhere around 12 to 13,000 Indian rupees and somewhere around $200 US, if I'm not wrong. So you can utilize these credits to use these services. because these services are chargeable. But the fact that you have free credits, you can utilize these services for free for 1 complete month so that you can test and practice what these services have to offer to you. So if you do not have a free tier account, just go ahead and sign in for Azure portal. And once you do that, guys, you would be having this free tier account which you can use. Once you do that, probably you would want to search for Azure DevOps, something that we are going to use. Just type Azure DevOps in your browser and you would be redirected to this page. And from here on, I would be taking you further. So let us take a look at what you can do with Azure Pipelines, guys. So I'm going to start with Start Free. No sooner I click on this icon, guys, it would probably, if you are starting as a fresher or somebody who hasn't worked on any project, it would ask you to create an organization and a project to start with. The fact that I already have an organization or a project, it has actually redirected me to this particular page. So let me just quickly see if I can just go ahead and delete this particular project or organization and see if we can start fresh. How do you do that? Just come here and say delete. And this was the name. Just gonna copy it. Control C, Control V, and delete. So guys, when you click on start fresh, this is how it should start if you started fresh. If not, you can continue from the interface where I just left from. So it says, do you want to get started with DevOps? I would say yes. Give it a name, your organization. I'm just gonna say sample for today. Okay, South India. I'm kind of based in Bangalore right now, so that is why it says South India. And it will say create a project. So the name should be Demo Project for me. You can name it whatever you want to. If the name is available, you can use it. Do I want it private? Do I want it public? I would say public for now because I wish to import certain repositories as well, and keeping it public would make it easier for me to get access to those repositories. No other reason. So I'm just going to go ahead and say create. So guys, we've gone ahead and we have an organization for our usage, and under that we have a project as well. So if I just scroll down, I would see following options. I can switch to these 5 services that we've discussed, and I can also have them on one tab as well, which you can see it here. I've already added those as extensions to my dashboard, so we can use it from here as well. Let's just say create pipelines for now. There are no pipelines here because I've deleted my previous project as well. So I'm just going to go ahead and say create a new pipeline. So where is my code is what it is asking me. Is it in Bitbucket? Is it in Azure Repositories? Is it in GitHub? I have some pieces of code in GitHub. So let's just go ahead and use a random piece of code that is there in my repository. Once you click here, guys, if you're not authorized to use your repositories or use your GitHub, you would be required to sign in here. It would throw in a page where you can actually log in with your credentials to GitHub and pick up your repositories if you wish to use those. I have this one here. It is available actually. You can look for pipelines, Python, Django for Azure, and probably you would get these anywhere. You can just fork it by clicking here. If you do not have it, do not worry. I would be sharing the link for this as well. For now, let us just go ahead and continue with the demo part. So I'm going to select this. So guys, this is basically a piece of code for Django framework supported by Python. What it does, it tests a Django project on multiple versions of Python. It adds steps that help you analyze the piece of code, save, build artifacts, deploy, and more. So basically, you can visit this particular link as well to know more about this piece of code. So this is what it does. You can see step by step the information is here. What VM it is going to use. Again, what are the versions that it is going to use. What is the script that is here to export a particular path. Source, plus if you go ahead, these are some of the commands that you would be wanting to take a look at. These are nothing major. It just basically goes ahead and builds a particular project for you and deploys it. So let us just go ahead and do that as well. Let's just say run. So it would configure your piece of code, and once it starts doing that, you would get all the information as in what is happening here step by step. So bear with me. Let it just configure the stuff and give you the information. Probably might take half a minute to get started. And there you go, guys. It has already started. The agent is ready for the job is what it says, and it would start the connection. Once it does that, there would be a log made available to you people. So guys, this is what has happened, and this is what is happening. You can see it is getting logged step by step, whatever is happening. And you can see the commands and piece of code running in the background. And once it has succeeded, it would give you the status succeeded. So it initialized an agent, prepared a job, initialized the job, checked out, then it used a Python version. It did actually go ahead and explore or export a particular project. installed the prerequisite, it ran test on top of it, it published the piece of application or the result basically, and it actually did go ahead and check out and finalize the job. So these are the things it has actually gone ahead and performed. You can take a look at the summary part as well, as in this is what has happened step by step. Tests, these were the tests that were run and those were successful, so you have the stats for those as well. You can click on release, but there is nothing to release for now. So yeah, so you can choose where you wish to actually go ahead and deploy your application. You can carry out these steps as well. So these are the options that you have, and you can just go back. Let me just leave it. Yep. And if I overview, it said pipelines, it is 100% successfully built. Member is the account that I'm using. Pipelines, if I go here, it would give me information about that as well. This is the master branch that I'm using. I can actually go ahead and update my piece of code as well if I wish to. So guys, there are a lot of things that you can do. You can actually go ahead and commit certain pieces of codes here as well. You can go to repos. You can decide what piece of code you want. The existing master branch that you're using in the pipeline, you can actually go ahead and fork that particular piece of code. When I say fork, you make a copy of it for your own sake. You make changes in it and then you push it to the master, and if the master finds the latest version doable with the proper access admin rights, you can actually go ahead and merge that piece of code, something called as commit. You can commit your code to that particular pipeline. So guys, this is how your pipeline works. This is how your piece of code works, or this is how basically you actually go ahead and use your Azure pipelines. There are a lot of other things that you can do. You can actually go ahead and install certain extensions to your Azure pipelines so that you get quick sites, or basically you get analysis as in what was the process that was implemented and what steps it took. If you wish to know more about it, do visit our YouTube channel and visit Azure DevOps video where we've talked about that. The video also talks about how you can actually go ahead and add badge to your particular piece of code or your application, suggesting that whether all the builds were succeeded or were successful or not. As far as this session goes, guys, I believe I've talked enough about what Azure pipelines are. I've shown you a sample as in how you can actually go ahead and create a sample piece of code using Azure pipelines, or not a piece of code, or how you can actually deploy a sample piece of code using Azure pipelines. I believe most of the parts here are covered, but let us quickly take a look at some of the other pointers and then probably we can rest this session. So here you'd be having summary of what is happening. Dashboards, I don't think it would show any dashboard. You can just go ahead and add widgets if you want. So you can click it or click on this particular icon, select a widget. You can add it here and you can say add. So now if you go to your dashboard, you can select a pipeline here. Let's say this is the pipeline and I say save. So it gives me the history as in what has happened 4 minutes ago, and whatever changes happen, those can be studied and understood here. So I believe, guys, we've talked about a lot of stuff here. I would not want to get into the details of these topics because we would be having separate sessions for all these topics.
Next thing that we are going to cover is about a demo on the Azure pipelines. Okay, and what I'm going to do now is going to go to something called as dev.azure.com. What you need to do here is, if you're not signed in, it'll ask you to sign up or sign in. And once you sign in, this is the kind of basically the dashboard you will see. What you can do here, the first thing you can do here is create a new project. All right, so let me create one. What do you see here? It is asking me that is it a private project or is it a public project? Now let's say if I want to create a project called my test project 4, I'm not going to create it. It takes some time, to set up everything. But what I can show you here is that now it is asking that what is the version control? So basically, where do you want to keep your source code? Do you want to keep it in Git or do you want to keep it in TFS? Okay, so you can go ahead and select the different version control options which are available. Now, of course, I think with time, they will keep adding more and more, source controls or the version control repositories here, which you can use. But most common ones, which everybody knows, is Git. We also have GitHub, which is again a repository for storing the Git-based version control. Of course, there is something from Microsoft which is available, which is the Team Foundation. If some of you guys have worked before with TFS or the Team Foundation services, this is the one. It is totally up to you. How do you want to store your code? So I'm going to select Git right now. The next thing is about work item process. So if you want to follow the agile process, you can use this one. If you want to use the Scrum process, you can follow this one. Then of course you have got CMMI and a basic one. Now basic is something which does not follow a particular process, but this is something which can help you set up either the agile process or the Scrum process. It's like a kind of a blank template. But if you are comfortable working with agile environment, you can select this one and you can click on create. Now, as soon as you do that, what you will see, it's something like this one, my test project 3, because I created this one and I added few things here. So I want to show you that. All right. Before we go inside this particular my test project 3, what are the things you can see here? Something called as Azure boards, which we have already talked about, the repositories, Azure repos. Then we have the Azure pipelines. We have got the test plans, and then we have got the artifacts. The same stuff that we have seen in the slide, it's available on dev.azure.com once you create a project. Now let me go ahead and first of all click on this project. What I've done as part of this project, I am using Agile plus I'm using Git. So I've selected this one and this is now showing up in my test project 3. The first thing, as I told you, that I want to show you about is boards. Now let me go here. On the left hand side, you can see boards, repos, pipelines, test plans, and artifacts. So I'm going to go inside boards right now and straight away show you what you can do in the boards. First thing is, of course, pretty simple. If you want to do the planning, so what do? You create something called as a, let's say a task, or basically you create a work item. Now work items are of different types. You can have something called as an epic. Now epic is something which is very, very high level. So let's say your leadership team comes up and they define something called as an epic. Now they will say that we want to deliver this kind of project. All right. So there they are defining a particular epic. Now inside the epic, what you can do, your product owners or let's say your project managers, they will go ahead and decide on the number of features that you want to have as part of the epic. Let's say you want to build an e-commerce site. So in e-commerce site, the business says that we want to set up some e-commerce setup for this business. That's an epic. Once you go inside that epic, you will say that I want to create a feature. Now what is a feature here? I want to deliver the cart functionality. I want to deliver the product page. I want to have a recommendation engine, or maybe I want to have a search engine in my e-commerce portal. Now, this is what will be created by product owners, or they will be created by the project managers. Now, when you say I want to create, let's say, a search service in my e-commerce site. So as part of the search service, what do you need? You will go ahead and create some stories. So in the story, what will you say? You will say that I want to have some database ready, which will contain all the information of my products. Then I'm going to have, let's say, one more story for building up a middle layer, which can help me, building some APIs, which can help fetch this information from my database and show it to the end users. Then I'll build another story to say that I want to show it to the end customers. And once you have these user stories, then you go ahead and create task inside that particular story. So let me start building up, let's say, one feature. I'm not going to, go into the complete agile model, but right now I'm just saying that we want to create a feature for, let's say, search in e-commerce. Okay. Just remember, guys, this is not the way we write in agile format. So if you want to, just create a new feature, there is a particular format in which you should create the feature. Basically, the text has to be in a particular format, but that's not the agenda for today. The agenda is to show you that you can create a new feature. You can provide a particular iteration path. This means I want to do it in this particular time frame. Okay, I can create multiple iterations. Okay, and I can put up the iteration here. Now, next thing, what I can do here, I can link it to some existing item. All right, so we'll do it later, but then we'll say what is the business value of this, what is the time criticality, what is the start date, what is the target date which we want to complete this particular feature. This feature is new right now, so let me save it. You can go ahead and provide description. You can use the discussion board to do some discussion on top of this particular feature. And once you are final that yes, our feature details are ready, then what is the next thing? Let me go back to work items. And let's say I want to create a particular user story. What will I do? I'll say that I want to create, let's say in the search, I want to create the APIs. And what do I need to do? I need to link it to the epic. Or in fact, I'll need to link it to the feature. On the right side, add link, existing item. And I can also say that what is the parent here? So the parent is me search for it. So the parent is search in e-commerce. Okay, so I'm going to link this one and say that I'm creating a user story. Let me save it. In fact, you can see that if you know about what is story pointing, so you can add story points here. Or in fact, let me tell you this. If you go for, for any kind of course, or not just from here, but if you go for any kind of course about how do you handle agile, so there you will learn more about story pointing. So you can also provide the risk. Let's say this is a medium risk. What is the priority here? All these kinds of setup you can provide here, that you want to do some architectural thing, or you want to, is it a business feature? All this information is provided as part of the user story. So let me save this one. Go back to the work items. So right now this is showing us separately, but once we'll go to the boards, let me go to the backlogs first. What you will see here, all the different stories which are available. Now this is something on which we want to work. Let me add one more story here, new work item, and let's say UI for search. Okay, let me add this one. Now what you see here is we have created now two stories. In the first sprint, or basically in the planning side, let me just open it up. And so as part of the iteration, what we are going to do in the first iteration, or let's say in the first 15 days, what we are going to deliver, we are going to deliver API for search service. Or in fact, actually both of them have got into the same iteration. So now you can see here, we have got one story which we are going to cover in iteration 1, which is right now the current one, and one story we are going to cover as part of the second iteration. Now, in fact, if you go ahead and add more tasks to it, let's say if I click on, I can even change the priority for this one by dragging and dropping. Now click on API for search service. I can go ahead and click on, or in fact, I can see the whole history of that particular feature, or in fact, that particular user story. I can also go to this particular link and I can say that I want to add some child items here. Okay, so I can say add a new item, and that is a child item, which is of type task. And then I can say that I need to do some basic setup, or maybe let's say some design of my search service. So that is one task I'm creating. All right, so what is the original estimate for creating this particular task? I can say 10 hours. What is the remaining time? 10 hours. Completed 0. And I'll provide some description here and save it. So this means if I close this one, and in fact, I'll just refresh this page, you will get a complete idea of what are the tasks which are, or what are the stories on which you are going to work on, or basically what are the backlog items on which you are working in, and what are the tasks under that. So this is the kind of thing that you can set up with Azure DevOps. I hope this stuff is clear to you guys. So we have got different iterations. Let me click on sprints. So you can see right now, the first iteration is going on and the design is here. Once I start working on this, I can even use the visual editor to make it active. Once this stuff is done, I can even move it to the resolved state. Okay, let me just open this one. I can just close this task and say that's it. So this is how my overall flow of basically the work items work. Now, next thing which I want to show you is repositories. Repositories, we mentioned that we can use either Git or we can use TFS to basically maintain our source code. I'm just going to show you a demo right now to show you how all this stuff works. So what you will do here, you can set up a repository, which is like a Git or a TFS. Then you can go ahead and start checking in your code. What first thing you will see here is, because we are using Git, so I'm clicking on something called as branches. And in the branches, there is a default branch which is always available. Now that's called as a master branch. In fact, you can go ahead and create more branches. In some of the source controls like TFS, you will have one single place where everybody is checking in the code. Now, in case of Git, it does not work the same way. It's a very different structure. So what you do is you create your own branch. You work in that branch, which means branch is basically a copy of a master branch. So you will go inside that branch, you will make your check-ins. Now that is your branch in which you are making the changes. You will do the testing. Once you are completely fine that everything is running fine, then you are going to push those changes from your branch to the master branch. Remember that if you haven't worked with Git before, so there is nothing to worry about because this is not something specific to Azure DevOps. What I'm talking right now about the branches, this is something specific to the Git. So let me show this thing that we have right now, a default master branch. If I'll click on this one, what you will see, I have already checked in one particular project into my repository. Okay, that's called as a web application 2. If I click on this one, it's a very simple MVC application that I've created and added it into the source control. I'll go to the Visual Studio. Now in the Visual Studio, you can again see that I am using Git tools for Visual Studio. And this is showing me that I have got a master branch. Now what I can do, let me create one more application and check that in. So let me create a simple application, file, new project, ASP.NET Core Web Application. Remember, you can use Eclipse, you can use IntelliJ, or you can use any other IDE to do the development. Okay, so this is not restricted to .NET or Visual Studio. You can use any kind of platform or any framework to build your application, or it can be in any IDE. Eclipse, IntelliJ, anything will work here. All right. So what I'm going to do is create a new application called Web Application 3. Let this application be created. All right. Now that we have created our application, what do we need to do? You can see here that my project is ready. I'm going to simply push this code into the source control. Okay, how do I do this? Let me first of all ignore a few of these items. And what I'm going to do is, okay, I'm going to state these items. Now, this is something very specific to Git. So if you are not comfortable with Git, do not worry because this is something you can learn very quickly. All right. So what do I have here? I have got my full application, which is Web Application 3. I can go ahead and check in into a Git repository, which is managed by Azure DevOps. So I'm going to say checking in Web Application 3. Okay. Also, I can actually go ahead and map it to a work item. Let me click on this one and go back to portal to my work item. In fact, we do not have a work item for development. Let's create one. So UI for search service. Let's go back to the links. I hope you guys remember now. You can click on add link, new item, and let's say we call it build web app 3. Okay, let's call it create. I know this is not the way we write the task, but just to give you an idea that I'm just creating a new task called create web app 3. That's it. So it is going to give me create web app 3 task is ready. I can click on this one and the task number is 10. Okay, so I'm going to copy this one, go back to Visual Studio, enter the ID of the work item. Okay, so I'm going to say 10 is the ID. And you can see basically the related work item. Now what we are doing here, we are creating a new application. When we are checking in the code, we are also specifying what is the related work item. All right, so let me commit all this stuff in the code, sync it back to the cloud, which means now I have checked in into my local environment. I just want to push these changes into the cloud environment. So again, this is specific to Git. You do not have to worry about this. Just give me a second. I'm just something related to, Git. I need to. Okay, so I think this should work now. We push these changes. Okay, so now this is going to push my changes to the source control. All right, so you can see here it has been successfully pushed to the master branch. If I go back to the DevOps environment, what you will see here, in fact, if I just open up the application as well, so you can see here, this is the parent side. And in fact, let me just refresh this one. Okay, so what you will see here in the description or basically in my history, I can see that I have done some check-in here. So it is linked to that particular check-in. Now you can start visualizing this stuff. So you have got tasks, you have made your check-ins. From those check-ins, it is coming in. Once you make a check-in and attach it to a particular work item, it will be linked to that particular work item. So if anybody is going and looking into what changes you have made as part of this task, you can actually go ahead and see all that stuff. Now this is a part of the task. Next thing is, let's go back to the repos and see the commits. Okay, we have made a commit into the repository. What do we see here? We have got check-in web app 3. Okay, so this is what we have checked in as part of the web application 3 that we just created. Now the next thing is, I want to build this application. Okay, so if you guys remember, the second thing was checking in the source code. After checking in the source code, I want to automatically build this particular code. So what do I need to do here? I need to go to the third component called pipelines. I see something called as builds, which means I want to take up this particular source code and do an automatic build of that. So what I can do, I can click on something called as new build pipeline. I've already got 2 created, but I just want to show you from scratch how this is done. So where is your code? It is asking me. So my code is present in a Git repository. So I'm going to select this one. And what is asking me that where is your source, okay? Or where is your Git repository, all right? So my repository is in Azure Repos Git. Okay, so I'm going to select this one. You can even select GitHub. For example, if you just want to pick up the code from GitHub directly and use it, you can do it here. Or you have the GitHub Enterprise server. If you have got GitHub deployed in your local environment or in your enterprise environment, you can use Subversion, or you can, in fact, if you have got TFS, there's a different way to use it. But then right now we are focusing on using the Git in Azure repos. All right. So here you can see it. I have got my test project 3, which is basically my repository and my team project. Then I'm going to pick up all the code from master branch. Okay, so I'm going to click on continue. And the first thing that I need to do is tell Azure how to build my project. So how do I want to build my project? I want to build this project as part of Azure Web App. This means I want to take my code and finally I want to deploy it in a service in Azure called Azure Web App. When we say Azure Web App, then I want to build my project as part of the Azure Web App. Okay. So if you want to do a normal build, for example, of your ASP.NET application, you can do it. If you have got an Android project, you want to build it. If you have got Maven, let's say you have a Java project and you want to use Maven to build your projects, you can do it. You have got Python packages. You have got ASP.NET Core. Then we have got, if you have know what is a container, if you want to build Docker containers, you can do it from here. If you want to deploy, basically build and deploy for Azure Kubernetes services, you can do it. Then if you have got just a function, you can build a C# function. You have the Azure Web App for Java. So all these things can be done as part of the Azure build pipelines. Okay, so what I'm going to do right now is select a service in Azure. Basically, I want to deploy in this particular service called Azure Web Apps. And that is why I'm going to select this one to build my code. Now, if I have to build my code, what do I need to provide? I need to provide where is my solution. All right, so I'm going to click on this one and tell the system, or basically tell my build pipeline, that it resides in web application 3. Okay, this is my new project that I picked up. I'm going to select this one and click on OK. Then finally provide where is this Azure subscription in which I want to deploy. So I'm going to select this is my subscription in Azure, and what is the name of the app service. Again, there are a few things that we are rushing through. Okay, so this is what we can select. And next thing is I can go ahead and select. So this is what we are going to do. We are going to build as part of the build pipeline. So we are going to take the source code from the Git repository, do a build of it automatically. Let me save this one and queue it, which means I'm going to save this pipeline and start doing the build of my project. So now that our build pipeline is ready, which means our code is going to be get built, let me show you when the build is happening, what is going on. So it is going to take some time to do the build because this is the first time it is happening. But I'm going to show you that I already have one pipeline which is already built for my web application 2, which was very similar. So while this is running, let me go to builds. And this was the pipeline which was completed successfully. So let me select this pipeline. So this is how the build happens. So if you open up anything, it is going to give you the detailed logs of how the build happened. So it picked up the code from your source control, it did a build, and you can see all the build activities which happened as part of this pipeline. So you can see here it picked up the web application 2 project and it started doing the build. It did all the copy files to output directory and cleanup and all that stuff. And finally, it did a build of my project. Now, once I did a build of my project, what next? So you can see here, it approximately took 5 minutes to do the build. So what you can do as part of your Azure DevOps, as soon as somebody checks in the code, it will automatically trigger a build pipeline using which your application will be built. And if there is a failure, then the person will be informed back using a mail that your code is not correct. Okay, so you have to rectify your code as soon as possible. Now, once we have done all this build activity, what next do we need to do? We need to release it to a production environment or maybe to a UAT environment. How do we do that? We do it using something called as releases. So now that this one is ready, either I can click on release and build up a new release pipeline. So let me click on this one. And I'll say I want to create a new release. So I'll click on release 2. And what you will see here, now that the complete build which happened, now it is asking me that where do you want to release it? So I've already created a release pipeline. In fact, let me click on this and let's create a new one as well. Releases, new pipeline. And it is asking me where do you want to do the deployment? So I'm telling Azure that I want to do the deployment in Azure App Services. You can deploy a Java application. You can deploy a Node.js application. You can install it in Service Fabric. You can install it, deploy a Rails on Ruby application on app service. You can deploy an IIS website. All right. So all these things you can do. And I'm going to deploy in Azure App Service. All right. So once I select this, I just need to provide what is the application basically which I want to build and what is the Azure subscription in which I want to deploy the application. Let me select this one. So there is one I've already created, my test app service. Once I've done this, I can save it. So this is my release pipeline is ready. So now my code has gone into source control. My build pipeline, which is picking up that source code and building it, that is ready. Now this is my release pipeline, which is going to take that build code and going to do the deployment. Okay. So I can click on here and say create a release and that's it. Or in fact, one more thing I can show you. If I go back to the main pipeline, I can even set up who will approve it before it goes into a particular environment. So I can click, for example, pre-deployment conditions and say who is going to do the pre-deployment approval. If your team lead needs to approve the overall release before it goes into UAT or production, then you can specify who is the approver. So in this case, I'm going to put in my name. All right. And I'm going to save this one. So this means as soon as the deployment will start happening, it is going to ask me for the approval. I'll get an email that please approve the release deployment. Then only it can go to production. So I'm going to click on now create a release and click on create. So go to the release which has been created now. And you can see it is saying pending approval. What I can do is, because right now I am the owner, so I can click on approve and say, yes, I want to basically approve this particular release. And then it will continue further to do the deployment. Now you can see here the approval is done. And right now this is under queue, which means as soon as the resources are available in Azure, it is going to start the release deployment. And while this is right now, it's in a queue state, I can show you the one which I deployed for web application 2. So I'll go back to the releases. Okay, so this one is already done. In fact, not this one, just give me a second. Okay, so this one is already done. So what you will see here, after basically everything is done, or basically the release starts and it starts deploying, you can see the logs here. If there is a failure in your pipeline, it is going to inform you that there is a failure in the release. You will get email so you can quickly act on that. Otherwise, it will download all your build artifacts. In our case, it was a web application. So it downloaded all the artifacts of my web application, and then it is started deploying it to the Azure App Service. Okay, so you can see all the logs In fact, you can even write custom logs here that this is what we are doing as part of the release deployment on Azure App Service. All right. So you can see here, successfully updated the deployment history. App Service application is running at this particular URL, and then you can use this URL. Now, once this release completes, which means our code which we created has been deployed into production. Let me go back to Azure now. Okay, and I'm right now into Azure portal, which you can get from portal.azure.com. You can click on My Test App Service, which we are using for deployment. And if I run this particular app service, which is basically a platform for hosting the websites, or in fact, platform for hosting different websites, APIs, mobile applications. So I can click here and see my application is successfully deployed. So just to summarize all this stuff, now you can see here the application is ready.
Today, nearly 80% of all business solutions and services have moved to the cloud. Most of the projects are happening by utilizing cloud platforms, which include software as a service, infrastructure as a service, and platform as a service. With projects being hosted on the cloud architecture, it makes perfect sense to utilize DevOps solutions to continuously deliver value for enterprises. Building upon that, we have the Microsoft AZ400 exam, or the Microsoft Certified DevOps Engineer Expert. But what is the AZ400 exam? As described by Microsoft, AZ400 certification training is an intermediate level course from Microsoft for professionals who want to gain knowledge of designing and implementing DevOps processes and practices for an enterprise. This 5-day AZ400 training course is ideal for professionals who combine people, processes, and technologies to deliver value to the organization. Some of the skills that are outlined by this curriculum include developing an instrumentation strategy, which carries a weightage of about 5 to 10%, developing an SRE strategy, which again carries a weightage of 5 to 10%. Then you have development of a security and compliance plan, which carries the weightage of 10 to 15%, as well as managing source control, which has the same weightage. Apart from that, you also learn how to facilitate communication and collaboration between your teammates, stakeholders, and vendors, and define and implement continuous integration or CI, which has the majority of the weightage, which is about 20 to 25%. And finally, you learn how to define and implement a continuous delivery and release management strategy, which again carries a weightage of 10 to 15%. Now, this is the entire skill set. But before you get ready to take on the world with your newly certified skill set, a candidate for this exam must be familiar with both Azure administration and development and must be an expert in at least one of these areas. Furthermore, there are other prerequisites that you should keep in mind before appearing for the AZ400 exam. Now, even though these are not mandatory prerequisites, these are the ones which can improve your chances of qualifying the exam, such as proficiency in agile practices, the ability for designing and implementing DevOps practices for version control, configuration management, build compliance, release, and testing, all of this by leveraging Azure technologies. Now that you know how you can qualify to give this exam, let's go ahead and look at who is this exam most beneficial for, or who can take up AZ400. First of all, this course is designed for professionals who are aspiring to clear the Microsoft Certified DevOps Engineer Expert exam, right? So individuals looking to establish their credibility and value in the market as experienced DevOps practitioners, agile practitioners, and cloud computing professionals. Apart from that, this course is also meant for system administrators, software developers, project managers, and technical leads, and practically anybody that wishes or aspires to lead a DevOps team. So now that you understand who can take up this exam, the main question arises, why should you take this exam? What are the benefits of taking the AZ400 examination? Now, the DevOps market is expected to grow from $3.42 billion in 2018 and 19 to $10.3 billion by 2023 at a compound annual growth rate of nearly 25%, which means this industry is going to grow more than threefold in the next few years alone. out of which Azure holds 19% of the total global cloud infrastructure market, which automatically qualifies you for a majority of the MNCs in the industry today. Not just that, this also has proven to give you a huge boost in your salary, as a mid-level Azure DevOps engineer earns on an average of $145,000 per year, whereas a senior level Azure DevOps engineer can make up to $185,000 per year. Apart from that, the Azure infrastructure is very ideal for DevOps, which is why a lot of companies are quickly moving to DevOps, which makes you a front runner in the race for all of these companies. Now, talking of companies, here are a few aggressively hiring for Azure certified DevOps professionals, including but not limited to Amazon, Ernst & Young, Dell, Accenture, Microsoft, Google, and VMware. Now that you know what all is there in store for you, I'm sure you're curious to know what does the curriculum outline look like. So here it is. First of all, you shall be introduced to Azure DevOps and understand the important aspects of Azure as well as DevOps. Along with this, you also learn the role of a DevOps professional in an organization. Then you learn about implementing continuous integration, followed by building containers with Azure DevOps, where you learn to create and deploy a multi-container application for your DevOps pipeline. Followed by that, you learn how to design a dependency management strategy as well as managing artifact versioning. Next up, you learn how to set up a release management workflow where you learn how to configure a CI/CD pipeline using YAML and manage your secrets using the Azure Vault. Followed by which you implement deployment models and services where you configure infrastructure as a service and platform as a service on Azure. Followed by which you learn how to implement and optimize a continuous feedback mechanism. Next is the meaty part where you learn a bunch of different Azure tools for infrastructure configuration as well as a few third-party tools. And finally, you learn how to implement compliance and security, where you learn how to manage and check code quality with Sonar Cloud on Azure DevOps. You also learn how to integrate Azure Key Vault with Azure DevOps to access secrets in the Azure pipeline. And that was all about the course outline of the AZ400 curriculum. This certification exam not just enhances your skills as well as demonstrates it to your employers, thus making you gain that edge in the industry. The time is right to upskill. And DevOps and cloud are two of the biggest domains in the industry to take advantage of the career opportunities that come your way.
Let's move on and compare AWS DevOps versus Azure DevOps. So let's talk about the services that it provides. The Amazon Web Services code pipeline is a continuous delivery service for fast and reliable application updates. Code pipeline builds, tests, and deploys your code every time there is a code change based on the release process models you define. On the other hand, Azure DevOps services for teams to share code, track work, and ship software. Azure DevOps provides unlimited private Git hosting, cloud build for continuous integration, agile planning, and release management for continuous delivery to the cloud and on-premise. It also includes a broad integrated development environment support. In the next comparison, we will talk about what category of tech stack do they belong to. As you can see, Amazon Web Services code pipeline belongs to continuous deployment category of the tech stack, while Azure DevOps can be primarily classified under integrated development environment tools. Now let's talk about the features of Amazon Web Services and Azure. As you can see, Amazon Web Services provides workflow modeling, AWS integration, and it also has some pre-built plugins in it. Whereas Azure, on the other hand, provides agile tools like Kanban boards, backlogs, Scrum boards, and it also provides reporting tools like dashboards, widgets, Power BI, etc. And it also allows you to integrate with Git, which provides free private repositories and pull requests. Now, why do people like AWS is because it is extremely simple to set up, whereas Azure, on the other hand, is a complete package. It's full and it's very powerful. Now, let's move on and check out the uses of AWS and Azure. As I've already mentioned, AWS is extremely simple to set up. It also has several managed services It can be easily integrated with GitHub, and it also has parallel execution. Deployment is completely automatic, and there are manual steps available, so you're never lost. Azure, on the other hand, supports open source. It also has several integrations. That is, it can be easily integrated with GitHub and Jenkins. It also has several project management features. And the most important plus point of Azure is that it is free for stakeholders. I hope the uses between AWS and Azure are extremely clear. Now let's move on and talk about AWS and Azure clients. So Amazon Web Services is used by companies like PlayHQ, Affirm, Curo Education, UP, Ready4, and Bitbank Incorporation. Whereas Azure has clients like Microsoft, Kingsman Software, Evodeck Digital, Muse, Energy to Market, and QR Point. Now, the next important difference is with what tools that these cloud services can be integrated with. Amazon Web Services, as you can see on the screen, can be easily integrated with GitHub, Jenkins, Amazon EC2, Amazon S3, AWS Elastic Beanstalk, RunScope, and CloudBees. Azure, on the other hand, can be easily integrated with Git and GitHub, Docker, Slack, Jenkins, Trello, and Visual Studio. Now let's move on and compare the salary of an AWS DevOps engineer and Azure DevOps engineer. As you can see on the screen already, the median salary for an AWS DevOps engineer is rupees 4,67,000 rupees, whereas the median salary for an Azure DevOps engineer is about rupees 6,04,000 rupees a year.
So the first question is, what is DevOps? Of course, this is one of the first Microsoft Azure DevOps interview question that you will be asked. So the answer to this is, DevOps is a set of cultural ideas, practices, and technologies that improves an organization's capacity to provide applications and services at high velocity by changing and enhancing products at a quicker rate than traditional software development and infrastructure management methods. In simple terms, DevOps essentially speeds up the process of delivery of application and software services. Coming with our second question, why use DevOps? So this is a common Azure DevOps interview question. So how do we answer it? DevOps is significant because it is a software development and operation methodology that allows for faster product creation and simpler maintenance of existing installations. When problem arises, the DevOps team is able to listen to the user and provide the necessary features and repairs. It also facilitates the delivery of smaller features to clients in a quick and efficient manner and allows seamless software delivery. So this was the answer to why use DevOps. Let's quickly move on to our next question. How does DevOps work? So DevOps is about breaking down barriers between previously compartmentalized departments such as development and operations. These development and operations team collaborate across the whole software application lifecycle from development and testing to deployment and operations under the DevOps paradigms. Going ahead, what is Azure DevOps? So as I said before, Azure DevOps is a Microsoft application as a service platform that offers an end-to-end DevOps toolchain for building and distribution software. It also interfaces with the majority of the market's main products and is an excellent choice for coordinating a DevOps toolchain. This process includes testing automation, continuous integration, as well as continuous delivery. People with both development and the operation skill work together and implement various tools for CI/CD and monitoring for quick response to customers' requirements and fixing issues and bugs. Moving ahead, what are the benefits of DevOps? So there are 5 benefits of DevOps which we'll understand one by one. So first is speed. DevOps practices let you move at a velocity you need to innovate faster, adapt to changing marketing better, and become more efficient at driving business results. Second benefit is rapid delivery. So when you increase the pace of the releases, you can improve your product faster and build competitive advantage. Third is reliability. In this, DevOps practices like continuous integration and continuous delivery can ensure the quality of application updates and infrastructure changes so you can reliably deliver at more rapid pace while maintaining an optimum experience for end users. At number 4, improved collaboration. Under DevOps model, developers and operation teams collaborate closely, share responsibilities, and combine their workflows. This reduces inefficiency and saves time as well. And finally, number 5, we have security. So you can adopt a DevOps model without sacrificing security by using automated integrated security testing tools. So these were the 5 benefits of DevOps which makes it more demanding. Let's move on to number 6. So the number 6 question is name a few DevOps tools. So the answer to this is some of the popular DevOps tools are Git, Selenium, Jenkins, Puppet, Chef, Ansible, Nagios, Docker. So you can answer any of the 4 DevOps tools which are easy to remember. Moving ahead with the next question. What are the popular DevOps tools for continuous integration and continuous deployment? So Azure Pipelines support macOS, Windows, and Linux. So some of the popular DevOps tools for continuous integration and continuous deployment are Jenkins and TeamCity. These two are the DevOps tools which provide you both continuous integration and continuous deployment. Quickly moving ahead with the next question. Question number 8, that is, what are Azure boards? So, Azure Board is a user interface that allows you to keep a track of tasks, defects, and features in your software project. It enables you to monitor all your ideas to each development stage in order to keep your team on track with all the essential code modification related to your work procedure. Azure boards include features like boards, sprints, work items, dashboards, backlogs, queries, etc. Going ahead, what is Azure Repos? This is a basic Azure DevOps interview question, but it can be difficult to answer. So, the answer to this is Azure Repos is a collection of version control tools for managing your code. Using version control as soon as feasible, whether your software project is huge or little, is a smart idea. Version control systems are a piece of software that allow you to keep a track of changes to your code over time. Azure Repos offers centralized version control system as well as the distributed version control system, that is Git. At number 10, what are containers? Containers are software packages that include all the components required to execute in any environment. Containers virtualize the operating system in this fashion, allowing them to operate anywhere from private data center to a public cloud or even a developer's own laptop. Containers also provide the means to package software code, its configuration, dependencies, and packages into a single unit or object. Multiple containers can run on the same machine or share OS with containers for running fast, reliable, and consistent deployment anywhere. Moving ahead, what containers does Azure DevOps support? So Azure DevOps support the following containers such as Docker, Azure Kubernetes Service, ASP.NET with containers, Azure Service Fabric application with Docker support. So these are the containers which are supported by Azure DevOps. Moving ahead, what are Azure Pipelines? Azure Pipeline is a cloud service that allows us to automatically create and test our code projects. The Azure Pipeline includes several features such as continuous integration and continuous delivery that allow us to test and build our code on regular and consistent basis and ship to any destination. It automatically develops and tests the code projects. It is a service on the Azure cloud that offers well with most project types and languages. Going ahead, at number 13, what is the use of Selenium in DevOps? Selenium is widely used browser automation technology, and testing teams heavily rely on it in DevOps pipeline. It is an open source solution that saves money for testing teams and functional testers that are in charge of UI testing. It specializes in the form of regression and functional testing. At number 14, what are Azure test plans? This is another one of the popular interview questions asked in Azure DevOps. So the answer to this is Azure Test Plans is a service provided by Azure DevOps that offers a browser-based test management solution for exploratory, scheduled manual, and user acceptance testing. In addition, Azure Test Plans includes a browser extension for exploratory testing and getting feedbacks for the stakeholders. Additionally, it also focuses on automated testing. It combines the contribution from developers, managers, testers, product owners, and user experience advocates and enhance the quality of the project. Moving ahead, what are the some important features of meme cached? So meme cached offers a wide variety of features. Some of them are like it is an open source, it's a UDP or TCP server client program. It works as a standalone service. The cached nodes are very ignorant, so they don't have other nodes involved. They are also under the license of Berkeley Software Distribution and it reduces the database load. So these were some of the important features of meme caching. Quickly moving ahead, at number 16, what is a dogpile effect and how can you prevent it? So a dogpile effect refers to an effect that occurs when a cache expires and websites are attacked by several requests sent by the client at the same time. It indicates the expiry of cache followed by the website being simultaneously hit by numerous respects. In simple terms, it indicates the expiry of cache followed by the website being simultaneously hit by numerous requests. This impact can be avoided by employing semaphore lock. When a log expires in this system, the first process gains the lag and begins creating the fresh value. At number 17, what is continuous testing? What is the use of test automation in DevOps? As we know, DevOps is all about people, culture, and automation. In this, continuous testing is the process of running automated tests as a part of the software delivery pipeline to get feedback on the business risks associated with a software release candidate as soon as feasible. DevOps use test automation to use the test cases to find the flaws and save time. Unlike manual testing, automation test cases accelerate testing, allowing you to get products to market faster. Moving ahead, number 18, what is a forking workflow? So before we get to know what is forking workflow, let us know what is forking. So forking is a Git clone process that is performed on server copy of the project's repository. The forking method supports open source projects and isolates changes from the main repository until they are ready to be integrated. What is forking workflow? Forking workflow is a Git clone process that is performed on a server copy of a project's repository. This method supports an open source project and isolates changes from the main repository until they are ready to be integrated. Moving ahead, what are some of the useful plugins in Jenkins? So it has a very simple answer. So there are many useful Jenkins plugins, out of which would be describing few. So among them are Amazon EC2, Maven 2 project, HTML publisher, join, copy artifact, green balls, and many more. So these are few useful Jenkins plugins and it will be very easy for you to remember it. Quickly moving ahead with number 20, can we move or copy Jenkins from one server to another? So the answer to this is yes, it is possible. Jenkins can be removed from one server to another just by cloning the job directory from the previous server to the new or the current one, and later you can rename it. This enables moving an installation by copying the corresponding job directory. So these were the top 20 Azure DevOps interview questions. So let's look on to some scenario-based Azure DevOps interview questions. So the first one is, we have 50 commits in develop branch, out of which only 5 commits need to be pushed in the release branch, which will eventually deployed in the production. Okay, so the question is, we have around 50 commits in the develop branch, which is mostly used for development activities. So in that we have multiple commits, and the release branch is used to release your changes into your proper environments like your stage production. So here, out of 50, only 5 commits need to be posted into the release branch. So the best way to achieve it is through Git cherry picking. Git cherry picking is the act of picking a commit from a branch, applying it to another. Git cherry pick can be useful for undoing changes. For example, say a commit is accidentally made to the wrong branch. So what you can do, you can switch to the correct branch and cherry pick the commit to where it should belong. More simply, it would be like a box of cherry in which you have to pick 5 best cherries out of it. So you start picking the best cherries, and if you want to run this cherry picking, you need to use the Git console. So using the getLine command, you can initiate the cherry picking. So let's move on to our second scenario. So in the second scenario, a developer has created an ASP.NET Core application, and now he wishes to automate the entire build and release process through Azure DevOps. Guide the developer with the entire end-to-end process and deploy the application on Azure Web App using IAC methodology. Okay, so guys, as you can see that we have multiple questions, and in this entire scenario which we are talking about, the first question is that there is a developer which is very much new to DevOps, and he has reached out of the reaches of DevOps engineer, and now he asks how to automate the entire build and release process. And in the another scenario, we need to deploy this on the Azure web app using the IAC methodology. So the first step is to be taken by the developer to build the application locally. After that, we create a Azure repos and push the source code in the remote repository along with the IAC configuration file. And lastly, we create a build pipeline, classic or YAML based, in which we can build the solution using MS Build or VS Build, run the code analysis through SonarQube, Veracode, etc., run code coverage, copy ARM or Terraform configuration files, also publish the artifacts either on FillerShare or Azure Pipeline drop location. So this was the answer to the scenario. Moving ahead with the next scenario, here the developer named Ram has few commits changes in his local branch, and now he has to empty the current work directory to accommodate emergency change. So how can Ram handle such scenario without losing his uncommit changes? So to achieve this, he used git stash. What is git stash? Git stash is a command that takes your uncommitted changes, that is both staged and upstaged, and save them away for later use, and then reverts them from your working copy. So there are commands like git stash, which stashes the uncommit changes, and next is git stash list. So you can list all the stashed changes. Then there are other commands like git stash pop to reapply the most recent stat changes, and git stash drop to drop the most recent stat changes. So this is how he can overcome the scenario without losing any of his uncommit changes. Let's quickly look on to our next scenario. That is, a developer has developed a microservice application, that is ASP.NET Core, and it automates the entire end-to-end process to deploy the application on Azure Kubernetes service. Make sure to use pipeline as a code methodology for the entire build and release. So for this, the first step to be taken is by the developer to build the application locally. Then he needs to create an Azure repos and push the source code in a remote repository along with the IAC configuration file. Then again, he needs to create a build pipeline, classic or YAML based, as we had discussed in the previous scenarios. Then after that, he needs to use an ARM template or a Terraform configuration to create an Azure web app. Later, he can create a release pipeline and run the ARM template task. And post web app creation, he can run ASP.NET application deployment task. So this was the answer to this scenario. So let's check on to our last scenario, that is a developer has developed an application module, and while developing he made around 100 commits locally. Now he needs to push all his changes into a remote developed branch as a single commit. We don't want the developer's messy history in the developed branch. So the answer to this question is Git squash. So what is Git squash? Git squash is a technique that helps you take a series of commits and condense it to the few commits. That means you can condense it to one single commit, and those 100 commits will be condensed and converted into one single commit. So you can use the git command line, that is git rebase hyphen I head 3, where I represents interactive. So it is interactive head. And 3 means it will take the last 3 commits you want to try on your console or get command or git command line. So this was the answer to the scenario.
So when we talk about Kubernetes, or maybe it may be GCP or Google Cloud Platform, see, first of all, the very first thing what you need to understand is what exactly is a cloud. First of all, if you want to discuss, either it may be Kubernetes or a Docker or about containers, anything you want to learn, the very first thing you have to understand is what exactly is a cloud. So without understanding what is cloud and the reality of it, there is no point in going to the high complexity, like high sort of information being provided to you, where you will not be able to get anything. So what I would do is I will go in a stepwise manner to make you understand the things in a better way, and then we will come back to our PPT and just see that whether we have covered all the things or not, and then later we will try to take up any questions from your end and we will wrap up the webinar. Okay, so let me go ahead and try to first make you understand like what is a cloud, and inside this cloud, why are we trying to focus on the GCP part, which is a Google Cloud Platform, and why it is important, what are certain things which have been present as part of it. Okay, so let me just go and try to show you all this important information. Okay, so first of all, if you could see my screen over here, I want to make sure that I give you an introduction to GCP. So when I talk about GCP and all these things, right, first of all, what exactly is a cloud? So when I talk about the cloud over here, okay, so cloud, what exactly is this? Previously, what used to happen, and right now why cloud is playing a vital role. For example, see, here we have a lot of data. Okay, so now what am I trying to make you understand is, so let me say you that you are there on one end, who is a user. Okay, user wants to access a particular website, just for an example. Okay, website can be anything, it may be Amazon, or it may be Flipkart, or whatever a user wants to access. So what is going to happen? User would request, okay, user would request whatever site it may be. Okay, so user would actually request whatever site it may be. Let me say it is amazon.com, just for an example. Okay, now what is going to happen? User has sent the request. So basically this would be present inside a particular server. Now server will go ahead and try to take the request from the user, and then the response would be provided by the server. Whether it is a failure or whether it is giving the amazon.com, it definitely the server will give a response. That what response it is, if everything goes fine, definitely it will give amazon.com site what you expected. But if something is wrong, either it will say a 404 internal error, or the site can't be reached due to some issues, if that is present. But generally the point which I want to make you understand here is, this is how a request and response model is being present in reality. This is also called as your client server model. Okay, client is here your user, and then server is other end, like where the data is present. So this is also a client server model, we call it as. Now let me say if it is an Amazon or a Google, whatever the data which is present with them, you are able to access that data. Now today when I go to google.com, so you will be able to see a Google page. Inside this Google page, I want to go for some information which I want. Now once you click on that, you are able to see that information. Now everything is happening in a very smooth and in a proper way. Why this is happening? Because at the back end, Google is able to manage a huge amount of data for you, so that anybody who wants to access any data, they would be able to give them up, because they have a huge server and everything, and that's where everything they are trying to store, right? This is one of the important point which all of us actually need to consider. So now here, the very important point which I just want to make you understand in this case is, let me say this is the server. Now you have to maintain the server. Let me say I am a Google company. Now if I am not able to maintain the server, then my customer who is accessing my site, which is a google.com, okay, and then if he's asking me some information, then definitely it is my responsibility as a Google company to give him the information. then only my client will feel satisfied and happy. For that, I need to maintain my servers, because from my server only the data would be coming. As a Google company, I have to take care of my servers. If it is one server or two servers, there is no problem. I can handle it. But if I have thousands of server or 10,000s of server where there is a number of people in the world who is accessing my site, then in that case, how can I manage it? How can I handle this huge amount of traffic? What should I do then? Then what you can do here is you can create your data centers. Okay, you can actually go ahead and try to create your own data centers. Data center means, we will not talk anything very technically, very simple language. Data center here means nothing but, let me say you have an empty room. In that empty room, you are going to put all your servers. Okay, every server, let me say you have 50 servers. You take a big room and you put all the 50 servers over there, and that place is actually called as your data center, or you can also call as your data warehouse. Okay, where all your servers will be present in a rack. Okay, and then you will have one admin to take care of that activity. You will also have your AC and everything, because your servers generate a lot of heat. So in order to emit that heat, you need to have some coolants present which will emit the heat out. And it is your responsibility as a Google company, it is my responsibility to handle those data centers or data warehouse, to take the buildings, to take that for rent and place all my servers. It is my headache. It's not my customer's headache. I have to take care of it, whatever it may be. So I don't have any other option. Either I do it or either I go out of the business. That's it. I don't have any other option available. If you serve properly, then your customers will be benefited and they will get the desired result out of it. It's as simple as that. If you're not able to maintain, then you will be out of the market, because if your servers are not maintained appropriately, then the end user will not get the right type of a data. So Google did it really nice. Google managed so nicely that they had a huge amount of data centers. Okay, they kept every servers in their own platform, in their own companies. They have kept the servers. They managed very well. They had a lot of IT admins. They purchased a lot of coolants. Everything they did really nice. But what is happening over here? In this case, what's happening is, see, for purchasing a room, you have to pay a lot of money. For purchasing those hardware, the servers and everything, which is a hardware, right? You have to put a lot of money for that. Third thing, you have to again make sure that your IT admins are also present, in order to make sure that at any point of time, if server goes down or if there are any issues, then what we are going to do. For that also, we require admin who is working 24/7 to monitor the servers and all. Okay, and on top of that, if there are any natural calamities or any natural disasters happening, then how are you going to maintain your servers? There are lots of things which are being present here. Even though you may be the best company in the world, but if these type of situations occur, at least you should be ready to handle the things like how I can do it. Then the cloud came into the picture. Cloud says that forget about whether it is GCP or AWS or your IBM cloud or your Microsoft Azure. Forget about it. The cloud says that get rid of all these servers and everything which you are trying to maintain. Let me say I have a X organization. Now my X organization is new. After 2 years, it became very popular. Everyone is using my company's website and they are entering into it, and then they are trying to like play with my website, or if they want to do some shopping, let me say it's an e-commerce platform. People are shopping, people are purchasing, traffic has increased, many customers have come. So what did I do? I started with 2 servers. Now I went up to almost like 15 servers or 20 servers, let me say. Now I am managing everything on my own by taking the particular room. I'm paying the rent for it. I'm purchasing the hardware servers. I'm having an IT admins to take care of it. I'm purchasing the coolants. I don't know if there are any natural disasters, how to take the backup. I don't have a vision, but I'm doing everything to satisfy my customer. Then cloud says on one fine day, it comes to me and it says that, hey, X organization, why are you trying to do all these things? I will give you some benefits. What are those? Get rid of your rent, get rid of your room, get rid of purchasing the servers. Okay, get rid of your IT admins who are taking care of this 24/7, this entire servers and everything. And you don't need to worry about if there are any natural disasters or any problem. Also, you don't need to worry about it. So we are going to take away your entire headache. Are you ready for it? Definitely I will say yes, that is what I want. I can pay you how much you want, but please make sure that I get rid of this. I don't want to have this tension with me. So then cloud came into the market by giving all these benefits, saying that okay, you don't need to do anything, we are going to take care of each and everything on behalf of you. And one more thing is, whenever you require, you can pay for that. For example, today you are using 2 instances in your cloud, you have to pay for only 2. Pay as you go model, we call it as. Okay, in the cloud we have something called as pay as you go model. Okay, that means as and when you're going to use the services, you need to pay for them. That's it. It doesn't have any other thing. So let me say you are using 2 instances, you'll pay for only 2 instances. If you are using 10 instances, you'll only pay for 10 instances. Okay, that is also one more benefit. In if you take your on-premise data center, like where you have your servers, either your customer is using that server, let me say either the customer is accessing your website or not, but your servers will always be continuously running, because you don't know at any point of time who is going to access your website. If you stop your server, and if at that time if your customers are expecting to have a look into your website, then it will throw an error. So for that, you need to always make sure that your servers are active 24/7. That is also cost. Okay, it's not a cost efficient mechanism, you need to pay a lot of cost for it. See how many disadvantages which you had at one point of time are being totally removed by the cloud. That is how cloud came into the picture. I hope I've given you an understanding. So this is the way how cloud has come into reality, and it is capturing the market. And in this cloud, many organizations have come with their own advantages and benefits. Like that, you have seen Microsoft Azure is there, Amazon Web Services is there, Google Cloud Platform is there, IBM Cloud is there. So like this in the market, there are multiple organizations who have come up with the same concept. Every one of them, they are trying to serve the same purpose by totally removing the on-premise data centers. Like you don't, as an organization, you don't need to focus on that. You focus on your application development and all, rest of infrastructure and everything we will take care. That's what cloud is saying. Now it is up to X organization to whom they want to go with, whether from GCP or whether to AWS or whether to Microsoft Azure or whether to IBM Cloud. It is up to that organization like what they want to prefer. But this is how in reality this concept is all together. That's how the on-premises data centers are being replaced totally by the cloud concept. Okay, so now our focus is all towards the Google Cloud, right? So let's first understand what exactly is this GCP, Google Cloud Platform. Okay, so as part of this, let's go ahead and try to focus, because as we got to know like what is cloud and how cloud is playing a vital role. So if you see here, cloud computing is actually nothing but it is breaking apart the key functions of your computer and laptop and then offer them as a service. Like what does that indicate? It says that we are actually breaking some key functions, okay, and then we are offering them as a service. Like as I already have mentioned right now, see, we can provide you as a cloud entire infrastructure, like where you can host directly on this infrastructure. That is one of the services which cloud provides you. It may be any cloud, AWS, GCP or IBM or Azure. Okay, so first level is infrastructure. Let me say as an X organization, I only want infrastructure to be hosted. Okay, then definitely I will host the infrastructure only. That is one service which cloud is providing you. If you want only infrastructure to be present, other thing would be software. Okay, so what you can do here is you can take your entire software, your application, your infrastructure, everything will be included here. Okay, so you can take this entire information and then you can put it inside the software altogether. Okay, that is also another important thing which we can consider. This is also one of the offering which cloud is providing. Okay, and the other one over here is platform. Okay, there are three services: infrastructure as a service, software as a service, platform as a service. These are three services which cloud is providing you. Any cloud, if you take all of them, they provide these three services. Now it is up to you as an organization which one you want to choose. If you want infrastructure, then they will handle only your infrastructure and you can have your application with you only. Platform as a service, if you opt, then application as well as infrastructure, they will take care of it. Okay, your application plus your infrastructure. Okay, both of them they will take care in your platform as a service if you opt for it. Now in the software as a service, right, everything will be taken care by the cloud only. You don't need to do anything. You complete writing your application and you can directly deploy on the cloud. Cloud will take the entire responsibility. So that is software as a service. So these are three different services which are being available, like infrastructure as a service, software as a service, and then finally your platform as a service. These are three services which are being available by the cloud to you. Okay, that's what is our first point. Now Google Cloud, which is present, right, it has a lots of open source softwares. There are so many partners, developers, third party software, and there are other cloud providers who have been connected with the Google Cloud. That means it is having a wide variety of options being available. If you see here in this picture, Google Cloud ecosystem which is present, right, it comprises of lot of people, like your open source software. There are so many providers, partners, developers, other cloud providers, third party softwares, because they're believing what that Google Cloud is really best. That is the reason why there are so many providers who have been present as part of our Google Cloud ecosystem. Like if you could see, everyone is been connected with the Google Cloud because of its potentiality and the way how it is been designed by the Google company. Okay, and then it is also a very strong supporter of your open source software. So that means it says that everything here is open source. At any point of time, if you want to use any of the services, right, you can use it without any problem, because as it is an open source, so you can use it whenever you want it. So there wouldn't be any problem at that case. Okay, now your Google Cloud which is present, right, inside your Google Cloud, there are so many platforms which are already been present. Now what are those? If you see here, Chrome, Google devices, your Google Map, your Gmail, your Google Analytics, Google Search, and your G Suite, all of them are being hosted directly on the Google Cloud itself. So Google company has directly deployed these services inside the Google Cloud itself, like your Google Chrome, your Google Maps, your Google devices, your Gmail, your Google Analytics, your Google Search, and then your G Suite. All of them are directly being deployed on the Google Cloud itself. Okay, so this is what we call software as a service. Software as a service means you don't have any dependencies at all. Directly the cloud will take the entire responsibility and they will take care of every service. So you don't need to worry or you don't need to focus about it. Okay, so this is a very important point which we need to consider when we talk about the Google Cloud. Here the other option which is been mentioned here in the fourth point, right, it is very clearly said that everything, your infrastructure, your platform, your software, whatever you consider, right, now Google Cloud is actually taking care of whatever I have highlighted right now. Okay, so all of this is actually called as software as a service because everything is taken care by the Google Cloud itself. So we don't need to worry about it. Okay, this is the entire Google Cloud, how it is being structured and it is being functioned. Okay, so now if I just go one step further and try to show you like what are the different regions like where it is being hosted. Okay, so I'll just show you over here, which is very easier for you to understand. Okay, if I just zoom it over here and if I show you the world map which is related to the Google Cloud, if you observe in India, there are two different data centers. One is in Mumbai and other one is in Delhi. Okay, so Mumbai and Delhi are two different places for the GCP. Okay, whatever is present, right, it is been hosted in two different data centers. Okay, now this is what we call as the backup. Okay, whenever if there is any backup or any failures happen, right, so you can get protected out of it. If you remember, I said one of the points when you're hosting your data centers on your own, then if any natural disaster or any unforeseen situation happens, then how are you going to protect out of it? So it will be very difficult. But whereas cloud takes care of that responsibility here, it says that you don't need to worry, that already there are data centers. We are going to ensure that your data will be replicated to multiple nodes in your country, as well as we will also try to replicate the countries which are near to you. Okay, it may be Indonesia or Singapore or maybe Melbourne or Sydney, like whatever is near to our country, it will also try to ensure that the replication would happen to the nearby countries' data also. So that what is going to happen at any point of time, if there is any natural disaster in our country, then if anything goes wrong, at least the data will be replicated to other country wherever the node is present or the data center is present, right? From there you can actually capture the data. Okay, so that there wouldn't be at any point of time a failure problems. If any customer or if any of your client accesses any data, it should not create any issues for them. That's how this regions concept and zones concept have come into the picture. This is how GCP is also taking care of ensuring that all your data is being replicated to multiple nodes by not creating any problems or issues. Okay, so this is another important thing which we need to consider when we actually talk about our GCP regions and then locations. This is another important point which I just want to make sure that you are able to understand. Now let me just move ahead. So that's what, if you observe here, Google Cloud is well provisioned across 60 zones. Okay, and then there are 130 points of presence. Points of presence means it's been present in 130 like countries wherever it is been present, right? It is been making sure that all the data centers have been present there, so that it wouldn't create any issues once we go ahead and try to use those particular data centers and when we want to connect. See here, if you see the blue lines over here, every data center is internally connected. Okay, if you see the blue lines over here, every data center is internally connected, so that it would not create any issues whenever if there is any data replication failure, or if there is no data is being transmitted at any point of time, it's not going to create any problem. That's the reason it is being present over 60 zones and over 130 countries in order to ensure that there wouldn't be any problems. Okay, if you want to use GCP, there are 4 ways like where you can interact with your GCP. One is using the console directly. Console means using your Google Chrome or any browser it may be. You can access from there directly, or either you can actually go with your Cloud Shell or your Cloud SDK, or either if you have your API readily available, you can use your API and access your GCP, or otherwise you have your Cloud mobile app, which is for both iOS and Android. So here using the Cloud mobile app also, you can go ahead and try to interact with your GCP. But in your mobile app, what happens? Once you interact with your GCP in this mobile app, right, you need to understand that whenever you access this particular mobile app over here, right, you will only be able to see, but you can't do anything. Okay, whereas in your web, Cloud Shell and SDK and REST based API, here you can execute the functionalities. But whereas in your mobile app, you can only just see, but you can't execute, or not you can't do anything over here. Okay, this is also another important point which I want to highlight. So in this ways you can interact with your GCP. So what I would do is I will just show you here. This is how your Google Cloud platform would look like. Actually the URL for this is console.cloud.google.com. Okay, so whenever if you want to access your Google Cloud console using the web browser, right, the thing what you need to do here is you have to go with console.cloud.google.com. Okay, so this is the one which you need to the URL for you. Once you enter into this URL, right, there will be some details which will be asked to you. The first detail here is you need to provide your information. Okay, so here in this case, so you need to make sure that you provide some amount of information, okay, which is actually present. Okay, so this is one thing which you need to understand. And what type of information do you need to provide? Like your name, your mobile number, and next important information will be either it may be a credit plus your debit. Okay, so anything, either it may be a credit one or it may be a debit card. You have to provide the details. Okay, either it can be your credit card or your debit card details, either of them. If you have whatever you have in your like anything which is handy with you, right, you can go and try to access, either it may be your credit card or your debit card. Okay, and then you have to provide that information just to make sure that they will only give you that access provided you pass them these details, and make sure that this is actually safe and secure. Okay, so no, they are not going to take your data, and they are not going to take away any money if you are new to it. This is just to make sure your identity is being present. Okay, and they will give you some amount of credits which you can use for 3 months. Okay, from which that is like a fake money or a virtual money. For example, if you play a game, so when you play a game, right, they will give you some fake coins just to make sure that you play the game. In the same way, once you pass your credit or debit card details, and once they verify and they say that yes, it's the right type of information, then you will be given some amount of money which is virtual. Okay, you can't just utilize that money. This is just a fake money, and where you can avail all the services in the Google Cloud platform for the 3 months, it may be Kubernetes or a Docker or a compute engine or spinning up your virtual machines, whatever it may be. Within 3 months, you can complete that. Okay. So you can go and try to utilize at any point of time. So that is also one of the good thing which the GCP is trying to provide to you, Google Cloud Platform. Okay, so and remember one thing, once you pass either your credit or your debit card details, right, a 2 rupee would be deducted from your account. Okay, 2 rupee would be deducted from your account, and just to make sure and just to see that whether this card is a real card or not, and then again they will refund you this 2 rupee back immediately. Okay, this is also one more information which I want to provide to you if you want to create your own GCP account. So first thing is you need to go to your console.cloud.google.com, and then after that immediately you will be asked to give your information like your name, your mobile number and your address, and after which it will ask you to reveal your identity by making sure that you pass your credit or your debit card, and along with that your phone number would also be asked. Okay, and once these details are being passed, then 2 rupee will be deducted from your account, and immediately this will be refunded to your account one more time. Okay, and then after which you will be given some amount of money for which you can use it for 3 months. All the services and whatever you want to create, you can go ahead and try to create at any point of time. Okay, so that is also one more important information which I want to share with you. Okay, so this is how your GCP account will be created. Once you're able to create your GCP account successfully, so here you will be having your projects. Okay, so you can create a new project. Like for example, you can just click on a new project and you can create your own project. Okay, you can just put any project name on your own. You can just customize your project name. Like for example, I will say here in this case, it is my Edureka project. Okay, and then you can just go ahead and try to create. So once it is being created, right, you will be able to see. So it's just creating. You'll get a notification over here saying that whether the project has been created or not. It's done. Okay, so select the project. Okay, I can just select the project over here, and then what I would do, see all the activities. Okay, yeah, I will go back one more step. Here is my Edureka project. Okay, so I have been in my Edureka project over here. Okay, and then if you just click on this 3 bars towards the extreme left hand side, you will be able to see all the services which GCP is trying to provide, like billing, APIs and services, support, IAM and admin. Okay, here compute engine means it is your VM. If you want to spin up your virtual machines, you can use your compute engine, Kubernetes engine, VMware engine, distributed cloud, and there are so many serverless like cloud functions, app engine, in order to store your files and everything, cloud storage, file store. Okay, big table, like if you want to deal with the large amounts of database, like you have your big table, data store, spanner, SQL. Okay, so many things, application integration. If you want to access with networking, VPC network, networking services. If you want to observe like how the things have been behaving, then monitoring, logging, profiler. Okay, so many things are being present. If you go ahead, this entire 1 hour will be less for us to understand, because every cloud services provide a lot of things as part of it. If you observe the GCP over here, there are lots of things which you can actually try to access from here. So these are all other services which are being available for us. Okay, so this is how your GCP looks like, and this is your console. Okay, if you want to activate your Cloud Shell, you can just click on the button over here beside your search bar. There is something called as Cloud Shell. So if you click on it, your Cloud Shell will be activated, and you can also run the commands from here directly, and you can also access some of the resources inside your Google Cloud platform. Okay, even that facility is also being provided to you. At any point of time, you can also connect with your Google Cloud Shell. And if you want to search anything, okay, if you also want to search anything, you can search from here directly. For example, if I want my compute engine, so I can just put compute here. I got an option. I can just click on the compute engine and I can enter into it. So there is also a search bar. If you don't want to go through all this list which has been present, if you know that what you need to do, you can go to the search bar and directly click on it and ensure that you'll get that services available to you. Okay, and here this is your Google Cloud Shell, like where you can pass any information or any commands and you can interact with it directly. Okay, this is how basically your GCP altogether looks like. This is your Google Cloud platform. Always remember one point: whenever you completed creating your console by passing your credit and debit card details, either of them, okay, not both the things, either it may be credit or debit, whatever card you have. Okay, once everything is been done successfully, First step is you need to create a project. Without creating a project, you will not be able to host any resources on it. Everything will be hosted on your project what you created. Okay, you need to create your project, and on top of that you need to host all your resources whatever is present. Okay, so this is the important point which you actually need to consider whenever if you want to work on this GCP platform. Okay, so I have given you an understanding like how the GCP looks like and what exactly is a GCP cloud and what are different services available by the cloud in terms of infrastructure, software, and then the platform. Okay, so now as we got to understand like all these concepts, so now I will go one step further, like what is Docker and what is Kubernetes. Let's understand these two things. Okay, and then we will see like where these things will actually play a very vital role. Okay, so let me just go and try to just make you understand like what exactly is the Docker concept first, and then later we will go ahead and try to understand the things in a better way. Okay, so let me just take you to the Docker concept then, as we are already into it. Okay, let me just go to our whiteboard. Okay, so right now what I'll be explaining to you here in this case is Docker. So what exactly is a Docker? Okay, so before you understand what is a Docker, right, I want to first make you understand what is a container. Okay, without understanding this container, right, it will be very difficult. Everything is interrelated here. Docker, why I'm saying, you may think that okay, we need to discuss about Kubernetes, but remember one thing, the Docker and Kubernetes, which I'm going to explain to you right now, which we also call it as K8. Okay, Kubernetes can also be called as a K8 also. Okay, Docker and Kubernetes both work hand in hand. So if you are applying for any of the jobs, right, definitely if you are applying for any Kubernetes role, it will be very clearly mentioned that you should have an idea of the Docker. In the same way, if you're applying for any Docker and anything which is related to DevOps role, right, it will also ask you that you should have a Kubernetes understanding. So these both work hand in hand. You have to know, in order to understand Kubernetes, you should know what is a Docker. Without understanding that, you can't understand what is Kubernetes. And along with that, the container which is present, right, this container topic is also very important. So let me go ahead and make you understand these things in a better way. Just for an example, let me say there is a VM. Okay, there is one virtual machine. Now in this virtual machine, what is going to happen here is, let me say there are two applications. Okay, for example, there are two applications which are being present. Okay, now these two applications have their third-party libraries. Okay, libraries means which is actually, these libraries are required for your application to run successfully. Without these libraries, right, your application will not run. It is like a dependencies. Without having these libraries, right, your application will not run. Now what I'm going to make you understand is, listen to me very carefully. I will take this application and I will deploy it in this virtual machine. That's great, there is no problem. Okay, virtual machine is present in order to host the application. Now I took my first application and I hosted it on top of this virtual machine. Okay, so that's fine. Now this third-party libraries and application, everything will be deployed on top of this VM. So now what I will do is, I will take another application and I will make sure that it is being deployed on this virtual machine. So now what is going to happen here is, when I'm hosting two different applications over here, okay, so when I'm going to host these two different applications on a single virtual machine, then what is going to happen is, sometimes there will be a conflict with the third-party libraries which are being hosted on these applications. So due to which, what is going to happen here is, there will be a problem coming up and it is going to create an issue. Okay, so that is the reason why this concept has actually not been successful. Like where if you have one virtual machine and if you handle on top of this multiple applications, then the libraries which are related to those applications may have conflict and it may create issues or problems. Okay, so that is the one of the biggest thing which we are having as a concern, that in one single VM, if you deploy multiple applications, then you would have a higher chances of conflict coming into the picture because of the third-party libraries. Okay, so then what should we do? Now this is our problem which we understood right now. So then what is that which we can actually try to do so that we can get rid of this problem? Now can I do something? See, if I take another VM, see there is one more solution which we can think of right now. What I can do, I will take one VM for this application and I will take another VM which I can deploy it on this application. That is also good idea. But the problem here is the cost will go high. I want to make sure that I have to design such a solution where my costing is less. I can't go with something which is more in terms of cost. So then what should I do? I have to make sure that everything is been cost optimized. So then what I will do right now here is I will just make you understand what is the solution which I want to make you understand here is I will have only one VM only, but I will go with a little bit of a different concept over here. Okay, let me just go with that concept. Okay, let me say the same concept. I have one VM, that is one virtual machine, same thing. Again, I have my one application. Okay, there is again libraries which are being related to this application, and also there is another application which is present where I have libraries being present. Now what I'm going to do is if I deploy these two applications in single VM, you know that there will be a conflict in the libraries. So what I will do is I will segregate these two applications. Okay, and that's when the container comes into the picture. Okay, so I can use the container concept, and then what I can do here is I can segregate these two different applications. Okay, so that what is going to happen is these containers will directly be deployed on top of the VM. Okay, so these two are segregated right now so that there wouldn't be any conflict. So we will use this container concept. So what is container trying to do here? Container is helping us to package this entire application along with their libraries. Okay, and if there are any dependencies which are being present, what it is trying to do, it is trying to package this application as a single unit. So that is the benefit of this container. Container will package this entire application where you will not have any conflicts with the other applications if you try to deploy in terms of any libraries. So in a single VM, now you can take multiple containers and you can deploy it on top of it. And in your container, you can have your application and libraries being present. Okay, so that is how basically your container concept has come into limelight, and this is the problem which we have actually tried to remove. Okay, so that we can directly use the containers and we can deploy on top of VM, and you can deploy as many applications as you want. It's not going to create any problem as everything is packaged in a single container. You will also not have any issues if you want to work on. Okay, and this is also portable. When I say portable, right, what does this indicate? So they can internally communicate among themselves. This application can talk to another application, and in the same way vice versa, because all of them are present in a single container, right? So you don't need to worry about it. So internal communication is being done within the containers itself. Okay, that's what we basically call it as our portability. Okay, so for example, if you host it in two different VMs, this is VM1 and this is VM2, and applications are hosted in containers over here, just for an example. Now they can internally communicate. That portability is being provided. If you allow an IP address, or if you allow those port numbers to talk internally within themselves, that facility is being allowed in the container concept. You can at any point of time allow your containers to go ahead and try to talk to them internally. That facility is being provided to you. Okay, so this is in the Docker. This is how the container concept is actually very, very important. Now, as you got to know that right now we are using containers, like where our application is being hosted on this top of this container, where container is a package, like where everything is being hosted in that container package. It is your library or your third party application, whatever you're trying to host, or your libraries or any frameworks which are available. Everything is present over there only. So you don't need to worry about it. Okay, so that it will be directly deployed on VM. Now, where is Docker playing a vital role then? So where can I add my Docker over here, and how can I understand my Docker concept? So now I'll make you understand that how the Docker will play a vital role here. Okay, so now you got to know that, okay, in the containers, I'm going to put my application, and this container I will host it on top of the VM. Great, you got to know that understanding. So now what I will make you understand here is what exactly is this Docker then? Okay, so Docker here means this is a platform which is used for developing, shipping, and then running your application. For example, you know that your container is present. Okay, this is your container. Your container, what did I say? This is present, okay, in order to host your application. Okay, whatever application is present, right, inside this container, you're hosting your application with all your libraries and frameworks. Okay, now in every virtual machine, okay, in every virtual machine, you will have your CPU inside your virtual machine, your memory card will be present inside your virtual machine, and then your network. Okay, this will also be present inside your virtual machine. Now in order to, for your, if you deploy your container on top of this virtual machine, your container will sit, but your container can't access either your CPU or your memory or your network. Now in order to make them access, you need to make sure that your Docker is sitting in your virtual machine. Then only your container will be able to access your CPU, your memory, and then as well as your network. Okay, so what is the point here? In order to make sure that your container is working appropriately, right, you need to make sure that your Docker should be present. If your Docker is not present, then your container is not fit for any purpose. So you have to make sure that your Docker is sitting inside this VM in order to host your container, and then your container can access your CPU, memory, and network which is present inside the virtual machine. That is the reason why we use this Docker and make sure that our container is using all the benefits out of it. Okay, so this is the reason why we just go ahead with this concept. And there is also another concept called as an image. Okay, now what exactly is an image over here? Image means, like, if you know about your VM templates, okay, virtual machine templates. Now what are these virtual machine templates here? When I talk about the virtual machine templates here, right, so what is going to happen? Let me say you will create one virtual machine where you will have all the configuration, and you want to spin the same virtual machine 2 more times. So you will again copy this template and you will create it easily. So in the same way, image is also like that. Let me say, using this image, you can create your Docker containers. You can, all the templates of your containers will be present in this image. So you can directly deploy this image where you will be able to make sure that your container is created. Like how you have in your Google Cloud or your AWS, already your ready-made templates will be present for your virtual machine. In the same way, you can also use an image. In this image, you'll have a ready-made containers available. Okay, those ready-made containers, you can just directly deploy it with the help of the image. So in the image, you'll have all those Docker containers which are required for you to create it. So you can directly take the image and you can create that container, and then in that container you can deploy it on top of a VM, and in that VM Docker should be readily available in order to make sure that your container can use your CPU, memory, and then the network. So this is altogether how the Docker concept has come into limelight. And Docker requires your container, and your container requires your image, like where you can directly in the image you can go ahead and try to create that template and you can use it without any issues. Okay, so if you want to see that, I can also show you over here. Okay, this is your Docker hub, hub.docker.com. So here you'll have all your images available here. These are your all your images which are readily available. So you can directly take this image, like if you want Ubuntu, directly you can install this image. Okay, you can directly install this image, and then your container will be definitely created. So MySQL, Postgres, BusyBox, Python. So in this way, if you click on see all the Docker images, right, you will be able to see, and directly you can install these images. Okay, so that your containers can be easily created. Okay, just to give you an example. And the last concept for today, which I want to make you understand here is, once the Docker concept is clear, so now I will go right now with our Kubernetes concept. As I already said you, Kubernetes and then your Docker both go hand in hand. That's what I tried to explain to you. So now what I will make you understand in this case is, let's discuss about something called as Kubernetes. Okay, so now when I talk about your Kubernetes over here in this case, right, so what exactly is this? So let me say, actually your Kubernetes which is present, right, it actually manages all your containers. Okay, whatever containers which are present, right, it manages your containers. Let me say, if you have 1 or 2 containers, yeah, you can manage it. But if there are thousands of containers which are being present, then it is very difficult for the organization to contain, like to go ahead and try to manage those containers. Sometimes there are 10,000 containers or 20,000 containers which would be present. How would you go ahead and try to manage those? It is very difficult for an individual to do it, or for an organization to do it. And even if you do it, that is again a manual task. Why don't we go with for an automation then? As the world is advancing, then definitely we should think about automation. So in that case, what you can do is you can use your Kubernetes as a container management, like where your Kubernetes will manage all your containers. It may be around 10,000 to 20,000 or 50,000 containers. It may be. The Kubernetes main advantage or the speciality is to manage all the containers at scale. At scale here means like as and when you grow your containers or as and when you decrease your containers, it's a Kubernetes responsibility. When you use it, it will go ahead and try to manage as many containers as are present. Okay, that is the main advantage of handling this Kubernetes and ensuring that this Kubernetes actually play a vital role. For that purpose only, we go ahead and try to use this Kubernetes. Okay, otherwise it doesn't have any significance apart from that. Using Docker, what you're trying to do, you're creating those images and containers and all. That is the speciality of Dockers. Now what Kubernetes is doing, it is managing all those containers which have been created out from the Docker. Okay, it's managing 10,000s or 50, like around lakhs of containers which have been present, right? The Kubernetes responsibility is to manage all those things. Okay, so now what I would do here in this case is I'll quickly make you understand the architecture of the Kubernetes, which will be the last concept for this particular webinar. So if I could just show you, so here in the Kubernetes, if I just take a cluster, okay, Kubernetes cluster, how the Kubernetes cluster works, like it is like a master concept and then there is a node concept. There are two concepts, master and node. In the node, if I take node, right, in this node, what you will have a pod. Okay, this is a pod actually, and then you have something called as a kube proxy. I'll explain to you the functionalities, like why it is and for what purpose it is been designed. And inside your master, right, what are the things which are available? So in your master, you have something called as your API server. Okay, and then you have something called as etcd. Okay, and then you have your control manager. So in the master, you have again your control manager is present, and then you have something called as your kube scheduler. Okay, so totally there are 4 over here in the master node, and then you have other part which you have a node here, right? They have kube proxy and pod. These two, master and node, both of them in combination is called as a cluster. Okay, it is a Kubernetes cluster. When you talk about a Kubernetes cluster, what does this indicate? It indicates that it is a combination of your master as well as your node. Both of this all together is called as a Kubernetes cluster. Now what is pod? Pod is nothing but it manages all your containers. Okay, all the containers will be present inside your pod. Whatever containers you are going to create, right, all those containers will be present in this pod only. So that is the benefit of this pod. And the kube proxy which is present here, right, it is basically meant for your networking, like what IP addresses should come in, to filter all your IP addresses, to make sure that only certain IP addresses are coming and certain IP addresses which you think it is harmful or malicious, you can use your kube proxy and make sure that only right type of networking is coming into the picture. That is kube proxy is meant for. Okay, and your API server which is present here, right, that is basically meant for internet. Like let me say, if you want to access any third-party applications or any third-party APIs, if you want to access, then you need to use your API server and you can connect directly to other third parties which have been present from the internet. You can use this API server and can access the information. Okay, and then the kube scheduler which is there, right, the kube scheduler which is present, what does this kube scheduler does? This kube scheduler actually looks after pods. Let me say if there are containers, 100 containers are present, for example. Now this 100 containers will go into different pods. Now this is one pod. In that there will be multiple pods present in the network. So this kube scheduler which is present, right, it will schedule like to which pod this container should go. So the kube scheduler will look into the pod's activity, whether the pod is working fine or not, whether inside that pod the containers are working fine or not. If there are some containers which are available, in which pod it should go, those containers, everything is taken care by the kube scheduler over here. Okay, that is another functionality. And control manager, which is present here, right? This is basically used for your public cloud. Let me say I am using now Google Cloud. Using Google Cloud, I'm using this Kubernetes. Now, if you want to connect to some other public cloud like Amazon Web Services or IBM Cloud or Microsoft Azure, then definitely you need to use this control manager, and then you can access another public clouds which are available in the market. Okay, and then finally the etcd which is present, right? This is a database. Okay, etcd which is present, right? This is the database. Okay, now the database which is being present here, right? This is a database of pods. Now etcd will take care of the health of all the pods, the database. Like if any pod fails or if any pod is having any unhealthy conditions, everything will be gathered in the etcd, which is a database of the pods, just to see that whether everything is working appropriate or not. Okay, so etcd is basically the database of the pods, like where it will go ahead and try to see like what are the things which are being present and whether the pod functionality is going appropriate or not. Okay, so this is altogether your Kubernetes topic, and this is your Kubernetes cluster. This is your Kubernetes architecture also, like where you have master and node, and in the master you have API server, kube scheduler, etcd, control manager. It takes care of everything. And inside your node you have your kube proxy, pods, and then the pod networking and all these things. Okay, so this is your entire Kubernetes cluster where you can able to see all important things. Okay, so I have given you a clarity related to this. Now let's go back to our PPT and observe like what are the things which we have actually covered. Okay, so we have done with all our Kubernetes. I have already explained to you that it is a container management tool and all these things. Okay, the features, as I have already said to you, like automatically it will take care of all the containers which are present. Self-healing, it will understand if any container falls down, right? It will go and try to automatically understand those things, and it will spin up the containers at the same time. Horizontal scaling, if you need more containers, Kubernetes will understand and it will create the containers automatically for you. And there is a proper load balancing available. Load balancing means the load will be balanced equally to all the containers by not creating any problem. As I said, it is a storage orchestration, like where all your container will store all the important information by not creating any issues. Batch execution, any jobs if you want to run, it will be run in a proper manner in all the nodes. The batch execution will be done without creating any issues. Okay, and it has a very good configuration management, and it is also secret by ensuring that you would get to know the information. Automatic rollbacks and rollouts, that means at any point of time if Kubernetes understands that we need more containers, then automatically it will come up, and then at the same time if it requires that there is no amount of high traffic, then it will go down again. Okay, it will scale down. So automatically Kubernetes is intelligent enough to understand when to roll back and when to roll out. These are some of the features of Kubernetes which are being available. Okay, and I already explained to you like what exactly is a Google Cloud platform and all. So we have done at the start of the session. So we discussed about the regions and all these things. Okay, what is that which GCP provides you? I have shown already in the Google Cloud Console. So these are all other services which GCP is trying to provide us. And I've already made you understand like how you can see the Kubernetes and all these things. Okay, so if you want to see the architecture, I've already shown you all those things right now. Okay, so these are all other things. If you want to work on the Google Kubernetes engine, you need to ensure that all of these things are being present with you. If I could show you even in the console right here, if you can just go and put it in the search. Okay, that is your GKE. If you just put GKE, right, your Kubernetes engine will come into the picture. You can just close this Cloud Shell as I'm not using it. Okay, you will be able to see your GKE being loaded. So once it is loaded, I'll show you that part. Okay, yeah, this is Kubernetes engine API. You can just enable and you can play with your Kubernetes engine. So the benefits of GKE already I've explained to you. So load balancing, it will balance the load equally. Auto scaling, it will understand and it will scale automatically based on your traffic in the containers. Auto upgradation, it will automatically update whenever if there is any features or any patch if you want to apply, it will automatically upgrade it. And finally, the monitoring and log, like where you can monitor like how containers are been working with the help of Kubernetes, and you can also see the logs, like where you can understand how it is been behaving.
Let us now see the reasons why one should consider Terraform. So Terraform lets you define infrastructure in configuration code and will enable you to rebuild and track changes to infrastructure with ease. So Terraform provides a high level description of infrastructure, which means it's infrastructure descriptive. Second, it has a lively community and is open source. There is a massive community developing around this tool. Many people are already using it, and it's easier to find people who know how to use it, like plugins, extensions, professional support, etc. This also means Terraform is evolving at a much faster rate. They do releases very often. So third is like speedy operations. So Terraform's speed and operations are like exceptional. One cool thing about Terraform is its plan command lets you see what changes you are about to apply before you apply them. Code reuse features and Terraform tends to make most changes faster than similar tools like CloudFormation. Also, it is like the right tool for infrastructure management, as many other tools have a severe impedance mismatch from trying to wrangle an API designed for configuring management to control an infrastructure environment. Instead, Terraform matches correctly with what you want to do. The API aligns with the way you think about infrastructure. Also, like Terraform is the only sophisticated tool that is completely platform agnostic as well as supports other services, while there are a few alternatives, but they are focused on a single cloud provider. There's a declarative code. So Terraform enables you to implement all kinds of coding principles, like having your code in source control, the ability to write automated tests, etc. Now that we have understood why one must choose Terraform, now let's briefly understand what Terraform actually is. Terraform is a configuration orchestration tool designed to provision the servers themselves. It refers to arrangement and coordination of automated tasks resulting in a consolidated process or workflow. So it is also an like open source tool, means open source software tool created by HashiCorp. So HashiCorp created Terraform to manage present as well as popular service along with the custom in-house solutions. So Terraform lets you provision Google Cloud resources with declarative configuration files, resources such as virtual machines, containers, storage, and networking. Terraform's infrastructure as a code, that is, the IAC approach, supports DevOps best practices for change management, which lets you manage Terraform configuration files in source control to maintain an ideal provisioning state for testing and production environments. Terraform manages external resources with providers, external resources like public cloud infrastructure, private cloud infrastructure, network appliances, software as a service, and platform as a service. HashiCorp maintains an extensive list of official providers and can also integrate with community developed providers. Users can interact with Terraform providers by declaring resources or by calling data sources. Rather than using imperative commands to provision resources, Terraform uses declarative configuration to describe the desired final state. Now let's look at some tools for using Terraform with Google Cloud. We will briefly understand these tools. So there are like variety of tools you can use to optimize your Terraform experience. So first, let's explore the Cloud Foundation Toolkit, which provides a series of reference modules for Terraform. The modules reflect Google Cloud best practices, and using these modules help you get started with Terraform more quickly. The modules are documented in the Terraform registry and open sourced on GitHub. So these are some of the features of Cloud Foundation Toolkit. So first is ready-made templates. So the Cloud Foundation Toolkit provides a series of reference templates for Deployment Manager and Terraform, which reflect Google Cloud best practices. These templates can be used off the shelf to quickly build a repeatable enterprise-ready foundation in Google Cloud. This frees you to focus on deploying your applications in this baseline secure environment, and with infrastructure as a code, you can easily update the foundation as your needs change. Second, like you can treat your infrastructure like software. So through the open source templates, you can automate repeatable tasks and provision entire environments in a consistent fashion. Plus, your teams can collaborate on the infrastructure by participating in code reviews and suggesting source code changes. Third, it's like built for enterprise. So the Cloud Foundation Toolkit is designed especially to meet the compliance and security needs of enterprises. By creating a foundational environment using these templates, you can be confident that best practices are implemented out of the box, including key security and governance controls. Also, you can like maintain consistency easily. By adopting the toolkit, you can be confident that different teams are deploying their applications and environments using a consistent set of tools and patterns. This reduces the potential for misconfigurations and inconsistencies while allowing easier collaboration across different teams. Also, you can choose your adoption strategy. Each template from the Cloud Foundation Toolkit can be used independently. You can choose which patterns make sense for your organization and add new ones as your environment evolves. The open source templates can easily be forked and modified to suit your organization's needs. Lastly,